Data nerds, welcome to this full course tutorial on Python for data analytics. This is the course I wish I would have had when I first started as a data analyst. For this, you're going to be coding right alongside me as we master the basics of programming. From there, we'll learn how to analyze data using popular libraries like Pandas and Matplotlib. And finally, we'll put all your newly learned skills to the test by building your very own portfolio project. Now, this tool that we're going to learn is one of the most popular programming languages for data nerds. Don't believe me? Let's check out the data. For data scientists, it's in 2 out of every 3 job postings. For data engineers, it's similarly requested right after SQL. And for data analysts, it's in 1 of every 3 job postings right after Excel. And this popularity is not only fueled by how easy it is to learn, but how easy it is to also read. This course is for absolute beginners. You don't have to have any experience in programming, let alone Python, or even data analytics. I'm going to be explaining and breaking down all the different concepts and topics you need to know. In the first of 3 chapters, we're going to be covering the basics of Python. You're going to be learning about important concepts like data type, loops, and functions, all while coding alongside me in Google Colab, a free and popular tool to use for analysis. In the second chapter, we'll be moving into more advanced concepts. We'll be mastering 2 of the most popular data analytic libraries, Pandas and Matplotlib, all while extracting insights out of a real-world data set. We'll also be learning how to set up and run Python locally on your computer for this chapter. Finally, for the last one, we'll be moving into building a portfolio project for you to showcase your newly learned skills. You'll be uncovering insights on that real-world data set on data science job postings. And you can even apply these insights to your job search in real life. Now, I'm a big believer in open sourcing knowledge. So this course and the course material is completely free. You'll not only get my step-by-step video instructions on how to run and use Python on popular free-to-use tools, but also I'll be granting you access to all the notes and codes to this course so you can follow right alongside me and work towards building your very own portfolio project to showcase at the end. Now, although this is free and I will be generating ad revenue from this video, it's not going to be enough to pay for the expenses needed to build this course. So I have an option for those that want to contribute to this course. Using the link below, you'll be granted access to extra perks to help you learn Python more efficiently. There's practice problems for each lesson you go through to reinforce what you've learned in the video. They range from easy to hard and provide not only hints, but also the solution. With this, you'll have community access to be able to ask questions and also answer other people's questions for these problems. And finally, these data nerds will be awarded a certificate of completion that they'll be able to post to LinkedIn and showcase as experience in using Python. One quick shout out before we go further, and that's to Kelly Adams, who helped produce this course. She's the brains behind producing all these different lessons and exercises we'll be competing. And I'm super appreciative of her help, because frankly, probably couldn't have finished the course without her. All right, so let's get into that first question of, what is Python? Well, it was created by this dude, Vito van Rossum, back in 1991, and he named it after my parents' favorite TV show, Monty Python. Over the past 30 years, this tool has evolved into a multi-purpose programming language. It's used for a variety of things. It's in the source code of a lot of popular websites, along with helping build a lot of popular AI and machine learning solutions. Personally, I like to use it for automating solutions, including things like web scraping. Now, because of this multi-purpose aspect, it makes Python great for data analysis. It's great at not only collection and cleaning, but also analyzing and presenting. Now, interesting enough, although Python is only the 3rd popular skill of data analyst, it's implemented into all of these different solutions. Most all databases, at least reputable ones, have some sort of Python API built into it to allow you to connect to SQL. Last year, Excel integrated it, and now you can use your spreadsheet as a code editor. Oh, and the same can be done for popular viz tools like Power BI and even Tableau. So based on these integrations, I'd value Python at higher than these other skills. When comparing the interests of Python, SQL, and Excel over the past few decades, Python is growing consistently year over year, so I don't think it's going to be trending out of style anytime soon. Now, Python is not only free, but it's also completely open source. If you wanted to, you can go onto GitHub right now and check out the source code. You could even write a pull request to implement a new feature in Python, but I don't recommend it. And because it's free and open source, a lot of top tech companies are contributing to help build out this language further. A lot of them including from Meng, or is it Mama? We're not including Apple, so it's Mama. Let's now get into the course material. And for this, the first thing we need to cover is how you're actually going to run Python on your own machine in order to complete this course. In addition to that, I'm going to be going over all the different resources that I'm making publicly available to set you up for success in completing this. Now, there's two major ways to run Python. One is locally via a code editor, and the other option is inside of your browser, or commonly known as the cloud. Let's dive into running it locally first. For this, assuming it's installed, the first thing you need to do is actually load a file. From there, all we have to do is do some light coding to get what visualization we want. Then inside of a terminal window, I can run the file, and we get our graph in a new window. Now, I'm not a fan of using Python files. Personally, I prefer to use Jupyter Notebooks, as each cell allows you to run the output right below it. In the case of that Python file code, I can just copy and paste that code into a new cell and then run it. And the visualization is displayed right in the file itself below the code. So for the remainder of this course, we're gonna be using Jupyter Notebooks because frankly, they're just easier to use for data analytics. But we're not gonna start out this course actually running locally, so no need to install anything right now. Instead, we're gonna use Colab, which is a Jupyter Notebook inside of your web browser. Any of that code that we're able to run locally, you're also able to run it here inside of Colab. For all the basics chapter, we're going to be using Google Colab. It's not until we get to the advanced chapter where we're going to actually install and run Python locally. But don't worry, if you want to continue to use Google Colab, you can. Now for the course material, I've made every lesson available on GitHub. I've organized the folders into chapters, and the notebooks are organized in that same order of the lessons. So you can just come right in and click where you need to go. And this will provide all the notes along with code and their associated solutions. And one cool thing about this is you can come up to the top here and select Open in Colab. And as expected, it opens up the notebook inside of Colab, and you can actually go in and if you wanted to, run the different cells and test out different things. So that was the course notes and code, but what data will we actually be analyzing and manipulating in order to learn Python? Well, I made this app called datanerd.tech that collects job postings and displays the top skills of data nerds. I can just come in and select something like data analyst in the United States, and it will tell me what are the top skills, along with certain trends for skills and how much jobs are even paying. Anyway, I've made the data from this app publicly available for you to go in and analyze for this course. It's hosted completely free to use on Hugging Face, and if you wanted to, you could download the data from here. However, later in the course, I'm going to show you how to access this data programmatically. And this is a lot simpler to access all this data. So what kind of data is included in this? Well, we have job postings from a variety of data science jobs, with the top ones being data analysts, data engineers, and data scientists. Additionally, we have data from around the world, with the primary location in the United States, but a lot of other countries are available as well. And this data comes from a variety of different companies within tech, healthcare, and whatnot. Now, for those that are choosing to support the course, you're going to have those extra practice problems as well for resources. And if you get stuck on any practice problems, you'll be able to use the comment section below to ask for help. Which brings me to the last point. How should you go about getting help if you get stuck? Which you're going to get stuck eventually. Now, you could post a comment below, but I recommend an even faster solution using any good old AI chatbot. I've had tons of success in speeding my workflow using chatbots like ChatGPT, Gemini, and even Claude. All right, so that's a walkthrough of all the different resources you're going to need for this course. I'll frequently be reminding you of these resources and to go access them, but I wanted to make you aware at the very beginning. All right, let's now dive into this first lesson and actually get into the basics chapter in learning Python. With that, I'll see you in the next one. Let's get into actually coding. For this, we're going to be going into an overview of how to access and also use Google Colab. And the first thing we need to do is actually get you inside of this notebook. The first thing you need to do is make sure you're logged into Google. And if you're using YouTube, these two accounts should be connected. If you're logged into this, you're logged into Google. But if you didn't realize that it's 2024 and you don't have a Google account, you can just go to google.com, select sign in, and then from there actually create your account. Once signed in, you can access Colab in two different ways. The first is just by using this URL of collab.research.google.com. That thing's a mouthful. It will navigate you to the starting notebook, and from here you just select new notebook. The other option is just go to your Google Drive, which is at drive.google.com, and then from there select new, more, and underneath there you can select a Google Collaboratory notebook. Anytime I start with a new notebook, I like to just rename it to what I'm actually using it for. In this case, getting started. The first thing we're going to focus on is the notebook itself. We're going to be actually writing the code. We'll get to the menu bars in a second. So inside of here, I can add things like code or text. For code, I'm adding a code cell. And then for text, I'm adding a text cell. For the coding cell, I can type right inside of it. In this case, I put this as a coding cell. I can run it, and it's going to output right below it. For the text cell or markdown cell, I can do a similar thing where I can double click it and I can get into editing it. On the left-hand side is where I actually type my text, and on the right-hand side is the display of where it's going to get to. So let's talk a little bit more about these coding cells, specifically how to actually run these. So let's say I want to do some complicated math, and Python is really good at this. So I can put into this code cell something like 2 + 2, and then from there, when I want to run it, press the play button. However, I'm going to recommend you learn keyboard shortcuts as they speed up your workflow a lot faster. So instead of pressing that play button, instead I'll put in 2 + 2 and I'll press Command Enter, and it's going to run the cell. However, besides this Command or Control Enter, instead what I can do is whenever I put something in, like 2 + 2 again, I can press Shift Enter, and now it will execute that cell and then put the next cell in, so then I can go forward and I'm doing my next coding example, and it sets me up to move forward. Now, sometimes you want to do multiple operations within a cell. Let's say I wanted to add those numbers again, 2 + 2, but then also I wanted to find out what another multiplication of 3 by 3 is. In this case, whenever I run the cell, I only get output 9, which is the last statement. It doesn't output that first line. So if we want to see both of these, we can use the built-in print function. Now, anytime you type in these built-in functions, it's going to pop up here with some hints to tell you what this function actually does. In this case, it goes over the arguments. Don't worry too much about what's going on there. But it basically says it prints the values to a stream or to a system.standout, which we're going to be doing. First, it talks about what you can input into this print statement. So basically what you can put in between the parentheses. And then it gives a single text description of what it does. And it basically says prints the values. Anyway, let's continue on to actually see what it's going to do. So we'll put in print 2 + 2, and then also we'll put in a print 3 × 3. And in this case, I'll run it again, pressing Control Enter, and I get both that 4 and 9 back out of this. Now, technically, since that last line always outputs out of a cell, I don't necessarily have to put a print statement around that 3 × 3, and instead can just run it, and it will still output that 4 and then that last line of 9. So what if you want to include something in your code to tell maybe somebody else what you're doing inside of here? Well, that is a comment, and it's denoted by the hashtag symbol that you're going to put first, and then from there, a statement to the right of it. Whenever I run this, it's going to have no output because everything in there is basically ignored by the Python interpreter, well, at least everything to the right of the hashtag. And we can have comments at the beginning of a line, or we can even have it to the right of what we're trying to execute. And in this case, when I execute it, it's going to only read that 2 + 2 and execute 4. So that's enough with coding cells for the moment. Let's move on to those text cells. And inside of these text cells, you're allowed to use a markup language called Markdown. This allows you to format out your text on the screen. If I don't use any special symbols, it just outputs normal looking text. If I wanted to do something like a heading, I would put a hashtag, then a space, and then put something like heading. And it's going to make it much bigger. If I wanted to bold something, I would just wrap it in asterisks, double asterisks on both sides. If I wanted to do a nicely formatted list, I could just start it with something like 1, 2, or 3, or even start it with things like bullet points. If you wanted to insert a link, you'd use square brackets to put the text that you want to have the link for, and then inside of actual parentheses, you'd put the link that you want to go to. In this case, if you want to find out more about Markdown, you can go to this link right here. And we executed the cell. We can see all these different things are formatted, along with going to that Markdown guide that you can go to learn more about how to use Markdown. Let's now get into a quick walkthrough of the functionality outside of the notebook with the menu bar. First, we're going to start with the sidebar, and we can have right here the table of contents, and it has all the different sections we've made so far, so that you can easily navigate to it if you want to. Next is find and replace, which if you used Word before, I think you know how it's done. From there, there's variables, which we haven't assigned any variables yet, but as we do in the next lesson that we're going to be covering, they'll start popping up right here. If you have any deep, dark secrets you want to keep from others, you can put them in here. But on a serious note, this is for things like APIs that sometimes have keys. In that case, you want to put it here and not in the notebook itself. as if you shared it, they would have access to it, whereas these secrets are local to you. And then lastly, in this section, we have files where you can go and actually access any files that your notebook has access to right here. You can even do things like mount your Google Drive. We're not going to do this right now. On the bottom left, there are things I use a little bit less, like code snippets. If I needed some sort of an example, I could go here and get a hint for it. I don't really use that much. Next is the command palette, and this is really a good location to know in case you forget of something like, hey, I want to go to the table of contents. You can go in there, type it in, and it'll navigate you right to it. And then finally, a terminal window. I don't have Colab Pro. You probably don't either, so you don't have access to this, so don't worry about it. Moving to that top bar, you can see we have things like add code or add text. You can see how much disk and RAM usage you're using, and you can even connect to different services and runtimes, but that's well beyond the scope of this course. The last thing is Collab AI, which is basically like ChatGPT or Gemini, that's Google's version, inside of here. And in it, you can ask a variety of questions. It's a large language model, and it will provide you the results. Now, whether you have this AI assistant or not, it's going to depend on a variety of conditions. Frankly, I don't really think it matters too much, as really any free chatbot these days is really just good enough to use. Moving to this last top menu bar, I'm not going to go into each one of these as they're pretty self-explanatory what they do, with the exception of runtime. If you ever log into a notebook and you want to run all the cells in it without going through and pressing Shift-Enter, well, you can select Run All, and in this case, it's going through, running all the cells again. Now, if Google Colab's just completely acting wonky, then you want to move on to restarting the session, and that's going to clear everything within here, and then from there, I'd go back and actually run all the cells. The last thing to cover in this section are special or magic commands. This is a very advanced concept, and we're going to be covering it more in future lessons, but you need to be aware of it before we get to that point, as the syntax of this looks slightly different than that of Python. Now, on my Mac, I have inside of it a terminal window, and this allows me to programmatically control my computer and install different packages that I might need for Python. Now, this Jupyter notebook is not running on my computer, it's running on another computer. We need terminal access sometimes in order to install different packages that we'll need for this course. And I'm guessing most of you haven't paid for Collab Pro, so you don't have access to this terminal in the bottom left-hand corner. But there's a workaround. I can start my code with an exclamation point and then type in some sort of bash command such as ls to list the directories, pressing Shift-Enter. I can see the directories in this case are sample data, which conveniently, if I just open this up, I can see also it's sample data. Don't worry too much about this ls command. It's specific to bash and it's not something you need to have memorized. All right, next up are line or magic commands, and they're prefixed by having this % symbol. Now, when I type this up, I actually have it pop up to where it shows me all the different shortcuts that are available with this. We're going to use the time it magic command. And what this does is actually times a different operation. In this case, I want to time how long it's going to take for it to execute this Python operation. And we see that it's 304 microseconds. But what happens if I had multiple lines of code? Don't worry if you don't understand this code. What if I have multiple lines of this Python code and I wanted to see how long it actually took? In this case, this line magic or this single % sign is not going to work on multiple lines. In this case, I want to actually put in 2% symbols for this. And now it's going to do the entire cell. Whenever I run it, I can actually see the time that it took for all of this. So that's a quick crash course on how to use Google Colab. Now it's your turn. If you haven't done it already, log in and get a Colab notebook set up. For those that are supporting the course, you have some practice problems now to work through and get you more familiar with working in the Colab environment. With that, I'll see you in the next one. So let's get into one of the most fundamental concepts behind Python, and that is the use of variables. In it, we're going to be talking about how to not only create it, but also assign it. And from there, do further manipulation, which is pretty common in data analytical tasks. So here's the data set we're going to be working with here a few lessons down the road, and it revolves around data science job postings. Anyway, we're going to be converting a lot of these different things inside of into variables and using it. In this case, look here, we have this salary column with a bunch of different salaries in it. So let's make a variable around this. So for creating a variable, I'm going to put the variable name on the left-hand side. So in this case, I'll just name it salary. And then I'll use an equal sign to assign a value. In this case, let's just do 100,000. Now I can run this by pressing Shift Enter, creates that new cell. Now salary is assigned to 100,000. Now from the last video, recall I can come over here and look at the different variables we have. Inside of here, salary is appearing. It's an integer and it actually shows the value right here of 100,000. Anyway, good place to go in case you want to keep track of what all your different variables are that you have for this. Now in this case, salary is the variable name. So if I were to actually type this out, press Shift Enter, it will display below here what are the contents of salary 100,000. Now I want to be clear, this is not the same what we were doing before. If I were to type in salary here with quotation marks around it, which is a string, which we'll cover in another lesson, that's completely different. It's going to output the string itself, salary. So let's say I want to do some manipulations with this, and I want to calculate what the total salary is. And in this case, it's the base salary times 1 plus the bonus rate. I can specify that base salary variable and assign it the value. We're just going to go with 100,000 as we did before. I can then also assign right underneath it that bonus rate. And we'll say that that is only 10%, so 0.10. I can press Shift Enter and then load these variables in. Once again, going into that variable sidebar if I want to. You don't have to do this every single time, but I can actually go and see that they're actually assigned inside of here. So now I could define this formula that we have above of total salary is going to be the new variable. It's equal to that base salary times 1 plus the bonus rate. Running it, I can do Shift Enter, and then we can actually print it out below this here, pressing Shift Enter again. Now, variable names have to be letters, numbers, or underscores. So let's say I had something like Luke's salary and assigned it a value of also 100,000. In this case, we're going to get an error message saying it's invalid syntax, and we're going to have this caret right here showing us where the error is. And we can see that it's basically between this Luke's and salary. The problem is you can't use a space in between here for variable names. I could either do something where there's not a value here, but it's pretty common practice whenever you name variables to use lowercase and also use things like underscore to separate different words to understand it better. Basically makes it more readable. Because it can be only numbers, letters, or underscores, I can't do something like add an apostrophe S in this case. Now going back to that data set, we can see from here that we're going to have a lot of other different variables besides different salary. And we're not limited to just numbers. You could have things like text, dates, Boolean values. So let's create some more example variables of different things we can do. So as an example, I can assign things like a company name, which would be a string. When I run this underneath here, I can actually see it here and see that it is a string by this single quote on the outside of it. I could also record whether something like a job is required to be work from home or not, and assign it a Boolean value of something like true or false. And looking at it here, I can see it is actually true stored inside of here. Now here's some other information as well. Let's say this all relates to a single job posting. So now I'm going to also input maybe the job ID, the job title, and also the salary behind it. Now let's say for fun, I want to actually print out all the different variables that I have for this one job. I have a title of data job description and then print out all the different ones below. When I go to run this, Shift Enter, I get this error message of name error, name job WWFH is not defined. Basically, I named this variable incorrectly. Now I want to show you something before I even executed this. So I'm going to just start this cell all over again and paste it into here. What you're going to notice is they actually have some syntax highlighting inside of here to actually hint you towards issues. In this case, I have these yellow curly line underneath this job WWFH, and it says, hey, it's not defined. And I can clearly scroll up and see that, okay, these don't match. I need to modify it. And then from there, they go away, running the code itself, I get all the values. All right, so that's a major overview of variables. And for those that have purchased the course notes and problems, you have some ones to work through and actually solve. And understanding this is really core to Python, as Python focuses heavily on designating everything as an object, and then therefore you can actually assign it to a variable. So we're going to do some pretty fun things coming up in the future. All right, with that, see you in the next one. Now that you've gotten some experience working inside of Collab and writing your first few Python statements, we need to move into understanding what are the basic definitions in Python. And a few of these you become familiar with, such as objects, variable, and functions, and then others you haven't necessarily seen yet, such as classes, methods, and attributes. So jumping into that first definition of objects. Everything in Python is an object, and it's basically a record of data. Previously, we defined the variable of salary, and we set it equal to an integer object of 100,000. Now, technically, not only is that 100,000 an object, but also that salary variable itself is an object. And if you recall from previously, we used a print function, which we're going to get to functions in a second. We used a print function to actually display a variable. Here it is displaying that 100,000 of salary that it's keeping. The print function itself is also an object. If I want to inspect what type of object something is, I can use the type function. And for the argument you place in between parentheses, it's the object itself that's highlighted in blue, and it's going to output the object's type. So in this case, if we put something like 100,000 into it, we can see that this is of the type int or integer, which actually brings us back to our core definition of what objects are, and they're an instance of a class. So this 100,000 is an instance of the class integer. If I had a string such as data analyst, I could run the type function on this, passing in data analyst. And for this, I'm going to see that it's of the type string. So I'm going to go into more detail on classes in a second. But how do I know? I'm telling you that integers and also strings are classes. How do I know that? Well, we can use the help function, and we can run this on that str or string. And this provides details on whatever you pass into it. So in our case, I passed string. It defines help on it and says, hey, this is help on class string in modules built in. So this confirms it's class string. All right, next up is variables. And we had a whole lesson on this. We define things like job title, job location, and even job salary. And with this, we use something like the equal operator to set it equal to a variable. Now, it's important to understand that the variable names itself point to an object. And what do I exactly mean by this? Well, I can use something like the ID function to get the identification number of an object itself to see if it's maybe correlated to another object. In our case, I can pass in the variable job title. And whenever I run this, I get a unique ID number for this. I could also run this ID function, passing in the argument of job location. In this case, it's just looking at the last 3 digits. I can see that these are 2 different IDs, as one references data analyst, one references United States. Now, this is where it's important to understand that variables identify or point to a specific object. In this case, I have job 1 equal to data analyst and job 2 equal to data analyst. One would think if I ran the ID of job 1 along with the ID of job 2, that these would have the same ID because they're the same string of data analyst. But if we inspect those last 3 digits, they're not the same ID. However, if I took a new variable such as job 3 and assigned it to, let's say, job 1, or assigned job 1 to job 3, in this case, the IDs, when I run job ID on job 1 and that of job 3, we can see that these IDs are the same because it points to the same object. Now, variables aren't confined to just only objects like integers or strings. You could also assign a function to a variable. So in the case of this print function right here, we can assign it to a variable. So I create this new variable called myPrintFunc and set it equal to print. And then I can call myPrintFunc, add some parentheses to it, and then print out the same statement. But I'll be honest, I don't really use that. The main purpose is to understand that variables, you can pretty much assign anything to it. Next up is functions. We've talked a lot about functions already, but it's important to understand that they're basically manipulators of different objects. In order for you to run a function, you need parentheses. So if I just ran this print right here, it's going to provide back that it's a function. But if I actually pass the parentheses and run this, nothing's going to output because I didn't put anything as the arguments. And so if I pass in something into the arguments itself, because print requires that, it will then actually print something out. Now, this is a built-in function. If I was routinely printing out this statement of what's up, data nerds, I could build this into its own function. Now, we're going to be going over some coding for functions and classes in this. In no way are you expected to go through and actually follow and actually do the coding of these. These are shown for example purposes only for you to understand these definitions we're going over. Anyway, a function starts with def, and that means define. And then you provide it the name of the function. So in this case, it's called greet. You need to put open and closing parentheses after it to then, if you want to provide arguments or not, which we'll get to in a second. And then from there, a colon to say, hey, we're starting the actual code for the function. Then everything indented in underneath the function is then run anytime you call this function. So in this case, we're returning what's up, data nerds. So I can run this greet function by putting parentheses, open and closing parentheses after greet. And in that case, it provides out what's up, data nerds. So going back to those three variables of job title, job location, and job salary, what happens if we wanted to print those out nicely formatted? Well, I could use this print function that I've gone through and actually manipulated. Don't worry about the code itself. You're going to be able to do this here in a few lessons. But whenever I run this, it actually prints it out very nicely formatted. But what happens if I'm doing this quite frequently that I need this printed out? Well, instead, I can create this function called display info, and I can pass 3 arguments into it: title, location, and salary. And I know those are the 3 arguments required for it because it's within those parentheses right there. And then from there, it's returning that print statement that we saw from above. Now I can call this display info function, and it tells me I need to provide title, location, and salary. So I can pass in those variables of job title, job location, job salary. Don't worry, the names themselves of the variables don't have to match word for word, just they have to be in the right positional order. But in this case, if I run this, it outputs it nicely formatted, and I don't have to use all this code that I had above. All right, next what we're going to be getting into is very advanced topic, and it revolves around classes. Classes are templates for objects. For that previous example for 90,000, whenever I ran this, whenever we investigated the type of this, we find that it was the type int. And running that help function on int to actually inspect the object of integer, it tells me that this is help on class integer. So integer is a class. This 90,000 above here is an instance of that class. If I inspect what's returned from this help function, it provides not only a bunch of information about what integers is, but also gets into what methods are defined inside of this class. We're going to get to methods in a bit. But let's get into building our own class ourselves. Don't worry, you don't need to follow any of this code. I'm going to build it. Mainly, I'm just showing this once again so that you understand definitions. Anyway, we have our job title, job location, and job salary. Let's say we want to store, this is a very standard job data. We want to store it inside of a single class instance. So in this case, we can define a class called job post. And then from there, I have a colon, and everything under that colon, and that is indented in, is specific to that class. Now you probably see something recognizable inside of this class, and that is this def or define. You would think this is a function inside of here, but this is actually a method, which we'll get to methods in a little bit. Anyway, this code goes through and actually saves all those different job titles, job locations, and salaries inside of that job post. Once again, don't worry about the code here. You'll be mastered on classes when we get to that lesson. The important thing to understand is I can create an instance of this job post class by calling it out. And then from there, it prompts me to provide the title, location, and salary. So I can provide in that job title, job location, job salary, these variables right here. And in this case, I've created an instance of this object. There's a bunch of bullarchy that those prints below because nothing special is set up right now to actually print out, but we basically created an instance. Now this actually brings us into our second to last definition that we'll be covering, and that is attributes. We learned about variables earlier, but attributes are like variables of an object. So going back to that class job post that we created, we defined actually attributes inside of here of title, location, and salary. So back with that instance that we created of job post, I can actually assign this to a variable. In this case, we'll call it job1. We'll set it equal to this. And we can access the attributes of job1, so in this case, title, location, salary, by using dot notation. So I call job1 and then dot. And then from there, 3 things prop up that you can then access. So location, salary, title. Let's go with title. And from there, from this instance of this class, we output data analyst. Scrolling back up to see, yeah, that job title should be data analyst. I can also run with this, that location, and it outputs United States. Now it's important to understand these are attributes, so you do not see an opening closing parentheses after this. You're going to get a type error with this. Remember, it's like a variable of a class itself, so you don't normally put opening closing parentheses after that. And this brings us into our last definition to cover, which we're going to be using a lot in the next upcoming lessons, and that's on methods. And they're basically the functions of an object. Inside of our class of job post, we had that first method right here that is called dunder init method. There's 2 double underscores right there. Python slang is dunder init. Anyway, in it, we defined our attributes underneath this method. Now, if you recall from previously, we created this function of display info. And then whenever we call this function with those 3 variables of job title, job location, salary, it outputs the different things. Anyway, this is a function right here because it's not inside of a class. But we could turn this into a method. So what I can do is take this code up here and put it into the class itself. Make sure that it's actually indented in properly. Then from there, update some variable names. Don't worry about this too much. Like I said, we're going to be going over classes in other lessons. The important thing is just understand we're creating a method right now. And the important thing to understand is we now have this display info method for our job post. So similar to before, I can create a variable called job1, which is an instance of that job post class with our 3 variables that we defined. I can see the attribute of it by running that title or .title on it for that one and see data analyst. And I can run a method on this, and that's going to be using that .nomenclature as well. Specifically, I can call job_1 period. And then look, multiple things are appearing now. And then we have this cube that defines it as a method of display info. Now it's important we put open and closing parentheses for this. And this is going to run the method of display info below, and it displays it nicely formatted using this. Now as a sneak peek into the upcoming lessons, let's say we had this variable called salary and we set it equal to 90,000. Remember, running type on this of salary, we can see that it's an integer object. Running the help function on int or see what's available, we can see that there's help on class int. Scrolling through, this is sort of the code of class int, and we can see that it has methods defined here, such as add, boolean. So in this case, I could use this add method on this. So for salary, I can use that .nomenclature, and then from there, put in add, and then the number we want to add to it. Let's just add 1 to it. And we have 90,001. But we're going to be going into more of methods for these different data types coming up. I just want to give you a sneak peek of how they're actually related. All right, so now you're a master of those 6 definitions: objects, functions, variables, classes, methods, and attributes. We're going to be using these terms a lot over the coming lessons, so it's important that you do understand them. And for those that purchase the course practice problems, I have some practice problems for you to practice learning these terms further. And with that, we'll see you in the next one where we're going to getting into understanding different data types, which are their own individual classes in order to find stuff like integers, strings, and whatnot. All right, see you there. So we ended the last section talking about objects. And in this one, we're going to basically continue on with that, talking about data types and specifically built-in data types of Python. Now we encountered some basic types already, including things like the integer. For text or words, we saw that this could be made into a string. For values that have a decimal place, this would fall underneath a float. And then if we need a true or false value, we can set this underneath Boolean. Going back to that data set that I keep on teasing that we're going to be using in upcoming sections, it shows that for all these different columns here, if we look underneath it, they have the different data types that it is. So in this case, they're showing a lot of strings, Boolean, and then also things like date time, floats, lists, and dictionaries. So we have a plethora of different data types that we're going to be messing with once we get to that data set, but we need to get more familiar with how we can actually use these data types with the superpowers they have. And what do I mean by superpowers? Well, I'm mainly referring to what methods or what capabilities are actually capable of certain data types. And what do I mean by this? Well, let's go with an example. Let's say we have 2 variables, total salary of 110,000, and then also what the bonus is of 10,000. I can run this cell by pressing Shift Enter. And then just to confirm, what are the data types of these? I can use the function of type. and then open the parentheses, I can see that this is going to tell me what the object's type is. So I can just put in here total salary, press Shift Enter, and it tells me it's int or integer. Because of this, it has certain superpowers or methods that we can do to it. So in our case, we want to maybe calculate what is the base salary, which we could calculate by setting the base salary equal to total salary minus that bonus salary. And then I'm going to go ahead and actually print it out right below it on what it is. Pressing Shift Enter, we can see that it does 100,000. So with this integer object that we have, I can do things like subtract and then also add like we showed in the previous video. Now, just because integers can do operations like addition and subtraction doesn't mean that other class types, such as strings in this case, can do the same thing. So let's say we have this here where we have a job title of data analyst and we want to remove the word data. So I'm going to go ahead and run this by pressing Shift Enter, and then just to see what it is, I want to see what the data type is of job type. Sorry, I want to see what the data type is of job title, which is string. So let's say I wanted to remove data from data analyst. I create this new variable of job title and set it equal to that job title minus remove word. And then from there, I want to also print it out to the screen. So I'll tie it up here. Now watch whenever I run this. It's going to give me a type error, and that's because it has a unsupported operation. Specifically, it says unsupported operand types for the minus symbol, string, and string. Basically, this geek talk saying we can't do this type of operation. Now we're going to get into exploring what are the different methods or capabilities available to these different data types. But first, I want to start with this table right here and showing that we're not limited to just those 4 different data types I showed in the intro video. Now we have a plethora of built-in data types inside of Python core to it that we have the ability to work with. We've already seen a lot of these and worked with them already, and many of these we're going to be covering in the upcoming sections, diving into greater detail to understand what methods or capabilities are actually capable of these different objects. As a spoiler, we're going to be basically focusing on all these with the exception of that binary type. That's a little bit more advanced than we need to get to for data analytics, but all the other ones are really core to what we'll be using in data analysis. So how can we learn more about the capabilities of these different data types? Well, they actually have a help function built inside of Python to help you with this. With this, it's as simple as typing help. And this explains for what you put in between the parentheses. You're going to put a request, which is an object, and explains this is a wrapper around py.help that provides a helpful message when help is typed at the Python interactive prompt. But I'm going to go down to this last statement where it says calling help and then thing inside parentheses prints help for the Python object thing. So in this case, I can put into that thing. So let's put in string and actually dive into more on help with it. Pressing Shift Enter, I get this bad boy printed out, and it starts with this of help on class string. So string is a class. We'll be covering classes more in an upcoming section, but for now, it's just important to understand that classes are one of the core building blocks for creating objects inside of Python, such as a string. So it gets into the documentation of this, starting with class string object. First, it starts about how you can use this string keyword as a function, which we're going to get to in a bit. And next, it gets into providing a description of this. And we're just going to look at this first statement right here of it creates a new string object from the given object. All the rest of this gets into a lot of detail. I don't want you to focus on too much just yet. But underneath here is what I do want you to focus on. Methods defined here, and this is the capabilities that it has. Here I'm going to scroll down a little bit, and we can see that we can do add with it. So what happens if you actually add strings together, it will add it to itself. Another method available is length. So whenever we do something like a length on it, we can see the length of the string. Now these are all the double underscore methods or dunder methods of the string class. And these are just special ones. Like if we go back to that addition, we can use that plus operator in order to add things. Now, other things we can do is a method called capitalize, and it returns a capitalized version of these strings. So just to demonstrate some of these capabilities that we've found out in this string class, we can actually do a lot of these operations. So here we're doing the addition one where I want to add data to nerd. Pressing Shift Enter, I can see that it adds it together. Now, if I wanted to capitalize this string, I can call the capitalize method. And what I'm going to do with this is I'm going to just put a period and then capitalize. And then from there, put a closing parentheses, running Shift Enter. And I thought it didn't do what I wanted to do. It did. It returned a capitalized version of the string. More specifically, make the first character have uppercase and the rest lowercase. And in this case, if we scroll back down, oh my gosh, this is a lot of documentation. Scroll back down to datanerd.capitalize. It lowercase the end because it's meeting this thing. Anyway, we're going to talk more in depth about strings in the upcoming sections. Don't worry if those methods don't necessarily make sense just yet. We're going to dive into it deeper. What I want to focus on now is this. So right here underneath this help documentation, it tells me that there are functions available with this string here. And I can actually run a string function on an object to turn it into a string. And spoiler alert, we can actually do these type of functions with a lot of different data types. So in this case, we have string at the top. We can run this str function on an object itself to turn it into a string. But we can also do this with a multitude of other built-in data types in Python. But you may be like, Luke, like in this case here where job title is set to something like data analyst and is thus cast as a string, why would I need to actually run a function on this to turn this into a string when it already is a string? Well, the purpose of these functions are actually to turn it maybe into another object. For example, let's say we had a job ID and we want to set it to this value of 102. This type, when we run it, we're going to see is an integer. Let's say we actually want to make the job IDs have decimal places because future values potentially will have decimal places to capture this ID. How could we do this? Well, we could do this by wrapping that float function around 102. And in this case, where we go and print out the type of job ID, we can see that it is now a float. I can also go into that variable menu on the left-hand side and see that now it's keeping track of job ID as a float. One thing to note that's special to Jupyter notebooks is now job ID is saved as a float within this entire notebook. Although right here we have the job ID of 102 and we see that it's an int, or at least it says it's an int right here. If I were to put a piece of code underneath here and see what it is underneath here, it's going to still say it's a float because inside of this kernel here, it's now updated. So just something to think about when working with Jupyter notebooks and maybe you're moving around to different cells. It really depends on what is going on in that environment of what variables are being stored and what you're going to actually access. Anyway, now that we have this float type of job ID, if I wanted to learn more about it, I would use that help function on float. Running it Shift Enter, it's going to do the same thing of providing me this class overview of it, showing the function itself, and then all the different methods available to this float object. So we're going to be going into a lot more of these built-in data types in upcoming sections. Particularly the next one, we'll get into strings. So don't get too discouraged if you're not following along with these different methods and capabilities to these different data types just yet. All right, for those that purchase the course problems, it's now time for you to dive in, start messing with all these different built-in data types within Python. With that, see you in the next one. So this is the first built-in data type that we're going to be diving deeper into to understanding. And a lot of the core concepts that we're learning from this section right here are going to be applicable to a lot of the other built-in data types that we'll be covering coming up. So why are we covering strings first? Well, if we go back to that data set that I keep teasing, string makes up a lot of the different columns in this data set. So a lot of the data that you're going to have to manipulate later in order to get data insights is going to be with a string. So we previously discussed defining certain objects like a string. And in this video, we're going to be diving into the methods of string, such as in this case, using upper to uppercase Python. In the next video, we'll get into a more advanced topic of string formatting, where here we can insert that skill of Python into another string. So jumping back into a Jupyter Notebook, let's dive deeper on this. So strings can be defined either with here, as I have it in double quotes, saying this is a string in double quotes, or you can use it within single quotes. Either way, it's going to get cast as a string. Now, the most common mistakes beginners make with strings is they forget to put these quotes around it. And you'll see this by the syntax error that you're going to receive with it. And you have this caret pointing right to it saying, hey, there's invalid syntax here. And recall, if we have some sort of variable such as skill, defining it as Python, I can go as far as to invoke the type function on skill to understand what is actually going on here, what is the type of it, and it's a string, str. So let's get into manipulating this string by using those built-in methods for a string. First one thing I want to try is actually uppercasing all the letters within Python of that skill. So I can type skill.upper and then close the parentheses, shift enter, and it's going to capitalize everything. Conversely, I can do skill.lower, close and open close parentheses, run this, and it's going to put it in all lowercase. And in no way should you have all of these different methods of all the different data types we're going through memorized. That's why you need to remember that function of help, and then we can insert into it something like string, run it, and then get the help behind understanding what the string can do. So in this case, when Kelly and I were researching examples to show for this video, we used this function in order to look in under what methods are defined here. And then we scrolled on down past these dunder methods. We'll go back to these in a second. But we looked inside of here to see what other ones we could do. And we found this upper method, which states that it returns a copy of the string converted to uppercase. And then lower, return a copy of the string converted to lowercase. Now, real quick, I want to go over why you're seeing this self and also this / in here. These are the arguments that we're providing for the function. Now, we ran this previously, and it looked, I'm going to simplify it to where we have Python the string, and then we used lower. And then running this, shift enter, we can see we have lowercase Python. But as you can see from this, there's no self inside of here, so it's sort of confusing, especially those new to Python, what's going on there, and then there's no also /. Well, if we were to write the verbose version of this, we would write out the class or string, then we would apply that lower method to it, and then inside of that, we would put the self of Python inside of there. And in this case, when we run it, it's going to give us the same thing, that lowercase Python. Now, what about that / in there? Well, the short answer is it's basically ignored. But the technical definition is that positional arguments are on the left of this, and keyword arguments are on the right, and this self is a positional argument. Anyway, don't worry about too much about that right now. We'll cover more of that in the function section. For right now, it's just important to understand that whenever we define a skill, so in this case, skill equals to Python, running this, shift enter. Now, whenever we run the method on it, lower and close the parentheses, it automatically will replace that self, in this case, with Python, and therefore it will lowercase it. Now, sometimes methods have more than just that self argument that go into it. In this case, let's look at this replace method. In it, it says it returns a copy with all occurrences of substring old replaced by new. Inside of the parentheses, we'd specify old, new, and then the count. So let's start by actually writing this. So I could say skill, and then from there, dot replace. And let's say I want to create Jython, which is a Java implementation of Python. I could say I want to replace P with J. So we've got the old, and then we've got the new, but what about this count? Well, as you can see from here, we have count is equal to -1. And if we read the documentation, count executes the maximum number of occurrences to replace. -1, the default value, means replace all occurrences. Because this argument is already defined with a value, I don't need to specify it here. So running this, press shift enter, I can see that I replace P and J. So let's show another case where we actually use that count argument. Let's say we have this job title of data analyst, and we now changed our language for some reason. We don't use data anymore. We want to use doto. So if you're looking at it, you can see that it's going to be replacing the A's, the first two A's with O's, but we don't want to touch the rest of the A's. So in this case, I can specify job title dot replace. First, I'm going to specify the old, which is the A. Then I'll specify the new, which is O. And then I'm going to specify the count. And in this case, I'll just say 2. Pressing Shift Enter, we now have Doto AntiList. Now with our Doto analysis example, it's pretty common that sometimes we want to split words apart. Right now, our Doto AntiList is one combined string. Let's say we wanted to break it up into 2 separate strings of Doto and AntiList. Well, conveniently, strings have this split method. And for this, it returns a list of the substrings in the strings using sep as the separator strings. We haven't got to list yet, but you don't need to know too much about that to understand this method. Anyway, the separator is used to split the string. So in our case, the separator in Doto AntiList is this space between it. Right now, it's defined as none. So we're going to have to actually define that whenever we go through doing this. Max split, which designates the maximum number of splits that we want to do, is -1. So it means there's no limits. In our case, we really only want to split it once. So in that case, I take the job title and then do split. Opening up parentheses, we have the self, and then we have that /. Now remember, everything to the right of that / is a keyword argument. Because it's a keyword argument, I have to actually specify that sep equal to, and in this case, a space. Additionally, I have to specify that max split equal to 1. Now running this, pressing Shift Enter, I can see that it did separate out the data and AntiList. But remember, we wanted Doto AntiList. In this case, right, job title replace this. We didn't set it to itself. So actually we need to fix our code right here. So I'm going to specify job title equal to. So I'm just going to run these cells again. So job title equal to data AntiList, job title equal to this to replace it and get it into Doto AntiList. And now when I run it, I do see it. Doto on one side, AntiList another. It's in a list. We'll cover lists more in a second, but we've separated it nonetheless. Now these keyword arguments, which are shown here with that max split equal to 1, and those positional arguments can be very confusing, so don't get too deterred by it. But just make sure we're on the same page. Going back to that replace method, you see we can now specify that old, new, and then it's all to that left of that /. So in this case where we have count equal to, if I were to actually put that into here and specify it as a keyword argument and try to run this, I'm going to get an error. And it says string.replace takes no keyword arguments. So I can't specify it. So I'll run this again. Conversely, looking at the split method where sep and then max split were to the right of that /, this specifies the keyword argument. And so in this case, we wouldn't necessarily have to define it, but I'm going to show you an error with this. We wouldn't have to define it. So if I run this, it's still going to work. However, let's say we wanted to go with that separator equal to none, and I just removed this and only had 1 in there. It's not going to know where to apply this to. So when I run this, Shift Enter, it gets confused. So keyword arguments, although in this case, when I run it and use that 1 space only, it could work. I don't recommend it. I recommend actually defining it. So that way your code is more reliable and you don't make mistakes like I could have right there. Now, the last thing to cover is something that I conveniently skipped over when we first introduced these different methods. And these are these magic methods or dunder methods, which stands for double underscore, as annotated by the double underscore before and after that method name. These are also conveniently called magic methods. Now let's show this add method very simply. In it, it's pretty self-explanatory. It has self, and then you have another value. What happens is it will add itself to the other. So I'm going to write this out the long way, not what you need to necessarily do, but just explaining actually how it works. So I'm going to do the double underscore, add, and then double underscore more. Remember, it's going to take that self. So we can do something like data as the first argument. And then for the other value, we can add in AntiList. I'm going to put in a space to before that. Now, whenever I run this, pressing Shift Enter, it merges those two together. Writing this a little bit more shorthand, although I don't recommend doing this either, I can invoke this double underscore add method on data and then pass as the argument that space and then analyst. I spelled that wrong. And then pressing Shift Enter, it does the same thing of data analyst. But both of those are not actually what you're going to do with this. Now, Python is pretty cool in its readability and usability. So a lot of these dunder methods have actually been overridden to allow you to use operators. So instead of having to write all that different crap that I had to write before, I can actually just write it simply like this: data plus analyst, making sure that I put them into quotes itself. Whenever I run this, I get data analyst. But this addition symbol is using this dunder method of add right here. We're just not seeing it. It's doing it on the back end. And it makes it a lot more readable. Looking at all these different ones, I can just tell this is adding both of these, and it makes it a lot easier to do. This is what makes Python so great. Now, besides add, we also have other things like we found out before we don't have subtract, but we do have this one of multiply, which I have something like data analyst, and I want to display it 10 times. I can say data analyst times 10, running this, it's going to actually multiply it out 10 times. Now, all these magic methods or dunder methods don't necessarily work with just operators like plus, minus, and multiplication. They also can work and be overridden by certain functions. So in this case, if we want to get the length of a string, we could use this length function. So instead of writing out the dunder method of length, I can instead just wrap this inside of here. And whenever I run this, I get the same value of 12. And once again, I find this a lot more readable and easier to use. All right, so that's a crash course on not only how to use methods with strings, but on just methods in general. So a lot of these core concepts that we've covered on methods are going to be applicable on other data types that we're going to be covering coming up. So don't get deterred if it's not quite clicking, because you're going to get plenty of practice with this. Especially for those that bought the course problems, you have some problems now to go into work and actually solve using different methods that I've done here and even more. All right, with that, see you in the next one. Heyo, Editor Luke here, and I went to a quick intermission on how to use resources such as chatbots and also the internet and going through this, because I think a lot of the concepts, especially what we just covered in strings on the different methods, can be pretty confusing, especially for those that are new to programming. So let's first talk about AI chatbots. I particularly like ChatGPT and also Perplexity. We're going to stick to ChatGPT, specifically the free version in this example. So you don't have to pay to get this. In the case of understanding methods, I'm just going to go to the chatbot itself and ask it, hey, what are methods in Python? Explain it like, I'm going to say I'm 5. Additionally, I'll say, explain this using the concept of strings. All right, it goes through and explains this, well, very much more simply than even I did. And it goes into saying that, hey, methods, think of methods as special tools that can do cool stuff with words, strings in Python. And it gives some examples of these. And I usually like to take it further of having it show me actual coding examples that I can do. So I prompted it further, show me how to use common methods in Python for string, actually show the code and what do you expect as the solution. Okay, and then scrolling up, it provides even more examples than I did in this case, where it goes through and shows things like, oh, this is how you do the upper. And then if I scroll down, I can see what is the expected output from this. Now, using these chatbots is also great at troubleshooting those error messages. If you recall back from whenever we did replace and we were investigating what to actually put into it, we saw old, new, and then that positional argument of count. Whenever I tried to run it with actually counting there, we got this type error. Anyway, let's say you didn't know what was going on here or received a different error message. What I can do is I can just copy this all. I'm going to Command C. And then inside of ChatGPT, it's actually sophisticated enough. I don't even have to provide it a prompt. I can just provide it the error message itself, press enter, and it will provide me the updated code. Basically, it removed that count keyword in front of it in order to fix it. But we can actually take it a step further. In this case, I want to understand what's going on here. So I prompt it, why did I get this error? Explain it to me. And it goes in further to explain that, hey, it's not a keyword argument, it's a positional argument, so you're not going to actually specify that keyword. Anyway, just wanted to share that insight because you're going to be getting a lot of error messages. And you're probably going to have a lot of different questions as you're going through this. And so take advantage of even these free chatbots to help explain these concepts more for what you may need. All right, with that, see you in the next one as we get into more on string formatting. So now that you've played around or should have played around with different methods inside of strings, let's build on that further by this topic of string formatting. So jumping back into my Jupyter notebook, we're going to be going over 5 different operations for string formatting. And some of them you may have even played with already the methods of it. And well, the first one, I know you did. Okay, so let's say we have these 2 variables. We're going to be playing with them a lot during these exercises. We have one variable of role, which is the string of data analyst, and then another of skill, which is the string of Python. Now let's say we want to write out to the screen role, and then we're going to be provided a role, in this case, data analyst. We're going to write out to the screen. So for concatenation, we can use the operator of plus, which is that dunder add method. And then from there, specify role. Running this, shift enter, we can see we get role data analyst. No space right here. I'm actually going to put a space, press play. And now we have role :space data analyst. So we did see that one before, but there's actually another one. And I want to actually go into using that help function again on str or string and shift enter that. And that is this format method right here. So for the syntax for this, we're going to start it with the string itself, append on, as we saw before, that dot format method. And then inside parentheses, this is probably new to many of you, of this asterisk args, and then this double asterisk of keywargs, which stands for arguments and keyword arguments. We'll go more into breaking this down in the function section, but just understand that these asterisks and these double asterisks are special methods for us to actually apply or put inside of these parentheses many different arguments or many different keyword arguments. Anyway, what does this thing even do? Well, it returns a formatted version of S. Using substitution from args and kwargs, the substitutions are identified by braces. So I'm just going to copy and paste this to make this easier into here, and I'm going to comment it out. To actually comment out everything, you have it selected, and then from there you press Command and /. Window users are going to press Control /, but it's a quick way to comment out things. Anyway, I just want to have it here so I can actually see it and reference it quicker. So similar to before, we want to create the string role data analyst. Remember, data analyst is in that variable already of a job. Similar to before, we want to create a string, and we're going to start first very simply doing role and then specifying data analyst. So let's start with this string portion right here that we're going to stick in front of the format. I'm going to write out role. Now, additionally, it sees the substitutions are identified by braces. So we're going to put these braces inside of these parentheses. And then from there, I'm going to type in that format method, and I'm going to specify inside of here what I want to put inside of these braces. So pressing shift enter, we can see it specifies role data analyst. Now let's take this a step further. Let's say we want to instead now have multiple different variables put inside of this string. And in this case, I want to define not only the role, but also the skills required, in this case, Python. So similar to before, I'm going to have that role and then the braces right there. And then next I'm going to have the skills required and then the braces for that as well. From there, I'll add that format method and I'll specify in here role and skill. Going back to that documentation, these arguments are actually going to be passed through this asterisk args or this unpack operator inside of arguments. So both of these are going to be applied to this. Running shift enter, we get role data analyst, skill required, Python. Looks like I also formatted it wrong. I didn't put in the colon. Oh my goodness. Okay, that's better. Anyway, this allows us not only to put 2, but multiple, any number of different variables inside of here, and then still format inside the string. So that is the format method. And I'll be honest, that's not necessarily my favorite. I still find this pretty hard to read. Like if I was going through it, role, I'd have to look back and forth to understand what's going on here. And I have to also make sure that I actually align these properly. Now I could modify this further and actually add variable names inside of here, such as I use role and skill, which are the same as these variable names. They're actually different. Anyway, but we get really confusing now because we have now these two things in here, role and skill. We could use keyword arguments instead of role equal to role, skill equal to skill. Whenever I run this, I still get the same results. And this would maybe potentially be used in a case where I have like 5 or 10 different values here and I want to actually specify it. Anyway, I just want to make you aware of this. I'm actually not a fan of this. I'm more a fan of F strings. They're not only fun to use, they're also pretty fun to say. So here I have my variables defined, and with F strings, it goes with the names, you put an F at the beginning of your string itself. So in this case, I'm going to have an F and then either single or double quotes. And then I'm going to write the similar statement that we're trying to do, role. And then I'm going to put a curly brackets and specify the variable that I want to actually appear inside of here. Similarly, I'll do the same thing with skill required. And I'm going to specify it inside of these curly brackets and specify skill. So now this F string very much works like that format method that we went over, where we're going to specify these variables inside the curly brackets. Pressing Shift Enter, boom, I have it. Role.analyst, skill required, Python. Personally, to me, I'm more of a fan of this, right? Because it's so much more readable. I can just read over this. I can just read over this. Role is, okay, I expect this role to be next, and then skills required, expect the skill to be next. Whereas the formatting one, it's, yeah, we can actually specify variables, but then we have to do it all and configure this at the end. It's a lot more work with that. F strings, I feel, are your best bet. Now, another one I think that you should be aware of is this printf style string formatting. This came with this came in a previous version of Python and it was carried on into Python 3. I'm not a fan of using this, but it does come up from time to time. So I think you should be aware of it in case you see it, but I don't think you should necessarily learn how to use it. Anyway, similar as before, I can use singular or double quotes. So in this case, I'll specify role, and I'm going to use that % symbol and then S. And then we'll continue. We'll write both these in a second, but I want to just show this for the time being. From then you put a % symbol again, and then after that you put role in parentheses. So running Shift Enter, we have role.analyst. Now, if I want to add both variables, I can do as you expect. I'll put skill required right here, and then put that % symbol and S, and then inside of the parentheses, put skill. And now in this case, it's going to output both role and then skills required. Find this really weird to read. I'm not a fan of it. I don't recommend using it, but you should know about it. And the last method we're going to be going over is join, and diving back into the documentation. First, for the method, you have join, inside parentheses, you have self, and then you have the iterable. So it has to be an iterable, which we're going to go over that in a second. Anyway, in it, it's going to concatenate any number of strings. The strings whose method is called is inserted in between each given string. The result is returned as a new string. So in this case, they give the example of there's a period here, and we're joining it with this list, which we haven't gone over a list yet, but this list, which we can see that there's multiple strings inside this list. And what it does is it adds a period between this. So I find more use out of this method whenever I have something like a string, which is an iterable, and I want to actually divide it up. So say I had something like years of experience and I want to separate it by all these values via comma. I could have actually typed it out 0, comma, space, 1, comma, space, whatnot. That's a lot of repetition. Python is good at automating things. So what I can do is specify how I want to actually separate all those numbers. So in this case, I'm going to use a comma and then a space. And then from there, put in join, and we need to list that iterable. Like I said, years experience, which is a string, is an iterable. We can actually cycle through it. I'm having some spelling issues. And we can run this, Shift Enter, and now we can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we haven't covered list yet, but I think you can understand the basic concept, right? You have items inside of here. You have a whole list. So let's say I have this list of skills. If I wanted all these lists of skills right now, they're inside this list. They're not a string. So if I type skills and actually run this, we'll see that it's a list. Anyway, let's say I want to get into a string. In this string, I want it to have a, similar to before, I want it to have that comma and then a space after it. From there, I can just add that join method, specify skills inside of there, and then run it. And then now I have this full string that I can copy right here. And it has Python, SQL, and Excel in it. All right, so that is string formatting. If you remember anything from this video in the future, I hope that you remember, it comes no surprise, F strings. They're the most powerful, the most readable, and the most easy to use. So take advantage of them. They're very useful. All right, got a couple practice problems for those of you that purchase the course's practice problems. And with that, I'll see you in the next one. So the core of data analytics really revolves around using basic math. And if you used a calculator before, like most people, you've used different operators that we're going to be going over in this section in order to perform math. We're going to first warm up with arithmetic operators, doing things like adding and subtracting. From there, build on it further to use assignment operators, which not only assign a value, but we can do a lot of that arithmetic operation while assigning a new value. And then finally get into comparison operators, which basically review where to point Pac-Man in order to figure out what's the greater number. So jumping into a Jupyter Notebook, we've already shown before how to do basic math. Adding something like 2, which is an integer, and then 3, which is a float, we get the final answer of 5. We also saw previously that we're not limited to just integers or floats. Sometimes we can also use strings as well to do operations like an add. And we're not limited to just add with strings. We can do something like in this case of multiplying a statement or a string times a certain number. And then from there, it's going to export it out with this number multiplied times 10. Now, what happens if I wanted to use something like the minus operator? So in this case, I'm using a float of 3 and an integer of 2. I can see I'm going to get a 1. But for a string, let's say I wanted to subtract, if you will, up from up and actually run this, I'm going to get a type error. It's going to say unsupported operand types for subtract, and then string and string. Operands, in this case, are the what's up and then the up. And then the operator is that negative symbol. Anyway, how do we know what is actually supported for these different operators that are available to us? And specifically in the string case. Well, we go back to one of my favorite functions, help, and then type in str, from there shift enter. And then inside of here, I can see underneath these magic methods, which are these double underscore methods that have the double underscores before and after it. I have this add right here, so I know I can use the plus operator in this case. Also, I have the dunder method for mul or multiply. In this case, I can use the multiply operator. But if I look through these different methods and try to find the subtract method or sub, I'm not going to find it. And it is kind of intuitive of what to expect, but I think you should at least know the documentation for it. As when I run help on int, I can actually see that the subtract method is actually there, and it uses that negative sign in order to subtract them. Now recall that you can call these magic methods technically. So in this case, I defined 4 to the variable 4, and then from there ran the magic method of sub on it, and then used the value of 2. So basically 4 minus 2. In this case, we're going to get 2. But as I talked about previously, that's just to show you that the method's available. The actual Pythonic way to actually do this would be 4 minus 2, and then shift enter, get 2. Now I do want to cover some of these methods that you may not have seen or have experience with before. They do come up from time to time. So let's say I had something like 5 divided by 2. One thing to note real quick, anytime I do these operators, I'm usually going to put a space in between the number and the operator. You don't necessarily have to do that. It's still going to work just fine, but it just makes it more readable and easier to go through. Anyway, getting back to it. So we have this 5 divided by 2, and that's going to give us a value of, as we expect, 2.5. Now let's say we wanted to maintain, right now we converted it to a float, the answer's in a float. We want to go something, we want to maintain it at an integer. In this case, I could do something like floor division, which is using 2 forward slashes instead of just one single one. In this case, I'm going to get 2. Alternatively, if I wanted to get the remainder of what's left over after we divide 5 by 2, which we would expect 5 is divided by 2 times, so 1 is left over. But we could use the modulus operator, which is basically the percent symbol. So 5 modulus 2, running this, shift enter. And this would be a pretty common operation I'd see, or we would see, if we'd have to do this of 5 divided by 2 is 2 with a remainder of 1 in order to maintain in integers and not get a float. Quick reminder on order of operations. Remember, it goes parentheses, exponents, multiplication, division, and then addition and subtraction. So let's say we had 2 salary values, that of the minimum salary of 20,000 and the max salary of 80,000. Notice here I have these underscores in between here. This underscore is actually ignored by the interpreter when reading these values right here. And this is pretty common to use, especially whenever you're getting to thousands, millions, or billions, in order for you to be able to count how many different thousand separators there are. Anyway, we'll show it working a little bit. So let's say we wanted to get the average salary. Well, we'd have to add the minimum salary, and then from there, add it to the max salary, and then finally divide it by 2. In this case, I expect order of operations, parentheses go first, along with the division at the end. And then I want to actually print this out to make sure that I got it. What do we expect the results to be? I had to do the math real quick. 50,000. So as expected, Python ignored that separator right there. It's not going to actually print it out with it in there anyways, but I can just take it out to also show that it's going to work as well. Still 50,000. Next up is assignment operators. And we've already gone over the equal sign before, but these are going to combine the arithmetic operations along with an assignment operator. And all the different arithmetic operations are still available. So diving in a little bit deeper to the core assignment operator of equal. Let's say we have 2 applicants. Applicant 1, Kelly, applicant 2, Luke. Let's say we want to switch those applicants. Well, I could do something like this. I could create a temporary variable and then assign it to, let's say, applicant 1. And then from there, assign applicant 1 to be equal to applicant 2. And then conversely, make it to where applicant 2, I have a spelling, no spelling error, is equal to that temporary variable. And then when I go to actually print these out, running shift enter, we can see now that applicant 1 and 2, it was previously Kelly Luke, it's now Luke Kelly. Well, the cool thing about Python is you can actually do assignments of multiple values on the same line. Let me show you what I mean. Let's get rid of this right here because we're not going to save that. So I'm going to rerun this line up here, assigning Kelly and Luke. Anyway, this assignment within one line allows us to use something like a comma. So applicant 1, comma, applicant 2 is equal to applicant 2, comma, applicant 1. So we can swap values on the same line. And then whenever we run this, we can see now it is Luke and then Kelly. Now this is pretty cool because you can't do this in other programming languages as well. All right, moving on to the next assignment operator. Let's say we have something like x equals to 1. And then from there, we want to add 1 to this variable of x. So I could write it to where I have x equal to, if I need to add 1 to x, I would define it again of x plus 1. And then running shift enter, and then printing out what actually x is, we can see that it is now 2. Well, as you expected, there's actually an easier way to do this. So instead of actually having to write x again, what I can do is use this add and assign operator. And then from there, just put the value that I want to do. This is basically the same as x equal to x plus 1 as we showed up above. And then whenever I run this and actually print out x below, we could see that it is 2. Conversely, if I wanted to multiply x times 2, I could go x and use the multiply and assign operator. And then from there, add that value of 2 in, and then from also print right underneath it, x, shift enter. We'll see that that is now 2. Now, all the previous arithmetic operators are available, but I'll be honest, I most frequently see the add and assign for this. So that's all we're going to cover in this. All right, last up in this section are comparison operators. And this, just like you did in 2nd grade, is verifying whether values are equal to each other, not equal, or even greater or less than. So let's say I wanted to compare 2 salary variables, which we're going to be doing a lot of that in the project section of this video. But for now, we're just going to compare these 2 variables of salary for Kelly and salary for Luke. So for this, I can check if the salary of Kelly is equal to the salary of Luke by using this double equal sign. Whenever I run this, this is going to return either true or false. And in this case, it returned false. Now this operator is not necessarily limited to just variables. So you could technically put in something like is 1 equal to 1? And then running this, as you'd expect, you would get true. Now, a common mistake that you are probably going to make if you're new to Python is you're going to forget sometimes that whenever you're trying to do some sort of comparison, you need to put 2 equal signs. You're probably going to put 1 equal sign in. If I were to do this of setting an integer of 1 equal to 1, or really any integer, it's going to say syntax error, cannot assign to literal here. Maybe you meant double equal signs. So pretty nice that they actually give you this little hint here. Now, as far as the importance of these things like comparison operators, because remember, right, we said they return either a true or false value. You're probably like, Luke, why the heck do I even care about this? Well, they're going to be used inside of other things. Like we're going to be going over if statements in the future. Don't need to worry about how to actually write this code. Just want to show it as an example. But in this case, it's evaluating if salary Kelly is greater than salary Luke, print this statement. Gotta love Python because it's so easy to read. All right, so shift enter, as you expected, it's gonna print Kelly is paid more than Luke. So these comparison operators are gonna be used inside of other different functions, loops or lists or whatever, whatnot, in order to conduct operations more efficiently. And coincidentally, we're gonna be covering more on conditional statements or these if statements here in the next lesson. All right, for those that purchased the course problems, you have some course problems to actually work through right now and get more familiar with these different operators. With that, see you in the next one. So as we hinted to in the last section on conditional operators, we're going to be using those type of operators inside of conditional statements. These statements do quite simple things of evaluating whether a condition is true or false and then executing it based on that. So jumping into my Jupyter notebook, there's 3 main keywords that we're going to be covering this of if, elif, and else. And we're going to be focusing on if first, just to break down the simplicity of it. So we start a conditional statement by defining a keyword, and they always have to start with the if keyword. Then for the condition, we're going to just keep it simple for the time being, and we're going to actually just assign it of true. We'll use those comparison operators in this place in a second, but we're just gonna keep it simple. Anyway, you have if the keyword, the conditional value, and then from there, you have the colon. Now for the action we want to complete, I pressed enter after going through the colon, and it automatically, if I highlight this, I can see it put 2 spaces in there. So it indented it. Anyway, now I can put in the condition or the action I want it to actually take. So in this case, if true, which is going to be true because I defined it as true, it's going to print what's up data nerds. Running shift enter prints what up data nerds. Conversely, if I change this to false, I expect nothing to happen because it's now false. Quick formatting note, this indentation is actually very important for whenever we go through and execute our Python code. The compiler behind the scene reads this indentation and actually uses it. So if I were to take that away and just have it underneath this statement and press play, I'm going to get an indentation error. Conversely, whenever I actually press enter, it went through and automatically put in 2 spaces in here. So sometimes you'll see 2, other times I'll just press tab, which is also going to give 2 inside of here. Sometimes you'll see people put in 4 spaces. And if I run it here with 4 spaces, this is still going to work. And actually, I can put in a number of spaces into it, and it's still going to work. The important thing is that it's indented. We're just going to maintain for consistency just those 2 spaces. So let's move into a more practical example of how I'd see this conditional statement operated in the real world. Let's say I'm trying to filter out applicants for a job based on a skill. Specifically, I'm looking for applicants with the job skill of SQL, and we have this one applicant and their skill is SQL. So let's get defining that. We'll start with the keyword of if, and then from there, we're going to be comparing the job skill if it's equal to that applicant skill. And then from there, I'm going to press enter. And so if those 2 skills are equal to each other, I want to print out that skills match. So I'm gonna go ahead and run this, press Shift Enter. And as you saw, I made a common error right here, right? So if job skills basically says syntax error, points the caret up at job skills, invalid syntax, maybe you mean the actual comparison operator, not actually the equal sign. Anyway, actually putting in another equal sign into there and running this, we can see that skills match. But now let's move on into that 𝗕 keyword. Let's say we have a condition now where we're checking those skills of SQL. Let's say they don't match this, but say they have a lot of years of experience, and so they would still be something that we want to match and flag and basically cue that we want to look at this person. Well, in that case, we can use an 𝗕 statement. So I'm actually going to just take this right here and paste it right below it. So 𝗕 is going to begin on the line right below it. It's not going to be indented, so it's going to be in line with that if keyword. And we'll say if the years experience, which we haven't defined yet, we'll define in a little bit, is greater than or equal to 5, then we do want to actually match this candidate. So we'll say print enough experience, no SQL. And I'm going to go ahead and just define that year's experience right above. We'll do an example value to make sure it matches first of equal to 6. I'm also going to move these other variables down underneath here so we can modify them and use them easier. Correcting that print statement. So we want to make sure that this is, well, first, let's actually just run this as it is. We can see we're going to match on the SQL skill because SQL is equal. So let's just change this applicant skill. Let's say they have a more superior skill of Python, just kidding, and then actually run it. So we're going to fail basically, or have false for the first condition of if, because Python does not match SQL. Then for the 𝗕, because years experience is greater than or equal to 5, which is 6 in this case, it's going to print enough experience, no SQL. So what happens if we change this to something like 3, run it, nothing's going to print. Now, I don't really like how this doesn't print something out or capture some sort of value whenever it doesn't meet the skills or experience. So in that case, that's a great fallback for our last keyword to cover, and that is else. And basically, else is going to execute if both the if and 𝗕 statement are not executed. So in this case, I'm going to, once again, go down and start the new keyword of else. And then from there, all I have to do is put a colon in. There's no condition for this. It's just going to satisfy if both if and 𝗕 are false. And then from there, actually print out no skill or experience. So whenever I go ahead and run this based on these conditions, I have that final statement of no skill or experience. Now, one thing I did gloss over with 𝗕, you can have multiple 𝗕 keywords within here. So let's say in the case of that job skill, since I'm really privy towards Python, let's say that we have a Python skill for an applicant. In this case, we could print out something like, this applicant should know SQL. Basically, if you know Python, you probably should know SQL. Anyway, going ahead and actually running this, Shift Enter. I can see we get no skill or experience, and that's because I wrote this wrong. I wrote this with the job skill, and I'm trying to look at the applicant skill, right? So that's why we always actually try to troubleshoot. So running this again with applicant skill in there, pressing Shift Enter. This applicant should know SQL. Now, the last thing to know on this is sometimes you may read some others' functions, and you may see this keyword of pass. This is typically put into place whenever you don't have, when maybe you don't know a value you want to put there for the time being, but you need something to be within or underneath that keyword of if or 𝗕. So in this case, when I run this, nothing gets executed here. But let me show you more what this means. So let's say we actually defined if job skill is equal to applicant skill, and I'm not sure what we need to put in just yet. If I want to run this and do this, it's going to say syntax error, incomplete input. What I can do instead is actually press enter, and then for the time being, just to run it and get it through, run pass. And from time to time, you may see hardcore coders put in things like 3 dots, which are called ellipses. And in this case, it's going to be doing the same thing as that pass keyword. But I actually like to write out my keywords and make it more readable. So we're just going to put pass in. All right, that's enough of me rambling on conditional statements. Now your turn to give it a try and test out different scenarios with these conditional statements. All right, and see you in the next one. So I just recorded this entire video on list and realized I wasn't recording, so now we're recording it again. Anyway, so this one and the next 3 are on the 4 different type of data type containers that I find that I use from time and time again. And that are list, dictionaries, sets, and tuples. We're going to be starting with list because not only is it the most commonly used, but also it's one of the easiest to get up and running quickly. Lists are denoted by their square brackets and contain any data type within it. And in this section, we're going to be going over common methods associated with lists for altering them, adding to them, and changing them. We're even going to dive into things like unpacking lists so we can access individual items of it. And why are lists important? Well, we use them not only in the real world, but we're also going to be using them inside our data set on job posting, where each of these rows are a job posting. And if we scroll on over to the right for each of these postings, they have a set of skills that is required for it. Here I'm selecting on the second line where I have skills like Python, R, SQL, Cognos, Alteryx, Tableau, and SPSS. Each one of those skills are a string inside of a list. And this data set has hundreds of thousands of different skills required for jobs. And Python is great at going through and analyzing, basically combining all these lists so we can analyze it. So here we are inside my Jupyter notebook. I have this table here. Don't worry about too much, especially since we have lists, dictionary, and sets and tuples. I want to be able to show as we go through this how they actually relate. But the first thing we're going to look at a list is its usage. It's for a collection of ordered items, and we're denoting it with that square brackets. And if I wanted to define a list with those square brackets, I can put anything in it from an integer to a string like Python, and then I can even put another list inside of there, denoting things like SQL and the number 2. So any number of items can be in that list. You're pretty much limited by your computer resources. Pressing Shift-Enter, we can see it inside of there. But actually, let's talk about a practical example, talking about a list, maybe a list of skills, some sort of list that maybe you have of skills you have. In this, I have SQL, Tableau, and Excel. All these items are strings inside this list. So what can we do with this? Let's say I wanted to maybe add or even remove from this list certain items or certain skills. Well, how would I find that out? Well, using my favorite function, help, and then putting within it list. Shift-Enter. Here's the help on class list. It's its own class, so list is an object. We can do things, as we saw before, of add, which we're going to get to, of adding values. We care about adding and then removing from it. So actually, I want to look at maybe other methods, including things like append, where we would append an object to the end of the list. And for this, all we have to define is an object to append to it. Additionally, we have methods like remove, which remove the first occurrence of a value. So if our job skills list, let's say I wanted to append a new item to it. So you can probably guess what skill I'm going to add to this. It's going to be Python. Press Shift-Enter. We added it to it, and then actually checking out that list, pressing Shift-Enter, we see we have SQL, Tableau, Excel, and then Python as it added it to the end. Now, if I wanted to remove an item from the list, I could do job skills.remove, and then from there, it has value. And it says remove the first occurrence of a value. So in this case, it's expecting a string for what we need to put in here. So we'll go ahead and remove Tableau, pressing Shift-Enter, and then actually showing this left right underneath it. We can see we have now SQL, Excel, and Python. Tableau is now removed. Now, another method I find myself using all the time is the length message, and that's denoted by len and then open brackets. And then inside of that, you can put any type of object. So I could put, before I put Python in there and ran it, and we can see that Python's 6 characters long. Anyway, I can do this also for lists. So I can put in job skills, running it, Shift-Enter. We see we get 3. 3 items are in there. So speaking of 3, let's go over the indexes of a list. So for this list here, we have 3 items. They are indexed as 0, 1, and 2. In programming, we don't start at the number 1. Instead, we start at the number 0. Why? Because we're better than everyone else. but there's an important reason why we're actually doing this as well. Let's actually put this to use on these indexing. So for this list of skills, let's say I wanted maybe the second item in this list. So I could say job skills, and then from there, I'm going to use square brackets. And inside of those square brackets, I'm going to then provide the index number of it. Remember, it goes 0, 1, 2. I want the second item, so it's going to be, no, not 2, it's going to be 1. So putting that in, running Shift Enter, we can see the second item is Excel. Now you're probably like, Luke, why does this even matter, understand the index? Well, because we know the index, we can more precisely control where we place something in this list. Remember, Python lists are ordered in nature. So we can use this insert method to insert an object before an index. So as expected for the arguments, it takes index and also the object we want to insert into the list. Conversely, we can use this pop method, which removes and returns items at an index and it defaults to the last value. So for these job skills, let's say we wanted to put Tableau back in, but we wanted to put it back in where it was previously in between Excel and Python. So I start by defining the list, use insert, and then when the helper box comes up, we have to provide the index first. Remember, it's the last index, what you want to put before. So in this case, 0, 1, 2, we want to put it before 2, and we want to put in Tableau. Running Shift Enter. It now inserted into the list, but we want to see it. So I'm going to go ahead and print it. And we see we have SQL, Excel, Tableau, and Python. And now let's say we want to remove Python from it. We can use that pop method. So I can define job skills and, oh my goodness, I'm not typing right. Job skills and then the pop method. And remember, this takes the index, but the default is last. So I could put 2 in this case and then put Shift Enter. Oh, dang it. All right, well, it doesn't matter. So it popped 2 in this case. So we pop Tableau. What do we have? Job skills, Shift Enter. Okay, we got SQL, Excel, Python. And just to show a point, if I wanted to remove Python from that list, I could just use pop. And then from there, whenever I run this, it's going to pop out Python. I'm looking at the list, job skills. We can see we have only SQL and Excel now, even less skills. Now these index values don't only have the ability to access them one by one. Maybe we want to access multiple values of them. And accessing multiple values is done by slicing. Now, slicing has a very common syntax to how we access the index, except now we're going to be inserting this colon here. We have multiple values of a start, end, and stop. So let's just start with that start and end first. So if I have job skills and I want to get all items in the list, I could say, hey, start at 0 and then go until the end of this. And as we know, we go to 2 for this, running Shift Enter. We can see from this, we only have SQL and Excel. And for this, one thing to remember, right? Starting index is inclusive and the ending index is exclusive. So it's not included in this. So in this case, actually, if we want to include all items of the list, we're going to put 3, running Shift Enter. We got SQL, Excel, and Python. Now, both of those values actually are the default values of start and stop. So technically, if I were to write this and have it include all the values of a list, I'd want to more appropriately have it as this with only the colon in there. It's going to have all the items of the list. Now, similarly, say I wanted only the first item in the list, I could do this 0:1, run Shift Enter. Like I said, any of those default values, you're typically not going to see it. So you're just going to leave it blank in this case. And in this case, we're going to get SQL. Now, the last item to cover in this is step, and that's the steps to take between items. It defaults to 1. So if I were to run this of job skills, leaving those default values of a colon, include another colon, and then adding the 1. Whenever I run this, Shift Enter, we get all the items of the list. Now, whenever I change this last value to 2 to do every other one or every second one when I run this, I'm only going to get SQL and Python. So it does every second one. Conversely, if I change this to a 3, run Shift Enter, we're only going to get the first item because there's not enough items to actually do that. But let's actually do this on a bigger list to actually show the effects of this. So we have these 2 lists here. This is Luke's skills and then also Kelly's skills. And there are 2 separate lists. Now I can define a new list if I want, and call this all skills, and I'm going to set it equal to my skills and then also plus Kelly's skills. Then whenever I print this out, we should have all those skills added together. Shift enter, Python BigQuery, R, Python SQL Looker. Now, one thing to notice about is this list has repeating values in it, and that's okay, and that's going to be allowed with lists. Also, it maintained the order at which we added those two lists together. Anyway, getting back to our example, if we wanted to see every second item in that list, we could call out all skills, and then from there, colon, and then we'll put in 2, shift enter. We can see every second item, which is Python, R, and then SQL. Now, what happens if we want the last item in this list? So as we recall, we have all skills. And if I wanted to do this, I would have to count over. So 0, 1, 2, 3, 4, 5 in this case. So I would put in here 5 and then a colon, and I would just leave that blank. Running shift enter, we can see we get looker. But that was actually a lot of work to access the last item in a list. Well, conveniently, the indexes of these lists are actually in reverse, but for their negative values. So we don't necessarily start at 0 because 0 is denoted for the first item in the list. So we start at -1. And in this, we have Excel is -1 because that's the first last item. And conversely, SQL is the second last item. So an actually easier way, if I wanted to get the last item in this list, is I would just go in and put -1 colon, shift enter, and then I'd get looker. Conversely, if I wanted to get the last 2 items, I'll just put -2 in there and I get the last 2 items. The last concept to cover is unpacking. And this involves assigning each of the variables of an iterable, such as a list, to a variable in one single line. And we can go further and even access it. So back with our core list of job skills with Python, Excel, and SQL, if I wanted to assign each one of those values to its own variable, let's say skill 1, skill 2, and then skill 3, I can then assign it to that list. And then I'm going to print out each one of those variables just to show what's inside of it. Calling print statement on each one of those, running shift enter, we can see we have Python, Excel, and SQL inside each one of those individual variables. And we did this all in one line. This is called unpacking. Now, let's say I only cared about that first item in that list, and I didn't really care about whatever second, or maybe there's going to be even like a fourth variable inside of here, such as looker. So I'll run in this case so we have even more variables. So I'll define that variable of skill, maybe that I'm concerned with, so skill concerned. But then for the other ones, I want to assign it to maybe a value of skill don't care. This isn't necessarily appropriate syntax. Anyway, skill don't care. I want to assign all these values to this, and I want to assign it to or equal to that job skills. But remember, right, we have, if I were to run this right now, I'm going to get a value error. There's too many values to unpack. Basically, there's 4 items in this list. I'm only defining 2 here. Anyway, what I can do now is actually use an unpack operator, which just an asterisk. It's also called a star operator. And what's going to happen here is this unpacks an iterable into here. So in this case, skill concerned about will put the first item into here, and then all the rest of those skills, because we have this unpack operator in front of it, is going to go into there. So printing this out, I have skill concerned and skill don't care. Great name, I know. Running shift enter, we have Python in that first one, and then all those other values in a list inside this other one. Now, the unpack operator is an advanced concept, but it does come up from time to time, especially when you need to dive in and understand functions, which we're going to get to more in an upcoming section. So you need to be aware of it, but you don't need to be a master of it. So going back up to our fancy dancy table that I made, we've gone over list already, right? So we understand it's a collection of ordered items. We understand that it's for a sequence, it's ordered, they use indexes, and that duplicate values are allowed. And then this last one here says mutability. It's mutable. What does that mean? Well, using ChatGPT to define this, in Python, objects are either mutable or immutable based on whether they can be altered after creation. So mutable objects can be changed after creation. Examples include lists, dictionaries, sets. Things that can't be are things like strings, integers, and tuples. we proved that lists are mutable whenever we appended Python onto our list, and also when we removed Tableau from our list, because we made a change to the list. Therefore, it is mutable. It's a common word that comes up from time to time for Python programmers, so you need to be aware of it. And now you'll be wondering, when would you need an immutable object? Well, we'll get to that in an upcoming section. All right, for those that purchase the course Problems, you have some problems to get to. Start diving in deeper to understand how to alter lists and some fun problems. All right, with that, I'll see you in the next one. Now time to get into a more advanced container data type, moving on from list now into dictionaries. Now this data type is very similar to the physical form of a dictionary. I don't actually have a book or a dictionary, but I do have this app here on my phone that I use from time to actually look up values. And in dictionaries, the definition is stored based on the term itself. So in this case, Python is what's stored underneath the definition. And dictionaries in Python are very similar. In this case, the dictionary is what's in between the curly brackets. Looking at just this first line of databases in Postgres, the databases is the key, and then the colon then denotes that everything following this is the values associated with that key. From there, we use a comma to separate to the next key value pair. In this, we're going to be going over popular methods, including this one of identifying the keys of a dictionary. And you're probably going to see some that are very familiar that resemble ones that we learned with lists. And so why is this important? Well, if we go back to those data science job posting data set that we're going to be using, we not only had for each posting a list of skills, but we also have a dictionary, which has the type of skill for a key, and then the value of it is a list of the associated skills for that type. So in this first example, we have types of skills of analyst tools, databases, and programming. So let's create our first dictionary. We're going to do it by starting it with a curly brackets. And then first we need to define what is the key. In this case, we're going to be storing a list of skills. We're going to start with databases first. So we'll put in there database. This is the key. From there, we put in a colon to denote now we want to put in the values. In this case, I'm going to put my favorite database based on the SQL course that I just made. And I'm putting this also in a string. Both of these are strings. We'll talk about data types in a second. Anyway, running this, pressing Control Enter. I have database and Postgres. This key value can be almost any data type. It has to be hashable, meaning it has to have a unique value. So you could do something like 4 in here, but you couldn't do something like a list. So I couldn't do a list of database as the key. It's going to tell me that it's unhashable. Anyway, just cleaning this up. Now, unlike keys, the values can be any number of data types. So I could have, in this case, a list here for the value. Running it, we can see that it is. I can even have other things in here too, like an integer, another string, and we haven't even got to it yet, but a tuple. Running this all, Shift Enter. Oops, I didn't put this in a list because I'm having multiple different data types in there. It has to store it in something, so I'll put it in a list. Anyway, running this, Shift Enter, we can see all those different values because it's still a list are inside of there. So for now, we're just going to stick with strings. So we've defined one key and value. We can then, if we want to define another one, we're going to put a comma. And then we'll define what we want to put in. I want to do one for language, and we're going to do, as you guessed it, probably my favorite one, Python. Running it here, I'm going to get Shift Enter, and we have all the values here. Now let's assign it a value and set it equal to this. Additionally, we're going to add one more data type to this, and that's of library. And we'll be adding one that we'll be covering here soon of Pandas. And I'm getting this red syntax highlighting because I didn't put the correct colon here instead of a comma. Anyway, if you notice, this is sort of hard to read and go through very quickly and seeing what are the key value. So because this is enclosed within curly brackets, we can actually break this up into multiple lines. And in this case, it'd be common to start a new line right here, tab it over. Same here, we're going to start a new line on languages, start a new line on libraries, and then move this over. Now I'm getting some syntax highlighting because it looks like I actually deleted my curly brackets. And now we got to run it to actually see it. So pressing Shift Enter, we can see that we have this. It's all in one line when it shows it to you here. But anyway, with this here, we can actually see this better and actually investigate a dictionary. So we're going to be defining dictionaries in this very similar format from here on out, but it's not necessary. You could write it on one line. You can just remove the indentation if you want. You can do the indentation all over the place. No matter what, it's going to compile because you have it within those curly brackets. So what can we do with these dictionaries? Well, like anything, we're going to actually use a function of help to actually investigate that dict data type. So running this, Shift Enter. This is the help on class dict in the modules built in. And the first one we're going to look at is probably the most common method used with this, and it's actually a magic method with a double underscore, and it's get item. And if we can see down here, yes, they have it written as X for the dictionary name and then Y for the key, but it can be very similar to how we indexed lists. We can do similar like an index method on dictionaries. So what does that actually mean? Well, let's actually show it in some code. So if I type out job type skills, and then from there put a square bracket right after it, and then inside of there put something like database, and running Shift Enter, we're going to call the key of database and get the value of Postgres. Additionally, they have the get method right here that returns the value for a key if key is in the dictionary, else it defaults to none. But I'll be honest, I don't use that method that much. However, ones I do use are this keys method, and it provides a set-like object providing a view on D's keys, which D is the dictionary. We haven't covered sets yet, but you're going to probably know enough already with list to understand what's going to come out of this. And also the values method, and it basically provides an object providing a view of D's values or dictionary's values. So starting out with job type skills and then adding the keys method, using that opening, closing parentheses, running this, I get the keys of this. Conversely, whenever we use the values method, we're going to get the values from that dictionary, Postgres, Python, Pandas. If we wanted to remove something from this dictionary, similar to what we did with lists, we can use that pop method. And so we do pop, opening parentheses. We can see that for this, you provide a key in order to pop up at a value. So let's pop out that library value. Running Shift Enter, we can see we get pandas out of there. And then whenever we run job type skills, we only have now the databases key and the language key. Now we can remove items for dictionary, but what if we want to add it? Well, this is where the update method comes into play. So to find the dictionary, use the update method, and then inside of here, I'm going to provide it with a dictionary. So let's say I wanted to add cloud technologies to this. So I'll start it by defining cloud, and then after that, I'll add in what cloud provider I'm going to go with. I'm sort of, I prefer Google Cloud. So in this case, running this Shift Enter. So we'll notice I got a value error. Dictionary update sequence element has length 17. Anyway, what's going on here is we forgot something, right? The colon. So putting in a colon here, right? We got to use a colon to separate this along with having it in there, running Shift Enter. Boom. All right. Actually checking this to make sure it is there. We have database, language, and now cloud. There's actually an easier method that I would actually recommend for updating values. So if you recall, whenever I did that job type skills and then set the square brackets of, let's say we wanted to look what cloud was now, running Shift Enter, we can see that it's Google Cloud. We can use this same notation in order to define a new key and then also value. So let's say I wanted to add the skills of version control. I would define it here, and then let's say I just ran it right now because we don't have version control in there. Basically, it says, hey, version control, a key error, it's not there. Anyway, we're going to create it. We're creating it now. We'll set it equal to a value, and we'll say inside of it, we're going to keep get there. So running this again, Shift Enter. Bam, should be in there. Let's actually check. Job type skills, Shift Enter. Boom, now I have multiple database, language, cloud, and version control in it. So going back up to that fancy dancy table, we've covered a lot about these dictionaries. They're for key and then value pairs, and they're a mapping data type. Unlike lists, which are maintained in order, dictionaries are not maintained in order, so don't try to keep any order in it. Now, dictionaries do allow duplicate values within it. Now, you can't have, because of the index or the key itself, you can't duplicate that, but you can duplicate the values inside of whatever following it. It could be in multiple different keys. And we did show the last point of it being mutable. By the fact that we were able to pop out items and also update items to this dictionary, it's mutable. It's able to be changed. All right, now it's your turn to dive in and test out those practice problems. Also, feel free to test out what I said about that values can be duplicated, but keys cannot, in order to very much clarify what the definition is and what the characteristics of a dictionary are. All right, with that, see you in the next one. Now that we covered lists and dictionaries, it's mostly downhill from here for the rest of these container data types. We're going to be moving now into sets. Sets are very similar to lists, with the exception of, instead of using square brackets, you're using those curly brackets. There's no colon, so it doesn't become a dictionary. As we're going to show, sets are mutable, so you can add and remove items from sets. However, sets are unique in the fact that if we were to convert this list into a set, it's going to remove items that are duplicated, like Python in this case. Inside of my Jupyter Notebook, let's compare sets to those other data types. Sets are mainly designed for unique items, and so they don't allow unique values. However, they're unordered and there's no indexing available with it. So let's get into defining our first set. We're going to do similar to our list of skills that we did before. We're going to define a variable of job skills and then define our set. So I'm going to start by defining it by creating these curly brackets. From there, I'm going to put a list of skills in there. Now I'm putting only a list of strings in here. Once again, you can put any data type inside of a set, and running Shift Enter, we can see that when we print out job skills now, we have all those values. But notice something about it. Whenever I defined a list before, all those different items stayed in that order. Now, whenever I go and call that set of job skills, they're not in the same order that it was previously. It is doing it in alphabetical order, but don't always count on that. So don't think that you can use sets in order to alphabetize things. Now for lists, whenever I wanted to find an item in a certain position, I could just define this with a square bracket and then put in an item. In this case, we have 4, so 1, I'll do in this case. But for us, it's not going to work because set object is not subscriptable. It's fancy talk for saying there's no index. You can't do this. Now going to my favorite function, help, let's actually look at some common methods that I use on sets. Here we are on the help on class set in modules built in. For it, we have things like add, where it adds an element to a set. And like lists also, we have that pop method where we remove and return an arbitrary set element. So a lot of the same characteristics we were able to do with lists, we're going to be able to do with these sets as well. So if I want to do something like add a new skill, such as looker, I can go ahead and Shift Enter and then printing that out, job skills. Running Shift Enter, we can see now we have looker in there. Now let's test that feature of having only unique values. Let's add something to this that's already in this set. Specifically, we'll add something simple like SQL. Running this, pressing Shift Enter, it runs, but then whenever we actually look inside of here, we're going to see that SQL is still only listed once. Now let's actually remove an element from this list. Let's use that pop method that we used before. Remember, whenever we did it, we did job skills, then open parentheses. Let's say I want to remove something like Tableau. If I run this, I don't have the correct format here. I got to put pop. Okay, running this, Shift Enter, I'm actually going to get a type error. Set.pop takes no arguments. So unlike lists where we could provide it an index value to remove something in it, we can't do the same thing here with sets because, well, they're unordered, so we don't have an index. So if I actually ran this job skills pop method, it's going to provide an arbitrary value from this and remove it. In this case, it picks statistics. It's just random. And then if I were to run these job skills, pressing Shift Enter, we can see that now we have looker, Python, SQL, Tableau, no longer statistics in it. So if I wanted to remove a specific value from this, I'd actually have to use the remove method and then specify something like tableau in this case, pressing Shift Enter, and then it did it. Now inspecting that set, we see we have looker Python SQL. You're probably like, Luke, what the heck are we using these sets for then? Well, the primary use case that I find for it is being able to extract out unique values, whether it's in something like a list or tuple, and being able to do that very efficiently. So let's say I have this list of skills, and inside of it, you can see that I have multiple values repeated inside of here. What I can do now is that I can actually convert that skill list to a set. So running Shift Enter, we can see that it removes the values from it. And then if I wanted to actually convert it back to a list, I could just wrap it again in that function list, all of this within the function of list. Running this, pressing Shift Enter, it's now back to a list, and it does it really dang quick. All right, now it's your turn to give it a try and give sets a little run for their money, seeing how they are used in order to make sure that we have unique values within some sort of container that we need to keep a list of values in. All right, with that, see you in the next one. So we're moving now into the last container data type that you really need to be aware of. And this one's gonna have a lot of similarities to lists as it's a sequence data type. However, there's one big difference. Tuples are defined by parentheses, and then you put items in here. Here we have strings, but it really can be any item inside of here. Now, unlike lists, however, if I want to actually modify a set, I'm not able to do things like remove or even add or append items to this tuple. From our fancy dancy chart that I made, we can see that tuples are for fixed data. So if we needed to have a unique set of items that we don't want to be able to alter, we'd put that in a tuple. Now, what is the applicability of this? Well, to be honest, it's more applicable in software engineering, where say we have a unique set of items that we don't want to change. And they're going to use that a lot in software engineering. In data analytics, we're going to see this less, but it does have its applicability. So let's say I had a unique set of skills and I'm not planning on learning any new skills anytime soon. Anyway, I can set this variable of Luke's skills equal to and create this tuple for items that I don't want to change inside of it. In it, I defined a list of skills, and then I want to print it out below this. So pressing Shift Enter, I can see that I made a spelling mistake. Whoops-a-daisies. Run this again, Shift Enter. I have all those different items from our tuple right here. Now, tuples are indexable, so you can call things by its index. Like if I wanted to actually define Luke's skill here, and then look at the first item in that list. Ooh, what is going on here? I need square brackets. And then 0. Running this, press Shift Enter, we access that Python. Similarly, I can do like we did before with the slicing. I can access the first 2 items in that list by using the same slicing method that we use with lists. And just to prove that these sets are immutable, if I were to take Luke's skills and then try to maybe append on a new skill of R, running this, I would get an attribute error. Tuple object has no attribute append. So what attributes does it have? Well, using my favorite function, help, and looking at tuples. This is the help class on tuple and modules built in. Now from this, we can see there's a lot of different magic methods with it, but not a lot of just common or basic functions built into what you could actually do with tuples. So we're not gonna be doing a lot with this. Now tuples are immutable, but let's say we do need to actually update maybe a list of items in here. How can we do this with operators? Let's say I have these skills still of Luke and then I have these new skills because I finally decided to get back to learning. I could technically write Luke's skills and then add this to new skills. Running Shift Enter, and keep on putting F's underneath, too many S's underneath it, running Shift Enter. We see get this new tuple list back right here. And investigating further underneath the help for tuple, we can see that they do have this add functionality for tuples. You're probably like, Luke, I thought it was immutable, you couldn't change it. Well, you're actually creating a completely new object whenever you now modify this. So I could set this equal to a new variable of skills, and then I want to print this out below this. So I'll print skills, doing Shift Enter, it's going to do the same. Conversely, I could do Luke's skills here, and then we're going to do that plus and assign operator, and then also define Luke's skills here. I'm going to subtract that. Running this. Now we've actually modified this Luke skills, but this tuple that was once assigned here is not the same one here. And now you're probably like, Luke, how do you know that this is a new object? Well, actually, if you were to investigate the object itself, they have this fancy function called ID, and it can identify the ID, the unique value of something based on its ID. So in this case, I'm gonna run ID on Luke's skills and see what it is. And it's this number right here. But let's look at what the ID is right here for this Luke skill. I'm going to do a print function here to actually be able to see this, and then define inside of it Luke's skills. Pressing Shift Enter, we can see that the IDs do not match. Conversely, I'm going to change this up and actually show you what this would be with lists, where lists are actual mutable objects. So I've changed Luke's skills and also the new skills to a list. I'm adding it to here, and I'm now printing out these IDs for both these lists. Running Shift Enter. The IDs, or the unique values of this actual list, are the same because it's the same item, whereas this one in the tuples is getting recreated or redefined whenever we're doing this plus assign operator. Anyway, that's gone too much into theory. Let's move on. So we just wrapped up covering the 4 most common types of container data types of lists, dictionaries, sets, and also tuples. But I don't want you to think that these are the only 4 container data types. Now, in an upcoming section on loops, we're going to be using the range function. What is the range function? So I can put range, and then you put a value inside of here. And if we look at how it's defined, let's actually just look at the first one. Range is the stop position. So let's actually look at it. So if I do range 5 and then press Shift Enter, it returns back this range 0 to 5. What the heck is actually going on with this range function? Well, let's actually convert it into a tuple to see what's going on inside of here. And running tuple range of 5, running Shift Enter, we can see that it's actually values 0, 1, 2, 3, 4. It doesn't do 5 because 5 is exclusive for the stop in this case. I can also do things like provide it the start value. So in this case, I want to start at 2. Running this again, I get 2, 3, 4. So this is really convenient if we need to iterate through a certain set of numbers. Say we want to go from 1 to 100. So in this case, we'll do 101. And let's say we only want the odd numbers. So we'll do every 2. Running Shift Enter, we can see we get a list of all the different odd numbers from 0 to 100. This last argument right here, as you're probably guessing by now, is the step value. What can we increment this start and stop by? Anyway, that was a little bit of a tangent getting into the fact that there's other container types besides just these 4 here, but these are some of the most popular that you're going to be seeing used in data analytics. So now it's your turn to give it a try and test out these tuples. A lot of these concepts are going to be very similar to what you've already learned previously with lists, dictionaries, and also sets. With that, see you in the next one. Quick check-in before we dive into this section on operators. We're about halfway through with covering the basics of just Python itself, core Python. Once we get through these core basics, then we're going to be able to move into things like Pandas and Matplotlib, which are going to allow us to actually dive into that data set and actually explore it that I've been teasing this entire time. So I bring that up to let you know there's a light at the end of the tunnel. We're almost halfway through of the core functionality of Python. You should be really proud of the work that you've put into so far in learning this. I promise you it's not going to go to waste. For this section, we'll be covering 4 different operators. And we're going to be starting with logical operators first, which are denoted by key terms like and, or, and not. So what's the purpose of the operators? Well, they can be applied in multiple different ways. So in our data set, we have columns on whether a job is classified on work from home, whether it has a mention of a degree, and whether it has health insurance or not. And this is classified as either true or false for meeting a condition. So let's dive into putting these operators to work. But if we're going to start by defining a variable of job work from home and set it the value of true. We'll also create a variable for job health insurance and set it also to true. So let's say we want a job that is work from home and also requires health insurance. How could we actually check this? Well, we can use that and operator. And I do job work from home and job health insurance. And what we're doing in this case is comparing whether both values are true, and if they are, return true. Now, I'm looking for a job that is requiring both of these situations to be true. So if I said maybe health insurance, maybe it's false. Running this now, it's going to be providing false. Anytime either one of these are not true, it's going to be false. And we're not limited to just comparing two values. We can compare any number of values. We'll add an additional variable of job no degree mentioned, so whether a degree is required or not for the job itself. We'll set this to true. And then from there, I'll just add it on with an and statement, adding in that job no degree mention. Okay, running this still, we're going to be checking to whether all of these conditions are true. We're using an and statement for each. So as you'd expect, we're going to get false. Unless we have every single one of these is true, we're not going to get a true statement back. In this case, we will. Now let's move on to that or operator for the time being. We're going to get rid of this job no degree mention. Let's say we only want to meet one condition or the other. We want to either work from home or we want health insurance. Doesn't matter which one it is, but we just at least want to have one of these to be true. In that case, we can use an or statement. And if either of these are true, as we're going to see, it's going to get true. However, if we change one of these to just false, we're going to get true still because we meet one of these conditions. Only in the situation where both of these are actually false are we going to get a false return. Adding back in that job no degree mention, and then removing this here right here. This one's put as true. We can do, once again, like and multiple conditions. The last keyword to cover in this is not. And not just goes through and changes which way where the true or false statement is going. So in this case, I'm putting not true. It's going to return false. So in the case of here, if I want to do job work from home, job health insurance, and then for some reason I said, oh, I care about the opposite of whether a degree is mentioned, I put a not statement in here. Now I'm going to change that to false. These logical operators are going to be used in a lot of different functions and a lot of different operations. Specifically, we've covered already conditional statements. And so using like the if keyword, I can put our different values in here that we're evaluating for the if statement, put a colon. And then for there, I'd print meets conditions. So running this, do we meet the conditions of this? Running Shift Enter. No, we don't meet the conditions of it. The next one to cover are membership operators. They're checking whether an object is inside of another object. So jumping into an example of this, I could check whether something like data is inside of the term data nerd. Running this, I would expect it to return true because it's inside of there. Now this is case sensitive. So if I was looking for a lowercase data inside of here and running this, it would return false. I do see it time to time used with strings, but I see it more specifically used with things like lists. And think of that, I think of our job skills list. So here I have this one defined with only 3 skills, but imagine we have a list with hundreds of skills in it and we need to check it for, does it contain a value? Well, I can say what I want to check for. So in this case, Python in job skills, and then check it. Conversely, if I want to verify a skill is not in a list, I would just use that keyword of not. And in this case, it returns false. This is the one thing I love about Python. It's so readable. You can just read it right here. Python, not in job skills. Moving on to identity operators. These are used to basically identify whether something is correlated to another item. Now this commonly gets confused with the comparison operator. Say in the case of here, I wanted to compare the values of salary for Kelly to the salary of me. In this case, we can look at it and see, hey, they're both equal. Running this Shift Enter, we get true. Those new to Python may confuse this with the is operator. Salary Kelly is Luke. So running this, we're actually going to get false because these values are not equal. So why is this? Well, the technical reason is the is operator is, it sounds like improper English, the is operator is verifying if these two variables are using the same memory location for the value that they're holding. So if you remember, I use that ID function before to return the identification number or the memory location of a certain variable. So I can do here 𝗕𝘃𝗃𝗃, running this shift enter, and then I'll also do that of 𝗕𝘃𝗃𝗃, running shift enter as well. We can see that these values are not equal. I can even actually, this is actually a pretty good use case of doing this. I can take this and I can set this equal to it. Are these values equal? In this case, no, they're false. So when would using this identity operator in data analytics be relevant? Well, to be honest, not really going to be relevant, but I want to make sure you actually understand it because it does show up from time to time. A potential case of this is, say we had a list of core skills of Python, R, or SQL, and then we said, hey, these are Luke's skills. They're equal to core skills. And then running this shift enter, we set them equal to each other. In this case, we can use that is operator in order to verify if it is in fact the same item. And it turns out it is the same item. They're both have the same ID, so therefore it's true. The last operators we're going to be going over are bitwise operators. And when I say go over, we're really just going to briefly review it so you're aware of them. These operators are used in conjunction with understanding the binary value. So if I did this bin function to look at the binary value of something like 42, running shift enter, I can see that that's basically what the computer is reading 42 as. These operators are working to compare that first bit of these binary values and then returning certain values depending on it. We're not going to go into it much. Mainly, I want you to be aware of it because this and symbol, this or symbol, and then this also not symbol is actually going to get reused again. Basically, it's going to get overridden whenever we get into pandas. So I want you to be aware of it, that these symbols are available. So although we covered 4 different operators in here, and now we've covered a total of 7, for this section right here, I want you mainly just focusing on those logical operators and also membership operators. Those are the most important ones that there are when it comes to actually analyzing data. All right, so you have some practice problems around those. And with that, I'll see you in the next one. Don't repeat yourself or dry is a core principle in programming. And loops are one of the ways we can go about in ensuring we're not repeating ourselves. It not only looks bad, but it's very inefficient to have repetitive lines of code one after the other. And for loops and while loops, of what we're going to go over in this video, help solve that. So let's jump into a quick example of how powerful these type of loops are. Don't worry if you're not following along, we're going to go dive into it deeper further. The main purpose of this, I want you to just understand the power of this. So I have this list that I've already defined and imported from the data set on data science job posting, and it's a list of all the job titles from the job postings in the data set we're going to be working with. You can see things like here, we have data engineer, senior data engineer. Do we have any data analysts? What's going on here? Okay, data analyst, financial and regulatory reporting. So a lot of different jobs in here. If I actually want to see the length of this list of how many jobs we're going to be going through, scrolling, oh my goodness, what's going on here? So if I actually wanted to see the length of these jobs going on here, I can see that there are 787,000 different jobs in here. Now you could think, if I needed to go through this list and maybe identify, like I was trying to do, how many data analyst jobs are inside of there, this would be very cumbersome to do one by one. But this is where for loops and while loops can help us. So let's say I want to get a collection of all the different data analyst jobs within this list, and I want to put it into its own list. I'd first start of defining an empty list of analyst list. And then from there, I can use a for loop to iterate through the job list that we have. Don't worry, we're going to go over syntax in a little bit, but you could pretty much read this, right? For job in job list. I want to evaluate if it contains data analyst. If data analyst is in that job itself that we're going to be iterating through. So that each one of those items in the list can be iterating through, checking to make sure that data analyst is in it. If it's so, we want to do something. What do we want to do? We want to add it to that analyst list. So we'll do analyst list.append, and we'll append that job. So running this, pressing Shift Enter, we go through it. You can see it was done in, well, less than a second. We went through 700,000 jobs. Anyway, let's actually look at that analyst list. Printing it out, pressing Shift Enter, we can see all these things inside of here have data analyst within the job title. And if we wanted to see the length of it, I could just see length of analyst list to see how many out of that 787,000 are there. So 163,000 out of that are data analyst jobs. So you can imagine what we're going to be able to do with these for loops. Let's actually dive into it further. Break this down to using a simple example. We have this list called numbers. So we're going to start this for loop with the keyword for. From there, we're going to define a new variable for each of those, in this case, numbers we're going to cycle through. So we're going to write number. This is a new variable only going to be used within this for statement. And from there, we're going to use the keyword in for number in numbers. And numbers is your iterable that we're going to be iterating through. We'll jump into more about iterables and iterators here in a second after we get through this. So for number in numbers, we want to do something. We're going to do something simple right now. We're just going to print the number. Pressing Shift Enter to actually see. It goes through number by number and prints it out right below. So getting back to this iterable of here we have numbers and it's a list. What data types are iterable? Well, everything we previously covered on dictionaries, lists, sets, and tuples, conveniently what we covered before this, is iterable. So you can use it in this case. Additionally, you can do other data types as well are iterable, such as a string. Let's say we had a variable called characters and we set it to the value of Python. Similar to before, I can define a for loop saying for character in characters, print character. Running Shift Enter, we're going to get printed out Python. This variable right here can be anything that you define it. I mean, that can make it as simple as an underscore and then also put this underscore right here. Running Shift Enter, it's going to give me the same results. So let's move into a real world example with using for loops. Let's say I have a dictionary of job applicants for a jobs, and I'm looking to hire somebody with more than 5 years of experience. So this only has 4 values in it right now, but really, I mean, I'm sure any type of job application process is going to have way more than this. Fun little fact with this, you can generate any type of data that I'm using for this course even more quickly by using something like ChatGPT. Let me show you. So inside your favorite chatbot, prompt it something like this. Generate a Python dictionary titled years experience with name as the key and years as the value. Use random values for each. Make it 20 items long. And once it generates the code, in this case, it wants you to run the code to actually generate this dictionary. I was hoping to give it to you, but nonetheless, we can still do it. I can just paste the code right in, pressing play, seeing we have years experience, and this has even more values than we had before. We're not going to use this one, but this is just something to be aware of. We're going to use the same years experience that I just generated with only 4 values. So I like to start simple whenever building something like this. I'm just going to start by saying for, and I'm going to give it a variable of person in years experience. And then we end that with a colon, remember? Pressing enter, making sure that it's indented in. I just want to print out person. Now remember, when we're iterating through each one of these items in this dictionary, what's it going to print? It's going to print the key and the value. Is it going to print both? Well, let's find out. So how do we get the values out? Well, we're going to use my favorite function for this, help, and go into dict to investigate how we could potentially get this out. Inside of this help class on the class dict, we can see they have this method right here called values. It's ran on the dictionary D, and then an object providing a view on D's values. So we can use this for the values. So for this, I'm going to add in the method 2 years experience of dot values. And I know I'm getting the values now out of this. So instead of doing person, I'm actually going to title it what it is. It is value. And then I'll put it inside of here because we're no longer using person. Running this again, Shift Enter, we get the values out of it. Okay, so we learned how to get the keys and we learned how to get the values. How do we get both? Well, the next method you need to be aware of is items. And dictionary.items provides a set-like object providing a view on D's items or dictionary items. So in this case, this set is going to be basically key followed by a comma and then value to have that set of the key and value. So I'm going to go up here and modify this further, and I'm going to change this method now to items, and I'll change that first variable to key, comma, value. So it's going to say for key value, which is the tuple-like object, in years experience items, I want to print key value. Shift Enter. We got Luke 3 all the way through. You get the point. Now remember the point of this. We're trying to find an applicant that has greater than 5 years of experience. So let's modify this further. We're going to be using an if statement to basically now check if a value is greater than 5. If so, what do we want to do with this? Well, we want to alert whoever's using this that this key has, and then from there, has whatever number of years experience. So running this, pressing Shift Enter, we can see that Kelly has 6 years experience. There's no more in here, so only Kelly's going to appear right now. So wrap this up on for loops. We have to use some sort of iterable to iterate through to check all the different values. If you remember from that last video, we went over that range function. I just want to cover this real quick because you may see this. And we converted this from here into a tuple to actually see the different values inside of it. So range is commonly used within for loops to actually iterate over a certain number of things. Like say I need to do something 100 times. So I could say for blank in range of 100, I want to print that blank out. So Shift Enter, and I have a syntax error. Can't forget the colon. And it prints out all the different items. So you'll commonly see this type of syntax, specifically this range function being used. And so I just wanted to make you aware of it. Next up is while loops. And while loops are checking for a condition, similar to what if statements do in checking conditions, on whether it's true or false. And while it's maintaining true, the condition underneath it's going to continue to execute. So it follows the syntax of while and then the condition. In this case, I'm going to just throw in true and then a colon, and then underneath it, what we want to do. Well, in this case, we want to maybe just print data nerd. Okay. I don't recommend running this on your computer, but I'm going to go ahead and run it. And it's going to continue to run and run and run because it's always meeting this while condition. I'm going to go ahead and press stop right here. Hopefully it stops. Okay, good. It stopped. Now, if I change this to while false, it's never going to meet this condition underneath here. So running Shift Enter and scrolling to it, we can see that we have while false, print data nerd. Nothing's printed out underneath it because it never meets the condition to do that. Now I'm going to give you a caveat with this. While loops are very much less common than for loops. For loops are so powerful with what you can already do. I really don't find too much of a need for while loop. But while loops, for those that have maybe coded in something like VBA or R, maybe familiar with something like this, where you have something like a count, and we'll start this count at 1. And while the count is less than 5, we want to, didn't get done printing that out. We want to print the count. And for each one of these occurrences that we're going through, we're going to add 1 to each one of those occurrences. So now running this, what happens here is it prints 1, 2, 3, 4. Once it gets to 5, it doesn't meet that condition, doesn't print it out. You're probably like, Luke, why do I have to learn about this? Well, there are some conditions that you may meet that you need to do this. So going back to that years experience dictionary that we have, imagine this thing is super long and we need to go through it, but we only care about returning the first instance of meeting condition. And then from there, we can just terminate it. We don't need to move on. We want to just find one occurrence of it. So in this case, we want to find an applicant that has more than 5 years of experience, but we just want to return the first applicant. So I'll add in Mary with 7 years of experience. So we're going to start with a while loop to check if the value inside these dictionaries, so we'll just kind of call it years, is less than 5. We want it to stop whenever it gets greater than 5, so we don't want to continue on. So already I see that this years is has a yellow squiggly line underneath it, so I need to just go ahead and define it right now. I'm going to define it, set an initial value of 0. Okay, now I want to iterate through all of these years experience. If you remember, dictionaries are unordered. And so we can't use something like an index to iterate through it. But we can actually convert this dictionary into a list, and then it has an index for each of these key value pairs in order to iterate through. So let me show you what I mean by this. I'm going to actually, I know I haven't finished this while statement right here. I'll say this is the years list. In here, we're going to define that we want to create a list out of years experience. Let's actually see what this looks like first. I'm going to comment out this line right here, pressing Shift Enter to see what years list actually looks like. we can see it only has the values in it. So we remember we need to put in that items method in there to actually convert that into key value pairs. Then running this, it's a list of set items through here. And if I wanted to access one of the items in there, remember we can use that square brackets and then define like, hey, I want to see the last item in this list. Press Shift Enter. I put the 3 in there and I'll get Alex. I don't know why I said last, not the last item. Anyway, getting rid of this, let's actually get back into programming that while loop. So while years are less than 5, remember we started out with it being set to 0. We converted our years into a list. We want to get the key and value from this years list. And remember, we have to define it an index. Now, once again, when I get done this index is not defined yet. We also want to define this as 0. Just for troubleshooting's sake, I'm going to go ahead and print out each one of those key value pairs. Now, the other thing to do is, right, we have that index. We want to be iterating through each item in that list. So we need to add to it like we did before with the count by using that plus and assign and do it by increments of 1. So let's go ahead and do this, run this now. All right, so silly me, I said while years less than 5, right? We don't have a value in here for years. Technically, this value we need to actually use right here. It should be the years itself. And we'll change this also to years. So let's actually run this again. Okay, so in this scenario, we printed out Luke and then Kelly. And then as you can see, it goes through each one of these. It prints through each one of these. So now we're getting closer to what we want. I don't necessarily care about printing out this Luke at 3 years. Remember, we just want to see Kelly and that's it. So now we're going to include an if statement here. So if years are greater than or equal to 5, we want it in that case to print out. So run this again. We can see now we're only getting Kelly. And then we'll just add a little amplification here of key has so many years of experience. Running this, we now see Kelly has 6 years of experience. So as you can tell from that for loop was a lot less involved than that while loop. And luckily for you, you're probably going to experience more for loops than you do while loops in data analytics when using Python. So that's one thing good to know about this. All right, so now it's your turn to give it a try, testing out those practice problems for different for and while loops while building on, as you've seen here, all those different things we've learned previously on lists, sets, tuples, and dictionaries in order to combine this knowledge. We're really building up, and you're going to be surprised at the end of this course how much you actually do know. All right, with that, I'll see you in the next one. As we move forward in this video, we're going to start combining a lot of the things we're learning. Specifically here, we have list comprehension, which combines basically lists and also loops. So what is this list comprehension? Well, we're going to show it real quick with code. We're going to break it down even further as we go throughout this, but I just want to show an example real quick. In this, the list comprehension, or the what's going on, is inside of the brackets here, which is a list. And what we're doing is we're generating numbers from 0 to 100. And if I go ahead and print out this variable underneath it, pressing Shift Enter, we can see that it has a list of values from there to 100 or 99. So let's actually think through what we'd have to do if we didn't know about this list comprehension and we just needed to generate it with the knowledge that we had already. The first thing we'd have to do is define a blank list. Anytime you want to define anything blank, a dictionary or whatever, or even list in this case, you just put the brackets and you don't put anything in there. Then from there, we need to iterate through a loop and put it into this blank list. So I would use for number in, we'll say range 100, because we want to do the same thing. We want to add that number to the numbers list. So we'd use numbers.append, and inside of here, put number. Underneath this, I want to print out now what we did here and print out that numbers list. We've done the exact same thing that we did before from 0 to 99. And so look at this. This is a lot more succinct whenever we did this previously in only one line of code compared to this right here, where it took multiple lines of code and multiple basically unnecessary steps that we can make and compress, if you will, in making a list. So let's go over the syntax of this. So walking through this step by step, we're going to start by defining the list comprehension we're actually doing by doing these square brackets. And the first argument in here is the variable that we want to put into this list. So in this case, we're going to just define it. We're defining it right now, X. We haven't defined it yet, but we are going to. After this variable, now we need to use a for loop, if you will, to now iterate through what we want to. So in our case, we wanted to generate the numbers from 0 to 99. So we'd use for X in range 100. So with this syntax, we're basically going through and iterating through this iterator of range 100. Each item that it gets, it's adding to the front to this X right here, and that's getting added to the list. So running this and actually printing it out below, I'm going to say numbers, shift enter. Okay, so everything's printed there. Now let's modify this to actually show what's going on here further. Let's say I wanted to do an operation to each one of those numbers as we're iterating through 100. In this case, let's say I wanted to multiply them times 2. So every time that I'm cycling through each one of these numbers, it's multiplying the value times 2, adding it to the list, and then we have our final list. And here we see we have this new list where basically everything is going by 2s until we get to around 200 or 198. And we're not limited to just doing math operations. I can even do things like maybe I want to convert X to a float. And doing this here, now I have all these different items converted to a float. Moving on to the iterator itself of that range 100, we're not limited to just using range 100. We can use any item that is iterable. And we talked about list sets, tuples, dictionaries, and things like this range function are iterable, and even things like strings. So if I modify this, removing that float, I can put inside of here if I want a string to iterate through. In this case, I'm gonna put in Python, running, I know it's called numbers, but we're not gonna change that. Running through that, we have the final values of Python inside of a list. And although this section is called list comprehension, we're not necessarily limited to just doing list comprehension. We can do set, tuple, and dictionary. All you have to do is actually change what's going on with the brackets themselves. So instead of using square brackets, I'll use curly brackets in this case, running shift enter. We get, well, you can't read that anymore because now we're using a set, but it has the letters of Python in there. You're probably like, Luke, what's the purpose of this list comprehension? What are the real world example? Well, if you recall back to the last video where we actually went through and analyzed that job list of almost 700,000 different jobs for whether they contain data analyst and then put that back into a list, we can basically do the same thing with list comprehension. I know we have this added if statement in it. We'll get to that in a second, but we can do this with list comprehension. So I'm going to start out by defining that list of analyst list. And then from there, starting it by opening the brackets. And we're going to define a variable. We're going to be iterating through that job list. So I'm going to name the variable job. And so we're going to cycle through that by saying for job in job list. All right. So we're going to stop right there and just print out where we're at. I'm going to print out analyst list. And it has a whole bunch of values. I'm actually curious to see what is the length of this list itself to make sure that we have all the values there still. Okay, so we still have around 787,000 things in there, which if we actually look at the length of job list, running shift enter, we can see that they do match. And I actually modified this further to make it more readable. And now we can compare original list is this, new list is that many jobs. Anyway, let's continue on with our list comprehension. So we've already defined that we can do the for here. Now let's incorporate this if statement in there. And as you're probably guessing, you can just put this right after the for loop. So in this case, if, and then from there, I'm going to define a condition. For now, we're just going to put true in there to show it. I'm going to run it. So we're going to iterate through each item in the list. From there, it's going to check if it's true, if we meet this condition for that item, and if it is true, it's going to put it in. So whenever I run this next one, okay, I still have the same amount of jobs in there. Now, if I change this to false, nothing should get put into there. So I'm going to run this one. There's now 0 jobs in it. So we're going to change that if condition to be what we were trying to use before of data analyst in job. And now running this one and then this other one, we can see, like as before, original list has around 700,000. New list has around 163,000. And when I go to actually print out this list to inspect it, we can see all these different jobs have data analyst in the title. So this is a pretty awesome feature that we were able to condense down. Here we had 4 lines of code, I'm not counting this space right here, to 1 single line of code. And I also feel it's a heck of a lot more readable to actually go through and understand what we're actually doing here in generating this new list. All right, enough of me yapping. Now it's time for you to actually dive in and test out these different list comprehension methods by some practice problems that we got for this. All right, I'll see you in the next one. So we've been going pretty hard at learning all these different fundamentals about Python, and I want to go through an exercise combining all of these different things that we've learned so far in order to showcase an example in a real world scenario. We'd want to actually use these type of skills that we're learning. And this exercise is pretty simple. We want to filter what jobs we're going to apply for based on a list of skills. We're going to assume that we have these skills or my skills of Python, SQL, and Excel. And what roles are we going to be filtered from? Well, inside of our repo, we can go into the exercise itself, and I'm providing this list of dictionaries called job roles. I'm gonna go ahead and Command C or copy this. And then pasting it into here, we can see that, yes, it is a list of dictionaries for different job roles where we have a key of the job title itself, and then we have a key of the skills and then a list of skills. So in the case of this first one of this data analyst role with the skills requiring of Python, SQL, and Excel, we would want to match on this condition. Now, where it gets tricky is we also need to match where roles may have additional skills. So in this case of this business analyst role, we have those skills of Python, SQL, and also Excel, but they also include Tableau and Power BI. And this is pretty representative of what I would advise to you if you're applying for jobs. If you have the skills, but not necessarily all of them, I would still apply for a role. Anyway, let's actually get into coding this. So for this, the thought process is we're going to loop through this list of job roles, and then secondly, verify this my skills list is in fact inside of this skills key of the dictionary. We'll also need to set a condition for whether a job is qualified or not, but we'll get there in a second. So the first thing I'm gonna do is just going to get into cycling in a loop through those job roles and printing out what was displaying, assuming we assigned a variable of job for each job role. We get displayed below all of those different dictionaries inside that list. And so we did that first part, and now we need to get into accessing the skills inside of these dictionaries. And so when we have this job variable, it's basically a dictionary that's getting printed out. So we can use that key of skills, and I could print out that list of skills right here. So you may be thinking we can loop through this job skills and then check if my skills is inside each one of these things, but we run into errors with this, as we wouldn't match on this business intelligence analyst because we'd meet a condition of when we hit this Tableau or Power BI, we wouldn't meet it. Anyway, what we want to do is we want to cycle now through my skills. So we'll define for skill in my skills. And then just checking on this as we go, I'm going to actually print out that skill right above that job skills dictionary. So now we are going to have everything we need. We'll check SQL, Excel, Python, SQL, Excel, Python, and we'll go through and check each of these lists as we go through it. So we'll now establish a conditional statement to see if it's inside of this list by saying if skill in that job skills. I'm going to indent this over. And I'm going to continue to print that skill and job skills for demonstration purposes. We'll delete in a little bit. But we can see it's only printed out Python, SQL, Excel whenever the lists themselves contain those values from the my skill list. But we're checking each item iteratively. So in this case, these top 3 things printed are just for the data analyst itself. So we need to basically establish a Boolean condition in order to keep track of a certain job for when it may not have all the skills necessary. So since this is specific to the job itself, I'm going to define this new variable of qualified up here and set it equal to true. So whenever I get to a new job, that condition will get reset back to true, basically innocent until proven guilty. And then once it's proven guilty or not true, then we'll basically end the loop. So we need something that will change it to where we'll get that qualified equals to false. But if I was to run this as is with also having qualified out, we basically see it saying false even though Python's in there. So we need to do basically an opposite, right? So if skill not in job skills, now running this, we can actually see that skill SQL is not in this list. And continue on, Excel is not in this list. So we've met this condition. And as you can see from this first posting right here, I can tell because the lists are the same with Python, R, machine learning, and deep learning. We don't need to necessarily go through both SQL and then move on to Excel then. We established that we haven't met these conditions, so we need to just break at that point. Running this now, there should be there's no more repetitive lists inside of here. And at this point, we don't need to be printing this anymore, so I can go ahead and remove this. So now we want to see what jobs we're actually qualified for. So I can say if qualified, i.e. we're still true, print out that job. Running Control Enter, we have the data analyst and then also the business intelligence analyst. Now this job roles was provided to me in a list, the my skills was provided to me in a list. So I want to get this back into a list. Anytime I need to create a list, I'm going to have to define a new empty list. In this case, I'll define qualified roles equal to this blank list where it's just these empty square brackets. And I can prove this list by running the type function on those square brackets. We can see that it is a list, it's just empty. Anyway, you have to initialize the list if we want to actually run methods on it. Specifically, instead of printing out the jobs, we want to take that qualified roles list and we want to append on that job and specifically the role from it. Running Control Enter, and then actually I should have actually printed out this below. So now looking at qualified roles, we get the data analyst and business intelligence analyst. Now technically you can write this all more succinctly if instead, this is basically I rewrit this entire thing up here, down below. You could write it more succinctly if you use this all function, which is using a sort of list comprehension inside of it to compare the skills and make sure that the my skills list is inside of the job skills. But we're not going to go into more detail on this all function. Instead, you can do this for homework and evaluate how you could have implemented this all function instead. Which now, looking at this function, if I remove these dang comments out of the way, we can see with how short it is, it's a good candidate for list comprehension. This is what it is in list comprehension form, which is not actually too bad, and you could technically do this, although I find myself, even as an experienced programmer, having issues just writing out list comprehensions quickly and easily. I like to start with functions themselves, and then if I need to condense them down, I can condense them down later. Basically, you're not right or wrong on either one you want to use. If it's easier to go through and writing it out entirely like this, I'm perfectly fine with you doing that. So with that, let's actually jump back into that Python standard library. We only have about 5 more sections that we have to cover for this standard library before we start moving to other libraries like Pandas and Matplotlib, where we actually are going to be working with the data set. All right, with that, see you in the next one. Now I'm all for automation. Just watch this. Hey Google, turn blue lights on. And I try to automate anything that I can in my life to make it easier. And that's exactly what functions do inside of Python. To basically streamline our lines of code and make it easier for us to execute things with less lines of code. And we've previously seen the use case for functions working through these problems. Let's say, for example, we wanted to see the length of these skills right here. All we have to use is that len function and pass into it skill list. Running Shift Enter, we can see it has 3 items in it. Imagine if every time I wanted to get the length of something like a dictionary or list, I had to call out this formula right here of these 3 lines of code, and then even go as far as to print that count of what's going on there to see that count is 3. And so I love functions, and there's 5 different types that we're going to be covering. We've already covered, and then some that we're going to be covering up in the next few lessons. So in this section, we're going to dive in deeper to understanding what built-in functions are available to you, and then also how to build your own functions. In the following lessons, we're going to be jumping into Lambda functions or anonymous functions, and then standard library functions. And then finally, my favorite, using third-party libraries like Pandas, NumPy, Matplotlib. Now, for any hardcore programmers watching this, there are additional functions out there like generator functions, async functions, and recursive functions, but that's just out of the scope of data analytics in general, so we're not going to focus on those. We're going to focus on these. So we've seen a lot of built-in functions already. So we've seen functions like print, that basically print out our things, type, which defines what is the data type of a certain variable, length, and then even the range function where we went and did something from like 0 to 5 and used that. Oh, my favorite one, help. But are we only limited to just these? Like, which ones are actually available? Well, if you wanted to, you could just execute this line of code that we're not going to dive deep into it, but it basically goes through, looks into what's available in the current directory in regards to built-in functions, and then returns it in a list using list comprehension. Anyway, we can look inside of here and we can see that it has things that we've already used before, like len and print. But an even better way is probably just go to the Python documentation for built-in functions, and they provide this convenient little chart here on all the different functions, along with all the documentation explaining each of those. Now, we're not going to dive a lot deeper into built-in functions, but I do want to focus on some math-based built-in functions that I use from time to time that you definitely should be aware of. So let's say I had a list of data salaries and I wanted to find different characteristics about this list. If I want to find the minimum, all I'm going to use is the min function and then supply it that data salaries list in order to see it. Here I find that the lowest is 85,000. Conversely, I can also use something like max to find the max value, or even sum to add up all the different values within this list and then display it down below. And my favorite is, if I ever need something organized better, I can use the sorted function in order to sort these values into numerical order. So now let's shift focus and actually get into building our own, if you will, user-defined functions in order to do something maybe we need to do. But we're going to start simple first. So if you remember early in our sections, we came up with a formula in order to calculate what the total salary is using the base salary and then the bonus rate. And we figured out it was this formula to get the total salary. Well, imagine if we have a bunch of different base salaries and a bunch of different rates that we need to feed into this. Well, this is a perfect example for a function. So let's start defining this function. Anytime you start a function, you need to start it with the keyword def. And this stands for define. And then from there, we're going to now name the function. And you can create whatever you want. We're going to call this one calculate salary. And then it's very important here, you have to put parentheses and then a colon. Now I want to make sure I executed this right. So similar to our loops and also conditional statements, I can just put in this variable, or I can put in this keyword of pass and then running it, make sure that it executes properly. So it's working just fine. We need to go further though now and define it. So for right now, just for demonstration purposes, I'm going to paste those variables inside of here just to simplify this. So we have this base salary inside our function, and we have the bonus rate. And we can tell it's inside the function because they're indented in. And then from there, I'm going to calculate that total salary and set it equal to our previous value of the base salary times 1 plus the bonus rate. I'm going to remove this pass because we don't need any more because we have contents in there now. Running this again to make sure that this actually works. We got no errors, good. So now we've defined this function. Let's actually call it and see what we get back from it. So just calling calculate salary and then adding those parentheses, because the parentheses after it is a function call. I'm going to run it, shift enter, and I didn't get anything. Why didn't I get anything? Well, I didn't return anything in the function itself. I returned none basically. Anyway, I need to specify what I want to return back from this. So I'll specify that here and say for return, I want to provide total salary. Running shift enter here and then shift enter down here. Now, whenever I run this function, we're getting output the total salary because that's what it returned. So now you're probably like, Luke, but this doesn't do me any good. I have to go into this function now to input those variables. Okay, let's make this function actually usable by providing it arguments to then provide us values. So I'm going to remove those variables from inside of here. And now I'm going to define those arguments inside of the parentheses right here. So I'm going to define that we're going to pass it base salary and also bonus rate. So now running this, I can see that the function works fine. Now let's run this calculate salary again and see what we're going to get. We're going to get an error. And it says to us, calculate salary is missing 2 required positional arguments, base salary and bonus rate. So we have to provide that now because the function is built like this, we have to provide that base salary argument and bonus rate. So I'm going to just put in base salary and bonus rate right here. And now running it, it provides it in and then provides us the value. Now, one technical note, these variable names that I'm using right here we're using the same ones, and that's actually not even necessary. Say I want to just actually plug in values, so 150,000 and say a rate of 0.25 as the bonus rate. I can do that, it's still going to run it. Or if I wanted to, I can even change this one to salary 1, and then this one to rate 1, running this up here, and now defining salary 1 inside of here and rate 1 below it, running it, we're going to get that 110,000. Now I'm going to shift things around a little bit before we continue, just to make sure that we have it all organized. And so now I have the function up above and then the actual function that we're going to execute right below it, and it's executing. I just wanted to make sure you understood that you don't need to have the variables above the function itself. That's not necessary at all, but the function does have to be defined before you actually call it. Now, building on this example further, what happens if we routinely have the same bonus rate and we don't want to necessarily slow down our coding and have to put in that salary rate or that bonus rate every single time? Well, we can add an optional argument. So I want to define that the typical bonus rate is 10%. You may be tempted to want to put something right inside of here to actually specify that we're only going to be using a 0.1 of the bonus rate and then running it. And then if we wanted to remove this from it, well, if we did this, we're going to get a positional error, argument error, because we didn't include that bonus rate. But here's what we do. Instead, we'll define what that bonus rate is right next to the argument itself. We'll set an equal sign and then the value we want to assign to it, should it be optional or not. So in this case, I'm specifying it to be 0.1. I'm going to run this now. Now below this, we're still calling calculate salary and we're only providing one argument of salary 1. Whenever I run this, we get the value. And no matter what I put in there, it's going to work. And in a case where maybe the rate is different, let's say at 0.5%, I want to definitely find that job where it's 0.5%. I could put back in that salary 1 and then that rate 1. And then whenever I run this, we can see 150,000, so 50% of that. It now takes in this rate 1 whenever we provide it, overrides that optional argument as 0.1. So that's the basics on built-in functions, which you're obviously familiar with, but also user-defined functions, which we have some practice problems on for you to dive deeper into and test your skills with it. We'll be moving up in the next few sections on that Lambda, standard library functions, and third-party library functions. So I'm looking forward to that. With that, I'll see you in the next one. So Lambda functions, also known as anonymous functions, are very similar in how they operate compared to those user-defined functions, and also built-in functions, and actually calculating or doing some sort of operation. But before diving into this, I'm going to be very clear. So Lambda functions are more of an advanced functionality. If you're not finding yourself using Lambda functions and instead just using regular user-defined functions, there's nothing wrong with that. Lambda functions are just a great way to flex on your coworkers. So here we are on the type of functions cover, which is halfway through with those Lambda functions. I promise you it gets only easier from here after this one. Lambda functions are written by starting with Lambda. Then from there, you provided an argument. In this case, we're just going to name it X for the time being. And it can be any number of arguments. We're just going to do one for right now. Then from there, you do a colon to then go about providing what we want or what formula we want to be conducting on that X argument. In this case, we're just going to keep it simple right now. We'll say X and we want to multiply X times 2. Pressing Shift Enter, we see that it's just a function here, but we actually need to use it and actually see how it works. So I'll call this Lambda function mul2 and set it equal that. Really ingenious right there. Run this again. And now because Python has functions as first class objects, so I can assign this function to a variable name, I can then use it. So I can call mul2, and then in parentheses to call this Lambda function, I can provide it an argument, we'll say 3, running shift enter, we get returned 6 back. Now this is 2 lines of code right here. Technically, the point of a Lambda function is be able to write something within 1 line. So I could actually take the function, wrap it into parentheses to wrap it up, and then put in parentheses on the outside of it to start the function call of it, and provide the argument of 3, running shift enter, we get it. Now, if I wanted to provide multiple arguments to this function, I could separate it with a comma. So in this case, we're going to pass x and y to it. And then we'll say x times 2 plus y. And then in the parentheses, we need to specify these 2. So I'll add, well, let's do 4. Running shift enter, we get this, which 3 times 2 is 6 plus 4 is 10. So you're probably like, Luke, how does this actually apply in the real world? Well, let's go back to that previous example that we did in our function section, where we were using this calculate salary function in order to calculate total salary, which is based on base salary times 1 plus the bonus rate. And now let's say with this function, we have a list of salary values we want to pass into it. And in our case, we're going to just assume that all the bonus rates are at, in fact, that 0.1% for all of these to go through it. So how could we, with what we know right now, actually implement it without using lambdas? Well, we can use list comprehension. So I'm going to define this variable of total salary list. I'm going to set it equal to the start of our list comprehension. And we'll define a variable that we're going to be cycling through each of these salaries in the salary list. So I'm going to name it the name salary. And we'll loop through that. So for salary in salary list. Now, you know, I like to iterate through things and make sure my code's working just fine. So I'm just going to print out what I have underneath here. Right now, we're not doing anything, right? We're just reprinting out this list, cycling through it and then reprinting it out. Okay, so all the values that we see above are still in there. Okay, now for list comprehension, right, I can, in that first argument, provide a function to apply to it. So in this case, we can do this calculate salary to this. So I can type in calculate salary, put this into here. Now, whenever I run this, it's going to pass each of those arguments into calculate salary and then feed it out. Bam! And then we have all of those through using list iteration. But right now, we're at just looking at only these lines of code. We're at like 4 lines of code. I'm going to make it even shorter. And technically, running this again to just make sure it works, we can shorten this down, remove that total salary. So the function itself is only about 1 line of code. And anytime we get into writing a function with 1 line of code, there's a use case for Lambda functions. So we'll go ahead and comment this out. So we're going to be altering this function right here and basically replacing it with a Lambda function. Remember, anytime we do a Lambda function itself, we need to define it inside of parentheses. And then I'll go Lambda, the variable we're going to pass into it. So in this case, we'll just say X, and then we'll pass back out X. Now for this Lambda function itself, we need to pass in something to it. So we're going to also put a parentheses outside of it for basically calling the arguments, and we'll pass inside of it salary. So let's go ahead and now run this. And having a little typo issue. Lambda was spelled wrong. Need to actually do that right. Anyway, this is providing basically our list back in this case. And so we can do now an expression on it to actually alter it. So I can do times 1.1. And then doing it this way, pressing play, we have those corrected values back. This example was shown in order to display that you can write with Lambda functions 1 single line of code and write things more succinctly. However, this isn't necessarily completely succinct. Technically, we could just put salary and then times it times 1.1, and we're going to get the same results. And that's what you actually should do in this case. But I wanted to show for demonstration purposes how you could actually use Lambda inside of list comprehension. So let's move on to a slightly more complex example of how we can use Lambda functions in order to clean up or filter our data. So here I have a dictionary of some jobs that are available. In it, I have a job title, the different job skills, and then also this final value here on whether it's remote or not. It's a Boolean value of true or false. If you don't want to type out all those different values I have on the screen right now and you want to follow along, go to your favorite chatbot, type in this prompt of generate a dictionary titled job data. It's a collection of data science job posting. The keys and data types for values for the dictionary are job title string, job skills as a list, and remote Boolean. Okay, and it only provides me one value, so I need to specify, provide, 5 values. From there, you can just copy the code and put it into your notebook. Anyway, we need to make sure that it runs and it's formatted properly so we can continue on. So because we want to filter this data, we're going to use a built-in function for this, and that is the filter function. So let's actually inspect it using my favorite function, help, and doing this for filter. So inside the help on class filter in module built in. For the function itself, it's defined up at the top. Inside of filter itself, you pass a function. So in our case, we're going to be passing our Lambda function to this. And then from there, you pass an iterable, which we have our iterable, our list, our job data to be the iterable. And in it, it returns an iterator yielding those items of iterable for which function items is true. That's just fancy talk for saying it's going to use the function, filter out our values, and provide it back the filtered values. So let's show what this does very simply. So I'm going to define that filter function. And then first we're going to put the function that we need to do. And then I'm going to define the Lambda function right here. And we're going to be iterating through the jobs itself. So I'm just going to specify and make up this variable called jobs. And I want to keep this simple right now. I just want to find those where the job of being remote is true. Remember, this function returns an iterator on those items of iterable for which the function is true. So I'm just going to put in there job and specify also remote because we want to look at the job remote column. From there, the next argument of this is the iterable, which in this case is jobs data. Running shift enter, we get a syntax error. And I think it's because we need to actually wrap this all within a parentheses to basically make it a function in itself. And I'm going to run it again. All right, oh my goodness. This is why, this is a silly error. I just realized what I did. I misspelled Lambda. I should have just looked at the highlighting right there. And I don't need the parentheses around it. Actually running this, we get a filter object returned. And so we need to convert this to something we can actually see. So I'm going to convert this back into a list and we'll print that out, running that shift enter. We can see we get back only the jobs where remote is true. And it looks like 3 of them are true. That's true. But remember, we want to find not only where the remote jobs are true, but also where the job skills contains Python. So I need to modify what we're doing, the operation that we're doing in here. So we can use that AND operator to make sure that both of these conditions are going to be true in order to satisfy this filter function. And we want to verify that Python, oops, we need to type it like it is in the list. Python is in the job skills column. Okay, so now we have it in the job skills column. Now let's run this. Bam! Okay, so now we have the 2 in here and we can see the job skill is Python in both of these and it's remote in both. So that's really the 2 major ways that I've seen Lambda functions used, whether it's inside of something like list comprehension or built-in functions like filter or even apply and map. Now don't get overwhelmed by this, especially if you're not getting your head to wrap around these Lambda functions. I frequently will start by just writing out a normal, plain, user-defined function. And then once I realize that it can be applied to a Lambda function, I'll eventually shift it to that. So there's nothing wrong with still using user-defined functions, but you look hella cool if you do it this way. All right, with that, I'll see you in the next one. So we've been talking a lot about functions lately. And if you remember, we had built that function that calculates salary by looking at what the base salary is and multiplying it times some sort of rate. Well, imagine now if I shift on to maybe a new project or a new Python file, and I want to do that same calculation again. Do I need to rewrite that entire function, or could I use something like modules? So jumping back into my Jupyter notebook, we're basically continuing on with our discussion on functions, but we're moving more in towards, we're not going to be building anymore in functions, Instead, we're going to be talking about how we can actually get other functions or even classes. And this is done through things like modules, which we'll talk about in this one. And then in the next video, we're going to talk about how to get it through libraries, which a library is just a collection of modules. Anyway, enough of that. Let's actually get into building our own module. And we're going to do a simple example first. So this Jupyter Notebook has access to an environment. Specifically, if I come over here to this files icon, I have access to the files inside of here. Inside the sample data folder, they have basically other datas in here that we're actually going to extract and actually look at how we can connect to it ourselves. Well, let's not get ahead of ourselves. Okay, so we have access to this environment right here. Specifically, we can access, if we have something like a Python file or a module, we could access it from our Jupyter Notebook. Let's see how it's done. So first thing I'm gonna do is going to right click in this area and I'm gonna say new file. I'm just gonna name this for simplicity, my_module. Modules are typically lowercase. And then I'm gonna end this with .py. That makes that a Python file. So this is my module. I'm gonna double click on it and it's gonna open over here in the right-hand side. And I'm gonna close out of this so we have more space. So I'm just gonna put something in here. Specifically, we're gonna define a skill list inside of here. And this is a list with Python, SQL, and Excel. All right, now it has this asterisk up at the top left-hand corner. That means it wasn't saved, but now it auto-saved, so I don't have to press it. But if it doesn't save, all you gotta do is press Command S and it saves. Now, how can I access this variable or list inside of my module? Well, we're gonna use the keyword of import and then the name of the module. So let's just run it to make sure that it actually works correctly. Bam, it works just fine. Okay. Scrolling on down to the next line. All right, so now we want to I want to see this skill list here. I want to see it inside of my Jupyter Notebook. So because I've imported my module now, I'm going to write my module again. And then I'm going to use, similar to what we saw before with methods, I'm going to use the dot notation in order to define what I want to actually import in. And Google Colab automatically has hints towards what you want to bring in, and it already identifies that skill list is available. So now if I run this, pressing Shift Enter, we're going to get that list right below it inside of here. Now, listing variables inside of a module is honestly not really a common use case. A more common use case is actually defining a function inside of here. So let's define a function that whenever we provide it the argument of a skill name, it provides back that that skill is my favorite skill, which will be in the form of a string. So I'll start by defining a function and I'm going to call this skill. Inside of here, I'm going to put that the variable that I want to define is skill name. For what I want it to return, I'm going to use an F string for this. And I'm going to define inside of curly brackets, this skill name is my favorite skill. Exclamation point to make sure that we're making a point here. So we have our function defined and we also have our variable in here. So saving this, pressing Command S, so all changes are saved. So let's actually try to call this. We're going to use my module. And then similarly, we're going to use that dot notation. And in this, we're just going to define the function that we want to call, and that is skill. Right now, I want you to watch something. Only skill list is popping up. So I'm going to do skill, and remember, we need to provide it with an argument name. So of course, you know what I'm going to put in here? I'm going to put Python. Running this by pressing Shift Enter, we're going to get this error message right here. Attribute error, my module has no attribute skill. Now we saved this file, right, and updated it. But the problem is the updated contents, whenever we imported it in, are not updated inside of this Jupyter Notebook for this new function that we actually just defined. Now the problem is inside of this Jupyter Notebook, it's being really lazy. It already loaded in my module previously before we defined this skill. And so even though I rerun this to import my module, it actually doesn't go through and recollect the contents of this. So we basically need to start this whole session over again. I'm gonna come up here in runtime and select restart session and run all. And it's gonna say restart and run all. Yep, that's what I wanna do. I'm gonna move this over so we can see better and delete this one down here. Okay, so now it is actually working inside of here. So don't be alarmed if you're experiencing the same errors as me. Sometimes, like any electronic where you gotta flip the on off switch, you gotta do the same thing with your Jupyter Notebook. Just flip it on and off. So let's get into a practical example of how I'd actually set this up for a real case scenario where I need to use this. Once again, I'm gonna create this module inside of my files by creating a new file. I'm gonna name it something appropriate to what it actually does. I'm gonna be doing a lot of different functions for maybe analyzing job data. So I'm gonna call this job analyzer. And then of course, end it with .py. So I'm gonna take this function that I used previously by Command C or copying it and then pasting it into the job analyzer.py file. And then Command S to save it. I'm gonna delete that previous function because we don't need it anymore. And now we're going to import it in. So we'll import job analyzer. And then we're gonna define it here. So we'll use job analyzer dot calculate salary. Remember, we only need that base salary in there, so I'm just gonna put that in for right now. And then running this bad boy, we get what we expect of 110,000. Now, import isn't the only statement we can use in here. This is cumbersome to write out this module along with the function name after it. If we're only using maybe one or two functions, there's an easier way to do this. Instead of only using that import keyword, we can use another keyword, and that's specifically from. So we'll use from job analyzer, import calculate salary. Okay, so we're going to be importing the function of calculate salary from job analyzer. Because we've imported it in like this, we no longer need to use this dot notation. And whenever we run this, we get the final results that we expect. Now, let's say we have multiple functions inside of our job analyzer module. And I just added this other one of calculate bonus. All it does is takes a total salary and base salary. And then from there, it returns what the bonus rate should be by performing this formula right here. Anyway, let's say we want to import both of these in. Well, instead of writing calculate salary, and then also we could do something like put a comma and put calculate bonus, which would work just fine, which I'm going to show real quick. So I define it as the function of calculate bonus, giving it a value of 110,000 and then 100,000 for the base. Running this, it says cannot import. This is the same issue that we were focusing before. And so what I'll just do is I'll say restart session and run all. So now I'm getting that calculate bonus rate down below it. Anyway, this is sort of cumbersome sometimes, but if we want to list out every single function we want to import. If there's not a lot of functions inside of the module itself, we can do something and use this star annotation. And this says, hey, import all the different functions that you have in there. Just for demonstration purposes, make sure that we restart session and run all whenever I do this to make sure that we're running clean with this. And bam, we just ran it again. And we're able to, with this now, actually import in all the different ones available. So what happens now if I want to give this Python file for somebody else to use as a module as well? And then they may have questions in understanding how to use this. Remember before we could use that help function in order to investigate things like strings, lists, and dicts. Can we do it here? Well, we can. So I can put in something like the function I want to investigate, calculate salary, and from there run shift enter. Now, similar to before, it says help on function, calculate salary, and module job analyzer, and it has what the function is along with the arguments, but then nothing underneath it. If you recall from our strings and lists whenever we investigate, they actually had a description underneath it. Well, a neat functionality of Python is I can provide a docstring inside of the function itself to define what the function does. And all a docstring is a multi-line comment. So we use those 3 double quotes at the beginning and the end, and then you can write multiple lines through this. In here I have that it's calculate the total salary based on the base salary and bonus rate. I'm gonna go ahead and Command S to make sure that this is saved. And now I'm gonna do that same thing of that runtime, restart session, and run all. Moving this over so we can actually see a little bit better. So now we have our help function. We have what the function is that we're asking about. And also we have the definition of that function to help tell you what's going on here. Now, sometimes whenever you're reading these documentation, you'll also see these extra lines included in the doc string. And that's args or arguments, and it gives information about, in this case, base salary and the bonus rate, saying what the type of data type it is, and then what it is. And then finally returns what's going on down here. It's returning a float that is the total salary. And I can go ahead and also include this for this other one as well. It'd be nice to have. Command S saving this. And then just to actually see to make sure that it's actually working just fine, I'm gonna restart and run the whole session. It's popping up, I'm gonna close this out. And now we have what looks like a legit module that we've imported a function from where we can actually run help on it and it understands what we need to provide to it. Now, shifting gears a little bit, Python itself has access inside of the Python standard library certain modules that are available right now for you to use. You just have to import them in to, in our case, into our Jupyter Notebook. And so in their documentation, they go into a lot of different modules that they have, such as numeric and mathematical modules, functional programming modules, and even a host of others. We're not going to go into all of them just yet. We'll go more in the next section. I just want you to focus on this for the time being, that in the math ones, they have things like math, random, statistics. These are common ones we have access to right now. If I go ahead and click on statistics, it gives me an overview of everything that is available to use with this module of statistics. I'm more of a nerd, so I actually want to check out what the source code is. Now we're inside of GitHub in the repository for Python. So remember before, CPython is the version of Python that we're using. And check this out. At the very beginning, they have a doc string talking about all the different functions that are available inside of this module of statistics. Let's actually check out this mean function, which description is arithmetic mean average of the data. Scrolling down to line 468, we finally get to the mean function. It takes one argument, data. They have a doc string here that basically goes over how to use it. And then for the code, it looks like it's about 4 lines of code to actually generate what the mean is. And it actually takes use of other different functions inside of this package in order to calculate the mean. We're not going to dive into this code here. I just wanted to show you the source document for it and how we're actually going to now use it inside our Jupyter Notebook. So back inside of our Jupyter Notebook, let's say we have a list of salaries, and this was just randomly generated. Feel free, if you're following along, to just make up 5 different numbers or however many numbers you want to make up and put it into something like a list, set, or tuple. So I'm going to go ahead and run this, and then from there, we're going to get into using this. So I'm going to start by importing in statistics. And remember, we want to use the mean function. So I'll do statistics, that mean, and then inside of that, we provide the data, which we can have this pop up here now, and it actually shows us some examples of how we can use this. But I'm going to just put in salary list. Running this, pressing Shift Enter, we get the mean. Now what happens now if I want to use something like median and also mode? Well, that's going to get cumbersome writing this all out, so let's actually import them in separately. So I've modified that import to say from statistics import mean, mode, and median. Now we could replace this all with that asterisk and then import them all, but I'm not going to recommend this. Whenever you get into bigger modules, even this one, I mean, it's relatively small, but it's getting big. We don't want to necessarily import them all, because if we in the future define some sort of variable or function that has the same name as this, we're going to run into issues. So in order to remove any of those issues and to keep track of what functions we actually have imported into the environment, I recommend just listing them out. So I've gone through and defined all of our different functions. I want to run all these cells, so I'm just going to come up here and click Run All. And now we can see we have the mean, mode, and median. For your homework for this, I want you diving into what modules are available to you inside of the Python standard library. Now they have a whole host of ones, which you can go through and actually just find out where it is by using Command F and then typing in something like module. But mainly I'm going to recommend that you focus your efforts underneath these numeric and mathematical modules, as data analysis is basically a bunch of math. All right, with that, you have some practice problems now to go through in order to create your own modules and also start diving in deeper into a lot of these modules that are available for you. All right, with that, see you in the next one. So like any data source, The data that we're using for this project requires some cleanup. So we're going to be using modules from the Python standard library in order to clean this data up. Let me show you what I mean. So here we are in our data set, which is located on Hugging Face, and it has the different columns with it, which has the column name, and then also the data type of that column, and then the values underneath it. It's got tons of them. Anyway, let's pay attention to the data type. So if we look at a lot of these, we can see there's strings, Boolean, and even over here for the salary data, it's a float. Now we run into a problem with two of the columns. First is this job posted date. If we look down here, we can see that it's actually a date and a time. And Python has a date time object. However, it's not recognizing this, it's calling it a string. Additionally, if we look at the skills column, we can see that it is a list of skills. And this one also is categorized as a string. Now the reason for this is pretty simple. All this data is located in a file like this inside of a CSV, or comma separated values. We can see this by these commas that are separating it. Anyway, diving into it further, looking specifically at those job skills, we can see that these lists, like this top one right here, it has parentheses around the list itself. So it's getting cast as a string in this case. So let's actually get to work in this exercise of cleaning up both that job skills column to convert it into a list so we can actually manipulate it, and also that job date column to make sure it's a date time object to make it easier to manipulate. Now this fake data that we're using has 3 different keys and then values. Specifically it has the job title, the job skills like we're familiar with, and now this of the job date. Now if you don't want to type out all those different values, I don't recommend you do. Come into something like ChatGPT, provide the prompt of generate more fake data for this list, and I would just provide it an example of what it needs to provide for that first list or that first job entry inside that dictionary. The key thing for this fake data is to make sure that whenever you provided an example, you have the job skills, this list wrapped in double quotes, and then for the job data, it can be double quotes or single quotes for that date value. All right, so let's get to cleaning this up. And we're gonna start with the date time, because frankly, it's a little bit easier to deal with. For both of these, we're gonna be using the Python standard library. And specifically for date time, we're gonna be using date time. Now inside the documentation of date time, I can see in the documentation on the left that they have a bunch of different available types. They have date only, date time, time delta, and then time zone information. Whether my data is dates only or dates and times, I find myself gravitating towards this date time object. And inside of this class of datetime.datetime, it has different methods available for it. Like in this case, we can use something like finding out what the date and time is now. So let's just try it out. For this, I'm going to import in datetime. It's part of Python standard library, so it's one of the modules. So I can just go from datetime, import datetime. Now this may be sort of confusing on why I'm listing it twice, but if you recall back, we could also be importing datetime, importing in date, or in something like just time. We're gonna import the date time object. Running Shift Enter, we have it imported in. So if I wanted to run the .now method on datetime, I would just define datetime and then now. Running Shift Enter, it provides me back this datetime object, which I know how it's formatted as, which is basically it has the year, the month, the day, the hour, the minute, seconds, and even milliseconds. So you can see why I'm filming this right now. So what are we wanting to do with this date? We want to convert it to the correct object that it needs to be. So let's actually inspect what's actually coming out by accessing one of these elements inside of our list of dictionaries of these different jobs. So I'm gonna first start by defining the variable of data science jobs, and I just wanna access the first element. So I'm gonna type in 0 inside these square brackets right here, run Shift Enter, and we get the first one. Now I wanna access the job date of this. So once again, I'm gonna open up those square brackets and just type in here, job date. Running it, we have it right here. So just to make sure that we're on the same page, I'm gonna run the type function on this because I wanna see and verify what is the type of this. And running that, we can see it is a string. We wanna get it into a date time. So back inside the documentation, I can see that underneath that date time object, we have the method of strp time, which is string parse time. We have a string, we want to parse it to time. For this, it takes two arguments, the date string or the string itself, and then how we want to format it. And then it returns a date time corresponding to that date time string. So I think we understand what we're using for the date time string, but how do we format or what do we put in this format? So if we go back all the way up to the top of the documentations, they have this link up here for skip to the format codes. And it provides this table where it has the associated code, the meaning, and then an example. First, we're going to want to get the year out of this. So we're going to use this percent and then capital Y. Next, we're going to want the month as a 0 padded decimal number, basically 01, 02, using %m. And then finally, we want the day of the month, basically %d. So let's do this. I'm going to set this up as test date as a variable of this. Remove this parentheses, run Shift Enter. And now let's actually try it out. So I'm going to do datetime.str and strp time. Then inside there, we need two things. We need the date string and then the format. Note that the format is a string as well. So I'll put in this one first, test date. And then for this, I'm going to define it. Remember, we need the year, which was %y, capital Y. Then from there, %m for the month, using a lowercase m. And then also %d. And I can go ahead and also establish that we're going to be using these tacks or dashes in between each one of those lines. All right, let's go ahead and run this and see what we get. And we get back this date time object specifying the month, year, and day. And you're probably like, Luke, this isn't in the format that we specified. Hold up a second. If I use the print statement with this and wrap it in parentheses, when I go to do this, it prints out the month and date and year in that format I wanted, along with, since it's the date time object, the hour and minutes and seconds. There's nothing of value right here, so it's just going to append it right to the side. If I didn't want this value here, which I don't care about right now, if I didn't want that value there, I would instead import in here the date object, and it has a very similar method for how you can actually convert this to the date you need. But like I said, I don't care about this addition of time. We're going to leave it date time. So what happens now if I want to go through and clean up all these date times? Because right here, we just did our test case of only one. How would I actually do this? Well, very simply, we're going to be using a for loop. First, I define for job in data science jobs and then a colon. And what I want to do for this portion now is basically just replace the values inside of the job date with date time objects vice these string objects. I don't need to keep these strings at all. So I specify job and then the column I care about, which is job date, as that's the one I want to replace. And I'm going to set it equal to basically exactly what we did up here. So I'm just going to take that real quick, place it into here. And instead of using that test date, I want to use the job and job date. So basically we're looping through every one of those lines on the list and we're going through and converting them one by one into the correct format and saving it into its previous location. So running this, it ran just fine. Let's actually inspect it. So printing it out to inspect it, we can now see that inside of here are date time objects. So task number one is complete. We've cleaned up those date time objects. Now we need to clean up these skills and convert them into a list. Now for this, we can't use date time for this because obviously it's not a date time to clean up. So back inside the Python standard library, we need something to actually convert this. Well, under Python language services, we're going to use AST, which stands for Abstract Syntax Trees. Now, I'll be honest, I had to use ChatGPT in order to find this module. This is not something I commonly use, and this is not commonly an issue you'll probably run into when converting strings into list. However, the datetime one is very common, so you should definitely know that one to memory. Anyway, the method that we care about is literal eval. And in it, it evaluates either an expression node or a string, so a string in our case, containing only a Python literal or container display, which lists our containers. And it also confirms down here a bunch of other different data types that you could feed into this if they were wrapped in quotes in order to convert it into what it actually needs to be. So we're going to be taking the same approach to loop through each of those values inside of that list or that contains our dictionaries of jobs and then perform this function on each one of those values. So I'm actually just going to come up here and start typing underneath it. But before we even do that, we need to actually import in that module of AST. So for each of those jobs in there, I'm going to define job and then job skills because we want to replace what's currently in there. So we're going to set that as the variable. We're going to do ast.literalEval. And then from there, we need to place the string inside of there. So we basically need to replace these contents that we're going to be doing on each of these operations. So let's go ahead and run this. And I'm getting this error because if we look at it, it's pointing at the line above it on job date. I tried to combine this. But anyway, what it's saying is the string parsed to time argument. One must be a string, not datetime object. We converted it already. If we look at that, if we look at data science jobs, it's already datetime. Anyway, what we need to do is we basically have to just run this whole script again. So I'm going to come up here to runtime and I'll say run all. Okay, so now we cleared that error because basically we passed back in data science jobs with our dates in that string and then also our list of skills in a string. It went through this loop. Now actually, let's inspect it. Putting it right below. We can see now we have the job skills in a list. It's no longer inside the quotes, and we have our date time objects. I'm not gonna lie, data cleaning is one of the most time-consuming aspects of my job as a data analyst. It can take up sometimes of 50 to 80% of the time just a project alone. So learning things like this is only gonna help you later. I promise you it's not for nothing. I think that's a double negative. So it means it's for something. All right, if you haven't done it already, it's your turn now to go through and actually perform these different operations, dig into that datetime library, and then also feel free to check out that AST library. With that, I'll see you in the next one. So picking up where we left off with modules, we learned that we can build them ourselves and they're very useful at automating routine tasks by providing us some sort of function or method in order to write less code in order to conduct some sort of operation. With that, we learned we can build our own modules or go to something like the Python standard library and get modules from that. But there's a whole heck of a lot of libraries, even beyond the Python standard library, that are available to you. Let's jump into my notebook to do a quick example. You don't have to follow along. I just want to show how third-party libraries can help speed up your workflow. So let's say we want to start analyzing data, which we're going to be doing here very shortly, jump into that data set that keep on teasing. Anyway, we can go under Files in the left-hand pane, peek inside of Sample Data folder, and see that we have CSVs, which are basically a bunch of data. How do we actually access this with Python? This data set just has a list of columns and then a bunch of values underneath it. Don't worry too much about what's included in this data. So if I want to read the CSV, I'm going to first need to open it. I'm going to use the open function for this. In this, you specify the file path. So this is inside the sample data folder, and I want to look at the California housing test CSV. So running this, we have some sort of text IO wrapper object right here. So I'm going to assign this to a variable of file because it's a file. We've opened it. Now with this file, I want to do something to it. And specifically looking at the different methods that are available, I want to read it. So with this printed out, we can see that this basically has all the different contents we need, although it's in a very unorganized manner. Like I'm not gonna be able to use this. I need to actually put this into another data type, if you will, in order to then go through and actually look at the longitude column, latitude, housing, minimum age, something like that. So what I'm going to do is save this file.read to a variable called content. Also for good practice, I'm going to go ahead and just close this file out. So we're at 3 lines of code, not too bad. But now we need to put this into, like I said, a data type that we can use. In our case, I think the best one for this, I'm going to say is a dictionary, where if we look at these values here, I'm going to assign each one of these column names as a key, and then the values underneath it, I'm going to assign as the values, basically a list of all the values. So this is going to take a for loop to enumerate through all the different rows of that file that we've read into content. And then another loop inside of it to make sure that we assign each value inside of the column to its associated list. Once again, don't worry about too much about this code. I don't want you actually having to repeat it. I just want to show now we're at 12 lines of code. So let's go ahead and run this. And then printing out what we have, which is called data dict. We can see that we have it in a dictionary now. So if I wanted to access something like this total rooms key right here, We provided the key of total rooms, and then if I wanted to do something like sum up all these different values, I could run the sum function on this list right here. And I'm already running into errors because apparently some values inside of those lists aren't just integers. It looks like some of them are also strings. This data isn't completely clean, which I have to use something like this list comprehension that goes through each of the different values in the list and then basically cleans up some values in order to get it. And we finally are able to summon and get it. Anyway, this is a whole host of work, and that's what I'm trying to show by this. We're now up to like 13 lines of code, which honestly is completely ridiculous for doing something that's probably going to be routine. So instead, I can use a library like Pandas, which I just import it by saying import Pandas. Now, we haven't done this before, but typically when you import Pandas, you use an alias, which uses the as keyword, and we rename it as PD. This just makes it a lot shorter to access it. From there, I'm going to create a variable called contents to store what we want in there. And I'm going to say, hey, for PD, which is pandas, I want to read a CSV, which we did previously. And then from there, I'm going to put in the file path to that CSV, and I'm going to print it out below it. So bam, now we have all this data from the CSV, and it's not in a dictionary, it's in a data frame. We're going to get to that data type in a little bit, but it's all here. But because you know dictionaries, you actually probably know enough to manipulate and work with these data frames. So in case if we want to go and access this total bedrooms column, we can just specify it just like a dictionary. And I'm going to call it here total bedrooms. And so now we can see this has all the different values for the total bedrooms. And then if we want to sum it up, they actually have inside of the data frame object, the method of sum. And now that I'm inspecting it, compared to our last method, I'm actually finding out that this sum calculation that I built right here is not correct. I trust this pandas formula more for summing it up. So the point is this, we used 3 lines of code in order to expedite our data analysis that is pretty common compared to 13 lines of code. So that's where packages and libraries are so important. They're going to speed up your workflow. So where do you go in order to access these mythical packages and libraries that I keep talking about? Well, depending on how you're installing these packages, you may find it in one of 2 locations, or at least 2 common locations. The first one is this, 𝗕𝘃𝗃.org. So I can search for packages that I may need. In this case, let's actually look for that pandas one. We have a few different options pop up, and I know it's this one, pandas 2.2.2. And the first thing it provides is the code to actually install pandas. But hold up real quick. If we scroll down here, we can see an overview of what the package is, the table of contents, some of its features, and then where to get it. So there's 2 major locations you can get packages or libraries from. And that is 𝗕𝘃, which we're right here using this pip install pandas, and then Conda or Anaconda, and it tells you this command right here to use. Now, this is where we get into a very complicated concept in Python on managing your environment and all the different packages that are within your environment. We're not going to be doing that in the basics section. We're going to keep it really simple, but at the beginning of the advanced section, we'll be diving deeper into this. For now, all you need to know is that we're going to be using this pip command in order to install packages while we're working in Google Colab. That is their package manager of choice for that environment. Whenever we get into the advanced section, we're going to shift over to Conda and use that as a method to install packages. Anaconda is completely free, and it's actually the preferred use case for environments for those that work in things like data science and AI, as there's a lot of support behind it, and it's highly reliable. But we're really not going to talk much more about Anaconda until we get into the advanced section. So basically just forget about it for right now. So let's get into how we install and also check to see what packages are available within our environment inside of Google Colab. Remember, we're using pip for this. Now, pip is not a Python command. It's a bash or shell command, and you would enter it through your terminal. If you recall from earlier in this session, we talked about the terminal. And right now, you have to have Google Colab Pro in order to access that. And that's not necessarily needed for this. Instead, we can use that special shell command of ! and then from there provided that command that we saw previously for installing Pandas. Now, you saw that I ran this already, but I hadn't installed it into the environment, but I'm gonna just run it right now to show you. It provides back that requirement already satisfied for all these different files it needed to install for Pandas to be installed. So it was already met with this. So what packages are inside this environment? Well, use an exclamation point, I'll put out pip list, and this is gonna list all the different packages. In this environment here, Google Colab's really nice, and they provide a shit whack of libraries and packages that are available to you right now. Scrolling down, I can see, in fact, Pandas is installed, and specifically the version 2.0.3. But for funsies, let's actually install a package that isn't installed inside of Colab. I found this one right here. It's called 𝗕𝘃𝗃𝗃, and the package itself provides one-line jokes for programmers, jokes as a service. Up at the top, I can see I can pip install 𝗕𝘃𝗃, so I'm just going to copy that over. And then inside the notebook, pasting it after an exclamation point and installing it in. It goes through and you can see it's collecting 𝗕𝘃𝗃s, it's downloading the files it needs, and then basically saying it's successfully installed 𝗕𝘃𝗃s. Now, although I've installed 𝗕𝘃𝗃s into the environment, that doesn't mean that it is actually ready to use in this Python file. Once again, you have to actually import it in and define it. I'm not really sure how to use this, so I'm gonna run help function on 𝗕𝘃𝗃s. Looking at the documentation on this, it's pretty bad. There's not much on here that I know what to do with. So I'm just gonna go on a whim here and I'm gonna type in 𝗕𝘃𝗃s, and then I'm gonna type in a period. From there, I can see based on this, it has two methods of getJoke and getJokes. So let's just do getJoke, close parentheses, and it provides this. A QA engineer walks into a bar, runs into a bar, crawls into a bar, dances into a bar, tiptoes into a bar, rams a bar, jumps into a bar. Okay, that's pretty funny because you got to test all the different ways. A QA engineer has to test all the different methods of getting into a bar. All right. So what third-party libraries do you need to know for data nerds? Well, this course gets heavily into focusing on Pandas and Matplotlib, along with a brief intro to NumPy and Seaborn. Pandas is really popular in accessing tabular-like data and then using something like a data frame to analyze it. Matplotlib has a different use case in that we can then take some sort of data that we want to visualize and it can make it into basically any type of plot that we want to. Being the two most important libraries that we're going to spend the majority of our time for the remainder of this course in, I want you to start getting more familiar with these for your homework. One quick note before we leave on defining what a package and a library are. We've been using this I've been using this term throughout explaining all this, and sometimes I use these interchangeably. So starting with the basics, a module is a single Python file containing definitions and statements. We created modules 2 videos ago. A package is a collection of Python modules under a common namespace. A package can also contain sub-packages, so basically folders with all these different modules in it, all wrapped up within a single package. So we have modules and then packages, and now we have libraries. A library is a collection of packages or modules that are grouped together to provide functionality. So both Pandas and Matplotlib are technically libraries because they're a group of packages inside of it, and also include other things like pre-written code, configuration data, documentation to help with development, basically speed up our workflow with data analytical tasks. So if you think of it this way, libraries can be packages, and thus we can go to things like PyPy or Anaconda and download it for a package manager. But a package alone, if it only includes things like modules in it and it's very basic, can't be considered a library. Anyway, I digress. What's important is you understand that we have access to third-party packages and libraries that are going to speed up your workflow, so you want to use them. All right, we have some practice problems available for you now to go through and download some different packages and test them out inside Google Colab. With that, see you in the next one. This video is going to be optional, if you will. A lot of the concepts and what we're going to be doing in this is only going to be applied in this video here, and we're not going to apply it further. However, everything we're going over with classes is going to help you better understand how these different data types like strings and lists and even data frames actually operate behind the scenes. So let's look at a very simple version implementing a list data type using a class. Now I want to show how this list data type would be coded. And so that's why I have this basically simplified version of list all within this class. We're going to go to it in a second. Now for this example, I did want to show you the source code for the Python library. But like I said before, Python, a lot of it's written in C. And here, the actual list object is written in C. I don't know C. I'm not trying to go through in this and try to explain it to you. So that's why we're going to this simplified version right here. Anyway, this is a class right here. And I'm naming this class Luke's List. And inside of this class, you see the structure is very similar to before. It's got class at the beginning, colon. But inside the class itself, we have different methods. Right here, 6 different methods. We'll dive into some of these whenever we get into our full-on example. But for right now, I'm just trying to demonstrate how the list class would work. Anyway, I'm gonna go ahead and run this. And now this class object of Luke's List is available. So the first thing I need to do is create an instance of this list. So I'm gonna call this my list and set it equal to Luke's List. And I need to put those parentheses outside to initiate that object, running Shift Enter. Now when I run my list, I should see a blank list. Okay, it's a blank list. Inside this class, I have this add method, and it adds an item to the end of the list by basically doing an append. So let's actually add something to it. I'm going to define my list, and remember, I'm going to use that dot notation to actually access those methods. Right now, we only have add available or being able to view that. And then from there, I'll say, we'll add data nerd. Running Shift Enter, bam, we got it. Now I actually print out the contents of that list. We got data nerd inside of it. If I want to add something else to it, I can just add that to it as well. So now we have finance nerd in there, print out my list to actually see what's going on there. We got them all. Now we're not going to do all these different methods here, but we're going to just do one more, specifically this len method, which returns the length of the list. So I can just use that len function and define my list, and it should print out 2. There's 2 items in there. Okay, so that's a class that we've built for a custom list. Classes are really important when we need to bundle up, in this case, a bunch of different methods and make an object behave in a certain way. And I think we have a good use case for this. So recall back whenever we were covering modules, and specifically we were working with a base salary, and we defined these 2 functions, mainly just the first one we focused on, but I also added the second one, in enabling the ability to calculate a total salary by looking at the base salary and bonus rate, and also calculating what the bonus value is based on the total salary and base salary. So what we could do is we could create our own basically currency data type for this base salary, and thus allow us to do these functions when called as a method, along with a few others. So this is what we're going to end up coding during this video. And it's a class on base salary, and it's going to have 4 different methods inside of it. Now, before we get into coding it, I want to demonstrate how it works so you understand the significance before we actually start coding this out. So I'm going to go ahead and play this to make sure that that class base salary is in our environment. So the first thing I'm going to do is initiate the class. And I do this by just calling base salary. And then I know I have to provide an argument. We're going to just do 100,000. And that's as I'm looking up at the documentation, that's the base salary. It also takes things like the bonus rate and the symbol we want to use for this. Right now, we're going to leave both those blank. Anyway, running Shift Enter, I get back provided to me, which is pretty neat, 100,000 formatted with a currency symbol and with a comma separating it. So I'm going to assign this to a variable of data salary so that way we can actually start playing with some of the methods of it. Running data salary to make sure that we have it in there. Yep, it's 100,000. So let's run this method of calculate total salary. So I define data salary and then put the dot. And then from there, I can see the methods by this cube right here of calculate bonus or calculate total salary. And then I provide open and closing parentheses. So it goes through and calculates that it's 110,000 and it has it formatted correctly based on that 10% bonus rate. Now let's say for some reason we come up here and we say, hey, the bonus rate is actually 0.2. Well, I can run play here. We can see now that it's still 100,000 for the base salary, but then we go to calculate the total salary, it goes up to 120,000. So let's get into building this thing, and to make sure that we're all cleared out and not actually running this in here, this code that I have, I'm going to reset the environment. So the first thing that needs to be done in defining a class is starting it with the keyword class. And then from there, we're going to name it. This is typically done for a class using what we call camel case. And that's where you use an uppercase letter for the first word for the start of every word. You're typically not going to see underscores or even something like lowercase used for classes because that's more reserved for variables. Well, I want to be able to quickly identify this as a class. So this is how it's named. All right, with anything, we're going to test iteratively. So I'm just going to provide the pass keyword here and then make sure that it runs just fine. So the first thing we're going to define is the dunder init method. And methods start just like functions using the def or define. And then we're going to use 2 double underscores, hence dunder, then put in init, and then 2 more double underscores, and then put a colon. Dunder init is a magic keyword. Anytime you see these double underscores, they're basically predefined methods inside of Python that whenever you run the compiler, Python knows that this specifically named method has a special use case, specifically the one that we're going to be using. And from there, I'm going to add parentheses, opening, closing parentheses, colon, and then like usual, I'm just going to run past to make sure that it's working properly. Now we're going to be defining multiple methods in here, and they all need to be able to work with each other and to basically pass around whatever data we have initiated inside of this object of base salary. And so we can do this by defining the first term or the first positional argument in init as self. So this now, running it, is the most simplest form of this base salary class. I can come down here and then actually run it to see what we get printed out. And nothing, it basically tells me it's base salary class. I can pass it something like, let's say we want to pass it a salary of 100,000. It's going to tell me this, that the base salary init takes 1 positional argument, which we see there's only 1 positional argument, self, but 2 were given. It automatically assumes the object itself is self, and then this 100,000 is now the second one. So we need to build in base salary as a variable into this. So I'm going to assign this base salary. So running this, and now this one with which second positional argument, because we already know class, we get this back, that base salary, the object, we have it. But let's say I want to call it. So we'll define this as the variable of salary. And let's say I want to see the base salary. So I wanted to call something like base salary. If I run the shift enter, it's going to go, hey, has no attribute base salary. So what I can do is inside this dunder init method is initialize this variable of base salary. That's why it's conveniently named init. It initializes these variables. And I'm going to set the attribute of base salary, and this is an attribute, not a method, equal to the variable that we're passing in here of base salary. So just so we're clear, this base salary that we're passing in through right here is this value right here, which we're assigning to the attribute of base salary. So I ran this class again. Now let's run this below. And we can see that base salary, now the attribute, has 100,000, right? This is not a method, so we're not going to be including double parentheses or open and closing parentheses inside and out of it. It's not callable like that. It's an attribute. So we're going to be defining like this. Attributes are basically variables. Also, I'm noticing we don't need this pass argument anymore. That's just not necessary. Even run this, it's still good. Okay, now we need to pass in 2 more variables that we're going to be passing this class, and that is the bonus rate and then also the currency we want to use for this. So we're going to set the bonus rate equal to 0.1. And then for the symbol, we're going to set it equal to the string of $. Now, just like this base salary, I need to now define these attributes and set these values to it. So I define the attribute of bonus rate to bonus rate and symbol to symbol, whatnot. So running this and then running this down below, we still have it. I can even change this attribute down here to see, hey, what is the symbol? And there's a $. Now, one quick thing, this self keyword is not like the required name of this parameter right here. So actually, I'm going to change all of these from self just to demonstrate. I'm going to use Control-Shift-L, and I have selected all of these, and I'm going to rename it obj for object. So now running this here up above and then running below, it still works. This name right here doesn't really matter what you do it, but self is most commonly what it's named. Now, the next method we want to build into this is to format how it's output. So if I were to see just salary by itself, printing it out, it's providing this base object right now. Whenever I call salary, that variable, I want to see printed out similar to what we did above whenever we had that original class in there. This actually formatted correctly with this number, with the dollar signs and then the parentheses every thousands place. Well, we can use another method for this, and it's once again a magic method. It is the dunder_repr method. This method, like all methods inside of this class, are going to have that passing of that first argument of self to it. So we have all of these things like base salary, bonus rate, and symbol passed in through this. For this one, that's all we'll need. We'll go down to the next line. And this repr method, because it's a magic method, it's known by Python. Whenever you go to print out the contents of a variable with this base salary, it's going to do whatever you tell it to do within this method. So I'm going to need to use a return keyword, and I want it to return something. We're just going to say return data nerd for the time being. So we demonstrate this purpose of this. Running play here, and then also in here, and then finally here, we get data nerd printed out. That's not very useful, all right? I want actually to see the $100,000. So we're gonna use an F string for this. I'm gonna use the curly brackets to specify to pass in self.symbol. And then after self.symbol, I wanna pass in the actual base salary. So I'll specify self.base salary. Running shift enter on this, shift enter again, and then shift enter. We got now 100,000. Now remember, we want this 100,000 to have a comma separator in it. And there's actually a special way we can do this inside of an F string. I don't want to dive too much into this because we want to focus on classes. But if we have something like value and it's equal to 1,000,000 here I put it into an F string. We know we can put a variable inside of curly brackets and then it'll print out below basically as a string. Run this again, 100,000. Okay, if I want to format that value, because we can do that, it's like a special feature, I can put a colon, and then from there, I want to format it with a comma. So I'll add a comma onto the end of that. Additionally, if I wanted to format how many decimal places after this, I'd put a decimal. And then for our cases, let's say we want to have 2 decimal places after it. I would add 2 and then F. Okay, now I have 1,000,000 with 2 decimal places. I don't want anything after it. I'm going to add a 0, running shift enter. Okay, so I'm going to take this basically symbols that I just defined right there, Command C it, and I'm going to place it right inside of here, inside of our class. Run our class, run this one, and then finally we have 100,000 with the comma, no decimal places. If you want to learn more about how to format variables inside of F strings, you can go right here to the documentation. I'll include a link below. I do this from time to time, but it's not the focus of this. We're going to focus on class, so we're going to continue on. All right, so we're actually almost done. We just have to add now those 2 methods that we've defined previously for calculating total salary and calculating that bonus rate. So what I did is just copy and pasted in those functions that we built previously and just put them into here. They're not going to work right now, and we're going to go over how to actually fix this to make them work, but at least it's some boilerplate code to start with. We're going to start first just modifying this calculate salary function right here. Remember, the purpose of this is to calculate total salary, which is our base salary times 1 plus our bonus rate. So this total salary is actually going to be used not only in this calculate salary, but also in this calculate bonus. Because of that, I actually want to define total salary up here in the init method. So I can define a new attribute of self.total salary, and I can set it equal to basically this formula right here, which I'm going to copy up here. Now that we have total salary defined inside of self, we can pass that in to the calculate portion right here. Now, what do we want to return? Well, we want to return similar to this dunder_repr method. We want to return what the total salary is, formatted similar to this. So actually, I'm just going to take this code right here, put it inside of here, and we have self.symbol, but now I want to provide back self.total salary. Similarly, let's do the same things here. I need to initialize an attribute of the bonus and set it equal to these contents right here. Now, we do have to modify this further. Total salary, you can see it has these lines underneath it. It's not defined. We don't pass total salary in, but it is initialized under self.totalSalary. So what I can do is write self.totalSalary, and now we have it in there. We still got the same formula. Then from here, I'm going to go down and modify the method of calculate bonus, passing in self, and we want to provide out, basically it formatted the bonus as a numerical value as all the other ones. So I'm going to provide it this f string, self.symbol, and now for this, I want to have self.bonus. Boom. So let's actually run this. I hope it works. We haven't compiled this recently. Okay, and it works. Running the next line to see, yep, we have the symbol, we have salary. So let's run some of these methods now on it. I can run salary.calculateSalary. And then this is a method, so I'm going to use the opening and closing parentheses, and we get 110,000. Similarly, I can do salary.calculateBonus, run this, and the bonus is 0. That's not right. Let's see what the error is. I'm actually calculating the bonus rate again, which if we already did, that's not what I actually want here. I want to have the actual bonus value. So I basically want to do the total salary minus the base salary. And I'm gonna go ahead and remove this right here. Running all these lines of code again, getting down to the bonus. This time when I run it, bam, $10,000. Now technically analyzing this class, these terms of calculate salary and calculate bonus aren't necessarily true because we're actually calculating inside the init. I'd probably update this further to call this show salary and also show bonus, but that's just minor things. But I do think this gives a good demonstration of when you may need to implement something like a class in order to automate certain tasks that maybe are repetitive, like in this case with manipulating salary. Like I said in the beginning, this section is completely optional. I just mainly wanted you to understand the power of classes inside of Python to streamline workflows. So I do have some practice problems for this, but like the video, they're optional as well. But I do suggest checking them out and trying them out so that way you can learn more and really deepen your knowledge of Python. With that, after this, we're gonna be diving now more into packages, specifically NumPy, Panda, and Matplotlib. All right, with that, see you in the next one. All right, so congratulations. You've covered all the fundamentals about the core Python library. We're gonna now be shifting our focus into diving into libraries, specifically Pandas and Matplotlib, and this one, NumPy. Now, this is such a powerful library, I'd be remiss if I didn't cover it in this course. Let's actually jump in, and I'm gonna show an example of using NumPy compared to just using Python alone, and basically in how fast and how good it is at doing analytics. So we're going to create some fake data in order to test the limits of this. And it's going to be 1,000,000 salaries inside of a list. And we're going to have values ranging from 50,000 to 150,000. For this, we're going to import in the random module for this. Random has a special method called randint. And we can see inside of it, it takes 2 different values. And this is A and B, which is basically a range, including both endpoints. So we'll put inside of here 50,000 and 100,000. Running this quickly, we can see we get this random value of around 53,000. Running it again, 81,000. I think you get the point. Now let's do some list comprehension to basically make a list of all these different random values. And for this, we want to, remember, create 1,000,000 values. So we'll say for, and we'll just provide underscore as this random value in range of 1,000,000. And then I'll close the brackets for this. And then running this, we have our list of over 1,000,000 values. And it looks like I printed it too. All right, so we'll assign this to the variable of salary list equal to this. One note, this is all for demonstration purposes to demonstrate how well and how computationally effective NumPy is. Don't necessarily have to follow along. So now with this salary list, let's say we want to find something of analytical importance, such as the mean or average. We can use the statistics library in order to figure that out, right? So I import in statistics, and then with statistics, I use its mean method and I pass into it salary list. Running this, we get the mean, okay, around 75,000. We don't really care about that. We care about how long this is taking because we want to compare this to whenever we start using NumPy. So what we can actually use is a magic command using the 2 percentage signs. And then the list will pop up of what we want to use. We want to use this one of time it. We want to time this operation right here. And this will run this multiple times and then provide us what is the average time that it took to run this whole thing right here. Actually, I'm going to stop real quick. It says 482 milliseconds. I'm going to stop. I don't want to count the import statistics as part of that. That's not fair to count that in it. So I'll import it above and then we'll time it again. Okay, much less this time because we didn't have to import the library. 335 milliseconds. Now let's do this with NumPy. And for NumPy, we import it as NumPy and we use the alias, so as NP. This is very common practice to use NP for NumPy and PD for Pandas. So running this and importing the library, I want to also time using NumPy to find the mean with the time it command. So I'll put in here time it. And then we're going to use NP dot, as you guessed it, we're probably going to use mean. And then we're going to pass into it in parentheses that list. So passing salary list into this and then running it. This one takes only 52 milliseconds, which both of them run 7 runs each, but that is a sixth of the time. And you're like, Luke, this is milliseconds. What does that even matter? Well, right here, we're only working with 1 million rows of data. And I've worked with even bigger or larger data sets than this. So I ran this again using just 10 million, so 10 times the amount of data. And then we actually see stuff that actually is going to affect us. When we use the statistics median method, this one takes 5 seconds. However, whenever we use NumPy's median method, this takes only half a second. I can promise you, you get bored after about 3 seconds. So this type of delay in time that it takes to compute, you're going to want to take advantage of and use NumPy instead. Now you're probably like, Luke, in that other video on libraries, you specifically called out that we're going to be focusing on Pandas here and also Matplotlib only, and didn't really stress that we're going to be covering NumPy. Well, I want to cover NumPy briefly in this section of the video because Pandas, if we scroll down and look here underneath the dependencies, we see they have 3 different packages or libraries supporting it. And the number one is NumPy. And if we actually navigate over to NumPy and then scroll on down to this section, we can see that there's a whole ecosystem around it. So NumPy not only supports libraries like Pandas, but also statistical libraries like scikit-learn. Additionally, looking underneath this visualizations tab, it supports Matplotlib and even Seaborn of what we're going to be covering later on. So although we're not going to be directly always importing in NumPy as NumPy and using it inside of a notebook, we're going to be still taking advantage of NumPy basically on the back end behind the code with Pandas and Matplotlib actually accessing NumPy and using it for us to compute faster. So in the remainder of this video, I just want to show some basic operations that you can do with NumPy in order for you to understand and appreciate it. But in no way is any of this stuff really required knowledge for you to continue on and to be successful in using things like Pandas and Matplotlib. All right, so let's jump in. We're going to start by first, we have imported NumPy as NP. We're going to define one of the core data types inside of NumPy to do operations, and that's an array. To define an array, as you guessed, you run NP and then you run the method array. And inside of here, you provide an object. We're going to provide a list of values. For right now, we're going to keep it simple of just a few different numbers. Running this, it will print down below the array. Let's actually save this to a variable of my array so we can start manipulating it further. With my array, we can do things like run the mean. Didn't spell that correctly. We're going to change that to my array. And my array, change it to the mean. So we see the mean's 2.5. So we understand arrays are the basic data type of NumPy, and we can do a lot of different things with it. Let's move to actually a more practical example of, let's say we're working with data science job postings, and we have our data inside of arrays. So I have 3 different arrays available for us. First are job titles of 4 different job titles, the base salaries of 4 different values, and the bonus rates of 4 different rates. As you were guessing, each one of those, the index of 0 is for all those items at index 0, and the index at 3 is all those different values. So let's run this. And now what's cool about arrays is we can actually do computations between arrays. So let's say I wanted to figure out what the total salary is based on these base salaries and bonus rates, but I wanted to get the array from that. So I can define a variable of total salary. And for this, I can use those same Python operators before of the plus, add, and subtraction in order to do operations on these arrays. So I define that this variable is equal to the base salaries times 1 plus the bonus rate. Then I want to see it right below it, so I'll print out total salaries. Also, just to maintain consistency, I'm using salaries. I don't know why I'm doing this, but anyway, we're going to just change this to maintain consistency of salaries. All right, so now we have this array outputted that shows our total salaries. And you want to, you can go through and check and see that is 90,000 times 0.12 this. Yeah, it should be. Now, if I want to see the mean of these total salaries, I can just do NumPy mean and then put in that total salaries. So you could imagine if we have hundreds or thousands of different values inside of something like NumPy arrays, we can do our calculations a lot quicker than if they were in something like a standard list inside Python. Now, let's say we have some values inside of our data that we have missing data. Meaning sometimes, let's say we collect a job title, but we don't necessarily know the salary. So I'll add in one more job in here and we'll call it AI engineer. And for this one, we don't have a value for the base salaries. Now we don't want to put something like 0 here because let's say we did, we'll put zeros for each of these. If we run this and then we see the total salaries out, we can see it's 0, but what's going to happen is it's going to affect our mean. It's going to drag our mean down to even lower of 66,000 because we have the 0 in there. We don't want 0 in there. Now Python has this type called none. If I go ahead and print it out, it is, well, it's not even printing anything because it's none. If I print what is the type of none, it will print below that it is a none type. So let's try that instead of using 0. So I'll put none in here and none in here. We'll run this one again. We'll run total salaries again, and we automatically get our first error. It basically says, hey, it's a type error. Unsupported operand types for that plus operator. Operands are what's on each side of here. So when we do 1 plus none, as it says int and none types, 1 is the int, none type is the bonus rate, we get that, hey, you can't do this calculation. So what would be a better way to store that we have no values for this? Well, NumPy, if we write it out, has a nan value, and that means not a number. And this is specifically for numerical data. If I run the type method on this, it returns back that even though there's not a value there, it interprets this as a float. And as we know before, float and ints can be added together, so we're not going to get an error there. So I can come up here and I'm going to replace that none with np.nan. And additionally do it here with np.nan. Running this and now total salaries again, we don't get any issues and our final value is nan. Now for our mean, we're going to go ahead and calculate this, but we're going to get back a value of nan. Mean, this method right here isn't meant to handle these nan values. So there's actually a special method for this to handle those values. We'll make it, we'll add nan in the front of it. It's called nan mean. And you can see there's a whole bunch of other methods that do things when there's nan values present. Anyway, going ahead and running this now, we get back that value that we saw before of 83,200. Now there are a ton of other features inside of NumPy that we could go through and spend. I could make a whole course on it, if you will. But we're going to stop there because I really want to shift focus now to Pandas and Matplotlib. However, if you are interested in learning more about NumPy, inside of our source code for this course, Kelly put together this awesome resource on all the different operations and math that you can do with NumPy. And it's a wealth of knowledge. Additionally, we have some course problems for you to go through and test out different methods and functions inside of NumPy to get yourself more familiar with it. All right, with that one, after this, we're gonna be jumping next into Pandas, one of my favorite libraries in Python. And that, see you in the next one. If I only had the option to use one Python library for the rest of my life, it'd hands down be Pandas. By far, it's the industry standard in handling tabular data. So anything that Excel or CSVs can handle, Pandas can definitely handle it. So this is the GitHub repo for Pandas. And if we look at the stars for this, it's at 42,000. This alone puts it at a very top library. Now, as far as how to use this, as far as understanding Pandas, I don't really recommend it. For any documentation, I go to what they have here at pydata.org. And if you go to the URL on the screen, inside of here, you're gonna have some different documentation. I recommend just going to the API reference, keep this window open. We're gonna be referencing it throughout this video and many more. So inside our Jupyter Notebook, we need to import in Pandas. Now, if you recall, Pandas is already installed in this environment here. Here I'm running pip list, and it's gonna list out the different libraries available. And right here we have Pandas. Now, whenever we run this locally using Anaconda as our environment, we're gonna have to install Pandas, but that's for future us to worry about. So since it's installed, all I'm gonna do is put import Pandas as PD. And as a reminder, PD is just the industry standard for making a shorthand notation for Pandas, so we'd have to write it out fully. Now that we imported it in, let's actually load some data. So back in the documentation underneath API references, I can go to input output, and that means how we're gonna get in data in and also how we can get it out of here. Now there's a couple of popular ways to read in data that you need to be familiar with. Specifically, we have this one right here on Pandas read CSV, which is a method of Pandas. Another popular type I find myself using is read_Excel method. And as you expect, you can read in an Excel file. Now we're using these methods in order to read in this data, and then we're gonna place it into a data type called a data frame, which we're gonna go over in a bit. So let's test this read CSV method. I can type pd.read_CSV and then opening parentheses. And I can see from this, it takes a file path. Now remember, we have inside of our folders over here to the left-hand pane underneath sample data, this California housing test CSV. I'm gonna click these three dots right next to it and select copy path. Inside of here, anytime you're pasting a path, so let me just say I go ahead and paste this path into here and I run play. I'm gonna get invalid syntax right here. And that's because it expects this file path to be a string. And right now, we're basically giving it some sort of weird variable name. So I'm gonna go ahead and wrap these in single quotes or double quotes if you want. Running this again, we now have all of our data inside of a data frame. So let's get into a brief intro into data frames themselves. Whenever we create this object right here, this data frame, we need to actually name it into a variable. And so it's common for, if we're just doing one data frame, I'm just gonna name it df. I'm gonna set that as the variable name. Running this again, we have df available. If I type in type df, I get back some pretty in-depth documentation on this. But the main thing is this, it's a two-dimensional, size mutable, potentially heterogeneous tabular data. That's really a lot of nerd talk. Data structure also contains labeled accesses, i.e. rows and columns. Arithmetic operations align on both row and column labels, can be thought of as a dict-like container for series objects. The primary Pandas data structure. So as it says, it's a dictionary-like container. So let's go ahead and run that again of df to actually see what's going on here. And inside of this, we can see we have the columns up here on the top, along with the index here right on the left-hand side. And I can tell it's the index also because there's no label on top of it. And then just like an Excel spreadsheet or Google Sheets or CSV, this data is laid out in rows and columns. So let's start with these columns first. Because it's a dict-like object, we can use a similar notation in order to access columns of here. So let's access the total rooms one. In here, I can type df, and then similar to a key of a dictionary, I'm gonna do those square brackets. And then inside of here, if we notice, it loaded the data sets, so it automatically provides hints on what we wanna put inside of here. So I selected total bedrooms. Running this again, shift enter, we can see we get back all of the different values for that column. Now this is not the only way we can access this column data, and I'm gonna change it up every now and then and do something different. Specifically, we can use this dot notation and use a similar way calling out the column name itself And then in this case, it's going to provide us exactly the same results. I'm lazy, so I really prefer this method, and I'm going to do this when possible. So we talked about accessing the columns, but what about if we want to access the index? So let's say I want to access the first item in total bedrooms. Similar to that list index, I can provide the square brackets and then the number of the index I want to access. Running Shift-Enter, I get 661. I can also do the same type of annotation with when we had to write out the column name in a string, providing that last row of data, 299, it provides it of 263. So you're probably like, Luke, that's cool, but let's actually access the data we're going to use for this course. So let's do it. So this data is open source to everybody, and I've made it available through Hugging Face. Hugging Face is a popular open source repository, and it's specifically designed towards the NLP community or natural language processing community. Anyway, they provide a great platform to host data sets. As I click here, I can see there's a wealth of different data sets in here, and this is where I hosted mine for free for you to access. So how do we actually get this data set into your notebook? Well, if I go in File and Versions and actually go to the CSV itself of data job CSV, you could download the CSV and then use that similar read CSV method that I used before and put it into your environment. But that's a little bit too much work. I got an even simpler solution. Digging into the Hugging Face documentation on how to actually load a data set from the hub, that's where the data set is located, I can see that they have this load dataset function, which allows me to provide basically the name of our data set and then load it into our environment after we've imported in data sets. Now, one note, we will have to install data sets into our environment as it's not available in Google Colab, and also it won't be available in Anaconda whenever we get to running this locally. So the first thing I'm gonna do is I'm gonna run pip install datasets. Remember, we're running a terminal command right here. So I'm gonna start with the exclamation point, and I'm gonna call out pip install datasets. Running Shift-Enter, it's going through and now installed all those different things. So now I'm gonna import it in using from datasets. We want to import in the load datasets function. Okay, we have it inside of our environment. So now we're gonna use load dataset. And for this, we need to provide the path or the string name. Now, if we go back to my data set itself, we can see that the data set name is 𝗕𝘃𝘁𝗿𝗃 data jobs. And I can actually come up here and just copy this right here and then paste it in. Now, once again, look at this yellow highline that's going on. Common mistake, people just go ahead and run this automatically. We're gonna get an error because this needs to be a string value. So I'm gonna go ahead and put single quotes around this. Run this again, Shift-Enter. Now it's downloading a bunch of different things into here. It downloaded the README, and then it downloaded the data itself. Now I can see down here from inspecting the object that is providing back that inside of this dataset dic, which is the data type that they're using to provide you with all this data, they have this key and then value provided with the key of train. We need to access that train portion to access actually our data set. So for this, I'm going to actually import this into a variable instead, and I'm going to call this dataset, set it equal to here, run Shift-Enter. It's already loaded in, so nothing really happens. And then from there, I'm going to do dataset. Remember, it's a dictionary-like object, so I'm going to use those square brackets and then put inside of there train. All right, and it outputs this where we have the dataset itself now inside of here. But if I run a type check on this to see what actually this is, it's going to come back that it's a data set. We want it as a data frame. So I'm going to remove that type right there, and we're going to run a method on this that data set actually has. Specifically, we're going to run this. I typed in TO and then underscore to see what we could do to it. And we can transform it into a multitude of different things. But you know what you're going to transfer it into? We're going to transfer it into Pandas. And then from there, we want to put opening, closing parentheses, run it. And now we have it imported in as a data frame. We can tell by just the way it looks. Once again, I'm going to set it to that variable of df and then run this again, Shift-Enter, and then printing it out right below it, right there. So we're going to stop here in order for you to load in that datasets library using pip install and then import it into a data frame like we've done here. In the next section, we're going to be doing a deeper dive on how to actually inspect data, like running things like this info method right here, where when I run it, I can get all of the different column data back, how many values or non-null values are in it, and then what data type it is. We're going to be doing this and a whole host of other things. Also, you do have a few practice problems to play around with this data set and access the different attributes of it. All right, with that, I'll see you in the next one. So for the next 3 videos, we're going to be diving into a lot of the basics behind Pandas. Specifically, we're going to be looking at inspecting, cleaning, and then analyzing data, all in that order, for the next 3 sessions. And this is like the fundamental basis that you need to know. And in this video and the other ones, we're going to be covering a lot of different methods and functions, pretty rapid fire. So with that, let's get into it. So I'm starting with a new notebook. You don't necessarily have to, but at a minimum, you have to have imported Pandas as PD, loaded in that datasets library, specifically the load dataset function, then load our dataset that we're going to be actually using for the remainder of this course and also for the project, and finally put it into a data frame. So let's get into methods of actually viewing our data. You saw previously I can type df and then run it, and then it prints it all up. Here it prints the first 5 rows and then also the last 5 rows. It also tells me how many rows and columns are available. I typically don't like this. I prefer to just specify that I want to see the top rows. And so I'm going to run this head method on here. I have to use the opening and closing parentheses for this. Running it, I get the first 5 values. I can also provide as a variable to this an int, and it returns the first n rows. So in this case, I want to return the first 10 rows, run it, bam, get the first 10 rows. So head gets me the first 10. What would get me the last 10? Well, tail. So I can type in tail here, and I'm actually going to just remove this of 10. And by default, it provides these 5 values. Once again, I can provide a value inside of here, and it gives it back to me. Now for both this head and also tail method, I typically use this in conjunction with specifying the column name. Right now we have a ton of column names, and maybe I want to just identify some that I want to actually use instead. So if you recall, to access the column name, it's similar to a dictionary. I'm going to specify this, and then from there specify, we're going to look at job title short. And then with this, I can run it with this head method here to provide the top 5. And as shown, this provides the top 5 values. I can once again run 10 inside of there, get the top 10 values. Anyway, removing this head, what happens now if I want to look at multiple different columns? Well, in this case, I need to provide the data frame a list of column titles. What do I mean by this? So I'm going to put the brackets around this object right here of the column of job title short. And I'm going to run it again. It's going to run just fine. And actually with this one, I would actually say it's formatted a little bit nicer. I like this formatting. Anyway, what I'm doing in here is I'm providing a list of column titles. So now I can use a comma, so I can specify another column name. So in this case, we're going to do something like job location. Running Shift Enter, we now have multiple different columns. Now, one of the biggest mistakes that I see with beginners is they forget to include those brackets to thus make this into a list. And so if I were to run this without it, we're going to get a key error. It's going to read this incorrectly as a tuple, and we need to be providing it as a list. So I'll come back up here and put those square brackets in. Rerunning it, I get the multiple different values with it. And once again, I can run that head or tail method on it and get those appropriate values back. But now let's say I want to access maybe the 100th row of this data. If I were to put in 100 in here, I could do that and then run this all, but I'm going to have missing values in here. So let's say I wanted to view 90 to 100. I can't necessarily do this with this method. It doesn't provide that. For this, we can use a property of data frame, which is somewhat similar to a method. But anyway, it is ILOC, and that stands for integer location. And we can use integers to call out things like the index number of a row and also that of the column, which we'll get to that. So let's show this without selecting any column. So I can say for the df, I want to use that ILOC property. And then from there, I'm going to specify I wanted row 90. I'm just going to put in 90. Running Shift Enter, it provides this back with the data, not only the column, but also the data itself associated with that row. Now, if I wanted multiple values, 90 to whatever, ILOC supports slicing. So we could do what we did before with something like list, where I provide, I want 90 to 100, running Shift Enter. I get the data frame back in a much more readable manner, I feel, inside of this tabular data like this. Now with ILOC, you can also provide it a second argument using a comma and then separating it. And once again, you can provide the integer location of maybe the column. So let's go with 0 for job title short. Running Shift Enter. I get back the job title short of all these different values. Once again, I'm not really liking this formatting, so let's include more than one value. I'm gonna specify 0 to 1. Sorry, and that's not gonna select anything, right? We actually have to do 0 to 2 if we actually wanna get the next one over, because it's gonna be exclusive for that last number. And now I get job title short and the job title column. One quick note about this data set, the job title short column is a much more basically shorter value for the job titles. The job title column is what the actual job description listed. So data management analyst has been categorized as a data analyst. And it makes it a lot easier with this job title short column whenever we want to dive into specifically looking at data analysts, data scientists, and data engineers. We don't have to necessarily filter through this job title column. Anyway, I digress. The main thing here though to remember is I don't really care about accessing the column through integers because you got to count over, and I think it's way too confusing. So instead, I would go about using the iloc to get those 90 to 100 rows in this case, and then from there, specifying the 2 columns or multiple columns that I want within this portion of the data frame to then call back those objects. So let's shift gear real quick now that we understand how to actually access different columns and rows of the data set. Now I want to go forward and look at how we can investigate the data types, the columns, and a lot of info and key characteristics of it. Specifically, we're going to be covering these different functions, methods, and properties that are available. The first method is info. So I could run df.info on this, and I get a lot of key characteristics back about this. I get the class of it, the number of rows that are included in this, and the total number of columns, which it then goes and further breaks down, providing the column index, name, how many non-null values it has. So in something like our salary data right here, we can see that there's a lot less data here, only about 3,000 values compared to almost 780,000 job postings. And then finally, the data type on here, a lot of different objects, but we can see Boolean values for things like job work from home and job no degree mention, along with float values, so decimal values for the yearly salary and also the hourly salary. Now the rest of these are classified as objects, but technically if we inspect them, they're strings. But don't worry too much about that. Pandas classifies it as this object over string, just to make it a little bit easier on the processing of the data. Now this info method, to me, is one of the most powerful. And you'll frequently see these other properties and functions and methods getting used. But as you can see from here, I have to run 1, 2, 3, 4, 5 different ones to get the same information that I got out of just the single one with info. So if you have to memorize one, I recommend just memorizing df.info. Now let's dive into this data set a little bit further. We're going to look next at these float values, so the values provided for the salary data. And for this, I can use the describe method. And with that, it's going to analyze statistic for only the numerical columns. And so it provides key statistics about that yearly and hourly salary, giving you the count, mean, median, max, and all these different percentiles. So this is great if we want a quick snapshot of how the data or the numerical data is trending. The last thing I want to look at in this data set is regarding this job title short. Remember I told you that this job title short basically buckets all the data types to categorize them more correctly and provide simple names associated with each job title. Well, let's say I want to get what are all these unique values inside of this job title short column. Well, I can start by defining data frame and then the job title short column. Once again, I can use either that string value inside the brackets or this dot notation. And then from there, I need to specify the unique method. With this, I get an array back, which thankfully I called NumPy before this, so I know what an array is. Anyway, it has inside of it all the different job titles available. And it includes 8 different job titles within this. And we're going to be diving into all of these different job titles as we go through the project. So now, what happens if I want to inspect our data frame specifically for certain job titles that we've identified here? Specifically, I want to dive into maybe more data analyst jobs. I can see that it's at random locations, and I don't want to necessarily have to call out like, hey, only pull up index 0, 2, 4. Well, we can use a comparison operator to actually filter for this. Let me show you what I mean. So I'm going to say df and then job title short. And for this column specifically, I want the values that are equal to data analyst. Now, if I go ahead and run this, we're going to get an error. And that's because we're using invalid syntax. Remember, anytime we're using any of these different values in here, this is a string value. So I need to put this inside of some sort of quotes. I'm going to use single quotes here. So whenever I run this, if you remember back to our data frame, like I said, we had the data analyst located in the index of rows 0, 2, and 4, and it returns true for these values. So being that it went through and actually classified what index values have an associated value of true or false, we can actually use this to filter a data frame. So I'm going to put in here df and then open up a square brackets and put a closing bracket. So this is the condition right here that we're evaluating, and we're putting this inside of df to filter for this condition. Running Shift Enter, I now get back inspecting it, all the different data analyst job postings in here. And it even tells me at the bottom, there's 196,000 of them. All right, so let's say now I want to continue on with this analysis, and I don't want to just only look at data analysts. I also want to look at where the salary for these data analysts is greater than 100,000. Right now, there's a bunch of NaN values or not a number values, and I want to actually see those that are greater than 100,000. So to do this, we need to use an operator that allows us to provide two different conditions for this. And remember, we want both of these to be true. For right now, we're going to just throw in and. And then from there, we're going to provide the DF and then the salary year average for greater than 100,000. Now, if we were to run it like this, we're going to run into a couple of issues. The first is this value error. The truth value of a series is ambiguous. So it's having problems resolving this. So the first error we're going to fix is we actually need to wrap these into parentheses. And that's going to separate to make sure that we have true actually evaluated and true on this side evaluated as well. Running Shift Enter, we're still having that the truth value of a series is ambiguous, and that's because of this operator right here. And is the incorrect operator we need to reuse right here. Instead, we're going to use the and operator, which is an ampersand. Running Shift Enter, we now have our results back for this, and we can see that it's not only the data analyst postings, but also going over here to salary year average, all these values are greater than 100. Now, if you don't remember from the bitwise lecture, we also specified that to use or, we use this pipe symbol, and that stands for or. In this case, I can run it here. And although the data doesn't show, or maybe it does show, we have data analyst postings, but not necessarily all the ones with salary data. We've met the or condition for it. Now, what happens if I just want to have all numerical values returned back for this DF of the salary year average? I'm going to turn this back to an ampersand right here. Well, for this, we can actually access this salary year average. We can run the method on this of not NA. Before running it in here, I'm just going to copy it and paste it down here to show you what returns back. And basically, if you remember from our data frame, most of the values did not have, or most of the values did have NA in it. And so it specifies it as not NA is false in this condition. And so we want values with salaries in it. So we want the true values of this. So coming back up here and actually running this now, we can see once again, we have all the data analyst salaries, but also now we have all the different salary year average, including those as low as 65,000. All right, let's take a breather. That was a ton of different functions, methods, and properties all associated with the data frame. But these are key and core ones that I use all the time in Pandas. So it's worth your time to invest in learning and having all of these committed to memory. I promise you, it will save you some headaches. All right, it's time for you to get some practice with actually implementing these different methods and properties that you've learned here in the practice problems. And after that, I'll see you in the next one. We're gonna dive into actually cleaning up this data set. See you then. Now that we've inspected our data, we need to move into cleaning. If I look at the time that I spend as a data analyst, the majority of it is spent in this alone. So needless to say, this is an important section. Anyway, let's jump into cleaning up some data. So similar to last time, we're going to start with importing the necessary libraries and then loading our data set into a data frame. Now there's a few different columns we need to clean up, but we're just going to focus on one for right now. Specifically running this .info method and scrolling down, we can see all the different columns and all the different data types. But right now the job posted date is an object. If I want to look at the first value of job posted date, I'm just going to do the square brackets and access it by its index location. Whenever I run this, I can see that it's basically a string because of these single quotes around it. And I can confirm this by running a type on this in order to see that it's a string. But remember, Python has the ability to use date time objects. And we can do a whole host of things with it that I'm going to show in a little bit. But so we want to convert this to a date time. Well, Pandas to the rescue with their toDateTime function, which this function converts a scalar, array-like series, or DataFrame dict-like to a Pandas datetime object. That DataFrame dict-like is basically what we're going to be using. We're going to be using specifying the column. So I can specify pd.toDateTime. And then there we need to provide the argument. And so for this, we're going to provide the job posted date. Now running this, we get back all these different date times and we can see that it converted to a date time by this D type. Now it converted basically in this cell, but if we inspect the actual data frame itself by doing an info method on it, we can see that job posted date is still an object. So what I need to do is reassign that job posted date column to itself once it's converted to a date time. So I put that at the beginning of this, putting it inside of square brackets and calling out job posted date. And then from there, I set it equal to this function call right here. And you noticed I use this bracket notation here, vice this dot notation. And that's something I commonly do anytime I'm reassigning a value to that, as we're going to run into problems that I'm going to show in a little bit. Anyway, I'm going to run this and reassign it to that job posted date. Now when I run this info method on here, I can see that job posted date is in fact a date time. So with this column of job posted date, we now have access to a new property, specifically this .dt, which is date time. And it's a date time property. And then it allows me to go even further with other properties that are available in order to convert it to maybe from a date time now to a date, or even things like month and then year. So a whole host of things we can get out of there. So for our future analysis, it's pretty common to use something like month in order to bucket different data and then compare it month to month. So I'm going to use the month in this case, running Shift Enter. There's a property and not a method, so we don't have to use those open and closing parentheses. We can see it ran, and we can see it provides back that it's an int and it has all those different values for it. Now this is cool and all, but running that df.info method again, we can see that that month value is not saved inside of here. We only have that job posted date. We want to get this value inside of our data frame and associated with each one of those rows. So we're going to do similar to what we did up here, but we need to create a new column. Now for demonstration purposes only, I'm going to run this using the dot notation. And I'm going to call, hey, we want a new column of job posted month, and then set it equal to this value. If you recall, I said this is a bad idea, and I'm going to show you why. Anyway, running this now, I get back this of a user warning. Pandas doesn't allow columns to be created via new attribute name. Basically, it doesn't let you use that dot notation. So that's why I brought up earlier, I want to use this bracket notation in order to specify what the new column is. So now running this again, pressing Shift Enter, and running the info method again, we now have that job posted month. And like we saw before, it's an int and it's assigned now to this data frame. I can even go in and inspect it by running df and scrolling all the way over. We can see that each of these has all the different month values for it. I like to double check it. And so I'll just make sure, yeah, it's all checking out. So now that I have this job posted date converted to a date time, I actually want to use something useful with it. And specifically, I want to organize my data in a logical manner, basically from the first job posting at the beginning of the year all the way to the last job posting at the end of the year. For this, we're going to use of the data frame, the method .sortValues. And for this, it only takes one argument and you specify by along with the column name that you want to sort the values by. You can also do things like select whether you want to do this ascending or descending. The default is ascending to set to true. And then another one we're going to mess with here shortly is in place, but we'll get to that in a second. So I've gone ahead and specified the data frame along with that .sortValues method. So now we need to specify inside of here that job posted date. And so we can see right now, the values aren't sorted. Running this, they are in fact sorted ascendingly. Now, one thing to note with this, we have the sort values, we've ran it, it's right here. And once again, we can see that it's in the order that we want it. But if I were to come down here now and run df and then inspect job posted date, we can see that the job posted date is not in fact sorted correctly. Now we can do one of two things. Whenever I sort these values like this, I could just reassign this variable of df to this new df that's sorted. But I actually have one better than this. And that comes with using in place. If we look at the documentation for this, we can see that it's in place, then we specify whether it's true or false. If you remember for the documentation, in place was false. So I need to specify this because this is a keyword argument. I need to specify in place, and I'm going to set it equal to true. Now, whenever I run this, nothing's going to print out below. But now when I run this df of the data frame itself and inspect the job posted date, all of it is in order as we can expect. Also, one little note, it's not required, but remember that first value in here is by. Typically, you're going to see by equal to actually still put in there for that key that we want to specify here, and it's still going to work. So I recommend you just do it this way, but the values are still going to be sorted. Now let's get into our final cleanup for this section. I want to analyze only the salary yearly data. If you remember, we have yearly salary data and also hourly salary data. So one, I want to remove this column of the salary hour average. And then two, I want to get rid of any rows that don't have values in it, or basically values that are nan. So let's start by dropping this salary hour average column. For this, we're going to use the DataFrame drop method. And in it, we need to specify the labels, or basically the columns for this. So if we come down here to the parameters and look at access, we can see that for 0, we're specifying it by the index. We want to specify it by the column name. So we're actually going to use 1 here to specify it by columns. So on our data frame variable, I'm going to run drop. And the first thing I need to specify is the labels. And for this, I'm going to specify the column name of salary hour average. Now the other argument, remember we need to specify, is axis. We need to set that one equal to 1. So now running this, we can see scrolling over that it no longer has that column in here. But once again, if I run that df.info method on this, we can see that salary hour average is still within this data frame. So similar to like we did before with using in place equal to true for the sort values, we can do the same thing here. Running Shift Enter, it executed the cell, and then running the info method on the data frame, we can see that we no longer have that hourly average data. So now we need to get our data frame down to those 22,000 rows that have only salary data. So we need to remove all those null values or nan values, which conveniently DataFrame has this method of drop NA. Now there's a couple things we need to pay attention to with this, especially with the parameters. The first is this axis. When we were dropping the hourly data, that was a column we were trying to drop. In this case, we're trying to drop complete rows that have NA values for a specific column title. So in our case right here, we want to leave this default value of 0 set because it drops rows which contain missing values. But what rows do we want to specify? Well, that comes into play with subset, and that's the column label or sequence of labels. So in our case, column labels. And with it, it specifies if you are dropping rows, these would be a list of columns to include. So it needs to be a list. So back inside, I'm going to specify this drop NA method. And the only one we need to provide for it right now is subset. And we need to set that equal to, like we said, a list. And we'll specify that this of salary year average. Running Shift Enter, we can see that all those different NA values were removed. Now, once again, if I run this df.info method, we can see that for salary year average, they still have, this says all the non-null values, but specifically, when we look at all the different entries in it, we still have over 780,000. So it didn't filter it down to this basically 22,000 that we need it to be. So we guessed it, we probably need to use something like in place. So copying and paste from up here and placing it as a second argument right here. I'm gonna go ahead and run this. And with that ran, I'm now gonna run df.info. And we can now see that there's only 22,000 entries, and that matches exactly with our salary year average for no null values. Now, one quick note on this cleanup that we did right here to only get down to 22,000 values is not necessarily the data set that we're going to be only focusing on for the remainder of the course. We're still going to be analyzing all those 700,000 different jobs, but I just wanted to go through this example to show how you might filter down a data frame to get something of where you want to actually analyze. All right, now it's your turn to get into and diving and clean the data set. I have some practice problems to go through and practice a lot of these different methods that we went through just now in order to better understand the data set and to help clean it up. With that, I'll see you in the next one. So we've gone through and inspected our data, cleaned it, and now we're into the fun part of actually analyzing it. And in this basics chapter, we're going to focus on two main features of Pandas for analyzing data that I use all the time, and that's aggregating our data to find things like min, max, count, and those type of things. And then also, even in a larger picture, actually grouping our data. So going down into things like analyzing job countries or job titles, things like that. So jumping back into the notebook, we have our standard import statements, loading the data set, and then also the data cleanup to make sure that we get that job posted date formatted correctly. Now, because we have this date formatted correctly, whenever I run the describe method on this, we actually get updated info. Before we were only getting the yearly and hourly salary whenever we were going through and using this method. But now we even have the job posted date since we converted it to a date time, and it has a whole host of information in it. Anytime I'm starting any analysis, this is the method I'm going to and using first, along with my other favorite method of info. Now, there's a host of different methods that you can use in order to run on the data frame and even columns themselves in order to better understand maybe some of the key statistics about a column. Now, we're not going to run through all of these, but we are going to do a few. So just to show a point, this info method shows the count here of each one of those columns, but I can also run df.count method here, and we're getting similar results. Now, if I move into more of a numerical analysis, like say I want to get the median value, well, we can only do this on numerical data. As you can see here, we get a type error, could not convert string to float. Data analysts basically run into an error on that first column of our data set of job title short. So some of these methods, I actually need to go in and put in the column name that I really want to actually dive into deeper for the median, which would be only numerical columns, something like salary year average. And here we get the return results for the median with no longer an error. Now, whenever we ran this describe method before, it provided a lot of these key statistics here, but specifically with this min and max, sometimes whenever this is provided of our min and max, I want to go in further and investigate what's going on here because we may have very strange values. In this case, they have a minimum salary of around $15,000, which is extremely low. So let's investigate it. So first to confirm, I'm just going to run the min method on this and confirm, yep, 15,000. Now I'm going to run this other method of idx_min, and that's going to provide the index value of this minimum salary. This is one of my frustrations when I was moving from Excel to Python is why I couldn't easily find something like I do in Control F. But this kind of methods allow you to do that. So I'm going to set this variable equal to min salary. So now to access that, I'm going to use that iloc property on DataFrame and specify in square brackets the min salary, which is the index of it. So it appears that this is a data engineering role in Brazil, and it is in fact full-time for that $15,000. So investigating this further with ChatGPT, because I'm not from Brazil, it provides back that this is actually a significantly higher than normal typical income. So, all right, this isn't an anomaly then. Now, if you remember before, whenever we were investigating that job title short column, which has like data analyst, data scientist, and data engineer in it, we use the unique method on it in order to basically provide back an array of all the different job titles. Now this is cool, but it actually doesn't provide much value. I want to find out what are the values or the unique value counts of each of these. So instead, I find myself using the value counts method on this. And it not only provides the numerical counts, it also organizes it in descending order. So we can see things like data analyst, data engineers, and data science take up the majority of all the roles and are the three most highest. And then from there, business analysts and software engineers, followed by the senior roles of data analysts, data scientists, and engineers. And then finally, we close this out with machine learning engineers and cloud engineers. So we've been using these statistical methods, but we've really been using it on one-off calculations. Basically like, hey, I want to find out what is the unique value counts of job title short, or I want to find out what is the minimum salary. But what happens if we want to dive deeper now into understanding multiple different aspects? Like what is the minimum salary of all of these different job titles short? Well, as you guessed it, there's a method for this. Specifically, it's the method relating to DataFrame. Now, the key parameter we need to focus on for this is just by, and it's used to determine the groups for the group by. Also, if you haven't been diving into the documentation yet, I think you should, as it provides a lot of different examples on how to run these different methods and functions that I'm going over. And so it provides a wealth of knowledge. All right, so let's run this method. I'm going to do df.groupBy. And inside parentheses, we want to list the group that we're going to be grouping by. And in our case, we want to group by that job title short column. Now I'm going to go ahead and just run this, and it's going to provide this object back, which isn't really useful. Now remember, we're trying to find what is the minimum value from that salary yearly average column. And right now we're doing group by on job title short, but then it's going to try to aggregate all the columns. So we want to now specify what columns we want to do this aggregation method of min on. And we do that by specifying it in square brackets. Now running this, we still don't have what we need. It's still providing that back, this group by generic or series group by object. And so now that we've grouped these, we can perform a lot of these different methods that I talked about previously using things like min, max, count, and I can apply this to the end of it. So let's watch it. Let's actually add in min in this case. And I'm being silly because I put job title short in there and y'all let me get away with it. And it's supposed to be job salary average. That's why we have these values that are repetitive in there. Anyway, let's try this again. And this is actually supposed to be salary year average. So let's run this again. All right, now we're getting values that we want. We not only see that lowest role that we found earlier of the data engineer at 15,000, but also a whole host of other ones. Now, I'll be honest, I don't really care too much about the min. I'm going to actually change this to something like the median. That's a better representation of the data itself. Now we got back the median values. Now let's talk about manipulating each one of these even further. So we learned that there's definitely fluctuations in salaries to different countries. So we could also do a group by, not only grouping by the job title short, but also the country. Now, if I go in here and try to put in, use a comma and use job country and then try to run this, I'm going to get an error, a value error. No access name job country for object type data frame. Basically, we have to provide this. If we're going to provide multiple values, anytime you provide multiple column values, you should probably putting it into a list. So now running this, we're getting a whole heck of a lot of different values. Previously, we were only getting around 8 values. Now, since we're using all these different countries that I've aggregated for this, we're getting around 1,300 values for this. I don't want to dive into all that just yet. So actually, we're going to just go back to our original one. So we figured out how we can do multiple group bys of different columns that we want to do. Let's say we want to actually aggregate or perform aggregations on multiple columns. Specifically, we have the yearly salary data. What happens if we also want to look at the hourly salary data? So anytime that I want to put multiple column values inside of here, I have to use a list. And then I specify salary, hour, average, close the brackets, boom. And now we have both of these values back, providing that yearly median value and the hourly. Now, one last thing to cover with this group by. Let's say now, yeah, I can get the minimum values of job title short for the yearly salary. But what if I also want the max value? So I want to do multiple different operations or aggregation methods on it. Well, there's a method for that. It's called agg. And inside of here, as you guessed, you need to provide a list of arguments. So I can provide in there the string values of what the aggregation method I want to do for this. So in this case, min and max. I can also, just for funsies, add in median. And now we have all those different values, the minimum, the maximum, the median, for that aggregation of the group by at job title short. So all these concepts we covered, group by can be one of the hardest ones to wrap your head around with it. So dive in and test out a lot of the different things that I've done here. I also have some practice problems available for you to go through and actually change it up a little bit and do different columns as well. With that, I'll see you in the next one. We'll be jumping into an exercise and combining all these different things of cleaning, inspecting, and analyzing data to one exercise. See you in the next one. So as we've seen, group by is a very powerful feature in aggregating and analyzing different groups of data. So we're going to be going through and doing a little bit deeper dive, analyzing the US job market. Feel free to adapt it to whatever country you're at. Specifically looking at some key statistics around these different job titles available within the country. Now, this exercise is designed for those that maybe aren't as comfortable with using group by or aren't as familiar with it and want some more practice. If you've used it before, you're very confident with it, I would recommend going ahead and just skipping this video and moving on into the Matplotlib intro, as there's not going to be any new concepts in here. We're just going to really drill down into understanding how to use group by. So inside my Jupyter Notebook, I've gone ahead and imported the libraries, loaded the data set, and also cleaned it up by cleaning up that date column, converting it to a date time. One note, if you're running this after the runtime maybe disconnects and you need to reconnect, you're going to have to do that pip install datasets again. Just go ahead and uncomment that out and put that in. So first, let's look at what countries are available by looking at that job country column. Now, this isn't really useful, so let's actually use an aggregation method to actually see something. And I'm going to run value counts on this to get the value counts of those different countries. Now, there's 160 total. It's not going to output all throughout here. I just really care about seeing the top 20, so I'm going to go ahead and put head of 20 here. Now, if you're still not seeing your country and you want to make sure it's available, you can go ahead and we can use the .isin method on this. And for this, we have to provide an iterable. So we can't necessarily just provide a string. We'll need to provide a list. And we'll go ahead, let's search if Brazil is in here. And this is just going through each of those columns and returning back whether it's true or false in that column. This doesn't really provide a lot of help for us. So I'm going to then run the any method on it, which in this case, there is jobs pertaining to Brazil because we get true back. Now let's run a country that may not be in here, something like North Korea. And that's going to be false. I don't have any job data for North Korea. So that was awkward. I'm going to go ahead and delete that. All right, let's move into now. We need to create a data frame. We're going to create a new data frame with only our country of choice filtered for with that job data. So in this case, I'm going to call this new data frame US jobs. And I'm going to set it equal to the data frame. And now we want to filter it, right? So we're going to use the bracket notation. And inside of it, we need to specify that we want to set the job country equal to our country of choice. Now I made a few mistakes with this. Let's see if we can catch it. First is this. I use the equal operator and we need to use the comparison operator here. Now next they have syntax error, invalid syntax, perhaps you forgot a comma. This honestly is a really bad hint onto what's wrong here. I like to use instead the highlighting here. And if you can't see, United has that yellow line underneath it on top of that red. And that's because we should be including this as a string, right? We're searching for United States as a string. So now that we run that, let's actually show this data frame and inspect it to make sure that everything looks right. Inspecting the job country column, we can see that. In fact, there's nothing but United States in it. So we have the data we need now. We need to now perform a group by aggregation in order to analyze it for things like the median, min, max, and also a count. And this is all of that salary year average column, which I'm noticing there's a lot of NaN values in it. So let's also clean this up just to speed up the process of any NaN values. So I'm setting the US jobs data frame equal to it again, but we're going to filter for it. And so inside our brackets, we want to set the condition for what we want to meet for that salary year average column. And we can use the not NA method on this. Basically, if it's not a NaN value, so it's true, it's going to stay in there. Inspecting the data frame to make sure that it removed all the NaN values. Looks like it did. All right, we're good. So let's start building that group by method on US jobs. Remember, we need to provide that first value of what we're actually grouping by, which in our case, we're gonna do that column of job title short. And we're grouping by the job title column, but we need to analyze by the salary. So inside of square brackets, I put the salary year average. And then finally, I can do the aggregation method. Let's just do something like count. Now, one quick note, this bracket notation right here is actually kind of optional in that I could do a count of all the different columns. So running this, we can see it provides basically the counts back for everything. But this doesn't necessarily work with all aggregation methods. Let's say I wanted to do something like run the aggregation method of min. What's it gonna do on something like a text column, like job title text column? Well, it's gonna throw an error. Basically, whenever it goes through looking for what is the less value using the less than equal to, it's gonna get an unsupported operation of string and float between the instances. And so like the job title column is a string, it can't get a minimum of that. This aggregation function can only work on numerical columns. So running it again on only the salary year average column, we can see we get it. Now, one quick note, this isn't formatted really how I like it. It looks like it's just a bunch of text printed on the screen. And we can fix that because whenever we pass this column of values that we want to actually aggregate, if we have to do more than one, we can do it in a list. And so even though there's only one item, I can provide it inside of this list here. And then whenever I get it back, it provides a much more user-friendly view that I can actually look at and feel more confident analyzing. Anyway, let's continue on. Remember, we want to do an aggregation of that salary column for multiple different ways. So we're going to use the ag method for this. And if we're only providing one aggregation method, we only have to provide one like this. But if we need to provide more, we need to put it into brackets to signify that it's a list. So in this case, I'm going to add min to this, and now I have multiple in here. Additionally, now I've added max and also count into here. And so now we have 4 different attributes of interest that we want to explore and have available now. Now, one last thing to do on this to clean it up. Right now, it's basically a hot mess. Like, where do I need to look at first? I typically like to analyze from top to bottom. And to me, the most important column of interest is the median one. So I want to sort these values by median. So I'm going to add the sort values method to this. And the first argument that we see is by. So we need to pass by what? What are we sorting it by? Well, we're supporting it by median. And median in this case needs to be defined as a string. Now I got this error message right here, specifically calling out a key error on the median value. Now, anytime I get these type of errors, and you will get them as well, all you need to do is just copy this error message, come over to whatever your favorite chatbot is, paste it in. Now, Gemini provided a solution that, I'll be honest, actually makes it more complex than necessary. Going with good old ChatGPT, it finds the error right away. And I can see inspecting the code, the problem has to do with how I actually put in the columns here. Let me show you what I mean. I'm gonna go ahead and remove this sort values, and I'm gonna run this again. So whenever we ran this and I provided this in a list for salary year average, you can see that it subsets the data even more. Whereas when I remove the list, it doesn't subset it to that other level. So now whenever I run the sort values by median, I get it back. You're gonna run into errors like this all the time with Python, so it's very important that you understand how to use the internet or chatbots to help you quickly troubleshoot and get through this. Now, I don't like how this is sorted, so I'm gonna adjust this. This has that we can adjust whether the ascending, whether it's true or false. So I'm gonna set this to false. And now we have all the median values put in the order exactly like we want it. And looking through this, you're probably like, Luke, this would look better if we actually graphed it. And to your luck, we're gonna do that. So with that, I'll see you in the next video where we actually jump into plotting with Matplotlib. Now that we master the basics of analyzing data, we're gonna be moving into actually visualizing the analytics that we're performing. And just like Pandas is the go-to source when cleaning up and analyzing data, Matplotlib is the go-to source whenever we're visualizing data. Now, the code for Matplotlib is made publicly available because it's open source inside of GitHub, but I don't really find much use out of this. Once again, I'm want to go to the documentation. We can go to matplotlib.org to get this. Now this library has a host of different visualizations we can use for this. I'm going to go in here under plot types. And the majority of visualizations that I find myself using are here inside of this pairwise data or underneath statistical distributions. If you ever need a reference for how to do something like say a box plot, you can just come inside of here and it provides you a simple code breakdown of how you should go about building these plots. Now the other major resource from Matplotlib, going back to that home page, are the cheat sheets. And you can access it on the left-hand side of the pane here, clicking on the cheat sheets. And particularly, I'm a fan of both these two up at the top of here. This one on the left-hand side goes into a lot of detail of all the different charts that are available. And then the second one is great for formatting, getting maybe colors and different orientations that you need for building your plot. Anything you build with Matplotlib is highly customizable, so there's a lot of things you can do, and you can make single visualizations that are 100 lines of code long. And by the end of this basics chapter, you're going to be able to go through and customize all the different things here that it's showing on what you actually can customize inside of a plot. So let's get into making sure Matplotlib is installed and importing it in. To see what libraries are installed, we're going to use that exclamation point and then type out pip list to get the list of libraries. Inside of here, we can see that Matplotlib is installed along with two other associated libraries of inline and ven. We're not going to worry about those for the time being. Now let's get to importing it in. So I can import in all of Matplotlib if I want, but even running this, I don't necessarily want this. Instead, I want a specific module out of Matplotlib, and I'm just going to show you where it is. You don't need to memorize this. But inside the lib folder, underneath the actual library of Matplotlib, we care about this pyplot module. That's what we want to load in. And it basically says that matplotlib.pyplot is a state-based interface to Matplotlib. It provides an implicit MATLAB-like way of plotting. It also opens up figures on your screen and accesses a figure of the GUI manager. So I'm going to copy this little example it has right here to just make sure after we load it in, it's working properly. So like we said, we want to import it in matplotlib.pyplot. Specifically, we use that dot notation to specify that within that Matplotlib folder, we want to access pyplot. And as we can see from the documentation here, it's commonly renamed as PLT. So I'm going to put that in as PLT and then run it. So we're going to create this X variable here where we're creating a list from 0 to 5 in 0.1 increments. And then for the y-axis, we're going to be plotting a sine wave. We put this inside of plt.plot, which we're going to go over in the next video. I just want to actually show and demonstrate that we can plot. Now, first thing I get is name error. Name NP is not defined. Silly me, I didn't import NumPy as well. So rerunning the cell above it and then below it, we get in the side of our Jupyter Notebook the actual plot itself. So I save it as sample plot on my desktop. And now if I want to share any of these visualizations with my friends, who probably don't care about it, but if they did, I could therefore go and give them this file. So now it's your turn to give it a try and import in Matplotlib, specifically that pyplot module. Also feel free to generate a visualization if you want to, but we will be jumping to that more in the next video. All right, with that, I'll see you in the next one. So let's actually dive into learning how to use this Matplotlib library of plotting by diving into a data analytical question. Actually, we're going to do multiple. The first one we're going to do is a line chart. And for this, we're going to be looking at what is the trend of job postings over time. For the second one, we're going to use a bar chart for this. And we're going to dive deeper into understanding how many jobs are associated with each of these job titles. So inside my Jupyter Notebook, if you haven't done it already, you're going to be pip installing the datasets library. From there, importing other libraries. Specifically, don't forget, we need to import now Matplotlib and that pyplot module as PLT. From there, load the data and done the data cleanup. We're going to start with a simple example first. We have two variables here, X and Y, which we'll use appropriately for each axis. And they're both lists of numbers, 1, 2, 3, 4, basically so we can have a straight line. So we want to plot this. Well, for this, according to the Matplotlib documentation, we're inside the pyplot module. We have this plot function available. It plots Y versus X as a line or markers. So this is great for line charts or scatter plots. So what do we need to pass into this? Well, we have this star operator and then args, which is an unpack operator. And actually reading down into the documentation, we can see that it's commonly referenced that we're going to be passing x and also y to that. So with that plot function, I just add in x and then also y. So as expected, we get provided back this line chart, which basically graphs 1, 2, 3, 4 against each other. Now it also prints up these numbers up here and this about the object itself. If I wanted to get rid of this, I could run the additional method of plt of show. And this is going to remove that from it. So from time to time, you're going to see me include it, or if I'm lazy, I'm not going to include it. Also, to prove that I'm not completely lazy, inside the documentation on the show function, it says that, hey, it displays all open figures. So it's made to actually display those figures, whether in a Jupyter notebook, or if you're running that from a Python file. That's where you're actually going to more commonly see it. Scrolling down, they have this note that it auto shows in Jupyter notebooks. And the Jupyter backends call show automatically at the end of every cell by default. So it's not necessary, and it says thus, you usually don't have to call it explicitly there. But if you're using something like ChatGPT or Claude to get answers, you're going to commonly see that they show this show function. So let's now jump into actually printing some actual data. And we're going to just start with a simple one first of the job posting dates. Just as a reminder, running the head method on job posted date, we can see that this includes not only a date, but also a time. Now let's go ahead and just plot the date values from this entire data frame, and we're going to just plot it against each other. So we're going to get a straight line. And we start by defining that plot function, and then we define the x and also y, which we can just use the data frame itself. And so it's sort of repetitive here. I have the job posted data as x and the job posted data as y. But we still need to get to our final goal of plotting the job postings over time. So what we need for this is we need to perform some sort of aggregation in order to count how many job postings are happening relative to that job posted date. So with our job posted date column, we can run the method value counts on it. And this is going to provide for each of the date times a count of the different job postings at the associated date time. Now let's save this to a variable, and we're going to call this date counts. And before we plot it, I just want to show that date counts, we did this operation on a data frame, but it's no longer a data frame. It's now a series. We're going to talk about more about that in a minute. Anyway, let's actually plot this. So we pull in plt.plot. For this, we have to provide the x value and also the y value. Now, if I go ahead and actually pull up date counts again for us to inspect it. So what we have on the left-hand side for this series is actually the index. These values on the right-hand side are actually the core portion of the series. So this 12, 10, 10, 10 is actually what is the date counts. So for this plt.plot, I can run date counts. And for the x-axis, I want to use that, basically that job posted date. So I'm going to specify the index. And like I said, the date counts of the series, the core of the series is the values of these counts right here. So technically all I have to put in is date counts. Now running Shift Enter, we get this hot mess right here, which has, you can see the dates are in order right here, and then the different counts are up here, but it's going all over the place. And that's because whenever we inspect this series of date counts, we can see that the index column is not in the numerical order or in that actual chronological order that we need it to be. Matplotlib is not going to sort it automatically for us. We have to actually sort it before providing it to us. So for date counts, I can provide it that we want to actually sort this index. Specifying date counts again, I could provide the method of sort index, running this, and then running right below it. We now have, as we can see here, based on the year dates, we have it in actual chronological order. Finally, actually plotting it. Boom, still a hot mess, but the lines aren't going back and forth. So why is this a hot mess? Well, if we inspect, right, we can see that we have the date times as the index. And sometimes there's a few seconds, multiple seconds, and we just have these values of like 1 for each. We just did see before we had like 12 or 10. Anyway, the aggregation we're doing here is not correct. We need to do something where we either aggregate it by day, week, month, or even quarter. We're going to go about aggregating it by month. So I'm going to specify a new column name in the data frame of job posted month. And I'm going to use the job posted date in order to calculate this. Specifically, I'm going to use the .dt accessor, so date time, and call out that we want to have the month attribute of this. Running this and then calling the data frame, we can see now that job post month is added and it has it in a numerical form for that month. But similar to before, we need to perform the value counts and also sort it. So with a new variable of monthly counts, I set it equal to the data frame or the column of job posted date, and then I'll run the value counts method on it. Additionally, for this, I want to sort the values because it's going to be coming in an unsorted order. And so I'll provide itself back to it and provide sort index. So let's see what we get out of this when we print it out. Okay, I already messed up because I put job posted date in here. We need job posted month. What am I doing? All right, now we have what we want. We have the months in the order that we want them, and then the counts of this as well. So let's get back into plotting this. We're going to run that plot function from our pyplot module, or PLT. And for the x-axis, I'm going to provide the monthly counts, and I want to provide the index for this, for the x-axis. And then for the y-axis, I can just provide monthly counts, the entire series. And bam, now we have something that's actually usable and we can get insights of it. We can basically see that January, as expected, has a surge of job postings at the beginning of the year, new budgets, a lot of people coming in. And so they're trying to get people at the beginning of the year. And then it sort of evens off for the rest of the year. Now with this monthly counts, I call it the index and then I provide the series itself. But we can actually access the values inside of there by providing it .values. And this is going to provide us exactly the same plot as we had before. It's a little bit more robust in the amount of information we include in it. You may see it from time to time, so I just want you to be aware of it. But now let's understand better about what is this series going on here. So we've been primarily focusing on using data frames, which are a core component or object inside of Pandas. But Pandas also has this other object called a series. A series is, if you think back to NumPy when we had a 1D array, this is effectively what a series is. I can create a series by calling pandas and then running series on it and passing it a values of data. So this is, in this case, a list from 10 to 50. And it prints it out 10, 20, 30, 40, 50. I can also with this provide the argument of an index. So previously it's numbered from 0 to 4. When I add this list of A, B, C, D, E, it updates to that A, B, C, D, E for the index. And then if I want to access that series index, well, first I need to set it to a variable. So I'll assign series equal to this. And when I type series.index, I get the index values back. And when I want the values, I type series.values. And I get the values back, which provides it back as an array. Now, whenever we provided previously, when we plotted the job posted date versus job posted date, we were effectively providing this plot a series, if you will. I mean, as you can see up here, it even says it's a series. So a column of data within a data frame is also known as a series. And so you've been familiar with this before, but we've more explicitly using series now. So I want to just make sure that we understand the differences. So moving on, we now have mastered how to make line charts. We need now move into making bar charts. And for this, we're going to be plotting how many counts of different job titles we have. If I inspect the job title short column, we can see we have things like data analysts, scientists, engineers, and there's 8 different job titles within it. We want to aggregate this similar to just like we did before, and we can do this by using, once again, that value counts method. Probably a method you need to have to memory. And this provides us back a series of these different counts. Let's go ahead and actually assign this to a variable. And I called it job counts. So now we need to plot this, and conveniently Matplotlib has this bar function. In it, we're going to be providing 2 values. So X and then also the height. And as we can see from documentation, really fancy here, it says makes a bar plot. So calling the bar function from our pyplot module, I'm going to specify that job counts index. And then also provide in the series itself of job counts. Now this thing is also a hot mess, right? Because if we look at these job titles down here, they're overlapping each other. And if we wanted to, I could run the head method on this and actually sort it down more so where we only have 3 of the jobs. And then when we actually plot it, we can actually read all the different values here, but we're going to actually just do something different. Instead, I want to use this bar h function, which is for a horizontal bar plot. And similarly, you provide it the values of y, and in this case, width. So all you have to do to our original formula is change that and add an h to the end, running Shift Enter. Bam, we now have all these things. And if you notice with this, it's in descending order. So I don't really like this. We're going to fix that in a second. Anyway, I want actually more values in this. Now that it's in a horizontal manner, we can bring back all those job titles. I'm going to remove that head here and then rerun everything below it. All right, now this is better. We have all of our different jobs in there, but it's not in the order that I want it. And this is because Matplotlib in a horizontal bar chart starts plotting from the bottom and then upward, which if you think of it makes sense because whenever we're plotting something like a normal bar chart, we're going to start on the left-hand side with data analyst. In this case, that says data analyst, sorry. And it's going to go all the way to the right. So it plots it similarly closest to the x-axis and works in reverse order. Anyway, there's a real simple fix to this. With job counts, what we can do is we can sort the values. And in this case, we want to set ascending equal to true. Running this again, nothing happened because I didn't set it to itself. And we finally got the plot that we want. And as a reminder from the beginning of this video, from the plot we started with, we could also run that plt.show function at the very end. And what that's going to do is provide just the visualization back to us. And we're also not going to get that extra text there. All right, so now it's your turn to give it a try and jump in, get your hands wet, actually playing around with how to plot different series and also data frames. So with that, I'll see you in the next one. All right, so we need to do some cleanup. Now, you noticed from the previous section that it takes a lot of time in order to get the data in a correct manner to plot. And I'm gonna also spend almost as much time on the latter end actually cleaning up the plots once I have this data. So remember the plot that we had for the counts of different job titles. Here we're doing it in the vertical chart right here. Anyway, there's a lot of problems with this. As we can see in the x-axis, we can't distinguish what the names are. What does the y-axis even stand for? Why isn't there a title? There's so many things that need to be cleaned up. Well, in this section, we'll be going over all those different things on how to actually clean up a visualization and make it presentable so that way you can share with others. So inside my notebook, I have the standard install of the data set. You already got this by now. Now, what you need to have is the data so that way we can work with what we're going to plot here. Specifically that job counts series. And what we did was we took that job title short and did a value counts on it. And then finally, just run that bar function on it using the index, the series itself, and then showing it below. Let's do something simple like adding a title. Well, inside the documentation under that PyPlot module, we have this title function available. And all it does is set a title. For what we need to provide to this is just a label. In our case, we need to provide a string to it. But let's actually look at an example of how this is implemented by scrolling down here and going to this first one that it has. So the title of this one is mask and non-data. And if we scroll down to the code that it has for this, we can see that the title was implemented right here. Now, I want you to ignore the majority of the code up here. It's not really important. What I care about here is notice how we've sort of like stacked all the different things that we want to maybe do to this. In this case, you can probably figure out we added a legend to the plot. Also, we added a title and then we showed it. We didn't define a variable and go about it in an object-oriented approach. Instead, Matplotlib enables this, what you call a stateful approach. So I can just stack up all these different commands that I want to provide for it. So in this case, I want to run this title function on it. And I named this one postings by job title. Anyway, this type of approach, this stateful approach, if you've worked with something like MATLAB before, this is a common way that they program in there, and it's how you're going to do it here. So now whenever I run this, it combines all these things into the current state, if you will, and applies it to this figure right here. And if I'm going to come down and maybe start a new plot, those attributes or what I've actually assigned to it are not going to be applied to that new plot. It's only applied to what I've run the code on right there. So now that I know that, let's add some other labels and documentation to this. I'm going to provide a Y label for this axis. With PLT, I had to run the Y label. And similar to the title, I provide a string. And I'll call this count of job postings. All right, so now that the y-axis is in order, let's actually get this x-axis. This thing is a hot mess. We need to clean this up. Now, if you're curious about what are the names of the different parts of a chart, if you come here to the cheat sheets and come to this intermediate one, it breaks down the anatomy of a chart and basically explains, hey, this is the y-axis label, x-axis label, these are minor ticks, these are major ticks, this is the grid, this is the legend. And frankly, the way I found doing about customizing plots is using something like ChatGPT to ask it what to do. Because if I'm in Matplotlib and I'm like, hey, I want to format the x-axis labels, if I type in x-axis labels, run this, I'll be honest, it provides me back basically to the PyPlot library. It doesn't provide a lot of good information, at least to search. So inside ChatGPT, I can provide something like this. How can I format the x-axis labels on the graph to be about 45 degrees? I want to slope them. And I also typically like to provide the code so that way it could just update it for me. With this, inspecting the code that it provided, I can see that it provides basically plt.xticks, and then this rotation argument provided to it of 45. So I just insert that right on in and press play. So now inspecting the chart, I can see that the labels are at a 45-degree angle, but there's something going on here where they're not aligning properly to the tick marks. This would be very deceiving for somebody if we gave it to somebody. So there's a way to fix this. One way is we could go about just providing it back to ChatGPT and ask it to help. But I would normally encourage you, if you can, to go back to the documentation and see if there's actually anything in there, because you may learn some things actually digging in the documentation. Unfortunately for us, there's nothing there. But I learned from ChatGPT that there's this special argument we pass to it of HA, or horizontal alignment. And for this, we're going to pass the value of right. What it's going to do is align these values horizontally, either to the left or to the right or center if you want to provide that. It was trying to do, I think, center in this case. So whenever I rerun this with right on there, it updates this chart to be more aligned with what I would expect, with the names itself at the very end aligned right on that tick mark. Everything looks good for this. I really like this one. If I wanted to, I could go ahead and save this image and hand it out to all my friends. All right, so now it's your turn to give it a try and get in there and actually practice this by cleaning up some problems that we have for you. As always, do take use of stuff like ChatGPT and Claude to help you with cleaning up these visualizations. You'll learn a lot from doing that, but I highly recommend don't become over-reliant on them. Make sure that you're still coding out the majority of it so you're getting familiar with what you need to know. All right, with that, see you in the next one. So don't be mad at me, but I kind of lied to you. There's a slightly easier way to plot using pandas, but I wanted to make sure that you understood Matplotlib first before introducing you to this basically shortcut. So let me show you what I mean by jumping right into this. Just like before, we've imported all our data. If you haven't done it already, pip install datasets. And then we're still looking at the same example from the last video. So where we performed that count of job titles short, and then we went through and actually plotted this into a bar chart. So now, ignoring all that formatting for the time being, we're going to just focus on the core code here itself. And that is, for this PyPlot module, we're using this bar function on it in order to specify the index and also the job counts. I'll be honest, this is kind of annoying to have to remember in this case, right, that I have to access that index value or the property of job counts. And then what do I put here, job counts, or do I need to include values to actually get these as well? Well, inside the Pandas documentation for both series and also data frames, it shows we have this plot function. Here's the same exact one for data frame as well. Remember, we've been working both with series and also data frames. We're just going to stay here on the data frame page because basically everything below this is very similar. So with our data frame or series, we run this plot function on it. And then we can provide this star args or star quargs, which is basically saying we can provide multiple different arguments to it because we're using that unpack operator. These are the actual parameters right below it that we can provide. The ones we care about are this: X and Y, which are the labels or the position that we want to use. So if we're using something like a data frame, we can just provide the string value of the column. Now, this is pretty cool. What I really like about it is this kind portion right now. No longer do I need to memorize all these different functions for different plots. Instead, I can just specify via string value all these different plots. So let's actually do this on job counts. And we're going to run the plot method on this. Remember, job counts is a series. Now, because of that, I'm not going to need to provide any X or Y value. All I need to do is provide the kind, which is equal to bar. Now running this, we get this bad boy, which not only is it much less code, but also these axes, we can actually read them for once. They're not overlapped. Personally, comparing this to the last code that we have of this right here, I think this makes it a whole lot simpler. And if we want to change it to something like a line, we just put it in and run Shift Enter. And now we have it. I don't recommend using a line chart for this. We're going to be using a bar chart. And now you're probably like, Luke, what about all that formatting that I worked on before? Well, everything that we did before still carries on. It still is basically using Matplotlib in the background, specifically that pyplot module. So I can still go through and specify all these different things that I want to happen on the figure. Now running this, I have everything updated. Although we can see now that I have this X label down here of job title short, I want to remove that. So I'm going to just specify with the pyplot module for the X label, I want the values to be an empty string. Running this again, we can see we removed it. So that was for job counts, which, just to reiterate, that was of the type series. Now let's see how this is done on something like a data frame, which we have that already with df. Now in this case, with the plot method, we're going to need to provide that X and Y parameters because our data frame has multiple different columns in it. It needs to know what to use. And specifically for this, I want to plot over time using the line chart how the salary is trending over the year in 2023. So with our data frame, we can run that plot method on it. And then we're going to first specify the X value, which in our case is that job posted date, providing it as a string value. Next, the Y value of that salary year average. And then finally, what kind of chart do we want? Well, we want a line chart. Running this ends up giving us this line chart, which I'll be honest, doesn't provide a lot of value, but we can see that the values are fluctuating based on the axis here. I can see it's around, well, it's less than 200,000. That's what that's signifying right there. And it's showing the dates from the beginning of the year to the end of the year. Anyway, this example is mainly just to demonstrate that you can do data frames. The data frame in our case has over 700,000 values. And so we're going to get a lot of noise in it. We would want to take a similar approach of actually breaking this down maybe on a monthly basis and then plotting it. I'll leave that for you to do. We're not going to do that for the time being. The more important concept is you understand now how to use series and data frames. All right, so now I got some practice problems for you to go through and practice plotting with Pandas now, which basically implements Matplotlib. And I'm curious to know, which ones do you like better? Do you like using Matplotlib or do you like using Pandas? I'm going to be flipping up through the remainder of this course on what I'll be using, basically which is actually easier I'll be using in that case. And so I want you to be aware of it since I will be changing around. With that, I'll see you in the next one. So to wrap up this basic sections, we're going to work on a problem that works towards solving our final project. For this, we're going to be calculating the median salary based on the job title itself, so we can better distinguish between high-paying and low-paying roles. And frankly, you can use this to determine what role you should be aiming for based on salary. So inside my notebook, I have the standard import of the libraries, loading the data, and then finally it's cleanup. So we want to aggregate the job titles, or basically group them. So we probably know the best method for this. It's going to be group by. Calling out df.groupBy. I then pass in, what do we want to group? We want to group the job title short. Now, what do we want to run an aggregation on? Well, we want to do this on the salary. So using square brackets, inside of here, we specify salary year average, the column for our salary. And finally, we need to call our aggregation function, which in this case, I said we're going to do median. So running this on it, we get this series returned, which has all of these different things in here. Notice they're out of order. I'm going to add one more method onto this of sort values. Running this, we now have it in descending order from lowest to highest. Okay, great. Now you're probably like, Luke, why are we running the median and not the mean for these salaries? And to that, I would say that's a great question. What I'm going to do is run this code, which is basically exactly the same as below, except now I've changed this to mean or average. Now, I'm I'm gonna give you a second to think about it, but look at how these salaries compare to each other, especially the ones in the lower brackets here. With the exception of the senior data engineer and senior data scientist, these values are lower than the average. So in order to show this better, I went ahead and plotted a histogram on the distribution of the salary itself. And there's the code up here. We're going to go into this more in the advanced section for a lot of the special functionality that I did right here. But anyway, I wanted to just show this histogram for the time being. Anyway, if you're not familiar with the histogram, it's showing the number of counts of something at a certain value. So in this case, for the salary of around 100,000, we're seeing around 6,000 jobs that have that. Now, the key thing to note here is this goes from 0 all the way up to 1,000,000. And that's because there's a high number of outliers up here. In this region, greater than 600,000 or even greater than 400,000. Anyway, these high outliers, if we were to use the mean as we showed up here, it drags this average number higher. It doesn't necessarily reflect a value that's more representative of what I'd actually see as a salary. So in the case of data analysts, it says the average is 93,000, but if I'm actually job searching, I'm probably going to more see around 90,000. And actually updating this graph to show where the median and mean fall, we could see that the mean is slightly right due to how this data is skewed. Anyway, enough theory on actual numbers here. Let's jump back into actually plotting. So back up here with our series, I'm going to actually create a variable to save that to of job salary. And with that, we can run, as we learned previously, the plot method on this since because it is a series. And I'm going to specify for this, I want to use a horizontal bar chart. So this is looking good, but I want to clean up some more. So I've added the X label of the salary and denoted that, hey, this is in US dollars. For the Y label, I don't think it's necessarily necessary. So okay. I don't think it's that necessary. So we're going to go ahead and just put an empty space right here to remove it. And then I put a title on the top of it. So now we get something that's actually usable that we're comfortable with now sharing with our friends. And we can now start to analyze some trends of our data. Specifically, senior roles, especially for the data scientists, data engineers, and data analysts, are all paid more than their junior roles, as expected. And we're confirming this with the data. Additionally, to my surprise, machine learning engineers and software engineers are actually getting underpaid or less than data scientists and data engineers. So it pays to be in the data field. Data analysts aren't far off of that, and they're not last, so that's one good thing. And then from there, we're followed by cloud engineers, and lastly is business analyst. And this makes sense with the data analysts and business analysts because business analysts typically have less technical skills than data analysts. All right, sweet. So we got a head start on our project now before we jump now into the advanced section, where we're going to be now leaving from Google Colab and working on your own personal computer. With that, see you in the advanced section. All right, welcome to the advanced chapter, and I'm breaking out a different flannel for this portion of the video. Anyway, for this, we're going to be running for the entire chapter and also for the remainder of this entire video. We're going to be going through and using Python locally on your own computer. And we're going to be walking through the setup for both Windows users and Mac users. They're pretty much the same, but I want to make sure that we cover any differences. For this video, we're going to be focusing on installing Python through the Anaconda distribution, walking you through all the different steps required in order to get it set up, ready to go, so we can start coding. In the next video, we're going to be going through setting up our code editor of choice, which is Visual Studio Code, along with the workflow on how to use this editor for your Python workflow. So why are we running Python locally now on our computer by using something like Google Colab in the cloud? Well, there's a few different pros and also cons. First, data privacy. If you're working with confidential or even protected data like HIPAA data, this ensures the data doesn't leave your machine and you don't have to worry about compromising it. Next is the learning aspect. You get a lot of experience setting up and understanding deeper insights into how Python works by doing this. Third is the cost. Although Google Colab is free, if you use it enough, you do have to start to pay for it. If you have a computer, it's already sitting there, so it's technically almost free. And finally, this doesn't require internet access. Therefore, you can work on it wherever you go, even on a plane. Now, there are some drawbacks. As we saw from Google Colab, cloud setup is a lot easier. There are no installation steps like we're about to have to go through. Also, managing Python environments can be a pain in the ass. That's a separate subject. Next, this provides you access to high-performance computing that you may not have access to currently. Depending on how shitty your computer it is, it may actually be a better option to run in the cloud, vice locally. And the third reason, which is probably most powerful, is that collaboration is a lot easier in the cloud. Multiple users can work on the same project at the same time, and you don't have to worry about having conflicts. Now, you may have concerns that you have a strong enough or powerful enough computer to do this. And my recommendation is if it's built within the past decade, it's probably more than powerful enough to power Python, because Python doesn't take up a lot of resources to use when you're running it. But if you still have concerns, or if you run into any issues during the setup, you have some alternate options. First is Lightning AI, which provides a VS Code-like environment inside of your web browser to use. They have a free tier available that would allow you to complete the entire course. One note, there is a current waitlist, so you need to apply now if you want to do this. The other option is GitHub Codespaces, which, similar to Lightning.ai, provides a fully configured secure environment. This option is completely free for up to 60 hours a month, which I think you can complete the remainder of this course in those 60 hours, so you could do it for free. Now, if you decide to forego installing Python and using VS Code and running it locally, that's your option, you can do that, but I'm not going to be providing any support on how to use things like Lightning AI or Codespaces. I'm only going to be providing this option. Now, during this install, if you run into any problems, I highly recommend that you go to something like ChatGPT and you paste in this error message, and it's going to guide you through what you need to do. It's a lot quicker than putting in a YouTube comment that you're having this issue and then praying that I'm going to come and actually answer it. I would do the actual ChatGPT instead. It's going to be a lot quicker, and it's going to help you in the long run with understanding how to use this. So let's get into the Anaconda distribution install, which is going to install Python into your computer. We're going to be using both a virtual machine of Windows and of macOS, so that way if you're using one or the other, you know what to do. Don't worry if you don't understand virtual machines. That's not really the important concept here. I'm just mainly have this here so you can see how to do it in each. The first thing we need to do is verify if Conda is installed in your system. For both of these, I've just created both of these environments of the Windows and also the macOS, so there's a fresh install. So there should be nothing installed in them. To verify if Conda is installed on your Windows machine, you're going to go in to search and type cmd and open up the command prompt. With this, you're going to type conda info. For these users, you should get this message saying Conda is not recognized as an internal or external command, operable program, or bash file. This basically means Conda is not installed. However, if it does provide back information on Conda, then it's installed and you don't need to install it. Similarly, on a Mac, you're going to use the Spotlight search, so press Command space, and then type in terminal. From there, you're going to pop up your terminal. Inside terminal, you're going to type the same command of conda info. What you should get back is a command not found conda, or something similar to this. In that case, conda is not installed. If it is, you can forego the installation of Conda. So open up your favorite web browser, whether on Windows or a Mac, and go to anaconda.com/downloads. They want you to provide an email address for this distribution. If you don't feel comfortable doing it like me, just go in and click skip registration. Your operating system of choice should be selected, so you can go ahead and click download for Mac. For us, we can select Intel or Apple Silicon. I have an Apple Silicon. So I have the M1 chip, or actually M2 chip, so I'm going to install with that. For Windows users, you don't have this option. You're just going to select download. I'm just going to get to downloading. Once the packet is downloaded, you're just going to go and double click it to launch it. And you may get a warning message saying this will run a program to determine if the software should be installed. Sure, allow it. Now for both of these on Windows and also on Mac, they're going to walk you through now the install process. We're going to keep the default values the same for all, and so it should be pretty similar. We'll click continue. They have this long document that you probably should read if you had a lawyer, and I'm going to click continue. Same thing with the license here. You should probably be reading this, but we're going to go ahead and click continue as well. For Windows, it's going to ask you if you want to install just for me or all users. Just for me is recommended, so just go with this. And it's going to specify this folder of underneath your root folder, Anaconda 3. We're going to go with that as well. These are the default selections that it came with. I'm going to just go ahead and click it and now click install for Windows. For Mac users, it's a little bit different. It says, hey, do you want to install for all users of this computer? Because it's going to store it up at the root location for this Anaconda folder. This is perfectly fine. I would go ahead and go with it. I'm comfortable with that. It warns you it's going to take 4 gigabytes of space. That's fine as well. And then you have to go ahead and enter your password to begin the install. In Windows, once the installation is complete, I'm going to click Next. It's going to tell you something about coding with Anaconda in the cloud. And we're going to skip that for the time being by selecting Next. And then I'm going to go ahead and just enable this to launch the Anaconda Navigator, which is the GUI, upon finishing this. And I'm going to unclick this because I don't need it. For Mac users, it just says the same exact thing about coding in the cloud. Sure, I'm going to continue. And then there's nothing else to click. I'm just going to go ahead and click that, close this. It then asks, do I want to move the installer to the trash? Yes, I want to do this. And during this time also, it did pop up with Anaconda, the basically GUI interface on Mac. So don't be alarmed if it does that. Inside both Windows and Mac, you may have this pop up. They say there's a newer version of Anaconda Navigator available with strong manual update. Do you wish to update? Yes, I do. And I don't know what, we have multiple pop-ups coming up here, but do you want to quit the Anaconda Navigator? Don't show me this again. Yes, just quit it. Update now. I'm going to do the same thing on Windows. And do you want to allow it to update? I'm going to quit Anaconda. Oh my gosh. And click Update Now. And anytime Anaconda is asking you to update, just go ahead and update it. It's always great to have the current version updated. Once it's updated, we can go through and actually launching the Navigator. Do this on both Mac and Windows. So that completes the setup for both. Now you have this Anaconda Navigator, which you can access through your applications. But I'll be honest, I don't really use this app so much, so we're not going to really go through and actually tour this and understand how it functions. We're going to be using other methods. But I do want to verify that Python is installed. So on Mac, if you still have your terminal open, go ahead and close that out and then start it back up. It needs to be restarted. On Windows, you need to do the same thing and close out the command prompt. We're going to use a new, basically, terminal inside of Windows, specifically when you're using the Anaconda prompt. And you can just find it by searching for Anaconda prompt. To see if Python's installed, which should be, we're going to type in Python and then tac or dash and then version. From here, we can see that Python 3.11 is installed on our system. Running this on the Mac, we don't have to use Anaconda prompt for this. That's why I love Macs. Anyway, it says that Python 3.11.7 is installed as well, so we're good to go. Also, if you notice on both of these, they now have inside of parentheses this base, which you can see here also in your Windows machine under base. This references to the environment that you have Python installed in, which we're going to be going into more on environments and using that in the third video of this chapter. But for right now, I just want you to be aware of that. So if you've been following along as we did this in this video, we're done with this. And we're now going to be continuing in the next video on actually installing a code editor so we can actually get to coding instead of typing things like Python version and only find out the version, which is completely useless. Okay, with that, I'll see you in the next one. So now that we have Python installed on our computer, we need to now jump into installing a code editor to use and actually run this Python code. Now for this part of the install, there's not a lot of differences between the Macs and the Windows. So I will call out if there are from time to time, but other than that, we're just going to stick with one operating system. Now we could run Python from a terminal or the Anaconda prompt by just typing in Python. And then we have these 3 dashes right here. I can give it a command. So as a test, I have it print, "What's up, data nerds?" And it outputs that. But we don't want to be doing our coding right here inside of this prompt. Instead, we're going to be installing VS Code. But why is that? Well, according to the 2023 developer survey, which actually interviewed 90,000 different developers, not only did they identify that based on programming, scripting, and markup languages, that Python is the 3rd most popular language out of them, with almost half of respondents voting for this skill. But in regards to the integrated development environment, it wasn't even close. Visual Studio Code, which we're about to install, was by far the most popular IDE to use for coding. And it's free, and I've been using it for years, so we're going to go ahead and use it. So if you go to this URL, it provides you the download option to download it either for Windows or for Mac. Click your appropriate installer. Once it's downloaded, open it up and accept the agreement. And it says it's going to put this into the program files. That's perfectly fine to put that as a location. And it wants to know where to place the shortcut. I'm just going to keep everything default and go to next. Here I'm going to leave the default selected. If you want to, you can create a desktop icon. And then from there, I'm going to click install. After the install, I'm just going to click finish, which will go ahead and launch automatically. Back on my Mac machine, I promise there's not a lot of differences. It automatically just went ahead and installed it. I don't think we're not going to have to go through any sort of setup. Yep, it just automatically launches. So you're not going to have those pop-ups and go through and all those selections like all those Windows users. For Windows users, they do have this basically walkthrough of what you need to do to set it up. I'm going to just skip that for now and click Mark Done. So now that we have VS Code installed, we need to connect this basically editor to Python. And we can do this by installing an extension. If you come over here to the left-hand side in the activity bar, I can come in here and I could search Python, but actually it's just going to pop up as the most popular. I'm going to click install or installing an extension. And this is ultimately going to allow us to connect to Anaconda or Python that's running locally. So I'm going to click install and it's going to go through and set it all up. Once again, it's going to have some setup that you can actually walk through for setting up Python and everything like that. I'm going to just skip this for the time being and mark done. I'm going to also close out these extensions. Okay, now that we have Python extension installed, we still haven't connected the two, so we need to connect it. So we're going to open the command palette by pressing Command, or in a Windows, Control-Shift-P. For Mac users, Command-Shift-P. And I'm going to type Python select interpreter. From here, it should pop up with that Python 3.11.7 base version that we saw before. And you should see some sort of file path like this of Anaconda 3/Python-exe. This is for Windows users. For Mac users, very much similar, but it's going to be in this location of OPT, Anaconda 3 bin, Python. And I'm going to select that as well. Now we need to verify that we've actually set it up properly and Python is now running. I'm going to click New File to create a new Python file. And I'm just going to select it here. I'm going to create a simple Python command that prints "What's up, data nerds?" Real original, I know. Now you've noticed up in the right-hand corner, we can run this Python file, but we need to save this first so that we knows where to access it. So I'm going to click Control-S if I'm on Windows, Command-S if I'm on a Mac. And I'm just going to save this Python file here and call it test.py. And conveniently up the top, tells me the save location. So let's get into running this now by coming up to the right-hand corner and selecting Run File. It's going to run it right below here in our terminal. And inside of here, it's specifying to basically use Python or the Python.exe file that we have installed through Anaconda, and then run this test file, which when it runs this, of printing this statement, it prints it right below this. Mac users should see the same thing in their terminal window with the specifications that it has before, and then printing out "What's up, data nerds?" So there's no longer really any more differences between Windows and Mac, so I'm going to be staying in Windows for the remainder of this. We can go ahead and close out of your test.py file. And now we need to create a folder in order to store this project for the remaining exercises and the final project that we're going to be building. So I'm going to click here to open folder. You need to save this project folder to wherever you feel most confident doing this. I recommend saving this in like a documents, or on Mac, you have a developer folder. For me, I'm just going to put the folder right here and I'm going to name it Python_data project. I'm using these underscores by spaces because it just makes it easier programmatically to access it later on. Anyway, I'm going to save it. And now we're going to select this folder. It's going to ask you if you trust the authors of the files in this folder. I'm the author. I mostly trust myself. So now that we have that project folder set up, let's do a quick walkthrough of VS Code and how you should be using it. Up at the top is a menu. I feel like that's pretty self-explanatory. Over on the left is the activity bar. First, we have the Explorer, which allows us to get to our different files. If I wanted to create a new file inside of our Python data project, I click that new file icon, and then I type in something like test.py, and it's going to create a Python file. Inside of here, I can pipe some code, and then if I want to, I can go and try to run this file. I don't know if you saw that, but VS Code automatically saved this file before running it, which is pretty nice. Anyway. The next thing is a search thing. So we can go in if we wanted to search for different keywords we may have used. We can find that we use that print statement in their test.py file. Next is source control, which we're going to go into a lot more detail when we get into the project. So just keep that in the back of your mind. There's a debug panel right here. I don't use it as much, especially when I'm working with Jupyter notebooks, but it is available if you're working with Python files and need to debug it. Next is extensions, which we're going to get to next. And also testing if we want to configure or do any tests. I'm not really using that much. Let's go back to those extensions. So remember, we installed Python. I can come here, I can see that based on this, like we could uninstall if we don't want it. But you can install any extensions that you want located in this extension marketplace. So another one that you're going to need for this is Jupyter. And this allows us to run those Jupyter notebooks. So I'm going to go ahead and click install. And once again, like all of these, they have some sort of walkthrough that they'll let you do. I'm going to click Mark Done and do it myself. So now I can come inside of the Explorer, create a new file, I'll call it test, and name it 𝗕𝘃𝗰𝗀𝗶 and run enter to create the new Jupyter notebook. Now, if you can't remember that extension of 𝗕𝘃𝗰𝗀𝗶, you can go to the command palette and type in Jupyter, and you just select here of create new Jupyter notebook. So now I have this Jupyter notebook, which if you remember from Colab, it's set up very similar. It's telling us which environment we're in, base, which we're gonna go more into environments in the next video. But we can go ahead and run some code and test it out right here inside of here. So running a simple print command, I can go ahead and press play. Now I get this pop-up for Windows security saying, do you want to allow public and private network access to this app? And I'll be honest, sometimes with Jupyter Notebooks, I do connect, I run APIs and stuff and connect to public networks or private networks. I'm gonna go ahead and select and allow both of these options. Functionality is gonna be really limited if you don't allow this, but I'm more than confident that it's safe to do this. Anyway, getting back to our prompt, it printed, "What's up, data nerds?" And I just confirmed, run this on a Mac, you shouldn't get this error. Now with Jupyter Notebooks, they put a lot of functionality available right up at the top of here. You spoke before about how we can create code and then also markdown cells. So I can turn this into something like a heading. Now, one cool thing about this though, is say I make a mistake and I actually don't want this a markdown file, I can select it right here, and then I can just reselect what I actually want it to be. In this case, let's say I want it to be a Python file, and this is actually a comment. They have options to run all or to restart your server if you want to. And then if I had some sort of variable like x equals to 1, I could then open this variables and see inside of it very easily all the things I different have. All right, so that wraps up the install of VS Code, which you should have been following along. If you want to now, there's no practice problems or anything for this, but I would actually go through and check out these extensions and see if there's any ones that maybe you want to install. I like this one right here of VS Code icons. So from selecting install, I also select what file icon I want to use. Anyway, now whenever I create folders or something, say I create a SQL folder, it will actually modify it. I don't know if you saw that. I'll do it again. When I make something like a SQL folder, it will add a little database on top of it. So it actually changes up the icons and make them look pretty cool. Another one that I like is Rainbow CSV. And I'm gonna go ahead and install this one as well. When I open a CSV, I got an example one in this case, it goes through and for the columns at the top, you can see like job work from home, it has the same color and I can actually follow it through. Now with that Rainbow CSV, it's still a little bit hard. I also like Edit CSV. I work with a lot of CSVs, you can tell. Back to that original CSV I have this option now if I want to edit a CSV. It puts it into sort of like a similar Excel format where I can actually go through and then if I wanted to, I could actually change different values in here. And then from there, I can just apply changes to file and save. All right, so the only problems for this is for you to dive into those extensions and maybe install some extra ones that you want. If you find any ones that you think are useful, feel free to drop in the comments below. In the next video, we're gonna be jumping into virtual environments and using Conda to navigate that. And then after that, we'll be jumping into some more advanced concepts using Pandas and Matplotlib. All right, with that, see you in the next one. All right, I'm not gonna lie, virtual environments can be a tough concept in order to grasp what is going on here. And these virtual environments allow us to have these individual, if you will, isolated environments of our own Python versions and all the libraries and packages supported for maybe a data science project we're working on. And if I decide to work on another data science project, I can create another virtual environment for that project. And so it keeps these two projects, if you will, separate. So we'll jump into more theory at the end of this, but I think the best way to learn is to actually play around. So to manage these virtual environments, we're going to be using Conda, which comes part of the Anaconda distribution. Now, Conda provides a lot of documentation for this, which I can go into selecting Conda above here, and they provide a whole user guide for this. The one thing that I find myself gravitating to is this cheat sheet here under the user guides. And opening this cheat sheet up, it provides all the different Conda commands that you need to know in order to manage virtual environments. So where the heck are we going to run these Conda commands? Well, you run these inside your terminal. Here in a Mac, I can run something like Conda environment list. And it provides a list of all the different virtual environments I've created. Right now, we only have this base environment, which is located in this folder location. And as you can see right here on the left-hand side, base is the one that was activated right now that we're using. Similarly, on a Windows machine, I can use that Anaconda prompt that was installed and run the same command in order to see this. Well, with VS Code, they provide an even easier way to access the terminal right inside your coding window right here. You come up to the menu at the top and select New Terminal. Or personally, I like to use Control-tilde, which is right there, right next to the number 1 key. Pressing this, it's going to pop up a terminal window right at the bottom of this window. And once again, I can run this command to list all the environments in here. Right now we have base. So we're going to walk through pretty quickly how to create a new virtual environment. And then we're going to actually set one up for the course. So you can just watch this first part if you want. So first thing, I'm going to create a new project, if you will, and I'm going to open a folder. And I'm just going to create a project on my desktop and call it delete because I want to delete it later. I'm going to open this. If you get a warning about trusting the authors, you're the author. Yeah, I trust them. Then inside of here, I'm going to create a Jupyter notebook. So I'm going to just name it test.ipynb. Now with this notebook, currently, as we can see in the upper right-hand corner, it's using the base environment. We want to create a new environment. And so I brought up a terminal at the bottom and it brought it up in base. And the nice thing about VS Code is that basically, as it says here, the selected kind environment was successfully activated. Anytime we create new environments, the terminal should automatically connect to that and connect to the right virtual environment. So I don't want to see this again. I'm going to click Don't Show Again. So we're going to run this command up at the top for creating an environment with a specified Python version. So write conda space create. And then I'm going to write a tach n, and this is a flag to signify the name of the environment we want to create for this. I typically name this the same as the project I'm working in to know that they're coordinated. So I'm just going to name this delete because we're going to be deleting it. And then from there, we're going to press a space and we're going to call out Python and then specify the Python version. Current Python version that's stable is 3.11, so that's what we're going to go with. Now it's identified that it needs to not only install Python, as it has right here, and the following packages will be downloaded, but also a bunch of other different packages that may be necessary. At the bottom, it says, do you want to proceed? And it has Y or N. The Y is default, so I can just click enter and it will start downloading them all. Now that it's all downloaded, it says, hey, to activate this environment, use conda activate delete. And then whenever we're done, we can deactivate it by using conda deactivate. So I'm going to go conda activate delete. Delete probably wasn't the best of names for this because it's probably confusing to you, but we're going to just go with it. So now we can tell by inner terminal that this delete environment is activated because of it's over here now in parentheses. Previously we had base for this command when we ran it up here, but now we have delete. But this is only in our terminal right here that we have this activated. Up here in our Jupyter notebook, we're still under base. So we need to change that. So I come up in here and I select this. And as we notice, delete is not appearing in here. Sometimes VS Code needs a quick reload in order to understand that it actually has this new environment available. So I'm going to go to the command palette by pressing Command-Shift-P or Control-Shift-P for Windows users and type in reload window. And then go ahead and select enter to reload it. Now it's detecting kernels, but now it noticed whenever I got here that there's probably multiple ones. So it has me now going through and actually selecting the kernel. Now when I do this, it says, hey, do I want to connect to a Python environment or existing Jupyter server? We're not using Jupyter servers, we're using Python environments. And then inside of here, we have our base environment, which we saw before, but now also that delete one is popping up inside of here. Now with it activated, let's actually test it out. And when I print what's up data nerds, it runs this saying, running with this requires the IPY kernel package. And the IPY kernel package is the package required for Jupyter notebooks to be run. And so you do want this. So I'm gonna go ahead and click install. I'm also gonna close out of this terminal window, but down at the bottom, we can see that it is installing it from Conda Forge, which is basically Conda. Anyway, we have it printed up now and it printed out below. Looks like Python's running fine. Now, another command that you need to know is conda list. If you remember from Google Colab, we used pip list in order to list the packages installed. For this, we're going to be using conda list. Anytime that I have a bunch of stuff inside my terminal, I can just type clear and it will automatically put me up to the top of the terminal. I like doing that. Anyway, running conda list, it goes through and lists all the packages in the environment of delete. And there's a whole host of different packages installed within here, specifically Python 3.11.9. All right, cool. I'm gonna clear this out. Now, like I said, I don't wanna keep this environment. This was just a practice to show you. I wanna actually delete it now. So to delete it, we're gonna use conda remove, then the name flag, provide the name, and then say all flag to basically delete everything inside of it. So conda remove, we'll specify the name of delete, and then we'll do the flag. It's 2 tacks and then all. Okay, we're gonna get an error message with this. And it's gonna say, hey, you cannot remove the current environment. Deactivate and then run conda remove again. So you can't be inside of an environment and delete it at the same time. Sort of makes sense. So I'm gonna run conda deactivate. Anytime I deactivate, I'm gonna go into the base environment. So we're back inside of base. I can run inside of here conda environment list to see a list of all the different environments. Right now we have base and delete. And now I wanna run that remove command. Anytime you've run commands previously, you just press the up arrow and I can cycle through all those different ones. I'm gonna cycle exactly to the conda remove one, and now I can run it. And it's gonna say, hey, remove all packages in the environment. The following packages will be removed, pretty much all of them, or actually all of them. And by default, Y selected, so I'm just gonna press enter. And then from there, it says everything found within the environment, including any kind of environments and non-conda files, will be deleted, which is perfectly fine. No is the default here, so I need to specify yes, and bam. So clearing this out and then doing conda environment list, I can see now only the base environment is there. All right, so the only thing left to do is now just get rid of this project right here. So whenever I close out, I saved it to my desktop. All I have to do is just move it to trash. Now that we mastered the basics of how to use conda environments, now let's go through and actually set up the conda environment that we'll be working with for the remainder of this project. With VS Code, we're gonna open back up that project that we created in that last video. I saved mine under documents, so I'll open it up. And I'm gonna create a new Python notebook, if you don't have one already, called test. And this is IPYNB type file. Now up in the right hand corner, we can see that it says select kernel, which is where we need to select our environment. Right now, if we navigate into the terminal, we can see that using conda environment list, there's only one environment base. So I'm gonna create that new environment by doing conda create, that name flag, and the name of Python. I'm gonna go with course. I know I typically said the project, but that's too long. We're just gonna go Python course. And then I'm gonna specify the version of Python that I want. As of the filming of this video, I recommend going with 3.11. 3.12 is available, and I'll get to why I'm not using that at the end of this. Now I can also specify any other libraries I want to install during this. So let's also install Pandas during this. Yes, do I want to proceed? Yep. And the last thing to do is just copy the statement of activating the environment and pasting it right here. So now we switch from base to Python course. I'm gonna go ahead and close this out. We don't need that. So now inside of Jupyter Notebook, I need to select that environment, go into Python environments. And right now Python course isn't appearing. So I'm just gonna go to the command palette of Command-Shift-P and reload this window. Let's try again. And now we can see that Python course is available. Running a simple print statement of what's up data nerds. It prompts me as usual, I need to install also the IPY kernel library. I could have done that whenever I created this environment. I was a little lazy, forgot to do that. So now that's working. Let's test to make sure that Pandas, in fact, did get installed. We'll go ahead and close out the terminal window here. And we're gonna import Pandas as PD. Running Shift Enter. Awesome, all of it loaded. Now, if you recall, for when we were working in Google Colab, we had also these other import statements of from datasets, import load dataset, and then also import the pyplot module from Matplotlib as PLT. If we go and try to run this right now, we're gonna get an error message, right? That the module is not found, specifically it's gonna flag on that first one of datasets not found. Opening up the terminal using Control-tilde, I can confirm that these libraries are not installed by running conda list. And scrolling through it, we can see that we have Python in here and we also have Pandas, but there's no datasets or Matplotlib installed. Well, except for this Matplotlib right here, but that's not the full one that we want. So we'll go ahead and clear this. So just like we did that pip install, we're gonna do conda install. And before you install anything, make sure you're in the correct conda environment. We're in Python course. We don't wanna be installing this into base. So back to our command, we have conda install. We're gonna add datasets. and Matplotlib. We just add these and separate these by spaces. You can add as many libraries as you want. Running enter. It asks if I want to proceed. Yes, I do. All right, and it finished the load. So I'm gonna clear that out and close out this terminal. Now let's try to run this again. And it looks like we loaded both these. I'm just gonna confirm real quick by generating a quick little plot of a list of 1, 2, 3, 4, and bam, there we have it. So now we are all set up and ready to go to get back into the advanced section and start actually programming. Now, I want to conclude this with one final example to demonstrate the importance of why we need these virtual environments, specifically here, this Conda environment, in order to manage and maintain these packages. So right now, using Conda list inside our environment of Python course, we can see that Python 3.11.9 is installed, which is what I'm recommending as of filling this. Now, prior to this, I found an error if I tried to use the most recent version of Python. And let me show you what I mean by that. So first, I'm going to get out of this Python course environment, and I'm going to go do this by saying conda deactivate. And we're going to be creating a new environment with the most recent version of Python. So we're going to do conda create. We'll name this, for convenience, Py312. And for this, we're going to install the most recent version of Python. And previously I was doing the equal to 3.11, but technically I can just leave it blank and it's going to install the most recent version. I'll show you this. And so when we look at what's going to install here for Python, it's installing Python 3.12. Anyway, continuing on to actually install this. The environment has been created. We are in the base environment. I'm going to now activate this Py312 environment. I'm going to clear the console, and also I'm going to switch to that Python 3.12. It's not appearing, so I'm going to reload the window, and I'm going to select another kernel, Python environment, Py312. Okay, so now it's inside of here. As I expect, okay, I didn't load the IPY kernel again. Sorry about that. Probably should have done that default. You should probably do that default. I think we're getting the picture here. Okay, so it runs just fine of What's Up Data Nerds. As expected, it's going to fail whenever we try to do pandas and also try to run these libraries. I'm actually going to put these on the same line. Sorry, put them in the same cell. We'll try to run them again. They're not going to run. Okay, we need to install these packages. So we're going to do conda install pandas, datasets, and also matplotlib. Asking if I want to proceed. Yes, I do. Okay, so the packages are now installed. Let me go ahead and clear this out and then close out of that. All right, so now we have this installed. Now I'm going to go try to run this. And unlike the previous time when we had Python 3.11, we're getting this attribute error. Specifically, we're running into problems with the from datasets import load datasets. We can see this by it's the first thing that's causing this issue. That's what the arrow is pointing to. And then these troubleshooting logs go through each step. And we basically have this attribute error, read-only attribute issue. Well, diving into it, what is happening is this datasets library isn't necessarily fully compatible just yet with Python 3.12, specifically a lot of the different dependencies of it. Like I think I looked up something like the library PyArrow. Yeah, right here, PyArrow isn't functioning properly. Anyway, this is a perfect example of why kind of environments are so important. If for some reason I wanted to test out some new features in 3.12, because 3.12 has Python 3.12 has new features, I could create a new environment and do it separately from this project that I have to use Python 3.11 in order to get all my libraries to work. So it maintains these completely separate and you don't have to worry about conflicts. If I want to, all I have to do, I just go back to like my Python environments, go back and select Python course. And then whenever I run this now with Python 3.11 with the same libraries installed, it runs just fine. So as you can tell, I'm really passionate about understanding how to use these virtual environments and making sure that you're setting them up properly and using them. Friends, don't let friends not use virtual environments. So now it's your turn, if you haven't done it already, to go through and set up your content environment for the remainder of this project. We also have some practice problems to get you used to using Conda in the terminal, so make sure you take use of that Conda cheat sheet. With that, see you in the next one. We're diving back into pandas. See you in the next one. So in this advanced chapter, we're going to start getting into actually diving into a lot of the problems that we're going to be solving for our final project. So we save a lot of time when we get there, don't have to do a lot of work. Because of that, in the beginning of this video, we're going to go over a quick overview of a lot of the different problems and insights we're going to eventually solve. And then finally moving into a new method of accessing data beyond just using that .ilock method into the .lock method. So here I am with VS Code open. I have the project folder of our final projects in here. I'm also going to go ahead and just select this entire thing and create a folder, as you should, for this advanced section. Also, if you want to, you could create a new folder for that basic section that we just went into, and you could put all those different Jupyter notebooks inside of this folder here, because we're going to eventually get to uploading it to GitHub and it could show all your work. For any of the work that you did, all you have to do is go to that notebook and then from there select File. And then down at the bottom it has Download. You want to download the Jupyter Notebook version. Then with your notebook or notebooks downloaded, you could just go and drop it into here. And not only is it right here right now, but it has all the different work that you did from there right inside your own editor. So diving into a quick overview of what we're going to be solving with our final project. For this, you're going to be the perspective of an aspiring data nerd looking to analyze top paying roles and skills in the field of data science. I'm going to be analyzing all of this from the perspective of a data analyst from the United States, but you can adapt this to your need. Not only can you select what job title you want to use for this, which we identified these different 8 ones back in the basic section, but also I have a host of different countries you can choose from. For the first problem, we're going to look at what are the most demanded skills for data analysts. And we'll be building a visualization to show the % demand of a certain skill for not only data analysts, but also senior data analysts, be able to compare them to each other. Next, we'll move into how in-demand skills are trending for data analysts. And for this, we'll be evaluating how they trended over 2023 for the top 5 skills. Once we understand that, we can then dive into how well do jobs and then the skills pay for data analysts. In the basics chapter, we actually solved this first part by analyzing what the median salary was for these different job titles. But now we're going to dive deeper into data analysts specifically to evaluate the top trending skills on what their salary is. And a little spoiler alert, Python's one of the highest. And then finally, we're moving into our last visualization of what is the most optimal skill to learn for data analysts. For this, I wanted to look at not only what a skill is paying, but also how in demand is a skill. So for this, we're going to be using a scatter plot, and we're going to break it down further when we get to this chapter. All right, enough of me yapping about the project. Let's actually get back into learning pandas and learning Python. I went ahead and created this new Jupyter notebook. I'm titling it 1 Pandas Accessing Data. I just use this nomenclature of this 1, as you can see from these folders here, 1, 2, 3. So that way it gets organized automatically. Also, you're going to notice from my screen whenever I start a new Jupyter cell that it has this of press Command I to ask GitHub Copilot to do something. Now this is because I have GitHub Copilot installed, which is an AI coding assistant. I don't recommend you using it just yet, but I just want to be aware about why this says this on my screen. If VS Code hasn't done it already, we need to go ahead and select our kernel, specifically using that content environment of Python course. Now, just like we did in Colab, we needed to import all our libraries, so pandas, datasets, and Matplotlib. We need to then go and load our datasets from load datasets function and then put it into a data frame. And then finally do that one data cleanup that we're doing right now of cleaning up the job posted date, converting it to a date time. Loading this, it takes about 36 seconds. I'm not gonna lie, I'm on a pretty fast internet connection here, and I have an M2 chip in my MacBook right here, so it's pretty fast. So those speeds may not be typical to what you may see. Now I keep on getting this warning message down here of this TQDM warning of iProgress not found. Please update Jupyter and IP widgets. This is basically a display that shows a progress bar underneath your loading. It's pretty fancy. You can go ahead and do this if you want, but if you don't, it's not a big deal. You're just gonna have this warning message. Warning messages are not that bad. Now inside my terminal, I ran conda list. And inspecting it, not only do I not have Jupyter, but I also don't have IPY widgets. So I'm gonna run conda install Jupyter and IPY widgets. It asked me if I want to proceed, I do, and it finished installing it. So running this again, and finally this one's going to be a little bit faster because we have the data set, and we no longer have this warning message. All right, like I said, that step is completely optional if you want to, but now I don't have the warning message, and I like that better. So previously we learned that if we wanted to look at maybe the first row of our data, we could use that ilock method, and then from there using square brackets, we could use an index-based notation in order to look at it. So in this case, I'm looking at the first row or 0, and we have it displayed back. If I want to display the first 10 rows, so 0 to 10, remember 10 is exclusive, running this, we have all of our data back from those first 10 rows. Now the one drawback of this, if I want to get maybe the first column back in this, I have to use the index notation of this. So in this case, 0, running this, we get the results underneath it, and it's not too bad. But let's say something else. Running it back to show the full data frame. Let's say I wanted this job work from home column. I'd have to go over 1, 2, 3, 4, 5, 6. And then remember that, right? It's a 0-based index. So I'm going to do 5 right here. And then we get it back. I think that was correct. Yeah, job work from home. All right, we were correct. Whew. So that works fine. Let's go back and look at that data frame one last time. Now let's say I want to actually include multiple columns. Specifically, I want to look at these 3 columns right here: salary rate, salary year average, and salary hour average. This is a mess to try to count over, Tom, and try to figure out. And that's where the .lock method is way better. So on our data frame, we now run .lock, and we still use that same annotation method using those brackets, where the first part specifies the row index and the second part defines the columns. Now, if you remember from our data frame itself, this index is index notation, if you will. And so we're still going to use that number notation for the .lock method. So when I specify this .lock of showing the first 10 rows of 0 to 10, running this, we have the first 10 rows. So that's not much different here because we have that index notation of using numbers already. But when we get to defining our columns, we can not only define it by using something like the name itself, so salary rate and our condition, but we can also define multiple columns and use that slicing method. And from now, identify I want to go from salary rate to salary hour average. Running this now, bam, we get now all these columns back. Now this is a bunch of non-values right here, which is pretty useless for me for actually interpreting this. So let's actually first filter it to include more values. And for this, I just listed a colon to just basically select all the different rows. And then from there, we want to drop non-values. But specifically, I care about dropping it for the salary rate, because if it's a salary yearly average, there's year in this column. And if it's salary hour average, it'll have hour in this column. So basically, I just want to remove the columns or the rows that say none. So I specify subset equal to salary rate. Running this again, bam. Now, like I said, we got all our different values. So we can actually see a slice of the data itself. So now it's your turn to give this .lock method a try. And that drop NA that we just covered is actually a sneak peek into what we'll be covering in the next section on cleaning up data sets. But for now, I want you focused on the problems that you'll have to do, which are focused on the .lock method. With that, I'll see you in the next one. So we have a mini little project we're going to work on in this section of data cleanup. Specifically, we need to clean up our data frame. And for this, I have a coworker that wants access to this data, but they have specific requirements. First, we have around 3,000 data salary points. However, the data set's around 700,000. So this coworker wants those non-values or not a number values filled in with something like a median value. Additionally, after we fill that in, they want us to go through and remove any duplicate job entries. So that way they can go through it, look at jobs, and then if a salary isn't there, they can see what the median or expected salary is for it. One quick note on this data cleanup, everything we do is not going to be necessarily applied to the final data frame that we're going to be working for in the final project. This is more of a case of showing how you can use functionality to clean up data sets. So for this and all the follow-ons, I'm not going to say it every single time, but I created a new Jupyter notebook inside of my number 2 advanced folder. And I've gone ahead and imported in libraries, loaded the data, and done the data cleanup of the date time. Make sure that you have the correct Conda environment selected. So in the last video, we learned about using that .lock method and that we can actually use the name of either rows or in this case, columns to filter data set and see it. And when we dived into it, we found that there were a lot of non-values in here. So we're going to be filling it in with the median values. And this is actually pretty typical in something like machine learning. If there are missing values, you could go through and fill it in with median, and then you could train models on this. So let's calculate the median values. First, we're going to do this for the salary year average column, and we can run just the median method on this. Running Control Enter, it's around 115,000. Similarly, I can run this on the hourly average column. And this is one that's around $46 an hour. I'm going to set both of these equal to a variable so that way we can use it later. So these variables are now saved. Now we need to get into how are we actually going to fill in these non-values without replacing the current values that are in there. Well, Pandas has this fill_NA method. And the first thing you need to specify it is value. One note down here, they got a deprecation warning, so you should always pay attention to that, but that has to deal with the method, which allows you to do some sort of forward fill or backfill. We're not gonna be going into that, but if you're curious about that, they have special other methods for this that they include right here. So let's get and filter it. But anytime I go to modify a data frame, I like to keep my original one intact. So I'm gonna create a new data frame called df_filled, and I'm gonna set it equal to that original data frame that we have. And we're gonna specify how we want to fill in this for each one of the columns. We have to do each one of the columns individually and run the method on each. So I'm gonna specify the salary year average column, and then I'm gonna use .fill_NA method on this. Now the first thing I pass to it is the value. So I calculated the medium salary year up here. So I'm gonna go ahead and just paste that right into here. Running Control Enter to see those first few values, and I can basically see it got filled in. But we haven't set it equal to its value itself. So if we actually ran to look at this column, we would see that it's still none. So I'm gonna go ahead and set it equal to itself and run Control Enter. Cool. We're also gonna do this for the hourly column as well, which is very much similar syntax of changing the column names, and then also that variable here of hour. Running Control Enter. And so now inspecting the data frame of filled on those different columns, we can go in and see that it filled in with these medium values. So the first thing that we need to do for our coworker is done. Now we need to move into the next step of drop duplicates. Well, as you guessed it, we have a method for drop duplicates, and it returns a data frame with duplicate rows removed. Now this also allows you to specify column labels, but we're not going to specify that just yet. So I'm going to create a new data frame of df_unique and set it equal to that data frame of filled. Now with this data frame of unique, I'm going to remove those duplicates. So I'm going to run the drop duplicate method on it. And inside of it, like I said, we're not going to specify anything inside of it. Running Control Enter, we can see we have around 787,000 or that many rows. But how many rows did we actually drop while running this? Well, what I did is typed out this code in order to compare the length of these different data frames. So first we see the filled data frame length, then the unique, and then finally it does a subtraction of the filled minus unique in order to see how many rows were actually dropped. And right now there's no rows dropped. That's because when I did this drop duplicates, I didn't set it equal to itself to actually save it back to whenever it does this. So running it again. All right, now we have 109 rows removed. And this means in this data set right now, there are 109 duplicate entries. And that's based at looking at this entire data frame and finding out where there's repeats and assuming all the lines in one is found in another. I'll be honest, this is pretty impressive that we just went through 780,000 rows in 0.7 seconds and found all these duplicates that quick. Now for dropping these duplicates, we didn't specify a subset or we didn't specify a column. We could go further, and we are actually going to go further, and select certain columns from here to then use those columns specifically to filter for if there's any duplicates. So based on what I know about the data set, I want to filter actually based on two things. First is the job title column, which is very much unique. As you see here, we have like data analyst, and the job title is data analytics. And then down here we have data analyst, but then we have manager of data analytics. So it's a very unique thing that we can actually filter on. Additionally, I don't want to filter out all the data engineers just because we match on this one data engineer. So the other column we're going to look at is company name. So that way we're dropping repetitive jobs from the same company. So we're going to continue to use that unique data frame that we created up above. And once again, we're going to run the drop duplicates method on it. This time in here, we're going to specify the subset. And we're going to set it equal to a list of those column titles. So specifically of job title and also company name. And then to actually show what work we did, I'm going to copy these print statements up from above and paste them down below. So now let's actually run this bad boy. So now based on this, our original data frame is around 787,000. The drop duplicates is around only 500,000. So we dropped almost 280,000 probably repetitive jobs from different companies. And with my experience of looking into this data set, there's a lot of companies that will sometimes spam job boards with repetitive jobs. So this is a good way of going through and cleaning it up if necessary. So now it's your turn to play around with this drop duplicates and .lock method in order to manipulate these data frames and clean it up. I have some practice problems ready for you. With that, see in the next one, we're going to dive deeper into not only cleaning, but also managing different data frames. In this section, we're going to be focusing on two important functions that I use all the time for data management. First, we're going to go over the sample method, which is pretty straightforward. And then we're going to cover the copy method, which, although it looks easy on the surface, it's a lot more advanced. So let's get into it. So inside my notebook, I've imported all the libraries, loaded the data, and cleaned it up. If you remember before, we could use methods like head in order to see the first 5 rows in a data frame. And then if we wanted to see the last 5 rows in the data frame, we could use something like tail, and that's going to provide these. But I'll be honest, this isn't necessarily representative of the data set itself. And so like in this case, the end result has mostly Germany postings. So there's not necessarily a true sample of the data. So similar to those methods, we have the sample method, which returns a random sample of items from an access of objects. Just like head and tails, we can specify the number to sample, or we can even specify something like the fraction, a float, how much of the fraction of the data to return. So running this method on our data frame, we get back just, well, one result. I'm going to put in, I want to get 10 results back. And now we have a sampling result. So we can tell this actually by this index over the left-hand corner, as it's very varied on which jobs are returned. So this is super useful to use. And every time I run this, it's going to provide new jobs within this sample, as we can see from this. So if you have a certain example that you find through your sample, you can output the same results every single time by setting this random state. So I'll specify that random state, and we're going to set it to a value. We'll just do 42. Now, whenever I run this, the same results are going to return every single time. So we don't have to worry about any variation in what we're returning back. Just a little fun fact, if you're ever running through code and see this 42 pop up, which you will from time to time, this comes from the book, The Hitchhiker's Guide to the Galaxy, and it's the answer to life, the universe, and everything. Just a little programming humor. Next method cover is copy. And if we run it on something like a data frame, it makes a copy of the object's indices and data. So we're going to start by creating a new data frame called DataFrame Original. And all it's doing is loading our inner data set into that. And then we can just inspect it to make sure that I'm not lying to you. And from this, it has the 770,000 rows along with all the different data inside of it. So copy creates a copy of the data frame. But you may be like, Luke, why do I need to use this copy method when I can do something like this, where I'm creating this new data frame called DataFrame altered, and it's equal to the original. And then if I were to print out the data frame altered underneath this, running Control Enter, I can see once again has around 787,000 results, and everything's in there. So what's the purpose of this whole copy method? Well, let's go back to that example that we did previously, where we filled in that salary yearly average data that was missing those non-values with median values. So if we inspect the altered column, we can see that, as expected, most of them have non-values in it. There's looking at the first 5 rows. I'm going to start by calculating that median salary and setting it equal to basically the median method of that salary yearly average column of the altered data frame. Looking at the results, we have it at 115,000. Now, with that altered data frame, I want to fill in those non-values in that column. And I'm going to set it equal to itself. And I'm going to fill the NA values with that median salary. And then finally, we're also going to print out those values right below it. Okay, so we can see that those non-values previously are now filled in with that median value of 115,000. But what about our original data frame? Technically, those should still be non-values. But whenever we inspect it, we actually find that the original data frame actually got updated just as our altered data frame did. And I'll be honest, this is not a good thing, because technically I could have multiple different data frames that I've done multiple different calculations on, And I wouldn't want those calculations on one data frame to affect the other. So why is this happening? Well, it has to do with the fact of how we assigned df_altered equal to df_original. When we use this assignment operator, the data frame original had a data frame in it that had a unique ID. This new data frame altered was also set equal to that same data frame. And that's a bunch of theory, so let's go ahead and actually prove this. So with our original data frame, we can run something that we've shown you before of that ID function. And this returns the identity of an object itself, which is a unique ID number. So if I look at the ID of df original, it's this number. And if I look at the data frame altered ID, it also has the same number. And if I'm too lazy to go through and actually compare number by number, I can use the comparison operator to find out if it's true if these two IDs are equal to each other, and it is in fact true. So these variables are referencing the same data frame. So let's actually show this in action. I'm going to recreate or reload the data set so we have this unique ID for our data frame original. From there, I'm going to now create that altered data frame again, and I'm going to set it equal to df_original. But this time, I'm going to use the copy method with it. All I got to specify is copy, open and close parentheses, run it. Now I made these fancy print statements where I show the ID of the original, the altered, and then comparing the two. And with this, we can see that the altered data frame is different, and it also confirms this with the comparison operator, saying that it is false. And now whenever I go through and calculate that median salary to then be placed within the non-values of salary year average column, it's done correctly on the altered data frame. And then for the original data frame, this one is unaltered. So from here on out, you're going to notice us using this copy method anytime we need to create a copy of the data frame and do some sort of operations on it. And this is basically to protect us, to make sure that we're not causing harm somewhere else. All right, so now it's your turn to test out that sample method and also copy method with some practice problems I have for you. With that, I'll see you in the next one. If you've worked with either Microsoft Excel or Google Sheets pivot tables, then this section of the video is going to feel right at home. Whenever we get to the project section, we're going to be using this pivot table method in order to analyze what are the trends of skills over time. And pivot table function makes this super easy to do because of it. However, there's still a little bit of cleanup we need to do before we can get to that. So in the time being, we're actually going to be forming a pivot on something else. Specifically, we're going to be looking at the top 3 jobs of data analysts, data engineers, and data scientists, and how the median salaries trend across the 6 most popular countries in our data set. And pivot tables make this super easy to make. So inside the Pandas documentation, we can see that we have this pivot table method for data frame. And there's 4 key parameters we're going to be using for this video: values, index, columns, and ag function. We're not going to overload you with all 4 at once. Instead, we're going to focus on just 2 for right now, specifically index and ag function. For the index, you provide a column or column name, and that's what we're going to be grouping by. And then for ag function, that lists the aggregation function like min, max, size, whatever that may be. So in a new notebook, I've gone in and imported all the libraries, loaded the data, put it into the data frame df. Let's run the pivot table method on this. And we're only going to focus on 2 right now. Specifically, I want to get the count of the job titles. So I'm going to start by specifying the index, which we're going to use that job title short, and then that ag func. For this, I'm going to specify size because we want the size of the job title short column. We're not going to do count. So running this, we get back what we expected. Now you may be like, Luke, I could just do a group by on job title short and also run that size aggregation function, then actually running this. And for this, we get the same exact results. I'm just going to stick with group by. Well, bear with me for a second while we learn even more. So now let's say we not only want to group by that job title short column, but we also want to aggregate it to get the median yearly salary. Well, in this case, we need to add this values parameter in order to specify the column or columns to aggregate. If you had multiple, you can provide it as a list. So with that original formula that we had before, I'm pivoting using that job title short and getting the size of it. I'm just going to add values to the front of it, specifying salary year average. And then for the ag func, I'm going to specify median because we want the median salary. But now you may be like, Luke, I could do the group by method on that job title short with the salary year average column as the column that we're going to aggregate and run that median method on that. And we'd get back the same results. Granted, this comes in a series, but I could make it into a data frame. But we get the same results nonetheless. And to that, I'd say you're correct. But this final one, group by, can't necessarily do it with a single line of code. We're going to now be calculating what is the median salary for these different job titles, but broken down by country. And this brings us the last parameter to cover, which is columns. This is the keys to group by on the pivot table column. And just so we're clear, index was what we group by on that index column. So by rows, columns is what we're grouped by on the columns. So just modifying our original pivot table formula that we had previously, I'm going to add in columns here, and I'm going to specify job country. Running Control Enter. I have a mistake right here. I'm missing a little parentheses. Pressing Control Enter. We have it back. And this has it by countries up at the top and the job titles along the index. I'll be honest, I don't really like wide tables. I like long tables. So what I'm going to do is I'm going to move around these index and also columns. I'm just going to have them trade places. Running this again because, like I said, index is for the rows, columns is for the columns. We've now transcribed this, if you will, and have the different job titles up the top and then the job countries in the bottom. I feel it's a little bit easier to read, although there's 103 countries to go through now. So recall, this is the graph we want to make now. We want to aggregate and find the top 6 countries along with plotting data analysts, data engineers, and data scientists with their respective median salaries for each of these countries so we can compare it. So in order to find out what those 6 top countries are, I'm just going to do a values count on it. And we can see it organized by this. So I'm going to only do the top 6. And then finally for this, I don't really care about those values from this. I care about the index column from this. So I'm going to do the dot index on this. And we return back the index in an array. So now for that pivot table we just built, I'm going to set it to that variable of df job country salary. And we need to go ahead and filter this data frame that we pivoted and get out those countries. So for this, I'm going to set it equal to itself. And in order to identify what index values we're going to use, based on, remember we got these index values and they're like a string, we can filter this using the .lock method, which is pretty cool. So I specify in here top countries and then printing it out right below it so we can inspect to make sure we've done this correctly. Bam, we got the top 6 countries. Now I want to filter the job titles to include these 3 specific job titles. And all we're doing in here is basically filtering the columns that we want from this. Because of that, we don't need to use any type of iLock or lock method for this. Instead, we're going to just pass in that list inside of here. So job titles. Running Shift Enter, we can see now, bam, we got this. So all that is left now is we need to plot it. So we can run this plot method on it, specifying the kind equal to, I want it as a bar chart. So running this now, we get, zooming out, we get this bad boy, which is pretty impressive. I mean, look at this, 1 line of code. And because we pivoted into a pivot table and have it, and Pandas understands how to plot it, it plots it super simply. Now, I do want to clean this up a little bit by specifying the X and Y labels, the title, and then rotating the tick marks. But then running this bad boy, I get something that I'm super proud of. With this, we can do some trend analysis with it. Right now, I'm finding countries like India and Germany have some of the highest paying jobs for data analysts, engineers, and scientists, although it looks like Germany slightly tops it out. Not gonna lie, this is pretty tempting for somebody living in the United States to move back to Germany. I've been there before, loved it, so may strongly consider it. So pivot tables can save you a lot of frustration and make it super simple in order to graph insights you get very quickly. Now, one note, you could have potentially done this with group by running a for loop, basically aggregating all the different job titles and all the different countries. That's a mess. Pivot tables saves you from having to even write more lines of code and makes your job easier, so take use of them. All right, we got some practice problems for you to dive into. With that, see you in the next one. So far, we've learned a lot about how we can manipulate data frames, either to filter it and then also do things like pivoting it. And when we do operations like this, it kind of jacks up our index. And so we need to know certain methods in order to fix back our index. So jumping back in, we have our standard code for importing libraries, loading the data set, and then also performing data cleanup. Inspecting the data frame using the .sample method that we learned previously, we can see the index is over here on the left. It doesn't have a name, and then everything's off to the right. But this index is obviously numbers. Let's inspect it more. We can use df.index, which accesses the index attribute. And it tells me it's a range index going from 0 to the last number, and it's stepping by 1. Which makes sense. Although I did sample here, we could also do head and show that, yes, it is in numerical order, just like this range index is claiming. Another attribute we can look at is df.index.name to see what is the name. And there's nothing here. It's blank right now. Now, attributes are basically just a variable assigned to a particular object. In this case, the data frame. So name is technically just like a variable holder. So if I wanted to, in this case, I could assign a name to this attribute of, let's say, job index. Running Shift Enter and then printing out the data frame below, we can see that we now have basically a new line inserted in here with job index on here. And we can go further now and actually investigate the items. Another attribute we can look at is the data type. So I can use df.index.dtype, and we're going to get returned back that this is an int or integer because these are integers in here for this index. So now that we have that refresher out of the way, we're going to be focusing on diving deeper into these three methods, specifically reset index, set index, and sort index. And we're going to go through explaining it in our data frame. So let's jump in explaining it, starting with reset index first. So let's say I want to create a new data frame that it's filtered for jobs particular to the United States. So I create a new variable called df_USA, and I set it equal to our data frame, filtering it for under df, and then the job country, setting it equal to the United States. So running this and printing it right below, I can see that yes, it in fact did filter for the United States, but we have a problem here. The job index here doesn't go in iterations of 1 by 1. Now, because we've extracted out some of these countries, we have missing values in here. So we can use the reset index method for this. And as expected, it resets the index. Now there's a host of different parameters we can use this, but we're going to focus just on the in place. And that's whether to modify the data frame rather than creating a new one. Right now it's set to false. We're going to set this to true, so we just don't have to create a new variable. So with our df_USA data frame, I can type in reset index. And then inside of here, I'm going to specify in place equal to true. And then I want to run it right below it. So I'll put this in and bam. All right. So now with this, we've kept our job index in here, but now we have this new numerical index. We can see it goes down to right here to the end of 2,600 rows. So it has what we want in this as a reset. Now, technically we could go through now and drop this job index, if we will, but I would actually argue that I'd want to keep it. Let's say in the future, when we learn about something like merge data frames and I want to use an index to merge it back, I could then use that in this case. So I'm going to keep it for the time being. The next method to look at is set index, and it sets the data frame index using an existing column. So we can take an existing column, just move it over to the index. Now for that recently altered data frame, let's say for some reason I wanted to go back to that job index. Really, we can go to any column, but we're going to go back to job index. So I can specify a data frame using the set index method. And the first thing to specify is the keys. Specifically, in this case series, we're going to specify that column title we want to set as the index. So I'm going to call job index here. Similar to before, I'm a little lazy and I don't want to put that variable at the beginning of this. So I'm going to just say, hey, in place equal to true. Now, so really now I was going to do this on the original data frame. We want to do this with the USA data frame. So running this and then printing it out right below it to actually inspect it, we can see that we now have that job index back in here. And inspecting it, we can see that it just drops what we previously had up here, this index column that was not named. It just completely drops it. So something to think about whenever you use this method is that we lose data sometimes. The last method to cover is sort index. And for this, it returns a data frame sorted by a label. In this case, we don't need to necessarily specify the index because, well, it's sorting the index. Now, with the operations we just did on our current data frame with DataFrame USA, these values remained in order. So sorting the index here, I don't really find ever a use case for it. However, I do find use case for this whenever I'm pivoting or grouping data. Specifically, let's look at this previous example we did where we pivoted the job title short column to find the median salary, and then also added in the mid and the max. Running this cell, we can see that, in fact, the index is job title short. There's all these different values in it. Now, we could sort by the median values, and we saw this previously using the sort values method. For this, I can call median pivot, and then use the sort values method. First, we'll need to specify by, and this actually has two levels of column titles of median, and then next of the salary year average. So I actually need to provide this as a tuple of median, and then salary year average. Running this, we can see that we get this, but we get in descending order. So instead I can specify ascending equal to true. That's a joke. Ascending equal to false. Had that backwards. Okay, so now we have it in ascending order. Anyway, that's just to demonstrate how to do median. Well, similar to this, we can use now the sort index method in order to sort these values. So I specify that median pivot and then do sort index. And then running this, we get these values sorted, and they're sorted here in alphabetical order. If I wanted to make sure that we actually modified the current data frame that we have, I could once again use in place and set it equal to true. And then it's not going to print it below, so now I have to actually show it below running median pivot. And bam! Now one note, you could technically put in here inside that sort values method we did, that job title short, since it does have a name. And whenever you run it, it would run it, this right now it's doing it in descending order, but it can still work. So you're like, well, when would this be a use case then? And that's when maybe the index doesn't have a column title. Similar to what we saw up here when we first ran the data frame. Oh my gosh, where I'm at. We ran up the data frame up here and we didn't have a name for it. We definitely want to use the sort index method in this case when it doesn't have a name. So being able to manipulate indexes are going to get you out of trouble from time to time and also keep your data in a very logical and also structured manner. So I got some practice problems for you to go through now and play around with these different index attributes and also these different index methods. With that, I'll see you in the next one. We're going to dive into inspecting what is the demand of certain job titles over the course of a year. And I'm going to do it specific to the United States. We're going to end up getting this graph right here. And it's going to be building on a couple key concepts that we've just learned. Being able to group our data by month and job title, but also being able to sort it properly so we can get those months in the proper order. So as always, we import our libraries, the data set, and cleaned it up. So I'm going to filter our original data frame for that job country of the US. You can do whatever country you want. And then as good practice, right, as we learned earlier, we're going to use that copy method with this. So we create a new unique data frame. With our data frame, we're going to now extract out the month values from this. Like I said, these are all from 2023, so we'll extract out the month. But I don't want the month number. I actually want the verbiage of like January, February, March. So I'm going to create a new column of job posted month, and I'm going to set it equal to the data frame of the US, specifically that job posted date. And then we're going to use that .dt accessor. And then specifically scrolling through what's available, we're going to use this string formatter to now format it properly. In order to get month, we need to use the % and then a capital B. As a refresher, if you're curious about all the different codes, you can go into the documentation and actually investigate what all the different % and letters next to it actually mean. In our case, we're using this one of month as a locale's full name, and then it shows a little bit examples to the right. Remember, this has to be inside of string characters for this because you're providing the argument of a string. I got a little bit of a typo right here. I'm going to not call that monthy. And once we do this, I actually want to see this data frame now to inspect it. Going into it, we can see we now have this job posted month right next to it, and it looks like it didn't work. And I'm an idiot. I modified the original data frame of DF. Should have modified the US one only. This is going to be fine for the time being. We're just going to continue. Running this now, scrolling over, we can see, okay, we have all the different months in there. Everything looks good. So now we need to pivot our data in order to get in a format necessary to plot it. Specifically, I want to put the job months along the index and along the index for a specific reason. And then along the columns, I'm going to have the different job titles. Remember, we're going to be aggregating the count of these different jobs over time. So on the correct data frame this time, I'm going to run that pivot table method on it. First, we're going to specify the index. We're going to specify it as that job posted month. The next thing we're going to specify are the columns that we want to use for this. Specifically, we want to use that job title short column. And then finally, we wanted to find the counts of all those different job postings or job title shorts in each month. So I'm just going to do the ag_func equal to size. So we're basically counting how many job title shorts there are. Running this, we get our data frame with job titles at the top, months along here, and then all the different counts in between it. Now, look at this. Look at job posted month. It's conveniently in alphabetical order, but that provides us no use because we don't want an alphabetical order. We want it in chronological order. And as we showed from the previous video, if I would try to sort this, I can either sort it ascending, descending. There's nothing in there for me to sort it chronologically. So we have some cleanup work to do. And these type of tasks always take up the majority of my time when I'm trying to actually make these visualizations. Like I'm like 99% of the way there, I feel, but I gotta actually clean it up more. Anyway, we're gonna be getting out for these different job posting months. We need to get the actual number associated with these job posting months and then sort it by that. So first, let's actually set this to a variable of dfus underscore pivot. So the first thing we're going to do is actually reset that index. And that's to push that month in so that way when we add the numbers, we can then sort it by those numbers. Running like this, I can see it basically flattened it out. So that way that job posted month is now in there. I'm going to use in place equal to true to set this. Now I want to create a new column for this, specifically that number of the job month. So on this data frame, I'm going to create this new column called month number. And specific to up here, how we use when we cleaned up our data to get the job posted date, how we use this PD to datetime function, we're going to do the same thing. We're going to provide it that month value along with specifying how we previously formatted so it knows what's going on there. In our case, scrolling back up, we can see we use this %B. So I'm going to just copy that and paste it into here. Now let's see what we actually get out of here whenever we do this. I'm going to paste this right below it, run Control Enter. First of all, it doesn't have a year in there, so it automatically just assumes the year is 1900 and the date is the 1st, but it does have all of those different months in there. So now what I want to do is extract out only that month. So we use that .dt accessor and specify we would just want the month. Running this now, we get the month numbers from it. Looking at the entire data frame, we now see we have this added month number, which August is 8. Yep. So I know this is good. So now we need to sort our values by the month number. Now, if I try to run this, it's going to sort it by the month number. But if you notice, we got another index put into here. And that's because I'm running all this code. Basically, every single time I have this in place equal to true. Basically, every single time I run the cell, it recreates a new index in here. And eventually we have an error. So if you're running this in the same cell, you have to basically do this run all. That's why I actually recommend probably breaking this out into different cells. Anyway, we have it sorted by our month number. So I'll also set this of in place equal to true. And then the next thing we need to do now is actually set the index of this. And for this, we want to use that job posted month column. Running all, we can see that we now sorted by the months. They're in the correct chronological order, but now we have this month number column that we don't need. So once again, we run dfus pivot.drop because we want to drop that column, and we specify that month number. And once again, I want to do this in place equal to true. And it looks like I got an error. I actually need to month not found in access. We need to specify this as a column. Running this all again, bam, So I'm actually going to expect what this looks like. Now, I don't like this job title short, and I also realized I made an error. Whenever I set that index, I didn't do in place equal to true. So I'm going to see if this actually fixes that problem with that job title short. Okay, it did. So now we have our job posted dates as the month, and that is on the index like we want it. So it's going to make it super easy to plot this along with all our different job titles. So now we can just jump right into plotting it. I'm going to do df.us_pivot, and I'm just going to plot this bad boy as a line chart. And we get this. And this is actually a little overwhelming in the amount of data here, but at least the months are in order right now. And there are 8 of the job title shorts on here. It's a little cluttered. So actually, I want to clean this up to only have the top 3 jobs, or the top 3 jobs that have the most counts. So for this, I just want to get a list of the top 3 in here. And I want to get into a list because then I can use it to filter this data frame further. So with this, I'll do top 3 equal to, and I'll use our original US data frame for this, specifying that job title short column. I'm trying to find the counts of all these different job title shorts. So we'll do a value counts method on it. And I just want to see the top 3 because that's all I really care about. Running this so I can actually see it below it. We have these available. And remember, we can also use the attribute of like index in this case with what we just ran. And so we have it here. It's an index currently, but I can convert it using the toList method. And now we have it as a list. So I'll just set this equal to itself to basically rename it. And we have this list available. So now whenever we go in to actually plot this, I can specify inside of brackets that top 3 values. And then from there, once again, plot it, specifying the kind equal to line. Okay, so now we have those top 3. It's not as cluttered, and we can actually do some analysis on this. Right now, we're expecting it. We can see there's a super high amount in January and also a burst here in August. So the January does make sense for the fact that that's normally when new budgets are approved for the year, and so they ramp up hiring. As far as the August, I'd have to dive into this further on why that is. It's sort of like an outlier here. Also, engineers are very consistent. They don't conform to the same thing as the analysts and scientists, so that's the unique insight with that. Now, there is some cleanup I would do with this, like putting a title and improving the labels on this. And yeah, now we have our final graph here, which has an appropriate title and appropriate labels for each of the axes. So bam, we just demonstrated a great use of not only pivots, but also when and why we need to manipulate indexes in order to potentially aggregate and get months in certain order or other values that you may encounter. All right, so we're halfway through this Pandas section in the advanced chapter. We only have a few more sections left specific to merging and concatenating data frames, basically combining data frames. Very, very useful. All right, with that, see you in the next one. From time to time, you're gonna find that your data is incomplete. So we're gonna need to merge it with new data. Take, for example, that previous example we did where we were analyzing data science jobs over time, how they were trending. What happens now if we wanted to combine this data with jobs in the tech industry, specifically those of developers, and see how they trended with data science jobs? Well, we can use merge for this. We're going to dive into how to build this visualization after we first go over a simple example to understand how to use the merge method. Now I have 2 data frames for this. Data frame jobs is only 5 rows long, and it's very similar to our data frame that we currently have of things like job title, company name, and job location. The second data frame is not similar to what's in our data set currently, and it's something we may have to source at some point. And this is company information. Specifically, I have information like the company name, industry, and company size. There's a whole bunch of third-party services out there that will collect data like this and provide it for you. And then we could technically merge this with our source data frame. So for this, we can use the merge method, and we'll be using the core data frame of our data frame jobs as the left data frame. And then we can see from the arguments and parameters we can provide it, we need to provide a right one, which for right, it is the object to merge with. So it's the data frame on the right. We're going to go into this how parameter in our second example, so hold off on this for the time being. But the other parameter I want you to focus on is this on, and it's the column or index level names to join on. In our case, both data frames have the same name of company name, so we can just use this on. In the case that you had different names for each of the data frames, you could specify left on for the left data frame and right on for the right data frame. In this example, we're only going to use on. So with df jobs, I'm going to run the merge method. I'm going to provide it that df companies, and we're going to specify on, specifically company name. Running Control Enter, I get the job ID, job title, and company name and job location from the original data frame. And now it's merged to that company's data frame with industry and company size. Pretty cool. So let's move into a more realistic example that you're going to be able to follow along with. In the notebook, I've gone through and imported all the libraries, loaded the data, and cleaned it up just like we've been doing. Now, in the last video, we made this data frame right here, where it analyzed jobs in the US specific to different job titles and how the counts of those different job titles trend over the different months of the year, specifically in 2023. We're going to be using this data frame from the last exercise. If you start a new notebook, bring that code into this one. But with this, it's somewhat limited in the fact that we only have data science job postings. This doesn't include necessarily all tech job postings. And a commonly associated field to data science is software development. So there's a lot of jobs in software development that I maybe want to compare these different jobs to. Well, I have access to this data. Truth be told, it's completely fictitious, so don't take any of these numbers for granted. But it has a similar schema or setup as our other data frame. We have our job posted month, and then in it, it aggregates the count for 4 different types of jobs, specifically front-end developers, back-end developers, full-stack developers, and UI UX designers. So because I have this data, we can use the merge method in order to merge it with our original data frame. So I've made this data publicly available so you don't have to try to recreate it. And it's available at this URL of https:// then lukieb.co/software_CSV. You need to include the HTTPS at the beginning in order for it to cue in that this is a website that you're pulling the CSV from. Anyway, we're using the read CSV function of Pandas. And whenever we import it in, we can see it has the job posted month and then all the different jobs. Right now it has an index in here where if we look at our original data frame, the job posted month is the actual index. So we need to fix that. I can either do something like set index, or I can just specify index call, which is the index column, and specify that it is job posted month. Running this now, we have job posted month shifted to this. Also, I'm gonna actually rename and actually assign this to a variable. And I've named it data frame US software pivot. Real original, I know. All right, so it has everything we need in it. Now we need to get to merging these 2 data frames. So with our data frame of US pivot, I'm gonna run the merge method on this, specifying the right one. So df US software pivot. And for both of these, we're using that index of job posted month. Running Control Enter, I can see now that we've combined all of these, and now we have all our data science jobs, but also our software developer jobs as well. Now going back to that merge method, we sort of glossed over this how parameter and how it's defaulted to inner. There's a host of different options available of left, right, outer, inner, and cross. Now, if you're not familiar with joins, they're also commonly done in something like SQL. And this is a visual representation from my SQL for data analytics course, where I represent left joins, right joins, inner joins, and full outer joins. Anyway, I'm going to link to the timestamp in that SQL course where I go over more in depth of how to do these left joins, right joins, inner joins, and full outer joins. So if you're not familiar with these types of joins, check out that real quick and then come back here. For the time being, we're going to leave this how parameter as inner, as it's the most common method to actually join data frames. And so we're not going to really even touch it. But I do find myself from time to time also having to do right joins. It's another commonly done one as well. That's why it's important you understand the difference between inner and right. One other resource that I'll recommend for this, that Pandas cheat sheet that we talked about earlier. I'll link it below. And over here in the second page, underneath combined data sets, it goes into different visual representations of how you can do left, right, inner, and outer joins with merge. The cheat sheet's pretty handy. Anyway, back to our problem. We want to now plot the top 5 jobs based on count of jobs in the year and see how they trend over time. So the first thing I'm gonna do is set this equal to a variable of df_us merged. And then we're gonna create a list of the top 5 jobs. And then once we get these top 5 jobs, we can then filter our data frame to include those. So it makes it easier to plot. So with this df_us merged, we're gonna do a sum. And I'm just gonna go ahead and print out this right below it so we can see what we're doing as we're going along. But whenever I sum them, it's going through and summing those columns. So it's really convenient. It's in a pivot table already. And we get the different counts, total counts of all these things. And this series isn't in descending order. So we actually need to set that of sort values. And for this, we're going to specify ascending as false. Running this, I now have it sorted in a descending manner. We only want the top 5. So I'll run head 5. Actually, I don't even think I have to put a 5 in there. I don't, it's automatically 5. And then we want the index because it's a series. And so the numbers, the values are the values. And then the index is the name. So I just want the index back. Okay, so I have the index back. And I'm just gonna go ahead and also run another method on this of toList. Now a little pro tip, whenever it's getting this long, when we're appending this many methods and attributes with this, so we can actually put this all within parentheses. Whenever I run this, it's gonna run just fine. But the fact that it has parentheses allows me to now break this up into multiple different lines. So in this case, we can more programmatically see every step along the way, and running it, it still works. And so if I want to include comments along the way, I could now in this manner as well. And so like in this case, get the index of the top 5. All right, enough getting off track. Let's actually plot this bad boy. For this, I'm going to specify my data frame of US merged. I'm going to specify that column names of the top 5. I have a little typo here, change that to merged. And then for the plot, we're going to make this the line plot. Running Control Enter, bam, we now got it. Although I want to clean it up a little bit. Now I want to add some different things to this to fix this chart right now because like legends over the top of things, it needs some titles and things like that. So I had this title of monthly job postings for top tech jobs in the US, an X label for the months to include that's from 2023, job count for the Y label, a Y limit, basically shifting it up to 20,000 because right now it's 14,000 so that we can get that legend to appear, making sure the legend appears, and now let's plot it. All right, this is actually more readable and is something we can actually use now. And with this, we can see some certain trends. Specifically, we can actually now see visually that front-end and back-end developers have a lot higher job counts. And this is pretty representistic because developer jobs are usually more apparent or more frequent than data science jobs. And then from there, it looks like full stack developers are more in line with data analysts and data scientists. None of them have really any outrageous values throughout the year. They look like they're pretty steady. All right, so now it's your turn with those practice problems to dive into merging some data frames. Now, as a reminder, if you're not as familiar with inner and right joins, I highly recommend you checking out the following URL from a SQL course in order to learn more about all these different join methods, because they are going to come up from time to time whenever you're merging data. With that, see you in the next one. Back when I was a junior data analyst and only knew Excel, I would get these monthly reports and I would have to go through every month and aggregate them and pull them into what I was maintaining as the master document that had all the data. I'm not gonna lie, this was a pain in the ass. But knowing what I know now about Python and concatenate, this function alone makes it super simple in order to bring together multiple documents. We're going to be working with this super example first, basically just to show the power of this function. So here I have 2 data frames very similar to our jobs data frame. And in it, I have January data. And in the one below it, I have February data. I want to go through and actually combine these 2 data frames. Now, if I were to merge these 2 data frames together, which I don't recommend, but if I were to do that, that's going to leave as a result that is not really what I wanted. I wanted to actually stack these data frames on top of each other. Here, I've created completely new columns and made this data a lot wider and basically unusable for what I need it for. Now concatenate, as shown here in the bottom half of this reshaping data section, shows that we can either combine data frames that have, in this case, all the same columns, and this is known as appending rows of data frames. This is what we're going to be focusing on. You could also technically use it to append columns of a data frame, but now we're getting into more of doing merge operations, and I would recommend using merge instead for that. So concat is a function of pandas, and we're going to call it by calling pd.concat. And for this, we provide objects. And objects in this case is a sequence or mapping of series or data frame objects. We're basically going to provide it a list of the data frames. The other thing to note is that its axis automatically defaults to 0. So basically, we're going to be concatenating it by appending the rows of the data frames and not the columns. The other thing to note is with copy, and copy is defaulted automatically to create a copy of these. So it's automatically set to true. So we don't have to worry about it altering that original data frame. So let's combine these two data frames. I'm gonna call pandas and then that concat function. Inside of here, I'm gonna provide a list of those data frames. So job posting January and then job posting February. Now running this, we have our two data frames combined. I can see up here at the top, we have our January data, and right below it, we have our February data. One thing to note about this is the index column right here. It goes 0, 1, 2, 3, 4, and then repeats again. If we wanted to create a new index, we could set ignore index equal to true. Running this again, it now has from 0 to 9 in this case. So let's jump into an example that you can follow along with. We've gone through and imported our libraries, loaded the data, and cleaned it up. So right now, we only have one data frame inside of here. And in this case, it has, looking at that job posted date, it has an assortment of months. So I have an idea. We're going to create some fake data in order to actually do this concatenate function on it. Specifically, we're going to make individual data frames for each month. So the first thing we need to do is go about creating a column that we can identify each month by. So I'll create a new column called job posted month, real original. And for this, I'll use the job posted date to extract this from, running that date time accessor on it, and specifically then the method of string from time. I'm going to specify only provide the month. Remember before we did that %B, and that provided the full month name. I just want a 3-letter month name. And so we're going to do lowercase b. Running this data frame below so we can actually inspect what went on here. Scrolling over, we can see we have this job posted month, and now we have all these different 3-letter months with it. All right, that looks good. So now we need to get into breaking this up into 12 different data frames because this data frame has all the months of the year. And I feel the easiest way to do this is to store it inside of a dictionary, which we haven't really done before. Here's a look at what I'm trying to create with this dictionary. For it, we have our different keys, which are those month values that we have in there. And then for the values, the data frame itself is inside there. A dictionary for the values can contain any different data type. And in this case, it can contain a data frame. So we can create this data set, because right now it's not made. We can tell by these yellow squiggly lines. We can make this with dictionary comprehension. But the first thing we need to do is get these lists of names of months. So I want to create a list of all the different months. So I'm going to create this variable called months. And in it, I'm going to get the unique values of the job posting month using that unique method. Running months right underneath it. I got a little bit of a typo, not job posting month, job posted month. Running that again. We can see we have an array of all the different months available. So now we need to start building that dictionary comprehension. For this, we're going to start simple and then build on it. I'm going to create a new variable called month. I'm going to use it for not only the key, but also the value. And then the main part of the dictionary comprehension is that for loop. So for month, the variable we defined in months. Okay. So this is the key value, and then it's cycling through using the for loop. Running this, I can see inside of here, we have a dictionary comprehension with the months as the key and the values as the same thing. But we want, as shown up here, we want to have the data frames inside of there. So for the value, I'll specify it as the data frame, but I want to filter that data frame based on the month. So I'll specify inside of square brackets, the data frame again, job posted month, and then use the comparison operator to compare it to make sure that it equals to that month. So now whenever we run it, we have a hot mess because it's not going to display it like we had up here with data frame variable name listed all nicely and stuff. It's actually going to show like December, and then here is the actual data frame showing it right after. So I need to now assign this to a variable, and I'm going to call this dict months. And I want to go ahead and actually see one of those months. So for dict months, I'm going to access one of the keys. We'll just go for January. And now we're getting that data frame shown back in a lot better manner. And this includes or should include all the January data, which scrolling through it, yep, looks correct. So all this work to create some fake data so we can run this concatenate function. So let's actually get into concatenating. So for this, my boss needs all the quarter one data, specifically January, February, and March. So I'll go ahead and start by running the concat function and then specifying in a list all those months of data. So starting at January 1st, adding February, and then finally March. And similar to before, we want to ignore the index. So that way it resets for all of it. Running this, pressing Control Enter, scrolling over job posted date, we have January up at the top, March down the middle. I don't really know if it worked just fine. I'm gonna actually run something else. So I'll assign this to a variable of df_q1. And for this, I want to inspect I want to inspect that job posted month, and I want to see the value counts of it. And specifically, we're going to actually run a plot on it. I like to see things actually visually. Running Control Enter, we have, well, looks like pretty good, right? Our January data, February data, and March data. As expected, January is a little bit higher than February, March, as we've seen before in our EDA. So this matches with what I expect to now give to the boss, and I'm confident in it. So concatenate along with merge are two powerful functions and, if you will, methods that I use all the time in order to combine different data frames. And being able to understand the use case of each of those individual ones, super imperative in data analytics. All right, so now I have some practice problems for you to go through and practice this concatenate function. And with that, I'll see you in the next one. So in that last example, we were able to extract out those quarter one results into its own individual data frame. The next step, but I'm sure the boss actually wants, is an Excel file of all of this data. So that's what we're going to do in this section by exploring all the popular methods that I use in order to export my data to a file that others and even myself can use. So for this example, we're going to be picking off right where we left off, where we created that data frame on quarter one results using the dictionary that had January, February, and March in it. And this data frame has over 220,000 rows. So we're going to be exporting a lot of rows to a file. So let's explore what methods are actually available to export our data. And I'm going to do this by typing in to and then underscore. And this provides a whole host of options that we can use. Some of the ones that we're going to be highlighting here are to clipboard, to CSV, to Excel, and then we'll also talk about things like to SQL, a pickle, and also a Parquet file. So let's start out with this to clipboard method. And I'm not going to copy the entire data frame to my clipboard because I don't want the thing to crash. So I'm going to just specify head in this case to only copy 5 values. Going back to the to clipboard, I'm going to specify in this case sep equal to comma. So that way it knows, hey, whenever you copy this, put commas in between each of these values. Running Control Enter, it is complete. So I'm assuming it's copied to the clipboard. So I'm going to go ahead and paste a markdown cell underneath here. So inside of here, I'm going to then use Command V to paste. And as we get back, we get the first 5 rows of data in the clipboard. But let's move into a method that I actually use all the time, and that is to CSV. And I'm frequently doing some sort of analysis and creating different data frames, and I want to export and save that data frame in case I want to access it and analyze it in a future scenario. Anyway, inside of to CSV, we're going to specify the file name that we want it to save to. So in this case, I'll just name it quarter one. Running Control Enter, I get a green arrow. and it's gone through and saved it inside of here. Now this is a comma separated variable file, if you will, but it doesn't have the correct notation. Technically, whenever you run this, you need to run this with the file extension that you want to save it to. So in this case, I want to save it to a .csv. Running Control Enter again. Now I can see that it's saved here under .csv. I'm gonna go ahead and delete this one because this is not good practice to do. And now going in here and inspecting it, looks like it has all the data. I'll actually scroll all the way down. And then we can see we have almost nearly 221,000 rows in here. And so now if I wanted to read that, all I would have to do is do pandas.readCSV, the function of that, and specify this file of quarter1.csv. So run this on our CSV. So it takes less than a second to load, and inspecting it, looks like we have all our different data, 221,000 rows. The one thing I will note about this is this first column right here, and that's unnamed 0. We didn't specify whenever we looked at this that that first column is the index. Also that if you notice, there's nothing right here for the name index. So what we can do when we read the CSV is specify index call equal to 0. Running Control Enter again, we can see that this fixes that issue. Let's now export this data in the same file format that our boss wants, specifically to Excel. Similar to a CSV, we need to actually specify the file name that we're going to save this to. So we're going to do quarter1, and remember we need to name the extension of this. So I'm going to automatically name it XLSX. Okay, we're going to run this, but we're going to get an error with it. And the error we get with this says this: module not found, no module named OpenPyXL. Basically, we need the Python to Excel module to actually do this. So let's actually install it. I'm gonna pull up the terminal by pressing Control tilde, and I'm gonna run conda install OpenPyXL. One thing to note, make sure that your environment, in this case, Python course, is activated and you're installing it into the correct environment. VS Code should automatically pick up whenever you're doing this project that that is the correct environment, so you don't have that issue. Okay, it says the following new packages will be installed. I'm okay with that, so I'm gonna go ahead and press enter. And it says it's complete. Now running this again, and after 1 minute and 6 seconds, which is pretty hefty, it went through and exported this out into that Excel file. Inspecting this Excel file, it has all the different columns that we had previously, and then scrolling on down, it has the 221,000 values. One thing to note, Excel has a 1,000,000 row limit, so you really need to think about that if you have data that is greater than 1,000,000 rows. Now there's 3 other methods that when you become more advanced in Python, you need to be aware of. And these are toSQL, toParquet, and also toPickle. You're probably familiar with SQL, and with this one, you would need to import a library like SQL Alchemy, and then from there you can export it to a database of your choice. If you have a connection to it, you can set that up to it and export it to that. I don't find myself doing that all the time, so whenever you encounter this, just go to ChatGPT. Now these last 2 are gonna save you some time if you're dealing with really large data sets and you're trying to export them and then also load them into Python very quickly. Parquet and pickle files, as denoted by this .parquet and .pickle in their file nomenclature, are very efficient files. So whenever you use this, you can then read in the data a lot quicker, sometimes more quickly than even CSVs. So when you become a hardcore data nerd with Python, definitely start implementing these so you can flex on your other coworkers. So now that we've gotten that task off our list of exporting that Excel file for our boss, we only have 2 more sections on the advanced section specific to pandas, and then we'll do an exercise. And then from there, we're gonna be moving into Matplotlib. All right, for those that purchase practice problems, you have a few to work through now to test out exporting to different file types. With that, see you in the next one. So we haven't even jumped into exploring and analyzing this job skill column that has that list of skills. And that's because there's a slight problem with this. It's not contained as a list inside of our data frame right now. As you can see up the top, it's being annotated as a string. Luckily, we have an apply method for data frames that we're gonna be covering in this session right here, where we can actually go through and apply something to that column to clean it up. But we're gonna start with some simple examples first. So jumping into our Jupyter notebook, we've imported in our libraries, load our data, and clean it up, just like usual. For this first and second example, we're gonna be looking at the salary year average column. And there's a bunch of non-values in it, so I'm gonna go ahead and filter it out. Using the not and a method from Pandas, I can specify I want to filter out that data for that salary yearly average column. I put that within brackets to then filter it. And then on the end, I wanted to provide that salary year average column. All right, so now we have this back. Anyway, this is the salaries that we have. And what we want to do with this problem is we want to calculate the projected salary for next year. And what we can do is this is just going to be some rough math. We're going to apply what inflation is right now of around 3%. It's basically take these values and multiply it times, well, 1.03 to get to see what would be 3% higher next year. So with that, how can we actually get inside the data frame? How can we get it to apply to this entire column right here? Well, we can use the apply function. Now, normally I would take you into the Pandas documentation, but I haven't used that help function in a while, so I think you should use it well. Anyway, whenever you plug it into here, apply can be applied on a data frame. It's a method of a data frame. So if I put df.apply and then run Control Enter, I get the help on this method, and basically the same thing that you're gonna get from those Panda docs if you go there as well. So this apply method takes one or multiple arguments, and we're gonna just focus on the first one for the time being, and that's this of func. It's a function to apply to each column or row. We'll get to this in a second, how we can apply this to rows, but for the time being, we're just gonna focus on one column, focusing on that. So the first thing we need to do is create a function, and we'll just call it def projected salary. And it'll just take one argument, salary, and then with that salary, what we want to return out of this function is the salary times that 1.03, so that 3% inflation. So now it's pretty simple. I can just take a column of interest, so in this case, salary year average, and I use apply on it and provide this function of projected salary. Now, because I'm providing this function, I don't need to put these open and closing parentheses in this case. I'm just providing the function name. It will apply it as necessary. Anyway, running this, we can see, well, no values here because we got some noun values in here. So to make it simpler for future views of this, and in order to filter out these non-values, I'm just going to create a new data frame called df salary and set it equal to our filter data frame, which basically removes all these non-values. And then down here, I'm going to actually reference that as well. Running Control Enter. Now we have back all these different salary values. Now let's actually inspect this and see how it compares to that original salary year average column. So I'm going to create a new column inside of here and call it salary year inflated. And then I'll set it equal to all this. I need to correct this, and I got a new data frame of salary. And then for the data frame salary, I want to then show these two columns of salary year average and salary year inflated. Running Control Enter. Once again, like similar to last time, we're getting the setting with copy warning. Remember, anytime we're doing alterations on an original data frame, we want to create a copy of this. So make sure we're doing copies of that. All right, now we get that warning message going away. And inspecting it further, we can see that in fact, that salary year average column was multiplied times 1.03. Now this function is actually pretty short. And for providing this apply method a function, we could use something like an anonymous function. So let's try writing this again with an anonymous function. So I'm going to define that data frame as salary, and we're going to be using that salary year average column. And we're going to be applying a Lambda function to that. So for this, you may have to dust off your hats if you haven't used Lambda functions in a while. But as a reminder, so we're going to define Lambda, and then you want to define a specific variable. So in this case, we're going to call it salary. And then you provide a colon, and after the colon, you're going to provide what mathematical or what operation you want it to do. And in our case, we want to do salary times 1.03. So once again, let's see what the salary year inflated column looks like next to the salary year average column. And once again, comparing it to the last one, it looks like all the math was done correctly for this. Now, for those hardcore data nerds, you may have noticed that I could actually rewrite this without that apply method or Lambda function, as this is actually a really simplistic case where we're only really multiplying 1.03 times that salary year average column. For it to actually call out the different columns to display below, we can see that it still gets it done. But this was mainly to show you an introduction to this apply method when running it on a column. So let's actually use this apply method in a situation where it's actually applicable and you can't actually simplify it. And that's in the case of our job skills. And specifically, we need to convert this from a string to a list. If I were to display that list of first skills, I can see that the list has double quotes around it. And even putting type around it to confirm, running this, I get it as a string. So how can we actually convert this back to a list? If you call back to our lesson on data types, in the past you could wrap certain objects inside of a data type like list and then try to convert it. However, in this case, if I try to do that, it turns this thing into a jumbled mess. Like it converts every single letter into the own item in the list. It doesn't work. Instead, we're going to go inside the Python standard library and use this module of AST, which stands for Abstract Syntax Trees. Honestly, I never heard of it before until ChatGPT hinted me towards it. So it's sort of special for our unique use case. Anyway, with this, you provide a node or a string. So in our case, we're going to provide that string to it. And it basically goes through and explains that it converts it to the container data type, in our case, a list, back to what it was supposed to be. Let's actually show this in action. So inside of this code block, I'm going to import in that AST module. It's part of the Python standard library, so we don't have to kind of install anything with this. And then for this, we're going to apply that function of literal eval. And we're going to apply it to that list, that string list. Running Control Enter, we can see that now we have this back into a list, and I can actually confirm this by running a type on this, and it comes back and confirms it is a list. So let's now clean up this column using the apply function. And just to show real quick, we can't actually run ast.literaleval on this entire column. If I try to go ahead and do this, I'm going to get a value error. I didn't pass in the stuff correctly. We have to use the apply method for this. So the first thing I'm going to do is I'm going to start with creating a function. And I'm going to just call this clean list. And I'll call the variable for this skill list. And this function is going to be going through each of those items in the column, so I can thus return that literal eval of skill list. So let's actually write this out then. So for this, I just want to replace it right on top of the original column of job skills. So I'm going to set it equals to itself and then write that apply method, passing in clean list. Now we're going to get an error here whenever we run this. Specifically, we're going to get a value error, malformed node or string, none. And I can show this by filtering the data frame to only show NA values inside of the job skills column. I'm using this isNA function and passing in what column I want to filter it for. Anyway, scrolling over to job skills, we can see that we have a bunch of none values. This is causing errors for us here because it's trying to do this literal eval on none when it's expecting a string to be passed. So what we can do is pass in an if statement. And unlike what we did down here of the function of isNA, we can use not NA, specifically calling out the Pandas not NA function. And we want to look at that skill list. And therefore, if it's not NA, we want to actually return it as the literal eval for skill list. Otherwise, we're going to leave it none. Okay, so let's try to run this again. So everything ran right, but let's actually inspect the first element of this. And we can see that we get a list back, and confirming the type of this, we can see that it is in fact a list. So it did do the conversion correctly. Now in this case, because of how simple this function is, I would encourage you to transcribe this into a Lambda function. I like to write a function first and then convert it. So with that job skill column, setting it equal to itself and then using apply, we're going to use a Lambda function. Then we want to define that variable. That variable is going to be that skill list. I'm going to fix this typo real quick. I need to have Lambda in there. Then we're going to go into what we want to actually do. We want to perform an ast.literaleval on skill list. We're going to get the same error as before, that there's a value error, malformed node, or string none. So we need to correct it for this. Basically include an if statement inside of our Lambda. And I can basically just copy that if statement from up here, paste it in here. And whenever I run this, I'm also going to get an error, expected an else after an if. And we just have to specify else. If it is none, just return back that skill list. So what the value is currently. Running Control Enter. Everything looks like it ran fine. Displaying the first value, I can see that it is a list, and just confirming with type again, it is in fact a list. Now for future notebooks, when we go into actually analyzing the skills, you're gonna notice that I do use this again inside of the import library section that I normally have up here. So this code is pretty important and you need to understand what's going on there because you're gonna be using it. Now I want to cover one more example with this apply method because we've only been applying it to a column and we may need to apply it to a row. So previously went through and just applied 3% inflation to every single salary. But let's say we have a new problem where we're assuming that for senior roles, such as senior data analysts, engineers, and scientists, they are going to have an inflation or projected salary of 5% higher, where the other roles are only 3%. So we're going to need to revise this code that we did previously in order to do this more complex apply method. Pulling up that help function on apply again, just to refresh. Previously, we only covered the function aspect of it, but now we need to look at this axis. The default currently is 0, which specifies that it applies the function to each column. But if we want to apply a function to a row, basically so we can access multiple columns in a row or check a column, this is what we want to use in this case. Because this one's a little bit more complex, we're going to be building a function first and then passing it into our apply method. So let's start by building out how we're going to use that apply method. For this, we're going to be using on that df salary data frame again, because this has all the salary data filtered out. It makes it just easier to display for us. So with this data frame, we're going to be creating a new column of salary year inflated. And in this case, instead of providing the data frame and the column, we're just going to provide the data frame because we want the entire row to go to at this time. And we're running the apply method on that. We'll be using a function. We haven't made this function, but we'll call it projected salary. It's going to have some, and we need to specify the parameter of axis equal to 1. So let's actually build this function now. So this function, like I said, is called projected salary. And inside of it, we're going to be passing the row. And what we need to do inside of this, as it's grabbing each one of these rows, is check, hey, what is the value in this job title short column? And if it's not, in this case, it's not senior, I want to then take that salary year average and multiply it times 1.03. However, if senior is inside of it, such as like in this case, we want to apply it of 1.05. So this is a great if statement. So if senior in the row, specifically that column job title short, then we want to return the row of salary year average. And we want to multiply that. So 1.05 times that. So this is actually a functioning function right now. So to make sure that it's doing correctly, I'm going to go ahead and I want to actually see the results below here. And for this, we're going to display below here the job title short column, salary year average, and that salary year inflated. Running Control Enter. Bam! Okay, so we have it back now to where it's only doing a condition on the column. Specifically, we have this one senior data engineer role, and it did the appropriate multiplication in order to get that. Now we need to solve for all these other things. So in this case, we're going to use an else statement. And in that case, we're just going to return 1.03 times the row of salary year average. Now running this, all the values are going to fill in, and we now guarantee that it worked correctly. Now all this code can be made into a Lambda function and simplified into one line. It's getting a little long. If you want to do that after this, go for it. I'm not going to walk through it because we've done enough of those practices already. But just showing us it can be done. All right, so that's the apply method. And I'll be honest, when I first encountered this method, it was sort of difficult for me to wrap my head around how this is applied to columns and also to rows. So you may need to watch this section of the video again in order to better understand it, as you're not alone. I had problems actually understanding this fully when I was first learning it. All right, for those that purchased the course Practice Problems, and you have some problems now, go through and test out how to use apply in different ways. With that, I'll see you in the next one. So we just spent the entire last session working through understanding how to clean up this column of job skills to convert it into a list. And it was a lot of work, but I promise it's going to pay off because now we're going to get into visualizing it and actually able to see what are the top skills for something like a data analyst. But in order to do this, we need to use the explode method on this job skills column in order to clean it up a little further. Let me show you. So why are we even learning about this explode method? Well, let's look at a fake example using fake data. I have a data frame with a few jobs and then a list of skills that each job requires. If we wanted to count up the number of times maybe something like Python or Excel appears, it's going to be a little bit difficult in this format. Specifically, if I called the data frame and then tried to run value counts on that job skills column, running Control Enter, I'm going to get a type error. And it's mainly due to the fact that list is not hashable in order to actually do this. Now you could use some loops or list comprehension maybe, and actually loop through each of the rows of the data set and then aggregate what skills are inside of each of the job postings. And then from there, make a totals column, which ignore this job title, short and job skills, but it could do totals for each of those skills. But if we look at the code that I had to do for this is 1, 2, 3, 4, 5 lines of code, and that's just way too ridiculous. Instead, what we can do with that original data frame is when we call it, run that explode method, which we're going to go over shortly, of specifying the skills column. Whenever I run this, it's going to explode it out to where every single value from that list is its individual row. So now we see we have 3 data analyst rows, 2 data scientist rows because there's 2 skills, and 3 data engineers because there's 3 skills. Scrolling up, we can even confirm this by looking at it. Anyway, in this type of format, it makes it really easy to then run, if we wanted to, that value counts method on the job skills column. And we can then get a quick count of how many skills each of these things have. If we want to take it a step further, we can even plot it. And we get this bad boy, which shows the counts of all the different skills. So inside my Jupyter notebook, I've gone in and imported all the libraries, loaded the data, and then for data cleanup, I've added an extra line. Specifically, we have our line here for cleaning up the job posted date, and then our final one that we just did in the last section of applying or using that method apply in order to clean up those skill lists into a list data type. So let's jump right into exploding out this job skills column. Here I have it displaying with also job title short. We're going to run this explode method on this column of job skills. So I'm going to run the help function on this explode method in order to understand better what it needs. And it takes 2 parameters, which are column and then ignore index. We're going to ignore index for the time being. So for this, we specify a column and it transforms each element of a list-like to a row replicating index values. So let's run this explode method and we're going to just provide the column name of job skills. Running Control Enter. So looking at the index alone and also the rows, we can see that they're now duplicated. Scrolling over to the job skills column, we can see now that it's broken out into individual rows for each skill. Pretty cool. Now we want to assign this to a new data frame. So I'm going to call that df exploded and I'm going to set that equal to this. I'm going to go ahead and run it and then printing out again. It looks good. So let's actually visualize now this job skills. Since we have these individually, we could do a value counts on this. So I'll call out the job skills column and then we'll run a value counts on it. This looks pretty good, but I don't like staring at numbers. Let's actually visualize this with only the top 10 results. So I'll run the head method on this, and then also we'll then run a plot on this, specifying that we want to run this a bar chart. And bam, we get this bad boy that shows the top 10 skills, visualized by their associated counts for each. So let's actually take this a step further because right now we're looking at all the job titles, data analysts, data engineers, and data scientists. I actually want to group them not only by their skill count, but also by that job title short column. And that way we can go through and pick out if we want to look at data analysts, data engineers, or data scientists. So for this, we're going to go back to that original variable that we had of that df exploded and build on that. And for this, we want to group by not only that job title short, but also those job skills. So we'll call out df exploded, use that group by method. And then inside of the arguments for this, we're going to provide the list of both of those. So job skills, and then also job title short. And then getting to the aggregation function that we're going to be doing for this, we want a count of all these. And so the best way to do that is size. Running Control Enter, we can see now it's grouping it by those skills. And then, so in this case, we have airflow, and this is the count for each one of those different job title shorts. Now, as far as the ordering that we were doing for this, I don't really think it matters too much. If I ran it this way, we just have job title short on the left and then broken up by all the skills associated with each job title short. So I'm going to assign this to the variable of skills count. And if we notice this skills count that we now created, the type of this is a series. And series aren't bad to work with plotting, but I prefer personally data frames. So we're going to go ahead and convert this into a data frame. I'll do this by creating a new variable called DataFrames skills count, real original, I know, and I'll set it equal to skills count. And so in order to transform it into a data frame, we need to use reset index. I'm going to print it out below and see how it looks differently. So we end up getting this one now, and those count column right now, it has this 0 title. So we actually need to change that and specify the name of that, basically that index that was previously the index for the series, but now it's 0 for this column. So we need to name it skill count. Running Control Enter, and it changes skill count. Now, the next thing I want to do is sort these values, and sorting the values by skill count is going to be necessary. So whenever we are visualizing it and only showing the top 10 results, we can just do like a head method to pull out those top 10. So once again, I'll define that variable of df skill count, and I'll set it equal to our data frame of skills count. And we need to sort these values. So we'll use the sort values method, and we need to provide what column we want to sort this by. So we'll specify that skill count. Running Control Enter, we get this, but now they're all in ascending order, but we want descending. So we'll specify ascending equal to false. Okay, and now we have it in that correct order from highest to lowest. So this is now what we need in order to plot. We're gonna go first and just plot data analyst, basically the top 10 skills for data analyst. So I'm going to create individual variables. So in case if I want to change it and make it easier. So I'll call it job title equal to data analyst. And then for top skills, I'll set that equal to 10 for right now. And then as far as our final data frame that is filtering for those values, I'll pass in our original one of data frame skills count. And we're going to be filtering that one by that job title short column. We want to make sure that it's equal to job title, the variable that we defined above of data analyst. Additionally, we get the top 10 values. So we're going to run the head method, passing in top skills. Let's go ahead and show this data frame right below this. And now we have only for data analysts, the top skills in descending order and their count. Now this is something we can actually plot. So I'll run the plot method on this. For kind, we can go with the bar chart, but I like the horizontal bar chart for these, so we'll add an H to the end. And then this data frame has multiple different columns in it, so we need to specify that for the X and Y values. So I'll call out job skills for X, and then for Y, I'll call out skill count. Running Control Enter, bam, we get this bad boy now. Now the one problem I'm already seeing this, which we've encountered before with horizontal bar charts, is the order in which it plots it. It starts plotting at the bottom left-hand corner and then works its way up from there. So that's why we're having this. So actually we need to reverse the axis. So I could come up into the code and put this ascending back to true. And then from there, instead of doing head, do tail. But I have a better method than this. So Matplotlib has this method for inverting the y-axis. The one sort of issue or one more learning point we have to go through with this method is the fact that it's run on the axis, which in order to get the axis, we need to run this method of get current axis or GCA. We're going to go more into this method and also the invert the y-axis, but I wanted to introduce it here. For the time being, just understand that this is going to get the axis and then we're going to invert the axis. Back in our notebook, I'm going to call the pyplot module with our alias of PLT. We're going to run the GCA method on it, and then we're going to run on that the invert y-axis. And as we can tell, the axis is now inverted. And now with how we built this, we can go in and actually look at other job titles as well. That's the good thing about Python, is you can make something programmatically changeable. So in this case, I want to look at data engineers and the top, I said top 115. Didn't mean that. That's way too many. We're going to scroll that down to only 15. And now we have for data engineers, the top 15. All right, so there's a little bit more cleanup that I want to do for this before I'm actually satisfied with this visualization. The first thing is I'm going to specify a title using an F string. With this, I can specify top skills of 15 skills for the job title of data engineer. And now it's appearing formatted correctly. Next thing I'm going to do is change up that X label to change that to job posting count. And I don't really like the Y label. I feel like the title's already explanatory enough for that. So we're going to leave that blank. The last thing to notice is the legend down here. I feel this is very much redundant and not necessary, so we want to remove it. So we can access our legend by doing plt.legend. And then this one has a method called setVisible. And then inside of here, you pass a Boolean expression of true, or what in our case, we want false. We don't want it to be visible. And now it's gone. And the last thing just to pass in is plt.show. And now we've cleaned it up to what we want with a very concise title and appropriate accesses. So that is the explode method, and it makes our life super simple in getting into analyzing this skill. Now it's your time to go through and actually do that. Along with those that purchase the course practice problems, we have some available for you right now. And with that, I'll see you in the next one as we're going to be going into an exercise, building further on these top skills of data analysts, but analyzing the trend of these skills across the year. All right, see you there. Now that we've wrapped up covering everything that you need to know for Pandas for the advanced chapter, and basically for the remainder of the course, I wanted to go over a quick exercise that covered a lot of those different methods that we just learned. Specifically, we're going to be using all those methods of explode, apply, and pivot in order to get this bad boy, which is going to show the trend of skills throughout the year. So let's get into it. Here in my notebook, I've gone through and imported our libraries, loaded our data set, and then done the data cleanup. Remember, we're still doing the job posted date cleaning along with converting those job skills to a list so we can do the explode method. Now for this analysis that we're going to be doing, I only want to focus on data analysts. You can focus on whatever job title you want, but that's what I'm going to focus on. So I'm going to create a new data frame called df_da. And set it equal to our original data frame, where we're then filtering it for that job title short column, ensuring that it equals data analyst. Now I don't want to alter this original data frame, so it's just good practice to use that copy method, and I'll run this. Inspecting this data frame, it looks like we have all data analysts in it. And now we need to go into, we're going to be aggregating these skills on a monthly basis. So we need to go ahead and extract that month out of the job posted date. So I'll specify a new column of job posted month. I'm also going to specify that it's the number. And this is going to be equal to, in that data frame, of the job posted date. Specifically, we want to use that accessor of month. Displaying the data frame below, we can see now that we got this job posted month number on the side. Next thing we need to do now is actually get into exploding out those job skills. So for this, I'm going to create a new data frame or new variable altogether for this. I don't want to save over the original data frame. And I'll specify our df_da data frame and pass that explode method to it, specifying we want to use the job skills column. And I want to see what this looks like whenever we do this. So I'll call out that I want to look at it afterwards. And it looks like it's repeating along with those job skills now being separated out. So now we're going to use both of these columns. We have our job skills column all broken out, and we have the associated job posted month number with it. Now what we have to do is pivot it. So on this df_da explode, I'm going to run the pivot table method. And for this, I want to use the job posted months as the index and the skills as the column. So I'll specify the index is equal to job posted month, and the columns is equal to job skills. Other thing we have to specify is the ag_func. And for this, we're wanting to do a count of all those job skills per job posted month. So we're not going to use count, we're going to use size. Running Control Enter, we have all our different values in there. Now I am noticing one thing. They're having non-values in here. And really what this means is there was no value there. So technically in this case, it is actually 0. We want it to be 0. Because if we go to plot this and there's 9 values, it will just skip it. So we need some values in there. We need 0. So for this, we can specify the parameter of fill value and pass it in of 0. Running Control Enter. So now we're almost there. We have our job posted month on the index and then all of our different skills on the columns. But this is a lot of skills. If we try to plot it, well, let's try. I'll show you. I'm going to rename this as the variable of 𝗕𝘃𝗃. I know, real original. And for this, we're going to run the plot method on it. And for this, we'll specify the kind is equal to a line chart. Okay, so not so bad to start, but oh goodness, this legend just keeps going and going and going. So we'll definitely need to make that legend disappear. Even that, we can see that there's just too many skills on here. I want to actually filter down the number of skills that are on this visualization, and we need to filter down by those that have the highest count here. And right now it's just sorted alphabetically. So what we can do in order to solve this is displaying our 𝗕𝘃𝗃 pivot table. We need to create a column, we need to create a row called total that basically sums up all the values inside of here. And this is actually pretty easy to do. For this, we're going to create a new index value. And so we'll use the lock method for this, and we'll specify that it's called total. So it's creating a new row called total. And this is going to be equal to the data frame and then running the sum method on this. Pretty neat that we can do this so easily. I press Control Enter, it's displaying below, and then now we have this total row along the bottom of here. So now what we need to do is sort these columns and specifically by what's in the total row. So I'll specify once again that totals row by using that lock method, and we're going to sort the values of this. Running Control Enter, we get this series back, which has for the index, the counts, and then also the names for all of it. I actually don't want it in this order. I want to change this. So I'm going to put ascending equal to false. And I promise this is all going to make sense. So we have this right now. So really what we care about this is getting these job skills back, which are the column titles. And from there, we can actually sort the data frame based on those column titles. So I can run the .index on this. And we have basically index values, which is inside of it's like a list of all the different columns. And now with this, we can pass this to our pivot using the square bracket notation to basically say, hey, all these values inside of here, sort the columns by this. And bam, now we get this, where all these different columns are sorted in the order that they should be, with these the least at the end. So the only thing left to do now is just drop this total column because it's going to jack up our plotting if it's in there. We don't need it anymore, so we're going to drop it. But before that, I need to save what our work to the variable of 𝗕𝘃𝗃. And then with that 𝗕𝘃𝗃, I want to then go ahead and drop that total row. Printing this, displaying this out below, make sure we did it right and didn't make any mistakes. See that, bam, now we have everything all sorted correctly, and that total row is now gone. So the only thing left now to do is to actually plot this. So to plot this, I'll just call out 𝗕𝘃𝗃, and we're gonna access what we want from this data frame here based on 𝗓𝗏. So I just want the first 5 values. I don't want to call them out specifically. We'll just use .𝗓𝗏. And we need to pass in the rows first. We want to pull all the rows. So we're going to pass in that colon. And then for the next one, we only want the first 5 values. So automatically assume 0:5. We don't have to write the 0. I can actually just show this down below. We have what we want. Let's actually plot it. And we're going to use a line chart for this. And bam. And like every visualization, you probably should clean it up. I'm going to add this title of top 5 skills for data analysts per month. Add a Y label of count. I'm going to remove this X label because I feel like we've already specified that in the title. That's per month, and you should know what that is. So going ahead and running this, bam, we now have what we want. Now, as far as what we're seeing with this, we have very high demand very in the beginning, but remember we had a lot of job postings in January. So that's why these counts are above normal. When we get to the project, I'm going to shift us from plotting using a count to using something that's more representistic via percentage. Specifically, we're plotting something like what is the percent of job postings with SQL, or what is the percent of job postings with Excel. And this is going to help clear up these issues that we're seeing here of these abnormalities in months like January and August. Now, personally, I don't like this month number notation down here, but we're going to stop here for the exercise. But what is available on GitHub and the code for this is I've gone through and cleaned up those job posting months, similar to what we did previously. And to now, whenever we plot it, it has like January, March, May, July, September, November. And was able to do this with 4 lines of code. We've all walked through this before, so I'm not going to do that again here. All right, so that wraps up everything you need to know for pandas, and you should be super proud of everything you've learned so far. We're now going to be shifting gears and getting into exploring more advanced features inside of Matplotlib. So with that, see you in the next one. So imagine this scenario. You've analyzed the top skills for data scientists, data engineers, and even data analysts. But now you want to compare the values across each other, but they're all on separate plots. How do you do this? Well, conveniently, that 𝗕plot module from Matplotlib offers a subplots function in order for us to graph everything on one single figure. And the best way to understand this is through their cheat sheets, I find. Looking underneath here at subplot layouts, with this function, we can specify the rows and columns for the number of axes, if you will, on the figure itself. Whenever we run this function of plt.subplot specifying a 3x3, we get back 2 objects, a tuple, a figure, and then the axes. Once again, this axis object is each of these individual plots on this figure. So enough with the theory, let's actually jump in. I've gone through and imported all of the different libraries we needed, loaded the data, and then done our standard data cleanup of cleaning up the date and the job skills. We're going to start by creating a subplot on basically a 1x1 figure. So for this, it provides 2 objects. It provides fig and ax. This is the standard nomenclature for this. You can really name it whatever you want, but it's pretty common to use fig and ax. And then we'll call out the PLT module, specifically the subplots function. Okay, running Control Enter, just make sure it works. It plots a basic graph here. If I wanted to, I could add in the different rows and columns of this. So in this, I specified 2x2 and I created a 2x2 subplot area. We're going to keep it simple for the time being, and I'm going to remove that. And with keeping with simplicity, we're just going to plot the counts of the job title short column. For this, we'll use the value counts method. Running Control Enter to see what we're getting. It's the numbers for all the different job titles. So running the plot method on top of this, specifying that we're going to want a bar chart. We're going to then run Control Enter. We have it. Now with this, we need to actually start using this ax. And we can pass in this axis for the figure itself into here. So I can specify ax equal to ax, which is this one up here. And when I run this, it's not going to change anything. It's still going to be those same values of those different job title counts for this. But let's now get into actually plotting 2 plots. So not only do I want to plot the value counts of the different job title short, but also we're going to run value counts on the job schedule type. So whether it's full-time, contractor, or intern. And then I'm only looking at the first 3 values for this. I want to get both of these plots into separate bar charts and put them on the same figure. So I'll start with specifying that fig and ax equal to plt.subplots. And then we specify the rows and then the columns. And I just notice it's highlighting as I go. So it's telling me that the number of columns is 2. That's pretty cool. Learn something every day. So now I'm going to copy and paste both of these into here. And with these, we want to plot both of these. So I'm going to specify the plot method on this, specifying the kind equal to bar. And in this one, we most definitely need to specify ax. I'm going to copy the plot and also paste it up here. Now, I'm going to pass both ax onto here. We're going to run into issues with this. And that's because now we need to specify of this ax, we need to specify the index of the ax that we're using. So similar to a list, anytime we pass an index, we're going to use that bracket notation. So in this one, we're going to use 0 for the first one. And then for this one, we're going to use 1. Running play. We can see that, okay, we have the job titles on the left and we have the job schedule type on the right. If I wanted to, I could just trade the 1 and that 0 to trade places, running Control Enter. We now have job schedule type on the left and the job titles on the right. So you may notice by this that we have some overlap here between these 2 different visualizations that are in their separate axes. Well, we can go ahead and fix this by passing in a function that we haven't used before called 𝗕layout. And this function we want to apply to the entire figure. So remember, we have figure and axes. Axes is the individual plots, figure is the entire thing. So I can specify figure.𝗕layout. Running Control Enter, bam! Now we get something that's a lot more readable where they're actually separated and they're not overlapping. Now I do want to call out, because there's sometimes people will plot differently, but we're using the Pandas methods in order to plot these different visualizations. Now this is the same visualization, but we're using Matplotlib's design way of actually building visualizations. I'm going to go ahead and run it just to show you. And it's the same thing. Well, kind of. They don't turn axes, they don't turn those labels on their side, so we have a bunch of overlap, but it's basically the same. Anyway, what's going on here? Well, instead of up here running this plot method, down here, we're now calling out each of the different axes and then running the applicable plot method on it, actually providing the values that we want to go into this plot and filtering it out, and then also doing the 𝗕layout. Like I said before, this is more verbose, and I'm not really a fan of it. I'm much more a fan of using Pandas to plot this. So let's now get into that final example that I talked about at the beginning. We want to get into plotting all the different counts of top skills for not only data scientists, data engineers, but also data analysts on one single plot. And for this, we're going to use that same data frame that we created during the explodes lesson, where we went through, copied the data frame into skills, exploded all the skills out, grouped them, reset the index, and then sorted the values by the different skill counts. That was a quick version. I'm not going to go through it again because we already did it. So for this, I want to plot data analysts, data engineers, and data scientists. So the first thing I'm going to do, just create a list. And we're using a list because we're going to loop through each of these different job titles, basically pull them out of here, and then plot them each individually onto our figure. So we need to start by creating our fig and ax, and we'll be specifying the subplots function. And for this, we're going to be specifying rows and columns. In this case, we're stacking it. So it's going to be 3 rows and 1 column. Now, like I said, we're going to be looping through each one. So I'm going to create a loop with this. So for, and we're going to pass in 2 variables. We're going to pass in I and also the job title. And I'll show you why. We're going to be using for this in enumerate job titles. And I spelled enumerate wrong. Okay, fixed it. Enumerate job titles. Just as a quick refresher for this, let's actually print out I and job title so we can see what's going on here. So whenever we enumerate through a list, it provides first the index, and then it provides the actual value. I provided in here job titles. I should have just done job title. And now it provides the index and then the actual name itself of the job title. So the first thing I want to do inside of here is filter the data frame for if we have data scientists first. I want to filter it just for data scientists and just for the top 5 skills. And just checking, the name of the data frame is df skills count. So inside of here, I specify df skills count, and we want to filter this data frame specifically on that job title short column, where this is equal to the job title. And we only want the first 5 values out of this. I'm not sure if this is going to display, but we're going to go ahead and try it. No, it didn't display below. Let's try actually print. Okay, printed the data scientists, data engineers, and data analysts. We're getting the correct results. We're going in the right manner. Okay, so this is what we want to actually plot. So I'm going to set this one of a basically data frame plot is equal to this right here. And then with our data frame that we're going to plot, we're going to run the plot method on it. Specifying what kind we want. Well, we want a horizontal bar chart. And then we need to specify the X and Y values. So job skills, skill count. Now, the last thing we need to provide, remember, is the axis, on what axis we want to plot it on. Conveniently, we did this enumerate function, which provides an index. So we can pass into it a X, create a bracket notation, and then just pass in I. Let's plot this bad boy. All right, not bad so far. I don't know who each of these graphs are associated with. We also have some overlap we'll fix, but off to a good start so far. In order to show the different titles on there, we can just add the parameter title and set it equal to job title. Running Control Enter. I forgot to put a comma. Running Control Enter. We now have all those different job titles up. Next thing I want to do is similar to last time. Remember, we inverted the y-axis. So we're going to do the same thing here. But remember, we had to run that GCA method in order to access an axis. So in this case, we're just going to call out the axis specifically. So we'll say axis, and then we'll specify the index. And for this one, we'll call out invert y-axis. Running Control Enter, bam. This inverted all those different values. Next thing I want to do is take out this job skills on the Y label because I feel it's redundant. Okay, running this, we now have that removed. The only thing left to do for each of these individual axes before we actually make it spaced out better is remove this legend of skill count. Like that's just like completely unnecessary. And similar to what we did a few lessons ago, we can access legend by calling .legend of the axis. And we can set the visibility of it, or set visible, equal to a Boolean's expression of false. Okay, so this now removes that. Similar to how we spaced it out before, we're going to access that figure and we're going to call that tight layout. Okay, so this now has all of this now actually spread. It's a lot more readable, but I want a title across the top. So once again, I'm going to access that figure and I'm going to set the subtitle, so the main title for it. And for the title, we're going to specify that it's counts of top skills and job postings with a font size. I'm going to specify here the parameter of 15. Now I'm having an issue right now where it's overlapping, and that's because of this tight layout. I'm actually going to change that to move that underneath. I'm hoping that fixes. Yeah, that does fix it. So that actually spaces it out better to where the title's not on top. Make sure that you have that in the correct order. All right. I promise the only last thing to do in this is right now I'm finding data scientists and data engineers have a similar axis, but whenever we look at data analysts, they're not on the same axis. It's not aligned properly. So for the axis itself, we can specify the set xlim, and we're going to specify not only the 0 in this case, so what is the lowest value, but also the highest value. Right now it's looking like it's around 120,000. That would be the best to make sure we capture all the different values. So I'll specify in here 120,000. Running Control Enter is now saying it. And also all of these are now on the same axis. And this is pretty insightful now. We can take a lot of different insights from this. Like data scientists, data engineers have some of the highest with Python, and data analysts are a little bit below that. And then when it comes to SQL, not only do data engineers cover it, but also data analysts, and data scientists, a little bit less. Now, like I mentioned in the last video, we're going to be getting away from counts in the project section. And specifically, we're going to be shifting more to analyzing what is the likelihood or the percentage of a skill appearing in a job posting. So I feel like it's going to be much more representative of us comparing counts to counts, because sometimes there's more data scientists or data engineers jobs than data analysts. All right, if you haven't worked through this already, it's now your turn to do this, along with some practice problems to familiarize yourselves with how to use this subplots function. With that, I'll see you in the next one. We're going to be diving into more advanced features of Matplotlib. See you there. So I have a love-hate relationship with pie charts. Frankly, they're pretty good at showing some things, but then other things, when there's too many variables involved, you can't really even use it. So we're not only going to be walking through how to actually plot a pie chart, but also when are the best scenarios to use these visuals. So jumping into a Jupyter Notebook, we have our standard import statements, we loaded the data set, and we've done our standard data cleanup. So let's get into plotting one of these columns. We're going to start with this job work from home because it's a Boolean expression, and we're either going to have a true or false value. And so with this, we're only comparing two things, which is actually really great for pie charts. So with that job work from home column, we're going to run value counts method on it in order to get the counts of the different values. So now that we have this, we can actually run the plot method on this, specifying the kind of chart we want for this. We want a pie chart. Running Control Enter, we get this one. Now, I'll be honest, this chart does need some cleanup because I don't know what we're comparing true to false for. Also, we got this random looking count on the side. So let's actually clean that up real quick. So I'll specify the title of work from home status. Additionally, I'm going to clean up that Y label. All right, so this is much better at showing the work from home status, and we're comparing the two values. It's an overwhelming majority of false values for the requirement to work from home. So I'd argue this is actually a really good pie chart to use. Now I've taken all this code above and I've pasted it below and just changed this column now to show the job title short column. Let's go ahead and look at that one. And I have the wrong title here and updating it for job titles in Luke's data set. Real original, I know. So with this, I'm not a fan of it because it's hard to compare the differences between these. Specifically, whenever I'm looking at this for data analysts, data engineers, and data scientists, I have a hard time telling which one is actually higher. When we compare this to, I basically ran the same thing below, plotting it with a horizontal bar chart. When we compare it to this chart, where it shows the job titles in Luke's data set, we can clearly see that data analysts outpace data engineers, outpace data scientists. Much better, especially with how many there are here. So we need to be very careful when we're using these pie charts that we're using it on the correct thing. If we have more than 2, I would start questioning if you should be using a bar chart instead. Now, getting back to that original pie chart, there's 2 things I want to customize on this. First is the starting angle of where this is actually starting. When you initially look at a pie chart, you're going to look at the top center portion of it. So I want to orient this to where these values of the true are up at the top. So I can specify the argument of start angle and pass it in. I want it to start at 90 degrees. So this is much better of what I want. And just to show how this is going, if I were to put in 180, it's pointing all the way to the left because the reference point is all the way over here on the right where 0 originally is. So we have 0, 90, 180, and then just for fun, this is where 270 would be. Now, the other thing I want on here are percentages outlining what the true values are and what the false values are. So for this, I'm going to specify auto PCT or auto percentage. And for this, we need to use a format specification mini language. So I'm just going to put something in real quick to show what actually it looks like. And it's going to be %, 1, and then F. And what this is going to return is the associated percentage for each of these. So true is at 8.8%, 91.1 for false. So if you're curious about the documentation, I'll provide the link below, and it's underneath the string section, and it goes into a lot of detail of all the different special characters that you could use inside of this to format a string. But the quick crash course is this. The percentage introduces that we're going to actually be formatting the text from here. So if I actually delete it and press Control Enter, it's only going to throw in 1F of what the text is right here. So I'm going to go and put that back. The 1 is the minimum width of number. So right here I have 8, but now I have 9, 1, which is 2. So it can be 1 or more. And then if I want decimal places, I can specify point. In this case, I only want 1 extra decimal place. So I'll specify 0.1 running this. Now we have 8.8 and 91.2. The F in this specifies that this is a floating point number. Now, the only last thing to add to this is we need a percentage symbol on there. Special for this, we need to specify 2 percentage symbols for it to actually do that. So now I have it completely formatted how I want it with appropriate title and different labels. Overall, pretty impressed. Now let's take this up a notch. We have 3 different columns in here that provide Boolean values for different job postings, specifically work from home, no degree mention, or health insurance, whether it's required or not. So let's use our knowledge of subplots and actually plot all these pie charts onto one single plot. Now, in order to do this, we're going to have to obviously define that plot.subplots, and then we get back that tuple of figure and axis. We're going to start simple first by only plotting 1, and then we'll build on more using a for loop. So I'm going to only plot the job work from home first, and we're going to use Matplotlib's way of plotting this, basically calling ax, and then from there calling its method of pi. And inside of here, I'm going to provide that job work from home and specifically the value counts. Make sure this is plotting correctly. I'm just going to have it show right below here. All right, so pretty ugly, but it's shown below here. But now we're using basically the Matplotlib annotation for this via Pandas built-in plot method. Now I want to use a loop for this because I have 3 different pie charts. I don't want to go through and write this out 3 different times. That's just too cumbersome. I'm pretty lazy. So what I'm going to do is define this dictionary of the different columns. I'll call out the column name itself, so job work from home. And then for the value, I'm going to provide what we want as the header on this pie chart. So we're going to have 3 different pie charts, so we need to update our subplots for that. Remember, for this, we specify rows and then columns. So it'll be 1 row and 3 columns. Now we're getting to defining our for loop. So we'll call for, and I'm going to fill in what we're going to do here in a second because I want to look at this. We're cycling through our dict column items. And specifically, we want to run the enumerate function on this, right? Because when we run enumerate on like a list, it provides us an index back. And we're going to be using that for this ax right here to provide an appropriate index for it to specify where to plot the pie chart. We also need to update this in here. We're going to get to that real ugly right now. So what we're going to be getting back while we're enumerating this dict column of items is we're going to be getting our index of I, and then we're also going to be getting a tuple, so inside of parentheses, of the column, because we specified column on the dictionary first, and the title, because we specified the title second, and that's the values. Also, I'm realizing now I have spelled enumerate wrong, so I'm going to quick fix that. And for the time being, I'm not going to plot anything. I want to actually show all these values in case you aren't keeping up with this. So we're going to print I, column, and title. Commenting this out as well, running Control Enter. So we get the index for the first one of 0. We get the column of job work from home, and then we get the title. Now this is a tuple, so you have to put this in parentheses. If I try to run this, I'm going to get a value error. All right, so let's actually get into building all those different plots then. So we already have that we're cycling through the different indexes and we provide the appropriate access via our bracket notation, so I in this case, and then we're going into the building the pie chart. We now need to specify the column in this case here, and we're going to basically be doing the same method of value counts on each one. So let's run this to see what we have right now. All right, pretty cool. Not too bad. We got 3 pie charts. They may be right, maybe not be right. We got to actually update it. So we haven't used this title yet, so I'm going to go ahead and set that now next by specifying that axis and I, and then of set title, passing in title. Running Control Enter. We now have titles above each one. Now we need to actually getting the values inside of here. So I'm going to come up here to the other pie chart we did, and I'm just going to copy this start angle and then this percentage formatting and paste it right into here. And then running this, we now have percentages. And yeah, this is looking good. The only thing we don't know is which of these values are true and which are these false. So we actually need to pass in one more parameter to this, and this is labels. And you provide a list of labels and you have to pass them in correct order or they'll be wrong. Specifically, we're going to pass in false and then true. Running Control Enter, we have it, and then I can come back up here. I'm going to just verify the false is the bigger value for the work from home. And it is over here. If I were to get these labels in the wrong order, I'm going to update in the wrong order. It's going to reverse it, and you're going to be providing people bad data. So don't do that. So updating this for the correct labels, bam, we now got our final visualization using loops in order to enumerate through and basically graph everything, and we don't have to write repetitive code. It's pretty cool what we just did here. All right, so now it's your turn to get in and get your hands dirty making these pie charts. Remember, it's very important that you're using it whenever you have the correct number of variables to actually showcase. If you're getting more than 2 or 3, you need to consider going to something like a bar chart. With that, I'll see you in the next one after you work those practice problems. See you there. All right, now that we got pie charts out of the way, we can get into more of my favorite visualizations, starting with this one of scatter plots. These type of plots are great at showing correlation between multiple variables. So in this case right here, we're able to see how things like median salary and also the demand or count of a skill correlate to each other. Just a spoiler alert on the insights of this, if we look at it, we can see Python is up in the top corner, meaning not only is it a highly paid skill, but also it has a high demand based on where it is on the x-axis. So super great insights out of these type of plots. We'll get to building that one in a bit. Let's start with a simple example. So let's get into just plotting a simple example first. And I'm creating this fake data frame here. Inside of it has different job skills of these skills right here. And then there are made up counts and also made up pay. And then we then transform this dictionary into a data frame. Now that's a data frame, we can actually plot it. So I specify the data frame.plot. For the kind, I call out that is a scatter plot. And then we need to provide the X values. So what we're going to put on the X axis, and in our case, we're going to use that skill count column. And then for the Y axis, we're going to pass in that it is the skill pay. Okay, running Control Enter, Bam, we have our scatter plot. Super simple to make. This chart needs to be cleaned up. It's a hot mess, but at least we're understanding now we can plot things by their X and Y coordinates according to the skill. Also, this isn't labeled. We'll fix that later in this. So we need to get our data in a form similar to what we provided here of that skill pay and also the skill count aggregated by each of those skills. So what we're going to need to do is create this data frame, which it has 3 columns. The first one is the index of the job skills itself. And then for each one of those skills, we need to know what the median salary is and the count is. And the purpose of this format is so that way we can use that median salary as the y-axis and the count of those skills as the x-axis on our scatter plot. So as always, I've imported on our libraries, loaded the data set, and then done our standard data cleanup. For this one, since the skill and pay is very dependent on the job title, we're going to filter this data set down to data analyst. We're replacing the entire data frame of DF. So we don't necessarily need to make a copy of it in this case. I mean, you can, but it's not really necessary because we're just replacing the entire data frame. So the first thing we need to do is explode out that skill column. Sort of fun to say too. So I'll create a new variable called df exploded, and I'm going to run that explode method on the job skills column. Showing it below, we can see that we have those repeated indexes, and now that job skills column is broken out. So now what we need to do with this is we need to do a grouping. Specifically for the job skills, we need to group the job skills in order to get the count of these skills. But then also for that salary year average column, we need to aggregate for each of those skills the median salary. So with this exploded data frame, let's actually start grouping it. We want to specify that we're using the job skills column for this. Just running a simple size on this, we can see the different counts of all these different job skills in this. But remember, we want not only the counts of these skills, but also what is their associated median salary. Since there's multiple aggregation functions, we need to use that ag method. Now I'm going to press enter to go down to the next line because we're going to do something that we haven't done before. We're going to be using basically like a dictionary, if you will, in order to find key and values for how we want to do these different aggregations. We'll start with something simple. We'll start with the skill count. That's what we want to the new column name. So I'm naming the column right now. And I'm setting it equal to a tuple of 2 variables. For this, we have to provide the column that we want to do the aggregation on. So we want to be doing this on the job skills column. And we want to do the aggregation method of count. So now running this, we can see, just to reiterate, that skill count is now the column name that we're doing. And then we're using the job skill columns to perform a count. And these values should be similar to what we saw just now whenever we ran size. But we also want to do that median salary. So I'm going to create a new variable called median salary. And I say new variable, but new column name. And we're going to set it equal to that tuple of the column of interest. So salary, year, average, and then the aggregation method, median. Running this one, we now have skill count and median salary side by side. Bam, this is great. Now I'm gonna call this data frame that we got provided back a variable of skill stats. And that's so we can get into actually sorting the values of it, because right now it's out of order. It's only in alphabetical order by the names. We want to sort these values by that skill count column. Running Control Enter. We have this, but it's now in ascending order. So we need to set ascending equal to false. Okay, and now we have the skill counts with the highest, so SQL, Excel, Python up at the top. And then the final thing we're gonna do is we only need the first 10 values of this. So I'm just gonna run the head method on it specifying 10. And we'll set this all equal to the variable of skill stats so we can get into now plotting it. So with that skill stats, I specify the plots method, and we're going to be doing a scatter plot. As always, we need to provide an X value. So we're using skill count for this one, and then a Y value. And we'll be doing median salary for this one. Running Control Enter. We have our scatter plot now with median salary on the Y-axis and skill count on the X. I'm gonna clean this bad boy up a little bit by providing an X label specifying we want the count of job postings, a Y label of median yearly salary. Also like to usually specify that, hey, it's USD dollars. An appropriate title of salary versus count of job postings for the top 10 skills, and running that tight layout like we did before to basically shrink it down and make sure everything fits. And now we have this, which isn't too bad, but there's a slight problem with it if you're picking up. What are the names of all these skills? Like what's associated? Where's Python? Where's SQL? I don't know. Well, unfortunately, Matplotlib doesn't make this easy to actually work and with annotating this. We'll go into the Seaborn library later in the advanced chapter, and it makes it a lot easier to do this, but Matplotlib doesn't. So we have to do somewhat of a workaround to get this to work. For this, we're going to be using the text function from the pyplot module, and it adds the text that you specify to the axes at the location x, y, and the data coordinates. So basically we provide three separate things. We provide an x value, a y value, and then what we want put in. So on our plot up here, I'm going to add that plt.text, and we're just going to do a simple example first. We're going to need to provide x, so I'm going to say x 50,000, y 90,000. Both of these are near the middle. And then for the text or string, I'm just going to say Luke. Running this, we get Luke in the middle here. So I could technically go through, find all these different points, and then provide the appropriate label, or we can use Python to actually do this for us. Scrolling back up to the data frame we're working with, we basically just need to iterate through here using a for loop, accessing the job skills column to get the name to provide as the text. And then as far as the X and Y coordinate, we just provide the appropriate value from the column using something like 𝗕𝘃𝗃𝗍, which we can access this index using the enumerate function. Let me show you what I mean. So let's start by creating that for loop. And for this, like I said, we need the index, and then we also need the column name. We'll get the coordinates here in a second. I'll show you how we're going to do that separately. So we'll specify in, and we're going to enumerate from this. So that way we can get, oh my gosh, I can't spell enumerate at all. Enumerate. And then we want to enumerate through the skills stats, specifically the index of this. So we're going to be basically provided just this list right here, and they're going to provide index values. So if I print out I and text, I'm also going to comment out all this stuff. I can press Command / to comment out everything else. Running this, you can see we get, for I and text, we get the index and then the actual value of the index. So let's pull that graph back up by uncommenting out all this other stuff and pressing play. Okay, and so we have a graph back. Anyway, we need to now getting to actually enumerating through this plot.text function. I'm gonna go ahead and delete this print statement. And for this, we need to provide the X value first, which is the count of job postings. So for that skills stats data frame, I need to call out that skill count column. And then we want the specific value from the location of the row. So we're going to use .𝗕𝘃𝗃 method for this, specifying I. Similarly, we're also going to pass in that median salary for the Y position, specifying its 𝗕𝘃 location to get that Y value. And then finally, we want to provide that text we have, which is getting back the skill name. So let's go ahead and run this. And bam, now we have this graph actually labeled with all of these different values in here. Granted, we had to do this special for loop in order to figure it out, but we're able to do it nonetheless. And personally, I find this visualization one of the most insightful that you're going to get out in this entire course. It shows that based on demand and salary, things like Python, SQL, and Tableau, maybe even Excel, even though it's sort of a lower salary, these are high quality skills that you can focus on because not only do they pay well, but also they're in demand. Now remember, this is for data analysts. So if we wanted to look at another job title, you'd have to actually filter the data frame for that. Now it's your turn to get to work building the scatter plot and also working those practice problems. With that, I'll see you in the next one. Before we move any further exploring other plots like histogram and box plots, we need to get more familiar with how we can customize all these different plots. So for the first half of this lesson, we're going to be focusing on this line chart here where we evaluated the trend of skills over time. And we're going to talk about all the different parameters that you can adjust on it in order to make your visualizations pop more. Now, everything that we apply on this line charts can be similarly applied to other charts as well. So it's going to go good use on all visualizations. Now for the second part of this lesson, we're going to be moving back into that scatter plot that we just worked on. But we're going to be upgrading it. Not only will we be updating it so that labels won't be sitting on top of each other, but Also, we're gonna be updating that y-axis so that way it provides in a format that's easier to read. All right, with that, let's jump right into it. So here I am in my notebook. We've imported on all our libraries, loaded the data set, done data cleanup. I've added one more step in here of filtering for data analyst roles. All of this analysis is going to be specific to data analysts, so I wanted to filter for it and just get that out of the way. Now we're going to be working on that chart that we created in that exercise number 12 on trending skills. And I went ahead and copy and pasted all the different code in here and then plotted it down below. And as a refresher, the data frame itself, all it is are columns with the job skills, and then for each of the rows, it's indexed by the job posted month. And we have this all sorted in order of the highest requested skill down to the least. So let's get into customizing this. And for this, we're gonna be customizing the line chart area. So I don't really care about the title or the X and Y labels right now. We're just gonna leave them be. Now for the final visualization that we're gonna be building or customizing completely, we're going to be adjusting all the different parameters. And so I'm going to be going through them pretty fast pace of all the different parameters that we can cover for this. But I just wanted to give you a sneak peek of what we're going to be getting to. So starting back with our original graph, because there's going to be multiple parameters inside of the parentheses of plot, I'm going to go ahead and press enter, and it's going to make it indented. The indentation doesn't really matter. It's not going to affect Python because it's in parentheses. It's going to do everything. Anyway, we're going to first specify the kind, and then we know it's line. Because it's a line, we can do different things, like specify the line width. I'm actually going to make this a little bit bigger than what it is right now and specify the line width equal to 4. That pops a lot more. I don't necessarily recommend making it this big for all your charts, but if you need to make a point, this is it. Next parameter is line style. And say I wanted to make it a bunch of dots. Well, I can specify in this case, providing it the string of colon, pressing Control Enter. We now have a bunch of little dots. Now there's a few different options for this. It's standard comes as a line, but you could also do 2 dashes to signify that you want it to be a dash line, or dash and dot if you wanted a combination of both of these. We'll go back. All right. The next thing that we're going to look at is the color, because right now this is using the standard Matplotlib color mapping. We want to provide a different color mapping, and we're going to specify Verdus. And we'll go into more in a second, but I'm gonna go ahead and run it. And I spelled Verdus wrong, and I think I'm even saying it wrong. It's Verdus. I don't even know. I've never heard of this color. And I'm also getting the error because it says invalid syntax. Perhaps you forgot a comma, and I did after here. So make sure we have commas after each one of those. Running again, we now have this new updated colorway. Now, if you're curious about different color maps that you can provide to this, you can come in here to the cheat sheets and zoom in on this. They have a whole bunch of different color maps that you can actually provide depending on what kind of color scheme that you want. Next up, we're going to move to the markers, and we'll identify a marker first by just specifying how we want it plotted on there. I'm going to do an O, a lowercase o. Whenever I run this, it now has dots on here. But as far as options go for this, you can have a whole variety of different things. I think another common one would be something like an asterisk. And in that case, it plots stars, which is pretty cool, I guess. We'll just keep it lowercase o for the time being. Next up is the marker size itself. So we're going to make this the size of 5 since it's slightly, to make it slightly bigger than our line. Running Control Enter makes it, well, actually, I think I've actually shrunk it a little bit. And the last parameter that we're going to be doing on this figure is the fig size. And this specifies the width along with the height. So let's say I'm going to make it super long and then super short. So in this case, it's a 10 by 2. I don't really like the dimensions of this. I'll change this to 10 by 5. And now this looks a little bit better. Now with all these additions, I'm going to go back and add in that title, Y label, X label, everything like that. And we now have our final visualization, which not bad at all. Now, if you're curious of what parameters can be provided to this, you just need to go to the applicable plot that you're calling via Matplotlib. Because in this case, yes, we're using the plot function of Pandas, but we're graphing it using the line plot method from Matplotlib. So if you're curious about what different parameters you can provide for a bar chart plotting it via Pandas, you can come into the Matplotlib library under the PyPlot module and scroll down to see all those different parameters. And a lot of the same parameters are here, like things like line width. All right, let's shift gears and now get into customizing that scatter plot that we did in the last lesson. Here I've gone through and copy and pasted the code into here from last time. And I will call out that I did specify a number of skills to plot on there, specifically for that head method that we filter our data frame here on job skills. And right now I'm setting it at 20. Last time we used it at 10. This time we're using it at 20. We're doing it at more. And the reason is this. With only 10 last time, there was no overlap. But as soon as I start adding more than that, we can see that there's a lot of overlap in the text itself, and it gets harder and harder to read this. Also, I just like setting things as a variable because I can always easily update it. So in this case, I wanted 50. I could have 50 skills, and then whenever I run it down below, it'll plot all 50 on here, and wow, that is a hot mess. Anyway, let's go change that back to 20. All right, this looks a lot better. So what we're gonna be working towards is updating this visualization to use a special library in order to make sure that we don't have these overlaps. And if there is, it provides arrows basically pointing to the associated dot with the skill. So for this, we're going to be using adjust text, and specifically, this is the documentation for it. And it's made to provide this function right here of adjust text. And the whole purpose of this library is to adjust text as shown here. And it can do some pretty complicated things. Now back to that documentation, we need to provide it the parameter of text, which is a list of Matplotlib text objects to adjust. When we just worked with that plt.text in the last lesson. So it's gonna be pretty similar with this. Anyway, the first thing we need to do is actually import in that function. So we'll do from adjust text, import adjust text. Now you have not installed this library yet. So you'll need to open up your terminal using control tilde, make sure you're in the correct Python environment, and then put in conda install adjust text. I'm gonna run it, but it's basically gonna say, hey, you got it already. And it confirms all requested packages already installed. That's for me, I've got it installed, you don't, you need to do that. Okay, I'm gonna go ahead and close this terminal out. And we're not gonna start over for this plot right here. I'm gonna take all of this code and bring it down into here. So I'm gonna come down here and insert that in, press Control Enter, and get that visualization showing. Now you can see that here, adjust text is grayed out. We're gonna add that in. We need to put that below where we're actually generating all that text. So we're gonna put it right here of adjust text. And the argument that we're going to be providing to it is the first argument of text, which is a list. So I'll just call it what it is, text. This is not defined yet. We actually need to create a list to do this. So I'll say text equal to an empty list. Now this list is a list of all of these different plt.text calls that has basically the X value, the Y value, and what we want for the text. So we need to insert this or append this into text. So I'm just going to call out text.append and wrap this entire thing in parentheses. All right, let's run this and see what we get. All right, not bad. It's actually moving stuff around. There's no overlap anymore, but you can't necessarily tell, like in this case over here, like which one's Oracle and which one's SQL Server, and which one's Flow. We need some arrows going to it to explain that. Now going back to that documentation, anytime I'm sort of caught up on what I want to do with it, I can just look at some different visuals and see potentially what I want to use. In this case, I want to use this arrow props parameter. I'm just going to copy this entirely in. And I want to use that to actually specify what to actually point to. And that was going inside of our adjust text function. So I'll paste it in right in there with the same things that we were using in there. And pretty neat. I don't really like this red value. We're actually going to change this to gray. And the line width, we'll make it a little bit bigger. All right, bam. Now we have arrows pointing to each one. So we now know which one the flow is, Oracle, SQL Server, all of these. So much better representation of the data set. Now, the last thing we're going to be doing is customizing this y-axis. Specifically, I want to better format these values to be a $, then the first basically 3 digits of the thousands, and then specifying that's the 1,000 by a K value. So it's not these long numbers that we have right here. So in order to do this, we're going to have to use the class of funcformatter. And inside of it, or what we're going to provide to it, is a function. Specifically, we're going to be providing a Lambda function to make it easy. Anyway, the function takes in 2 inputs, a tick value X and a position POS. and returns a string containing the corresponding tick labels. That's why it's underneath ticker. And let's get into modifying this using that func formatter. Now for this, we're going to be modifying, we're not modifying the figure itself, we're going to be modifying the axis. So we need to access that access element or object. So we can do that one of two ways. I can call out 𝗕𝘃𝗃, and then from there specify plt.subplots, and then just pass in no arguments. And now we have access to the axis object, running it like this. Have Control Enter. Alternatively, I can specify ax is equal to, inside of our 𝗕plot module, we have a function called getCurrentAxis. And that will also, running this, getCurrentAxis, that will get the current axis. So we'll just leave that one for the time being because we don't really need fig. Now the one problem with this function call of GCA, if we look down here, our scatter plots completely disappeared. We actually have to call this of getting current axis after we actually generated the plot. So I'm going to come down here, at least underneath here, and call out the axis itself. Now running this again, we can actually see we get all our value backs. Okay, so we want the y-axis of this axis object. So I'm going to specify ax.y-axis, and then we're going to call the method of setMajorFormatter. And now this is where we're going to put in that plt.funcFormatter. Okay, remember inside of here, we need to pass a function. Specifically, it's going to be a Lambda function. And with that Lambda function, we get two values. It said X and also POS or position. And just for the time being with those two arguments, I'm only going to print back out the X that it provides. Now I'm going to go ahead and run this. Whenever I run X, we're going to notice the labels down here are going to change with the X. And they're going to change now to basically a floating point number. Anyway, we're providing the number back. That's what's inside of this X argument. Also, I'm realizing now this is the y-axis. So we're going to change this actually to Y. Alternatively, if I wanted to see the position, just to understand what it is, it returns the index value, or you will, of each of these tick marks. But we don't really need that. I don't really care about POS, but I have to call it. All right, so we have our Y value. Now we actually need to get into actually formatting this. And the easy way of doing this is actually just passing this in via an F string. So I can do an F string, and we're just gonna pass in the variable of Y for the time being, just to make sure that it's running. But we can format this now. So if I want maybe a $sign at the beginning, I'll put a $sign, and then I want a K at the end to get what we want at the end. We now have a $sign and K. Now we want to cut off basically these decimal places and also these last three zeros. So what we can do is take Y, divide it by 1,000, trying this. We have it, but now we have this .0, and that's not really necessary. So what I'm going to do is convert this, now this operation that I'm doing, to an int. Running Control Enter, bam, we now got what we want. That y-axis is now formatted exactly how we need it, with those 2 to 3 values in between the $sign and also that K value to indicate 1,000. Now, when you jump into it, if you want to, you can get into formatting the x-axis, but like I hinted to in past lessons, we're going to be actually changing this out to a percentage based on what is the skills percentage based on all job postings. So I'm not cleaning it up for the time being. Now, formatting axes doesn't always come super easy to me. So don't be afraid if it's not coming easy to you as well. And feel free to take advantage of things like ChatGPT. I'll frequently just take the code that I currently have that needs to be cleaned up, and I'll copy it. And I'll provide it a statement of what I want to do of, hey, I want to format the x-axis to have commas in it. Then from there, I'll just paste this code into it. And in this case, it went through and did a lot of the same things that we just did. Well, it did exactly the same thing except did for the x-axis. Anyway, I'm going to come up here and copy the code just to check it, paste it on into here. And this new line of code now goes through and updates that x-axis to have commas in it. So I'll be honest, I don't have all these formatting memorized. I have to rely on things like Google and ChatGPT to get me to the end results. All right, now it's your turn to dig in with some practice problems, and also if you haven't done it already, finish that exercise that we just did. With that, I'll see you in the next one. So we've covered the major type of plots already with lines, scatter, and bar charts. Now we're going to be moving into more of statistical analysis visualizations, particularly in this session of the histograms and the next one of box plots. Histograms are great at showing the distribution of values. In this case right here, where we're looking at salary, we're able to quickly see by this that the salaries are very much grouping around 100,000. And then when we diverge from that, they're becoming less and less frequent. Now, what we are noticing from this is that the data is skewed to the right. Basically, we have that long tail where the data is going out to almost $400,000. And this is pretty common whenever analyzing salary. But enough of me actually talking about it, let's get into it. So I've gone through and done the standard imports, loaded the data, and done all the data cleanup of cleaning up the job post date and the job skills. Both of these actually aren't really necessary for this section. Now I want to filter down to not only specific job titles, but also specific region, because salary is going to fluctuate depending on where you are around the world. And in our case, job titles. So I filter it for data analyst and also for the job country of where I'm at right now, of the United States. I've also used this copy method to make sure we're not altering the original data frame. Now, in order to generate this visualization is pretty simple. You just provide it a column and it automatically does the aggregations necessary to build the histogram. So here I am with the salary year average column, and all I'm going to do is call plot on this. And I'm going to specify for the kind equal to hist. Running Control Enter, we get this thing, which is an ugly piece of mess, but nonetheless, it's showing pretty similar to what we saw in the intro. But we can fine tune this further. Right now, the bins, so basically how wide each of these are along here, there's about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, about 10 bins right now. So what I can do is I can specify a larger number of bins, such as bins equal to 30. And now it's making them a lot smaller and we can see a lot of things within the data set. If we go too big of a number, we're going to start to see a bunch of like ups and downs throughout the data set, and it's not going to tell us as much as we want to. So I'm going to settle on 30. The last thing I'm going to do to customize this is add an edge around each one of those bins. So I'll specify edge color and set it equal to black. Now familiar with how to make histograms, I want to go through and clean this up. I think the main thing I want to focus on is down here on the x-axis. And these are the salaries. And right now we have a pretty long tail. Personally, I don't find a lot of value here after 300,000. I know we have an outlier out here of around 375,000, but we don't necessarily need that in here. So I could come up here and call out plt.xlim, and you provide two values of this. You provide the start of 0 and then where we want to go. So in our case, let's go to 250,000. Running Control Enter. Now we can see a lot closer into the histogram. I could even now when we zoomed in, I could probably boost up those numbers a little bit on bins. And yeah, this thing is looking beautiful. Okay, now what we want to do is format this x-axis. In the last session, we went through and actually formatted these number values to be a $sign and then cut it off on the thousands place. So I'm not going to walk through all this code again. I just copied and pasted from the last time, and also updated the variables to be x now for both of these since we're doing the x-axis technically. Anyway, now we have number values. I think the only thing last to do now is actually add some titles. And I've added this title of Distribution of United States Data Analyst Yearly Salaries and updated the X and Y values for this to get our final visualization. And bam, we now have this bad boy. We could probably put on the Wall Street Journal for how good it looks, showing the distribution of our different salaries. And we can really see how now this median is probably somewhere around 80 to 90,000 for these yearly salaries, along with showcasing how it has this longer tail. So a lot of great insights coming out of this. All right, so that's probably my fastest lesson in the advanced chapter. But now that you have this knowledge of histograms, after you work through those practice problems, you're going to be then set up to go into box plots next, which are going to build on this. With that, I'll see you in the next one. All right, now that we're familiar with our first statistical distribution plot, specifically histograms, we're going to now move into box plots, which I feel are really great at comparing values. Specifically, we could look at something like the distribution of salaries across data analysts, data engineers, and data scientists. We're going to be doing that. Now, the reason why we covered histograms first is because box plots really build on that. They both show distributions of numerical values, and box plots are very much coordinated to this. So after we go through a simple example of graphing, we're going to break down how to interpret box plots. So here we are in my notebook. I've imported in the libraries, I'm loading the data, and going through all the data cleanup for it. Just like the last lesson, we're going to be focusing on only data analysts in the United States because we need to make sure we're not including too many jobs when looking at a single distribution. Also, we've gone through and dropped all those non-values. So let's inspect that column that we're going to be looking at most. And for this, I just want to get a sample of the top 10 values of it. And as we can see, they're numerical values. None of them are really the same. They're distributed all over the place. So this is why box plots are great for that. So jumping into building it using Pandas, all I'm going to do is list that data frame along with the column of interest. So in our case, salary year average, and call the plot method on it and specify I want it to be a box plot. And we get a box plot. Alternatively, if I wanted to use Matplotlib to plot this, I could use the box plot function. And for the argument, all I provide is that column of salary year average. Running this, I get the same looking thing. Now, personally, I don't like the orientation of up and down using that y-axis. I would prefer it to be horizontal. So whether you're using the Pandas built-in method to plot this or Matplotlib, you can just specify vert equal to false. And vert stands for vertical. Anyway, this is something more online on what I feel I can interpret a lot more easier. So let's break down what's going on inside of this box plot. So this was a great diagram I found on KD Nuggets, breaking it all down. We're going to start in the middle first with the box itself. The yellow line right here, in this case, is the median. So it's representing the 50th percentile value. And we've talked about median and average before. I prefer median, especially in salaries, because of that skewed right that's happening. I don't want to use average because we would think that the salary would be higher than it actually is. Now the box itself has, on the left side, is at the 25th percentile, and the other it's at the 75th. So everything in the box is 50% of the data. And this is also known as the interquartile range. Now we also have these lines protruding out this side. They look kind of like whiskers. So you also hear this chart being referred to as a box and whiskers chart from time to time. Anyway, these lines that go up and down on each side are meant to signify the minimum and maximum. They're not the true minimum and maximum. They're calculated by these formulas, and they're definitely not something you recommend, but they are something you need to understand that they're not necessarily the true minimum and maximum, because we could have data points that protrude even further out. And for those, we call outliers. And they're plotted as individual points when they fall beyond those whiskers. So I stayed up all night last night, and I ended up making this beautiful thing, which I'm quite proud of. And for it, we have both that histogram that we plotted in the last lesson and also the current histogram that we have for data analyst salary in the United States. And I made sure to plot them on the same x-axis. Now it's pretty neat with this because now we can see how this data actually correlates between this histogram and to this box plot. Specifically for the median, where it's marked with that blue line here, I put a red dash line also on the histogram above to show where the median is. And look at it. It's right in here where the peak is of the most values, although that's not always the case. Next is the interquartile range, and I'd had this outlined by the yellow dashes on each side. So even look at this histogram where we can actually see the bins of all the data. We can see more realistically, okay, yeah, 50% of the data does look like it falls within those yellow dotted lines. And then finally from there, we have our minimum to maximum. For minimum, we don't have any outliers on the low side, but look on the high side. We have a lot of different outliers with this. Remember that maximum is not the true maximum because, well, we have more than that. Anyway, pretty proud of this visualization. May put it on my fridge. Anyway, let's build on this box plot that we have from our first example for data analysts only. I want to actually now get into comparing different salaries of different job titles in the United States. And trying to compare histograms on top of each other, I'm not really a fan of, but box plots are great for this. So what do we need to plot all three of these salaries of data analyst, engineer, and data scientist? Well, this is what we're going to be providing back into that box plot function. The first variable is the job list, and that is a list of all the different series values for the salary for data engineers, data scientists, and data analysts. And then along with this, we will also need to provide labels. So just the name of data analyst, data engineer, and data scientist. And then of course, I like it false, I'm picky, so we're gonna go with that. So let's start with the job titles first, because that's the simplest. I'm just gonna make a list of the different job titles. So now that we have that list, we need to, up above, we had filtered the data frame to be for data analysts in the US. We need to basically do this, but remove that of the data analyst. So instead of this data frame being data frame DAUS, I'm just going to remove this. It's going to be data frame US. We still want that country of United States. So this portion is going to remain the same, but I want to alter this portion here of the job title short. With this column of df job title short, we can run the is_in method and pass in job titles. So that list above. Basically, it's going to filter through and only return the rows that have data analysts, data engineers, and data scientists in it. I'm going to go ahead and comment that out and then show this down below. So doing a value counts on the job title short column, we can see we have data analysts, data scientists, data engineers. Now, inspecting that salary year average column, we're going to have to remember we have a bunch of non-values. So I want to remove those out of here. So for our data frame US, I'm going to set it equal to itself, and I'm going to drop NA. And specifically, we'll specify the subset equal to salary year average. So running this and then running below. Okay, now we removed all our non-values. So now we have a data frame that has our data scientists, data engineers, data analysts, all that data into it. So looking at what's left, we need to still get that job list, which is going to be a list of each of those different series values, if you will, for the salary year average column for data analyst, for data scientist, and for data engineers. And so we can do list comprehension for this. So I'll specify job list here, and we'll start building that list comprehension. Now we're going to define how we're going to filter the data frame at the beginning. So I'm just going to put some blanks for the time being. But to understand, we're going to be going through for job title, which is a new variable I'm defining, in job title. So we're cycling through this list in here, and we're going to be passing it to here on what we want to filter for these different series. So specifically, we want that DFUS and that salary year average column. And we want to actually filter this even further by the job title short. So I'll put another brackets in there. We'll specify the DFUS, job title short, and we're going to use the comparison operator. Hey, is it equal to this job title that we're going to be passing through it? Okay, so let's see if it runs, and we didn't have any mistakes. So let's actually inspect it below. So I'm going to call job list, and I just want to call the first one. So we'll specify 0 in that list. And we get a series back of all the different of the salary year average. So got what we want. So we're going to uncomment this. We're going to plot it now. We're going to pass in that job list along with the labels of the job titles and the vert equal to false. And bam, now we got this one, which definitely needs some cleanup, especially that x-axis. But we have now all the values put onto a single plot. I'm going to add some titles, specifically adding the title of salary distribution in the United States, the yearly salary for that X label, and then a plt.show so we can get rid of this stuff right here. Now it's looking better. Still want to clean up this bottom axis. Now, in order to do the bottom axis, we need to get that axis attribute. So we'll call plt.getCurrentAxis, and I can set this equal to a X. Now with our axis, we want to modify the X-axis, and we specifically want to set the major formatter. Inside of here, we're going to use that func formatter function. And for this, I'm going to just copy and paste what we used before. Although we did the Y-axis before, so I'm going to change this just to X to have the nomenclature right. It's still going to work. Anyway, it's going through, dividing the values by 1,000, so we get rid of those last 3 decimals, or so we get rid of those last 3 zeros, and then adding a $sign and a K onto it. Let's run this bad boy. And it looks like I have an issue. Not enough parentheses on here. And now I do have enough parentheses. All right. Oh yeah, this is good. Now the only other thing I've noticed, I have this major outlier up here. I would definitely want to be truthful about this, but in my case, I care about looking more into this. So I'm going to filter the X values from 0 to 600,000 so I can look better into it. So for this, I'm going to specify the plt.xlim, specify 0 and 600,000. Running this, bam. Now we have this beautiful bad boy. So we can interpret a lot of things out of this. First of all, data scientists, look how big their box is compared to things like data analysts and data engineers. It has a lot bigger spread for the salaries. We can also see it as a bigger spread by the outliers that go out from it. The other insights we can see from this is obviously data scientists are more likely to have higher salaries than data engineers, and likewise data engineers than data analysts, which we're going to need to investigate more on why that is the case when we move into the project. And it has a lot to do with the skills and the years of experience required. But this is pretty neat to actually see visually how these different salaries are distributed and what you could expect depending on the role that you choose. So now it's your turn to dig and try it yourself. And we also got some practice problems for you to go through and make some different box plots as well to better understand how to use these bad boys. All right, with that, see you in the next one. So we're getting into the final exercise for this advanced chapter, and I promise it's for good use. We're actually going to be building, or what we're building here is going to be going towards what we're trying to solve in the final project. Specifically, we need to dive further into those skills and analyze for data analysts in the United States, my situation, feel free to adapt yours. What is the pay for their associated skills? And specifically, I want to analyze this from two perspectives. One, I want to just see in general, what are the top 10 paying skills? And then related to that, I want to see for skills that have the most demand or the highest count, what are their associated salaries? So we're going to be taking advantage of everything we've learned so far in this advanced chapter, be able to plot all of this on a single plot. So let's jump in. I'm inside of a fresh new notebook, imported in all the libraries, load the data set, and done our standard data cleanup. Similar to last time, because we're analyzing salaries, I want to get very specific with what we're looking at. And we're going to be filtering for data analysts in the United States. Make sure when you refilter, run that copy method. Additionally, because we're only looking at salary, we don't need any of those other postings that's just going to slow us down that don't contain salary data. So we're going to go ahead and just remove it by dropping NA. So now we have just this final data frame, and it has only data analysts in it. We need to now go forward and clean up this skills column, basically explode it out. I love saying that. So I call out explode method on this and specify job skills. And then just to inspect it, I'm going to call this on the job skills column to see what happened there. When I control enter, we can see nothing happened here because I didn't save it to the original data frame. This is why it's always good to check your work. And okay, now we have all the skills broken out. So now we need to get a new or two new data frames aggregated based on the salary year column and job skills. Specifically, we need that median salary correlated with each skill, but then we also need the counts of each of these skills so that way we can filter later to get what are the highest count skills to display at the bottom of the chart. So basically, we need to do multiple aggregations. So we're going to use the group by method for this. So with our exploded out data frame, I'm going to call the group by method on it. And these groupings need to be done on the skills themselves. We basically want to see the counts of the skills and then the associated median salary of those skills. So I specify job skills. Now for both of these, we're going to be running a count and also specifically the median on that salary year average. With both of these, I'm going to run now that ag method, and we're going to specify with a list that we want to do count and also median. Let's go ahead and run Control Enter. And now we have it back. Right now it's sorted in alphabetical order on count and median. So I'm going to call this DF, DA, US group. Set this equal to this. Now we need to get two new data frames. We need one data frame with basically the top 10 highest salaries. And then we need a second data frame with the top 10 skills that have the highest count with their associated salary. So for the top pay one, I'll create this new data frame called DFDA top pay and set this equal to DFDA, that US grouping that we have now. But we need to sort the values of this. So we're going to sort values specifying the by of median because we want to use this salary column to sort by. And then we'll just throw in an ascending to making sure that it does it in the correct order. And finally, I'm just going to run a head on it of only 10. We only want to display 10 values. Showing it down below this, pressing Control Enter, we get top 10 skills based on median salary. So let's create that second data frame we need now for the skills with the highest count. So we'll call this one DFDA skills, and we'll set it equal to that original data frame of the US grouping. For this one, we'll sort values by count. And pretty much everything else is the same, ascending equal to false, and head is of 10. Let's inspect this one as well. All right, we can see, as we'd expect, SQL, Excel, Python near the top with the highest counts, and then their associated median salaries. Great, let's now get into plotting this bad boy. So since we're using 2 plots on this, we need to run that subplots function. So I'll specify a fig and ax and set this equal to plt.subplots. Then we need to specify the rows, so 2 in this case, and then columns of 1. So we're gonna plot the top pay data frame first. So I'm gonna run the plot method on this, specifying the kind equal to bar h. Next, we need to specify what y is equal to. Do we wanna do it the count, or we wanna do the median values? What are we actually plotting here? We wanna plot the median values. From there, we're gonna set the ax equal to ax, and then we're calling that 0 indexer. Now we're gonna do the exact same thing for the other one of skills. And I'm gonna go ahead and just copy everything from above and paste it in below because it's exactly the same. Except for the ax, we gotta change that to 1. All right, let's go ahead and plot this, see what we have so far. All right, oh, not too bad. Definitely some cleanup in the formatting, but we have what we want. Well, the ones for the top 10 for the most in-demand skills, this is not sorted correctly. We didn't sort this, so let's actually fix that real quick. We sorted that by count up here, but then we needed to sort it again, basically, by the median after this. So I'm gonna just take this little snippet right here and then append it on to the end, run this again, then run this. Okay, so both of these now are sorted in, well, descending manner, but we're gonna fix that. Now, one way we've done this before is just calling ax, and then from there specifying 0, and then running that invert y-axis. Pressing Control Enter, okay, we inverted it. An alternate method that you can do for this is whenever we pass the data frame itself, we can just call it in reverse order. And we can do this by specifying : -1, because the last value in this is the step value. And in this case, we're saying, hey, plot it in reverse. I'm gonna remove this and run it again, and bam, we have it like this. So it's really up to you on what you wanna do. There's so many different ways you can go about it. But now we have both of these sorted in the correct order. Now the next thing is I want both of these plots to be on the same x-axis. So right now this one at the bottom goes to 100,000, this top one goes at 200,000. This is not good to compare to one another. So we basically need to set an x-lim on this bottom one and extend it out to whatever exactly is the top one using. So since we're modifying the axis, we'll specify the axis of 1. And then we'll call that set xlim. And what's neat about this, we can then get whatever this upper axis limit is by specifying x of 0, so for the first one, and then running get xlim. Okay, so now running this, hopefully this works. Oh, it is work. Okay, so now the axes are perfectly matched and it actually is representative of the data. Now I'm just gonna do some minor formatting cleanup with these labels here. So for the first one, I'm adding a title and then removing the X and Y labels. Similarly for the bottom graph, I'm doing the same thing of send title, but I do keep an X label down here for median salary. I only think we need 1. Additionally, we have this currency and we've formatted it before. So I'm not gonna go through this again, but we're using that func formatter in order to format it. So I not only use it for the top one, but also for the bottom one. Let's see what we're running at right now. Okay, this is looking good, but now we're starting to have overlap between the two, specifically this titles running into the axis up here. So on the figure itself, we can run tight layout. And also, sorry, and the only last thing I think is now we need to remove this legend because it's sort of redundant to have this median right here. For this, we can just specify inside of here, legend equal to false. Running this, we have now our final visualization. Yes. And this is obviously specific to data analysts in the United States, but it's really interesting to see some insights from this one. None of these tools up here in the top 10 highest paid skills are necessarily super popular, with the exception of maybe I would say Hugging Face. But I can say the one core thing about all of these is they seem to rely on understanding cloud technologies and how to use these type of technologies in order to build data solutions. So don't overlook learning about the cloud. As far as the topmost in-demand skills for data analysts, this seems to be more generic level skills like Python, R, SQL, Power BI. And these are skills not only data analysts would use, but also potentially business analysts and managers. So not bad work there. Make sure you're saving the work that we did here because we're going to be using the same plot inside of our project. All right. We're now moving into the final lesson of this advanced chapter, and it's sort of a bonus one I wanted to include on the Seaborn library. I'm super excited to show you some of the visualizations we're going to build with this. With that, I'll see you in the next one. This lesson is going to be somewhat of a sneak peek into how to use the Seaborn library for visualizations. Now, it's only one lesson because, frankly, it's pretty easy to pick up, especially if you've already been using Matplotlib. Seaborn is built right on top of Matplotlib, so just like Pandas is built on NumPy, Seaborn is built on Matplotlib. So it's super easy to integrate Seaborn with Matplotlib, as we're going to show. So you're probably like, Luke, why do I need to learn another dang library? Well, if you go back to the plot from the last exercise, this thing's great, but if I wanted to maybe color it in order to show higher paying skills, or basically a more contrasted color to draw my eyes to it, it's gonna be super hard to do this in Matplotlib. But with only changing a few lines of code, I can implement this in Seaborn, and it allows me to color graphs a lot easier. Then the real power of Seaborn is unlocked whenever we get into more advanced visualizations. Like that histogram we did, well, we can turn it into this plot right here, where we actually smooth the lines and make it a lot more visually appealing. And it's not only for histograms, but also for box plots. What we did previously with them, we're now able to make into, I feel, much more beautiful and color contrasting to really draw my eyes to where I need to look in these types of visualizations. So Seaborn is going to save our butts. Now, Seaborn has a lot more visualizations than I demonstrated there. You can actually go to their homepage and check underneath gallery, inspect any different one that you maybe like. Oh, this one on black holes look pretty good. And it will provide all the different code needed to build this. And even as demonstrated here, they're still using Matplotlib along with Seaborn. And there's a lot of familiar code that you've saw before of like generating subplots with fig and x. So everything you've learned so far in Matplotlib is still going to apply when you use Seaborn. Now, before we get into writing away with Seaborn, I think it's important to understand the actual syntax we're going to be using to plot this. So if we navigate back to the Seaborn page, we can go into APIs. This has all the different code that we need for this. You can just scroll down the left-hand side until you find the plot of choice. So let's jump into my notebook. I've gone through and imported the libraries, loaded all the data set, and started the data cleanup. Now we need to install and then import in Seaborn. So using Control tilde, I can pull up the terminal and we're going to run conda install Seaborn. In my case, I've already installed it because I was working on building this course. But you'll go through the loading process and you'll need to accept, install, and proceed forward. Okay, for me it says all requested packages already installed, so I'm good to go. In here I'm going to do import Seaborn, and then it's very common to use the alias SNS. All right, running this, we now have Seaborn imported into here. For the first two examples, we're only going to be using data analyst data in the United States. Also, I'm going to be breezing through the code because all these different graphs we've generated before, so we're not going to spend a lot of time on them, going back into and explaining them. Anyway, running this, Control Enter. Then the first example we're going to move into are the bar charts that we created in the last exercise. And I've gone ahead and copied and pasted all the different code into here, and we have the different charts below it. So what we're going to do in order to show that this is in fact pretty much the same, I'm going to take all of this code right here and I'm going to paste it below here, run it, make sure it's still running and generating visualization. We're going to now alter this with what we can now use in Seaborn. Specifically, all the stuff that we modified the axes for, all this stuff can stay. It's actually this portion right here whenever we run that plot method on both of those data frames. So I'm going to go ahead and comment that out on both of these and create some room. Now this bar plot code is very similar to what we did back with the box plot. We need to provide that data and then also the X and Y. In our case, we want that horizontal bar chart. So the X values are going to be that median salary and the Y values are going to be the skills themselves. So basically the index. Now this example that we're about to do is exactly why I love Seaborn more than Matplotlib. It's because we can also specify this hue. And hue allows us to specify a column in order to color by. So we can have a gradient. In this case, we're going to specify the hue of the salary. And so whenever we have things like a higher salary, we can make it to where it has a darker color. And when it has a lower salary, it has a lighter color. And to determine what color to actually use, we're going to define this underneath the palette parameter. This is provided typically via a string. And we're going to cover more about the options of the different palettes in a bit. So we need to actually generate these plots now using Seaborn. So we'll specify SNS dot, in our case, we want a bar plot. That's the method that we're going to be running for this. The first thing we need to provide is data as shown on the screen. And that is just the data frame itself. And I can't really see because it's covering up, but I want this 𝗕𝘃𝗃𝗃𝗃. Okay, so that is our data. The next thing I want, although it's not highlighting it, is X. And for this, we want that median column. Down here, it's also Y. It does switch, but I promise that's for good reason. So we not only need to provide the X, but we also need to provide the Y. In that case, we're going to be doing the data frame itself, but we need to provide the index. And then the last thing we have to provide is this axis to basically specify which one we're actually using. Now with this built, we need to do the same thing basically on the bottom. So I'm going to copy it and paste it down here. And then I'm just going to alter it based on this data frame right here. So first replacing the data, what is going in there, this is 𝗕𝗃𝗃𝗃 skills. We're still using median. With that data frame itself, we want to reference the index for the Y value, and then their X is actually 1. Like I said, everything else is going to stay the same. Running, Control Enter, bam. We have exactly the same looking thing up here, although it does look like the bar plots are a little bit bigger. But I promise you, this is where it's good. Now we need to get into coloring it. Well, I like this example in the Seaborn library to help understand or show what I want to do. We want to go basically with sequential. As it gets from high to low, we want to color it in a gradient type format. Similarly, diverging is very much similar, but it's going to go from one color to another, vice a light color to a high. What we don't want to do in this case is qualitative. That is, we don't want to have a separate individual color for each skill. We wanted the color to be associated with the salary itself. So back in our code, we're going to provide a hue value, and that says, hey, what do we need to look at? What column do we need to look at in order to color off of? And we'll also add that down here. Well, now that we specified what we're coloring off of, we need a color palette to choose from. And Seaborn has a host of different ones to choose from. I'm a big fan of color blue, so we're going to use these two right here, basically combine it. For the top one, I want a dark to blue, and then the bottom one, we use a blue to a white. So inside of here, I'm going to specify palette, and this is a string. In this case, we're going to provide dark and then :B. Similarly down here, I'm going to do the same, but I'm going to call this one light, and the B just means blue. Now I'm going to go ahead and plot this, and we're going to have issues with this already. This isn't going in the order of coloring that I want. I want it dark up at the top, basically to draw your eyes immediately to it. And I wanted them to be basically associated. So in this case, the blue is good. Anyway, I want to reverse the coloring. It's actually pretty easy with Seaborn to do this. Every one of these different color palettes you have access to, you just add in an _R to reverse it. And now it's going from blue all the way to black. Now I'm noticing now that the legend is getting in the way. So I'm going to go ahead and actually remove that. I'm going to paste that in here, removing both of these. Running Control Enter, we have, bam, this, which is actually now more in line with the coloring scheme we need, and it really draws your attention up to the top, and then you slowly from there go down to the bottom based on the coloring scheme. Now we can also alter the themes of the graphs itself. So this is like the default theme, but we can change up the backgrounds and even how light or maybe dark the different colors are and how the axes are, basically by just specifying set theme. And then from there, specifying a style. Personally, I'm a fan of this one right here, of this tick style. So I'm gonna go ahead and just copy this right here. We're not gonna use that custom params. And I'm gonna come up here at the top, paste it in. Like I said, we're not gonna use this custom params parameter. We're not gonna go over it. Anyway, Control Enter. Now this thing, much more appeasing to the eyes. And I think compared to our last one, actually gets the job done on directing our attention. Next, let's move into that histogram that we worked with previously. We're going to be reusing a lot of this code here, but anyway, this was the visualization that we got with that. Now, let's alter it using Seaborn. Here I navigate to histplot, which is for a histogram. However, we're not going to be using this because whenever I scroll down here to show these different images that are generated by it, I want a smooth curve for this. And right now, this is very jagged edges, and you can't do this with the histplot function. But you can do this with displot or distribution plot. This allows much smoother curves in the final visualization and is more in line of what we want. Now this one's gonna be pretty simple on what we need to provide to it. We just need to provide the data and then how we wanna actually plot. Anyway, the data itself, if we scroll down to the parameters, you can provide something like a data frame, an array, mapping, or sequence. In this case, we're gonna provide the column of salary year average. So all the data is gonna be included when we provide this. So we don't need to worry about providing an X or a Y. The other thing that we need to specify is kind. There's 3 different types you can use in this. We're gonna be using that KDE. So I'm gonna copy all this code with the exception of that top plot method. I'm gonna come down here and paste it. Now, Seaborn has a histplot method, but we're actually gonna use the displot method. I personally like the style of the displot better. For the values we need to provide for it, we can provide the data source, but I'm gonna go ahead, since it's just a series that we're gonna be plotting here, I'm gonna just provide the column of DFDA-US of salary year average. That's all we really need to get started, and we'll go ahead and plot it. Now this is already compared to this, not too bad, but I wanted a more smooth outline of the distribution here. So what we're gonna specify inside of here is the kind. We're gonna use the string of KDE, which is kernel density estimation. Let's look at this one now. All right, so now this is basically an outline of it. I like this a lot more. I can specify some other parameters like fill, set it to true, so basically fill it in so it's not all that white stuff. So overall not bad, and even like last time if I wanted to set the theme, in this case using ticks again, nothing is going to change because I've already implemented inside the environment for this. So if I wanted to change it, I could, but it's already set in the environment. Anyway, we now have our final visualization, at least for the histogram, and I feel it looks a lot better than the last one. We could definitely put this bad boy in the Wall Street Journal. All right, one more example to go. Now with plotting bar plots in Seaborn, this is where we start to get slightly different the syntax that we used in Matplotlib. Previously, we had specified the data as only a series of values for the salary year average, but in this case, we need to provide X and also Y values for this. So instead, for our data, we're just gonna provide the name of the data frame. And then for X and Y, we'll just provide the column names and we'll know to use that data frame in order to access those columns. Pretty cool, as we can minimize the amount of code we have to write for this. This was our previous box plots example that we ran in the box plots lesson. And we can spice it up once again with Seaborn. So I'm gonna take all this code with the exception of that box plot right there that we ran and just paste it on below. For this one, I'll just call that box plot method on the Seaborn library, specifying the data is equal to the data frame of the US. We have X and Y values in this, so we need to specify all of it. For the X, we're basing it off the salary, so salary year average. Then for Y, we're gonna be using the job title short column. Okay, running this, pressing Control Enter. Looks like I have a typo in here, job title short, Control Enter again, bam! And now we have this one. Look how fast this one was. I don't like this over here on the Y-axis label, so we'll go ahead and remove that. plt.ylabel, and we'll specify an empty string, running Control Enter, bam! But look at this. Look how quickly we were able to make this visualization out of what we already did in Matplotlib. And personally, I hope you feel the same, that this one here, the Seaborn, a lot more visually appealing. So I obviously commonly use ChatGPT to help build visualizations, and frequently it provides back code using the Seaborn library. So it pays to be able to know and understand what's going on there. I don't feel it's that much harder to learn now that you've understood and mastered Matplotlib, so I do highly recommend you learn as well. All right, we have some practice problems for those that purchase the course practice problems. And with that, I'll see you in the next one. We're going to dive into actually building our final project. All right, congratulations so far. See you there. All right, it's time to get into the final chapter. You know what that means? You got to get on a new flannel. Now this is my business flannel. And basically we're going to be getting into business with this third chapter. And really it's a twofold approach that we're going through here. The first thing is we're going to be building on all the skills that we've been learning over the first 2 chapters in that basics and advanced chapter. And we're going to be doing this by building several beautiful visualizations that we're going to get into in a little bit. And the main point will be to put together all of the different work and insights you've gained over this course into a singular location, so that way you can then share it with the world and showcase your experience that you've learned in learning Python. So what is the ultimate goal of this project? Well, we're going to be investigating top paying roles and skills in the data science industry, and you'll be able to select which roles and location you want to use in order to fine tune your analysis to get insights specific to you. To accomplish this, you'll be using Python like we've been using on that same data set. And for those that are job seekers taking this course, you can use these insights in your job search in order to maximize and optimize where you get your next job. So what will be the final deliverables for this project? Well, opening up the Explorer, we have a folder created here called 𝗕_project, and we're going to be investigating 4 different questions. And then the first notebook was basically this one right here where we do some EDA. Now with these notebooks, we're also going to be having an accompanying README markdown file. And this markdown file is going to detail all the different analysis that we've done, along with providing insights for any non-Python users to go in and read what you've done. This makes it perfect to list in your resume, so that way recruiters can look and identify that you do have relevant experience in using Python. And in the next video, we're going to be showing how we can link our project to GitHub, so we can not only show all the different code we've done, but also show all those visualizations. So for this project, I'm going to continue to explore data analyst roles in the United States, but you're not limited to that at all. As you're probably more than familiar with that job title short column in our data frame, you have a host of options that you can choose from and pick on what you want to specialize. Also, you don't have to necessarily limit to just one role. Similarly, you can pick the country that you're located in. There's a 99.9% chance that I have that country available for you to use. Although there is a lot of data from the United States, there's still a lot for other countries. And this is going to allow you to explore job postings from a variety of companies. We can see some of the most popular include Citi, Walmart, Accenture, and Deloitte. So a lot of top names. So what questions are we going to be exploring on these follow-on notebooks that we're about to build? Well, let's walk through them each real quick. First, we'll investigate what are the most demanded skills for the top 3 most popular data roles. And this one we're going to build on further from the advanced chapter on Matplotlib, specifically this visualization that we built on counts of skills requested in US job postings. But we're going to step up this visualization a notch, and instead of using a count, we're going to use a percentage or likelihood of a skill being requested in a job posting. I feel percentages are much more applicable and useful to understand. If I'm a data scientist, I can see that Python is in 72% of job postings, which is an overwhelming majority. 3/4 of job postings require this skill. So super valuable insights from this one alone. The next thing to explore will be how are in-demand skills trending for data analysts. And you may recognize this plot from our exercise on evaluating trending skills back in the advanced chapter. But once again, we're going to build on it further. Specifically, we're going to clean up this plot with Seaborn, and we're going to change this to also show a likelihood of a job posting containing a skill. So that way it has more applicable numbers for us to evaluate. From there, we're going to look at how well do jobs and skill pay for data analysts. And for this, we need to evaluate other roles besides data analyst. So we're going to build on our box plot lesson by building this out to include even more job titles and sorting it appropriately so we can get some insights of how data analysts compare to other roles. Additionally, our work at the end of the advanced chapter is going to go to good use because now we have a use case for that visualization of understanding what are the highest paying skills and what are the most in-demand skills. And so this is also going to go in this section. Finally, we're getting to our last question to understand what is the most optimal skill to learn for a data analyst. And for this, we're going to be modifying the graph from our scatter plot lesson and updating the x-axis so that we include the percentage or the likelihood of a job appearing in a job posting. Additionally, as a bonus with what we learned about Seaborn, we're going to also color code this in order to find deeper insights with core technologies and how they are trending, whether it's for a program language, database, or cloud technology. A little sneak peek, it pays in no programming languages. All right, now it's your turn to get to work. You need to create a folder inside of here that's going to house all your different project work. I conveniently named mine 𝗕_project to basically have it in order with the chapters that we've done so far. We're going to be adding each one of these notebooks and this images folder and this README as we go along, so don't worry about that right now. You only need to create one Jupyter notebook right now and title it something like EDA Intro, as we need to go through and perform exploratory data analysis. So in this notebook, I'm going ahead and I'm importing all the libraries, loading the data, and done the data cleanup just like we've done before. With that down, I'm going to now filter down for US data analyst roles. And I'm going to specify the variable of df_DAUS and then filter that main data frame that we imported in for the United States and for data analysts. Now for this, I want to pick out a few columns from this data frame in order to perform some initial EDA. And also, if anything we've done in the advanced or basics chapter, feel free to bring into here as EDA. Before this, I'm going to explore in some things like this, like job location to see where all the city and states are, an analysis of the Boolean columns of whether work from home, a degree required, or health insurance is required. And then finally, analysis of what are the main companies in this data set. So let's get into that job location first. So for this, I'm going to use the value counts method and look at the top 10 of these. Running Control Enter, I see quite a bit of spread across the United States, with anywhere being the top one, which also correlates to all those remote jobs. So let's plot this. And I want to use Seaborn for this because I like the customization of it. And because of that, it makes it easier if it's in a data frame. So I'm going to use the method toFrame. Running Control Enter, we can see this turns now into a data frame with columns of job location and count. So I'll assign this data frame to dfplot. And we're going to be using that dfplot throughout all these different plots that we're going to make it. So since we're using Seaborn for this, I'm going to call sns.barplot. First thing I need to specify is data. So that's the data frame itself of df_plot. Next thing we need to specify is our x value. And since we're doing a horizontal bar chart, it's the values that we need to show our count in this case. And then for y, we're going to be using that job location. This is good enough for now. We'll go ahead and plot this. And we get this visualization. Now I want to spice this up a bit with some coloring. So I specify for the hue, I want to use count to color it by. For the palette, we're going to use my favorite one of dark B, and we're going to put that in a reverse order. Running Control Enter, we have this now. And this is obviously a different color than we're used to or you've probably seen previously. And that's because we're using a theme. So I can come up here and specify for the Seaborn, I'm going to set theme and specify the style equal to ticks. Running Control Enter. All right, there's a lot better coloring that I like. All right, I don't really like this legend here, so we're going to remove that as well. And we'll specify this as false. Now I need to clean up all these different columns and titles. So I've changed the titles, the X labels and Y labels, and then also add this D spine to basically remove this border around the graph. Running Control Enter, bam, we got this. And I realized I had an improper title, so I'm going to rename this as Counts of Job Locations for Data Analysts in the United States. Now the next thing we said we're going to explore are these Boolean values of job work from home, no degree mentioned, and health insurance. But we already did this in our pie chart example. So I'm just going to take the applicable code that I've already done from that Jupyter notebook, and I'm going to basically paste it right in here. And the only thing that I should have to change is the data frame, I believe right there to specify we're using the data frame for data analyst in the US. Let's run this bad boy. Sweet, that was pretty quick. Gotta love Python for being able to just redo work very easily with previous code that you've done and a update. So now we have for data analysts in the United States, it looks like 7.5% of jobs offer the ability to work from home. 28% have a requirement to have a degree, which I think that's pretty low. That's actually pretty cool. On the other side, only 35% of data analyst jobs offer health insurance. All right, moving into the last thing that we said we're going to explore, and that was the company name. So what are the different counts of the company name? Now I'm going to just copy and paste this job locations code that we used previously, because it's basically going to be a bar chart and it's going to display very similar data. Instead of using job location, however, we're going to be using company name. So I need to replace job location here and here. I can press Command-Shift-L. It's going to highlight all of it. So then I can go in and replace company name. And then I also need to update that title of counts of companies for data analysts in the United States. And we get this one where we see there's a lot of top companies as well from this. So Dice, United Health, Citi, and Hamilton. So a lot of good companies inside of here that we have access to for data analysts in the United States. All right, so that wraps up the exploratory data analysis I'm gonna do for this video. And with this alone, we've uncovered a lot of good insights on job location, on what are the different requirements or offerings from a job, and additionally, what companies are available for this. Now, in no way are you limited to only performing the analysis of those 3 visualizations. Feel free to take this further, or feel free to even dig back into what we've done previously in the basics and advanced chapter and bring it into this notebook to show the EDA for this. All right, with that, I'll see you in the next one. We're going to be getting into setting up a GitHub repository for our project. See you there. Have you ever wondered how teams of people work together in order to build things like Google, Facebook, or even ChatGPT? Well, version control systems are the core technology behind coordinating all those efforts in order to put code together and then build an app. And these same principles can be applied to what we're going to be doing in this lesson in setting up our Git and also GitHub in order to set up a version control system to track our changes and then share our code to the world. So what the heck is Git and what the heck is GitHub? Well, it all starts with the core technology of Git, which is a version control system. And these projects or folders that you have Git inside of can then be hosted on things like GitHub. That's an online solution that allows you to collaborate with others on your code. Now here is my project folder for my SQL for Data Analytics course. Inside of here, I have different folders, like this section here is on my advanced SQL queries, and it has all the different SQL files for it. This project itself has the version control system implemented of Git. When I press Command-Shift-, here I can do that on Mac, the following hidden files are shown, and hidden files are denoted by a period at the beginning of it. It basically just hides it from here. I can toggle it on and off if I want to. Anyway, I'm referring to this folder right here of .git. Inside of this bad boy is all the contents needed or files needed in order to maintain up to date on what changes I'm doing within my project. Now those files are hidden for a reason, as you shouldn't touch them at all, so I'm going to go ahead and make them disappear again. But the main thing to understand is any changes I do are tracked in that .git file. Now here we are inside of GitHub for the same SQL project, which is accessible at this public URL. So anybody can come in and access and view all the contents of this course. If they wanted to steal a SQL query, they could go into my advanced SQL file and then navigate in, and they have access to all my code. So combining both of these tools is super powerful because Git, like track changes in Microsoft Word, allows me to go back to previous revisions of a mess up and recover my saved work. Alternatively, GitHub allows me to store all this stuff in a remote repository, so that way if I need to go or share this with others, they can go to this. Now I've been using this term repository, but basically it's that folder that contains all the different files and folders or contents of your project. And Git is managing all those changes while GitHub is hosting them. So with this, you'll hear common terms like local repository and remote repository. There's a little bit of an oversimplification, but local repositories are what's located on your computer locally, and you can use version control systems like Git in order to maintain it. Now, alternatively, remote repositories store your local repositories. And there's a lot of popular options for this, not just GitHub for a remote repository. You can use things like Bitbucket or even GitLab. But GitHub seems to be the most popular, so that's why we're going with it. And these type of online services are great at collaborating. Kelly and I worked to build this course using Git and also GitHub to actually track and manage all these different changes for it. So it's super valuable. So what are we going to do in this? Well, 4 simple steps. First thing we need to do is get Git installed onto your machine. The second thing we need to do is set up a GitHub account and prep everything so we can get a repository onto GitHub. Next, we're going to go back to our project folder that you have on your computer and initialize the repository, basically start Git with tracking the changes on it. And then finally, probably the easiest of all, we're going to push it onto GitHub. So let's jump into the first thing of downloading Git. Go to the URL that's shown on the screen right here and download the applicable one for your operating system. For Windows, this is super simple to install. First, you'll need to allow the app to make changes to your device, accept some lawyer talk, accept the window that it has, keep all the defaults selected for what it needs to install and where it needs to install. For default editor, we're going to use Visual Studio Code. We'll leave the default for letting Git decide and also for adjusting the path. We'll keep the default for OpenSSH and using OpenSSL. And then we'll also check out Windows style, use MinTV, fast forward on merge, get credential manager, and enable file system. We won't enable any new support, and then we'll load. Oh my goodness, that was a lot. Then it'll be finished. For Mac users, you're gonna run brew install git inside of your terminal. Now for some of you, this may not work because you may not have brew installed. So running this, zish command not found brew. We need to install brew. So back in Git, I can click here on how to install Homebrew via this link. And it provides this, a terminal link on how to actually install this system of Homebrew, which manages different packages on your Mac system. It's super useful, so I highly recommend you install it. All right, so pasting that in, pressing enter. It may prompt you for your system password. I'll put that in. And it says it's gonna install these new folders for this. I'm perfectly fine with it. Okay, brew is installed. So it does say run these two commands in your terminal to add Homebrew to your path. So I'm gonna go ahead and copy this, the first one at least, press enter. Okay, so the first one looked like it ran, and then I'll copy the second one right here, paste that one in, press enter. Okay, we should be good to go. And then now we can run brew install git. And unlike that pesky install from Windows, we're now done. Now for both Mac and Windows users, you can check it's installed by just typing git inside of your terminal. And it should display a list of commands that you can run with associated git. Now, one thing that we need to set up now that you may be prompted for later if you don't do is setting up your username and email so Git knows who you are. So the first thing I'm going to provide is my name with git space config, then 2 dashes and global. And then from there, user.name and provide your name. Do this in quotes, it's a string. Next thing is providing the email. So we'll do git config tech global and then user.email and specify our email. And then bam, we're all set. The next thing we need to do is navigate to github.com/signup. And now if you have an account already, all you're gonna do is go ahead and sign in. Otherwise, go through this process of filling in your email and providing your credentials in order to set up an account. They'll send an email to your email, and then from there you'll verify and you'll be set up with your GitHub account. Once you've done the verification, you should be directed back to your account. And from here, I would go through and set up your profile information so it's all set up. I include things like a bio and all my different social media links. Now this has a bunch of pinned repositories on it right now, which we'll get to eventually for you. But just understand this is how if somebody wants to come to my profile and access a course, they can get it from here. So we've installed Git, set up GitHub. Now it's time to initialize our local repository. Now there's a few ways we can create local repositories. We can do it inside VS Code. They make it super simple via this method. But there's also alternate options you can do that I think you should know about, like GitHub Desktop, which is its own app you can install on your computer and manage repositories. Additionally, you could go directly to github.com and that can do it as well, but then you'd have to actually pull it from the remote repository. And the last one is using the command line, basically using Git commands in order to add, pull, and push different requests from Git. I do recommend you learn this option at some point, but we're going to stick to the easy option of VS Code first. So here we are in my VS Code inside of my project for this Python course. Now, I may not have the same folder structure as you, but I've been using that 1 for basics, 2 for advanced, and then 3 to keep my project stuff. For the project itself, I only have 1 file inside of here of that intro file that we made in the last lesson. Anyway, over here on the left-hand side of your screen, we're going to click Source Control. And you're going to have 2 options for this. Now, if you have no intention of publishing to GitHub or creating a remote repository, the first option is for you to initialize repository. Otherwise, we're going to go with that second option of publish to GitHub, as not only it's going to initialize this local repository, but also it's going to publish it to GitHub to create our remote repository. Now I'm going to go ahead and click that. Then it's going to say publish to a private repository or a public repository. I want the world to see it, so we're going to make it public. It then asks me which files should be included in the repository. I want all of these folders. I don't want this .ds_store. Remember, dot files are hidden files. This one in this case is not necessary, so I unselect it. I'm going to then click OK. Now for me, it's publishing it to GitHub and it says successfully publish the name of the project repository to GitHub, and then I can open it on GitHub. You may, during this, be prompted to sign into GitHub via VS Code. So you need to go ahead and do that in order for VS Code to then be linked to your GitHub account. I was already set up with my VS Code for that. Anyway, once you've done that, open it on GitHub. So now our local repository has been pushed up to GitHub and we have a remote repository available. Anybody can come in and download this. I can even go into that number 3 project folder, open up our EDA, and it's going to include all the different code that we did along with the visualizations that we built. All right, so we've now done those final steps of initializing the local repository and then pushing it up to GitHub. Told you the last step was going to be the simplest. So we're going to have a little fun now, and we're actually going to practice performing pushes and also pulls from GitHub. And we're going to be doing this all through VS Code. So starting with the push changes first. This is for sending our changes that we do locally on our computer up into GitHub. And this will allow for these changes to be visible there. So back inside VS Code, you're going to notice now that you have this .gitignore file. This thing just ignored that file that we previously said ignore. Don't worry about it for right now. Anyway, let's make a change to this repository so that we have something to push. So inside of our project, I'm going to create a new Jupyter notebook for our next lesson that we're going to be going over. I'm going to title it 2, and we're going to be going into skills counting with that. And I'm going to title that a IPNB file. Now, after I did this, you may have noticed over on the left-hand side that 1 appeared next to our version control. And basically, source control has already picked up that we have a change here. And right now it has a U associated with it. Basically, it means it's untracked. So we need to add this change to our staging area. Now, anytime you add something, you need to include a message on what you actually did here. And you want to keep it super short. And I'm just going to say add project 2 file. From there, I'm going to click commit. So right now, this is a stage change. So right now, this has been committed to our local repository, but it's not up on our remote repository. Hence why we have this now that says sync changes. And it says push 1 commit to origin/main. And that's the branch of what we're on in our remote repository. So I'm going to go ahead and click sync changes. Now inside of GitHub, I can navigate into that 3 project folder and in fact see that we've added that Python notebook to this. We're going to ignore it's invalid for right now. We haven't added anything to it. We will next lesson. So that's how we do push changes with VS Code. Now we need to move into pulling changes. And for this, we need to have a change on our remote repository and then actually pull that down into our local repository. So inside the remote repository in GitHub, if you scroll down, it has this here of add a README. And a README file, we're going to be building it out more on the project, but basically outlines what you did for it. So I'm going to click add a README, and it's going to change or alter the project. And I'm going to put a to-do of need to fill this in. Okay. And then upper in the right-hand corner, I'm going to click commit changes. And it's going to have a commit message created already of create README. And from there, I'm going to commit directly to the main branch and commit changes. So now this README is part of our project. It even has that to-do of need to fill this in with it. So inside of VS Code in our project locally, that README is not available right now. So what I need to do is actually pull it down. So I come down here into source control. I can click these 3 dots right here and click pull. It does a little loading in the background. And now when I navigate over to the files, we have this README here along with the to-do of need to fill this in. So that is the basics of how you can go about pushing and pulling changes from GitHub. This is super powerful when implemented properly and allows you to collaborate with others and build some pretty cool solutions. All right, so you haven't done it already, it's your turn now to go through and set up Git and GitHub. In the next lesson, we're going to be moving on to building out our project and working on that first problem for it. With that, see you in the next one. So let's get into tackling our first project problem. And for this, we're going to be looking at what are the most in-demand skills for not only data analysts, but those other 2 top roles of data scientists and data engineers. Now, previously we built this visualization in the formats charts lesson from the advanced chapter. This was great at showing a high-level look of not only what the top skills are we should focus on for data analysts, but also how they compare to those other 2 roles. But there's 2 major issues they're going to fix with our new visualization. First, instead of having counts of job postings, which is sort of frivolous, what is the percentage or likelihood of a skill to appear in a job posting? That's what we're actually going to calculate. Additionally, we're going to add some highlighting along with some formatting to cue the viewers of these charts in to the highest percentage skills. Now jumping into my Jupyter notebook, I've defined our question that we're trying to answer along with the methodology. Now we're already done with steps 1 and 2 of cleaning up the skills and calculating the skill count, which we plotted previously. We just need to bring that code back in here and then move on to steps 3 and 4, which is calculating the skill percentage and then plotting those final findings. For all of this, I'm going to be going back to that previous notebook that I have on format charts, copying all the different code that we need, and then just pasting it right into here. So this obviously includes all the importing libraries, loading the data, and then doing that data cleanup. Next, we need to keep all the different job titles in this data frame, but I do want to filter it specific to the United States. So I add this condition and set up this new data frame of df_US. Then we use the explode method to break out those lists of the job skills and get them into a new data frame of df skills. We can then visualize to see what is actually here now, and we can see the job skills are broken out. Now that df skills is broken out, we can do a group by on the job skills and also job title short column. Displaying this below this, we can see we have job title shorts along with the skill, and then the counts of each one of these with their association. This right now is technically a series when I run type on it, so I want to transfer this into a data frame to make it a little bit easier to manipulate. So I run reset index on it, and we rename that values column to skill count. Displaying it below this has the same results. The only thing left to do is now sort these skill counts to be from highest to lowest. So on this data frame of skill count, I sort the values by skill count in descending order. And I do this in place true, but you could just set it equal to the variable itself. But now we have the higher skill counts near the top. Now we need to get the top 3 roles, and we can just define a list, which is what we did previously. Personally, I like to programmatically get anything like that 𝗕𝘁𝗍𝗍 hard coded in. So here I'm getting the unique values in the job title short column, and it's making it into an array. So I'll make it into a list using the toList method. And now I only want the top 3 results. So I'll use a slicer to do this, specifying I want :3. And then we have data scientist, analyst, and engineer. I'm picky. I want it in alphabetical order, so I'm going to use the sorted function on this. And now we have data analysts, engineers, and scientists. Next up is plotting it. Remember, we want 3 separate plots for this. So I'll insert the length of job titles and then specify we only want 1 column. Next, now that we have this fig and ax, we need to iterate through each one of these and then plot the associated graph. So we'll use a for loop, pulling out the index and then also the job title name out of our job titles list using the enumerate function. Then we'll define the data frame we want to plot, which is our data frame skills count, which is this data frame up here. But we need to filter by that job title short column and only get the top 5 values. So we'll specify this filter and the head equal to 5. And then from there, we'll plot it using a bar chart, specifying the X and Y values, along with what axis it needs to go on. Additionally, put a title above each of these subplots with the job title itself. Let's go ahead and run this. And this is what we got in the Matplotlib section, but let's clean this up a little bit. I'm going to invert the axis, remove the Y labels, and remove that legend as well, and then also put up a super title, if you will, above all of it. And I forgot to implement a tight layout so we don't have overlap. Okay, so now we're all caught up to where we were with the Matplotlib, and we can actually see we have the counts of all the different skills. So now we need to convert these counts to a percentage. And if we scroll back up to our df skills count data frame, we can see we have the skill counts for each of the different roles and the skill. What we need to do is perform an aggregation to get actually how many job postings we have for data scientists, data analysts, and also data engineers. And then with this total number of job postings, we can take that skill count, divide it by that total, and get what is the percentage of a skill in a job posting. So with our US data frame, it's very important that we use the correct data frame for this. We need to do a value counts of the job title short column. And so I'll add in that value counts method. Right now there's a series, so I'm going to reset the index in order to make it into a data frame. And I want to name that values column jobs total. So I'll set name equal to jobs total. Running Control Enter. We now have this in our data frame. And this has the counts for all the different jobs. So we need to now merge it with our df skills count on that job title short column. So we use the pandas merge function for this. We need to specify the left data frame. In this case, we'll use df skills count. And then we need to find the right data frame of df job title count. And I just realized we got the yellow syntax because we actually didn't save it into this for this actual data frame up here that we did. So I'll go ahead and run this, Control Enter. Okay, Continuing on for our merge, how do we want to do this? Well, we're going to do a left join. Basically, everything in the left table of the DF skill counts, which is below, we want to maintain, and we just want to merge what's available onto this data frame. Finally, we need to specify the column that we're merging on, which is job title. Okay, running Control Enter. And now we have that jobs total column appended right onto this data frame. So we'll name this one DF skills %. Now I'll show that. And now with this, because we have in the same data frame, we have the count, which should be less than the jobs total. We're gonna do some math to calculate what is that skill percentage. So for this data frame, I'll specify a new column called skill % and set it equal to the skill count divided by jobs total. Run this, Control Enter. We now have skills %. And the math looks all right. Now this is in decimal because that's a percentage, but I want this to be in a full value. So whenever we go to plot it, we can see things like 20 or 30% and not 0.2 or 0.3. So I'll multiply this all times 100 and that will fix that. So now let's plot this. I'm gonna come up here to this plot up here and just copy everything we have and then paste it down underneath to have a starting point. Remember, we defined this DF skills %. So in our data frame to plot, I'm going to change this to DF skills %. Also, I want the filter to do that as well. And then the only thing left to change is we don't want to plot the count. We want to plot the percentage. So this should now work, pressing Control Enter. And bam, we have it. Now for these percentages, you should be seeing very similar ones with things like data engineers be around 60 to 70%, SQL for data analysts around 50%, and then the data scientist around 60 to 70%. If you don't have these values, you need to go back to that original data frame that we calculate the totals and double check your work. Now, frankly, this chart is good enough to go for you, but I'm a perfectionist, so we're gonna clean it up a little bit. This is all pretty much optional if you wanna do this. But I guess what isn't optional is actually changing the title to reflect what this actually is, and that's the likelihood of skills requests and job postings. Okay, but let's get into cleaning this up. I wanna upgrade this chart by using Seaborn instead, and I'm gonna call out the bar plot for this. I'm noticing I didn't import Seaborn with this, so actually I need to go back up here and specify import Seaborn. Anyway, now that that's loaded, I've gone through and specified the arguments of data of DF plot above. X is the skill percentage, Y is the job skills, what we're using as the axis, the hue itself that we want to use skill count to color this, because that's the whole point of using the Seaborn library, so we can actually color it. And then this palette of dark blue, putting it in reversed order. Let's go ahead and check what this updated visualization looks like. Okay, not too bad. I'm not a fan of this theme though, especially this color of the blue that it's using. So I'm gonna set the theme to the style of ticks. And this is much more appeasing to the eyes. I'm gonna go ahead and remove our previous Matplotlib since we have that copied over. Now the next thing I did was go through and set the title itself, invert the Y-axis, remove both the X and Y labels along with the legend, and then I set an X limit of 0 to 78, basically so that way all of the charts were on the same axis. So let's go ahead and look at this. So now we've cleaned up the axes, but it's all on a comparable percentage so we can look from one to the other, and it's a lot more usable. Also, I made a mistake here. So Seaborn actually doesn't do that thing where Matplotlib plots backwards. So I can remove this invert axis. Now, the next thing I want to do is similar to what we did with our scatter plots of using that plt.text function to label all our different data points. I want to do that the same thing with these bars, but provide it with what is the percentage. So what we'll need to do is loop through our DF plot, specifically going through on that skill percentage column so we can get those values from here and then plot it. And this loop is going to be inside of our loop already that is plotting a graph. So in the case of data analyst, once we get to the end of this of setting the X limit, we'll then go through and it will label one by one each of these points. So I'll need to indent this further and then start from here. For this, we're going to be also cycling through the index and then value in the DF plot skill percent column. And we want the index, so we have to do enumerate. Now, previously we were using plt.text for this. But instead of PLT, we're going to be using the actual axis itself. And if you recall back to this function, we need to specify the X value to plot over and then the Y value. So we need to first specify the X of what percent and then the Y of how many index levels down to plot it. So X, as far as the value, would be V, and then the Y would be that N, or that index position from it. And then from there, we want to actually plot the value itself on this, so I'll put V in there. We're going to go ahead and run this and see what we get. All right, so there's a couple problems with this. First, it's too close to the bar, so I'm going to fix that by doing V, by adjusting the X position, do V plus 1. Okay, so now it's farther away from the bar. The next thing is it's not centered, it's like slightly up some. So we can specify the vertical position by calling out VA equal to, in this case, center. Okay, so now the numbers are much more in line with the bar, but we actually need to clean up these values now of just the decimal places are way too long. So what we can do for this is just specify it as an F string. So I'm just gonna start simple first and put the variable inside the F string and then define it with curly brackets around it. Running Control Enter, nothing's gonna change. I want a percent symbol at the end, so we'll add that. We got a percent at the end. And then the last thing we need to do is just convert this to an int because we don't want any decimal places with it, or I don't at least. Now, one thing about converting to an int, we're slightly not being truthful in our percentage. So data scientist SQL is 50%. If we come up here to data scientist and look at SQL, it's at 50.99%. So technically, we probably need to actually change that. And we can do that string formatting method that we learned previously, specifying that we want .0 decimal places and that we're using this as a floating point or specifying it as a floating point. All right, and now we have the updated percentages. SQL's now at 51%. The very last thing I'm gonna do is, I feel like this x-axis on both data analysts and data engineers is repetitive, especially since it's down at the bottom. And we also have all these data labels on it. It's just way too many numbers on this. And so we can remove this by specifying the axis itself and then saying set xticks. And we set it to an empty list. Running Control Enter basically removes everything. But I actually do want it to plot for data scientist. Or better said, I want to keep the axes on the last plot. So instead, I can define an if statement that if I is basically equal to 2, which in our case, we're going to programmatically say this by the length of job titles minus 1. In that case, we want to set the xticks to nothing. Running Control Enter, we have this bad boy now. Whew, our final visualization. I told y'all I was picky. But I think it actually conveys what we want to show here, which captures what are the top skills of these 3 top roles. And as we can see from this, Python and also SQL are very common across all 3 of these roles. So if you haven't taken my SQL course yet, probably need to take that next. So what do we do now that we got to these final results? Well, we need to capture them somewhere, specifically in a README. Well, inside of a repository, we've created 3 folders, the basic, advanced, and project section. Along with that README, if you remember, we created it up on GitHub and then pulled down. This README is where we're going to be capturing all the different insights from our project. And so we can start now so we don't have to do that later. Specifically, I want to capture the insights from this visualization in this README. And what do I mean by this README? Well, here's a sneak peek at what we're going to build around this. Well, in this, it's going to start with something like an overview and then the questions we're going to be answering in this project. This first one here of what are the skills most in demand for the top 3 most popular data roles is what we're doing now. In the beginning portion, I defined the tools I use, data preparation and cleanup, and then getting into the analysis itself. That's where we need to be putting what we learned from these insights there. From there, I share any code that I find is relevant along with the image itself or the graph we finally made. And then finally capturing any insights, which is where we're at right now, and so why we need to do that in our README right now. And then from there, it repeats for all the other different ones as well. So let's actually get to formatting this bad boy and building it out. First thing I'm going to do is specify a section for the analysis we're going to be doing. So I'm going to call that the analysis. Now remember, we're in a markdown file, so we're going to be using things like a hashtag and then space to format the document. We can actually see what the README is going to look like formatted by clicking over here in the top right-hand corner to open preview to the side. And now we can see that we have the analysis. I like to keep these side by side as we're going through it. So we're going to start by looking at what are the most demanded skills for the top 3 most popular data roles. From there, I just give a brief overview of what we were actually trying to tackle. If you notice from this, I have some squiggly lines over underneath here, basically calling out some grammar issues that I have. I have the Grammarly extension installed, as you can see by here, it says Grammarly. I'm in no way promoting Grammarly that you need to have it for this, but it is good at going through and actually cleaning up your markdown files to make them sound like you're not a blabbling idiot. The next thing I'm going to specify is where to view my notebook, and we can provide a link to this. Specifically, I'm going to call out the name of the notebook, and then we need to provide inside of parentheses, because see now it's actually a link, the link to this file. If I come over to the 3 project folder, I can right-click skill demand and select copy relative path. Then from there, I can paste it inside of here. Now, when I come over here and click this link of to skill demand notebook, it takes me to my notebook directly. Pretty cool. And this will work in GitHub too as well. Next, I like to show some relevant code that I did in order to generate my visualization. You could really pick whatever code that you find of most importance to you, and that really showcases a certain skill you want to demonstrate. And for me, I like demonstrating that I'm pretty good at making charts. So I'm just going to put in this short code snippet for that. Finally, we're going to get into the results. Now, I want to put the image that we generated here into the README. So what we can do is actually go back to this plot here, and we want to save this. And so what I'm going to do is save it inside of our 3 project folder. And I like to have organization. So inside of that project folder, I'm going to create a new folder called images. And then I'm going to name the graph appropriately of something like skill demand all data roles. You can name it whatever you want. Anyway, saving this. Now, if we scroll back over, we have this images folder with this in here. So I can copy this relative path as well. Now back inside of our README, we need to insert a link similar to what we did above with the Python notebook. In the brackets here, it's just going to be the alt text, so you can just be descriptive of what the graph is. So I just specify visualization of top skills for data nerds. Then inside parentheses, I'm going to paste in that hyperlink to the relative path of that image. And then finally, we need to make it into an image and not a link. So we're going to put an exclamation point at the front of this and made it into an image. So let's go ahead and save this by pressing Command S. Now we only have one last section to do of identifying what are the insights. So what are we taking out of this actual visualization right here that we learned? So I went through and talked about 3 insights from this that I felt are most relevant to me, specifically talking about Python, SQL, and then also specialized technical skills like cloud skills. So I'd recommend doing this first, but if you're having trouble drawing insights of these visualizations, I have a backup plan for you. If you go back to our Jupyter notebook and then you scroll down to the image of interest, you can, instead of just saving it, you can also copy it. And you can go to any chatbot assistant, paste it in, and you can prompt it something like, provide me short bullet point insights from this visualization. I'll be honest, these insights are mediocre at best, but it is a good starting point. You can even play with it further. So then I can prompt something like, provide a more holistic look at this for all 3 roles and the relevant skills and technologies. This I feel is a lot better analysis as it specifically calls out how Python and SQL are so core across all 3 roles. And then finally, it gives some key takeaways for all the different roles. All right, so that wraps it up on the format that we're going to be going through now for the remainder of the questions. We're going to be using a Jupyter notebook to then perform some analysis. And then we're going to be going into our README and filling it out with the applicable insights. All right, so it's now your turn to dive in and investigate. Remember, you don't have to necessarily limit it to those data analysts, data engineer, and data scientists. You can spread it out or make it adapted if you went on something like machine learning engineer to roles that are more applicable to that. Anyway, I'll see you in the next one where we'll be going over evaluating the trend of these skills over time. And with that, I'll see you in the next one. So now that we found out what are the top skills of data analysts, along with other top data roles, we can now dive further into this. And specifically, we need to find out if there's any trend with these skills. Like, should we be worried that any of these technologies are going out of style or they're actually booming? So if you remember back from the advanced chapter, we actually did a bunch of analysis on this already, and we analyzed how skills were trending for the top 5 for data analysts. There's just one major problem with this plot. It's going by counts. Because we did counts, we have a little bit of skewed data. We go back all the way back to the basics chapter where we plotted the number of job postings per month. We had a surge in January, also in August for some reason. And those surges can be seen in the counts of these skills. So what we need to do once again is to calculate the likelihood of these skills appearing in a job posting, basically calculate that percentage. Also, we're gonna do some formatting cleanup. Obviously this chart looks a lot better. So let's jump into it. So here we are in my Jupyter notebook, and I've gone ahead and created a new one for calculating this question of how are in-demand skills trending for data analysts. The methodology is this, going to be similar to last time, of we need to aggregate the skill counts on a monthly basis, which we've done previously, and now our new analysis is reanalyzing based on percentages of the total jobs, and then plot this new demand and upgrade the charts. So I've gone through and imported all the libraries, included Seaborn this time, loaded the data sets, and then also performed all that data cleanup. For this analysis, we're only focused on data analysts in the United States, so I'm filtering the database on this and creating a copy of the data frame. We're going to aggregate this on a monthly basis, so I'm creating a new column of job posted month number. With these month numbers now in there, I can now explode out this data frame on the job skill columns and assign this to a new data frame of data frame data analyst US explode. So let's go ahead and pivot this using that data frame that we exploded. I'm going to use our pivot table method, specifying the index of job posted month number. And for the columns, I want to use that skills. So job skills. For the ag function itself, we're going to be specifying this of size because we're doing a count of the different skills. For any non-values, we want to fill them in with a 0. So we're going to specify the fill value equal to 0. Running control enter. We have this all printed out. Notice the skills though are in alphabetical order, but job posted month number is in the correct order. So I'll assign this to a new data frame of basically this of pivot. And we need to be able to sort those columns or the job skill columns. So we create this new row of total using our .lock method. And for this, we're getting the sum of those columns. And now we have that total row. So now we need to sort this data frame. So we'll specify the data frame we're going to be filtering on. And we don't want to filter by a column. We want to filter by a row, the row of total. So we need to use the .lock method for this to access that total row. And we want to sort the values based on this. And of course, we want to set ascending equal to false. Running control enter, we're going to get an error. And that's because if we're to take this value that we're sorting by and paste it down here to see what we're actually evaluating, whenever we're doing this, we're passing in right now these values, these counts. We need to pass in the index because it's a series. So I'm going to specify index here. Okay, now it actually sorted by those index values of SQL, Excel, Tableau, Python, and it's in the correct order. I'm going to assign this to our original data frame. And the only thing really left now to do is to actually drop that total row. So let's see what we got now. Okay, now we have it sorted appropriately with job post num and the skills and no total row. Now, just to check to see what we're working with, we can plot this using a line chart. This has a bunch of the different visualizations in it, but we can basically see that we are back to what we had previously for all these different skills. Granted, we have this legend here and all this stuff. This probably needs to be cleaned up. We're going to be making our other visualization using percentages, so I'm not really too worried about cleaning this bad boy up. And now we need to get this DFDA US pivot into, well, from counts into a percentage. What is the percent of the skill appearing relative to all job postings? So in order to do this, we need to go back to our original data frame of data analysts in the United States, and then we're going to form a group by on job posted month number. And we want this to see the size of it. We can see all the different months and what are the number of job postings in each of those individual months. I'm going to call this data analyst totals. So now that we have these totals per month, we need to go through and basically divide the appropriate row by these totals to get the percentage here. Now we could use a for loop to loop through each one of those months and divide appropriately, but Pandas actually makes it easier with their .div method. We're going to provide to it two values. The first parameter of other, any single or multiple element data structure or list-like object. In our case, we're passing a series, so the data analyst totals. And then the axis, whether to compare by the index or columns. Since we're using the series and we have a certain index for it, and we want to compare it to the index of the data frame, we need to specify this of 0. So with our DFDA US pivot, I can run the .div method on it. We're going to pass in that data analyst totals and then specify the axis is equal to 0. Now, similar to last time, I don't like that they're in decimal notation. I want them in actual full numbers. So I'm going to take these DA totals and I'm going to divide it by 100. And now we have the full numbers. They're basically the same, just multiply by 100. So I'm going to assign this all to a new data frame called DFDA US %, real original. Now I want to do one more thing we're getting to plot in this, and that's clean up this month. I don't like using numerical values. I don't think it looks good visually. I want actual month names. And this is the code for it. I'm not going to run through it line by line because we've gone over it multiple times before. But if you want to, you can pause the screen and take a look at all of the code here. And with this, we have our updated data frame with the month names itself and then all the different skills. So let's get into plotting this bad boy. So the first thing with this data frame is I only want those first 5 columns. So I can use the ilock method and specify that I want all the rows, and then I only want the first 5 values. So it's equal to Power BI. And we're going to be using Seaborn to plot this. So I'll specify Seaborn, and then from there we're using a line plot. Now the first thing we need to do is specify the data source. So I'm going to set this data frame up here of df plot equal to this. And then inside of here for data, I'm going to set it equal to df plot. Let's go ahead and run this, and then we'll clean it up after that. So off to a good start. That is looking like it should, along with everything on here. Let's get into cleaning this up. I don't like the dashes, so I'm going to specify this as false, along with that palette. And I found this color scheme of tab 10, which I kind of like, so we're going to go with it. Now, I've been also setting the theme of all these, so I'm going to set the theme of the style of ticks. And it changes a little bit of the font and formatting with this. I kind of like how it looks. Next thing I'm going to do is clean up the titles and then also the labels. So adding an appropriate title to it and appropriate labels. And for now, removing the legend. Not too bad. Remember, we removed that legend because I actually want to go through and label each one of these lines and have an appropriate label next to it so you can quickly identify what line is associated to what skill by having to go that damn legend. Once again, we're going to be using that plt.text function for this. Now, we don't have multiple accesses, so we can leave it that plt.text. And what we need to do is go through each of those lines and write next to it what we want to have on it. So we can do a loop basically for I in range 5. And then inside of plt.text, we want to first specify the X position. So for the X position, these are numbered in index value, so it starts actually at 0. So we want to start it around 11. Then for the Y value, we want to have the very last value in the data frame itself. So we can do is specify df_plot and then use that ilock method to access the last row. And then for the column itself, we just pass in that I. That's why we're doing this I in range. So it knows to go over to, for SQL's case, go over 1. Now, what value do we want to plot in there? So the string that's next, well, we want the column name. So we can call it the data frame plot, specify the columns, and it's provided in a list. And then we can access this or the element in the list by also passing in I. All right, so this is good probably for right now. Let's run Control Enter. Not too bad. It's plotting it right at 11. I don't like it that close. We're going to do 11.2. And yeah, it looks good, except for we have this giant line running through our names. So what we can do now is use that Seaborn function of dspine. Running Control Enter, removes the spine, makes this look a lot more visually appealing. Now, there's only one last thing to do. I want to format this y-axis. Specifically, I want to have a % sign next to this so it knows it's not a full 60. So in order to do this, we need to access the axis. And we didn't do any subplots here. I mean, you can do that if you want, but I'm just going to do ax is equal to plt.getCurrentAxis. And then with our axis, I'm going to access the y-axis. And for this, we need to specify a formatter for it. Now, inside the documentation, you can see that you need to basically set the formatter of the major ticker. We need to pass in some sort of formatter. And Matplotlib actually has some underneath this ticker module. But they don't have it actually listed here, the one we need to actually format as a %. So we import it in. So we specify from matplotlib.ticker import, we want to do a % formatter from there. And then inside of here, we can specify % formatter. All right, running Control Enter on this. We now have this in percentage. I don't like the 0 in the end. I told y'all, I'm really picky. So inside of here, we can actually specify decimals equal to 0. And bam, now we have our final visualization that's all cleaned up and ready to go. So I'm already noticing some trends from this. First of all, SQL is somewhat steady, but it's also declining. It's still the highest skill, so I'm not too concerned, especially since it's high. Excel also looks like it has a decline to it, but Python, Tableau, and Power BI, who are in 3rd, 4th, and 5th place, seem to have steady values with it. Although I'd argue Python is slightly increasing. So you know what we need to do now? We need to capture the insights of this that we're getting from these visualization in our README. So we already have our first question there. I'm going to scroll on down, and I'm going to put in our question of how are in-demand skills trending for data analysts. From there, put in any code blocks that you feel are appropriate to this. I love plotting, so I'm going to include all my code for actually generating the plots. And I simplify it, removing any unnecessary things to basically bog it down. I just want to keep the most important things in there. The next thing I'm going to do is add in that final graph that we got in our visualization. So we can go back to our Jupyter notebook, click save it inside of that image folders that we created previously. And then with that new image saved inside of there, we can just go and copy that relative path. And then paste it into here, and we need to make sure it actually appears as an image. So put an exclamation point. And the very last thing we need to do now is just add our insights in. So I added all those insights in, focusing first on SQL, then Excel, and then those 3 remaining skills. And the key point of doing this analysis was to ensure that if we actually targeted or went to learn any of these 5 skills, we're not learning a skill that is potentially going to be deprecated and not used in the future. This graph basically proves all these technologies are safe for the time being to learn. So now with confirmation that these top 5 skills are relatively stable, we can now dive into our next question and understanding how well do not only jobs for data analysts, but also skills pay for them. So that's what we'll be tackling in the next one. With that, see you there. All right, so we're halfway through the project, and this one by far should be the easiest because we did a lot of pre-work already in the advanced chapter. For this, we're going to be going back and drawing up our box plots, but I want to expand our search to not only include the top 3 roles, but also their associated senior roles to see how well they pay. And once we have a good snapshot of how data analysts pay, we can then move into that other visualization that we already made on how well different skills pay for it. Not only the top paid skills, but also the most popular. So let's jump right in for evaluating the median salary for those top 6 data jobs. As always, we're going to be importing all the libraries, loading the data, and doing some data cleanup. For the first analysis, we're only going to focus on the United States, but we need to keep all those different job titles, and we'll use this method to drop any NA values for the salary year average column. Similar to how we got the top 3 jobs in the last lesson, I'm running a similar set of methods in order to get the top 6. And with this top 6, we can then filter another data frame, calling it DFUS top 6. Specify we want to filter the job title short column using the isIn method, basically checking, hey, are these titles in this list? If it is, keep it in the data frame. So back in the lesson on Seaborn, we plotted these 3 data roles: data scientists, data engineers, and data analysts. A lot of this formatting, everything's going to remain the same from this. So I'm just going to go ahead and copy this right here. Coming back into our notebook that we were working in previously, I'm going to go ahead and paste it. And we need to update it for this new data frame. So specifically data frame US top 6. Everything else I believe should remain the same. So I'm going to go ahead and plot it. And we get this bad boy, which not too bad, although I do want to fix it up a little bit. Right now, visually, I would want to actually have this to where the median salary slowly ascends for each of these different values. And so we need to reorder these rows to basically have, it looks like data analyst is the lowest, and next followed by senior data analyst, and then data engineer, data scientist, and so on. So we need to basically sort this y-axis by the median salary. So coming back up here underneath our data frame that we created, we're going to need to perform a group by aggregation to find out what are the different median salaries for these job titles and then order it by that. So I can do a group by specifying job title short, and then using that salary year average column that we want to do the aggregation on of the median salary. So let's go ahead and run this. Not bad. We want this in descending order though. So with the sort values method, I'm going to specify ascending equal to false. And then we don't really actually care what these median values are. We want the index of this series because this is a series right here. And so I'm going to specify index. Okay, now we have a list of the different job titles in the correct order that we want it. I'm going to call this list job order. So now what's convenient about Seaborn is they provide a parameter of order. And so I can specify job order. Now running this, we get them now basically in descending order. Now I was really surprised by the fact that not all senior roles are more than the junior roles. So senior data analyst is higher than data analyst, as we'd expect, but it's not higher than data engineers and data scientists, but their respective seniors are definitely higher. So I think this provides a great insight that if you're working as a data analyst and then you're ready to go to the next level, you may consider, besides going to a senior data analyst role, to go to maybe a data scientist or even data engineer. So before we proceed further, we need to basically capture those insights we just said there inside of our README. Going back to the graph that we created, I'm going to go ahead and save it. And now let's add these insights. I'm going to start with the title of how well do jobs and skill pay for data analyst. And we'll start with this first section of salary analysis for data nerds, basically our box plot section. We'll have a little section in here on visualizing data, because that's my favorite, along with including those box plot results underneath it. And then finally, I wrap it up with these insights, capturing how the senior roles compare and what I feel about data analyst roles. So let's move into that second visualization we're trying to build, and that's investigating the median salary versus skills for data analysts. And just like the last visualization, we've done this before, so I'm going to be flying through this. I need to create a new data frame because now I don't want to include the top 6 roles. I only want to include data analyst. So I do that along with the country of the United States, making sure I run the copy method on this. Additionally, since we're only analyzing jobs with salary, I'm going to drop any values that are non. Next, we need to explode out that job skills column because currently it's in a list. And then let's actually investigate it by looking at the salary year average column and the job skills column. Yep, looks good. The first thing I want to do is find those top paying skills. And so what we're going to do is do a group by on job skills using that salary year average column as an aggregation, aggregating count and median. Now we want the top paying skills at the top of this data frame. So we're going to use sort values on this to sort by the values of median, putting ascending to false. From there, we'll set it equal to a new data frame of data frame, data analyst, top pay. And for this new data frame, I only need the top 10 values. And now we need to repeat that group by again and aggregation, but we want to get a data frame now that has the most popular skills in it. So in this case, we don't want to sort by the value of median here. Instead, we want to sort by the count. So now these have the top popular skills, so SQL, Excel, Python, Tableau. Yep. Now with this, we're going to be graphing this data frame, and we're going to be graphing it. We want the salaries in the appropriate order. So now that we have the top 10, we need to actually sort it by the median values. So now we have that top pay data frame along with the most popular skills data frame. From there, I'm going to go back into our notes from Seaborn, see the visualization we have here. I'm going to come in now and actually take all this different code we did to generate this. And I'm going to paste it on in. The data frames still, I use the same nomenclature for the names. So the data frames are correct along with their columns. So we'll go ahead and run this and bam, we have our other visualization that we're trying to get. So with this visualization, we're seeing a lot of good insights with it. For the top highest paying paid skills, we're seeing things like technologies around Dipler, Bitbug, and GitLab. So web service technologies are a lot more popular. One note about this, we actually scroll back up to this data frame up here and look at the count of these jobs. The counts are around 2, 3, 1, 2, 6. So not a lot of jobs over the course of the year requesting this, but have a high salary with it. Conversely, if you look at our most popular ones, they have in the hundreds and thousands of jobs available. So I wouldn't neglect your Python studies to learn something like Ansible. A niche technology like that's going to be good to know, but it's going to pay off to know something like Python in this case, which is the top paying job for the top 10 most popular skills. Pretty meta that we discovered this using Python. Anyway, other trends I'm noticing with this is that Microsoft products like PowerPoint, Excel, and Word seem to have a lower related salary compared to like programming and visualization softwares. So it pays to know more advanced technologies, basically. So you know what we need to do? We need to capture these insights in a README. So for me, I added in the code to go about visualizing these different graphs and then adding in that visualization that we just built.
And then finally, wrap it up with the insights, talking about the core technologies that pay the most, along with the most popular technologies and what the insights I got out of that.
So we've learned two major things here. One, we understand now where data analysts stack up to other data science roles. And two, what skills pay the most for data analysts. In the next and final iteration of our project, we're going to be using what we learned on skill pay here, and then also what we learned previously on the counts of skills, and combining those both together in order to find out what is the most optimal skill to learn. So with that, I hope you're ready to come to a close, and I'll see you in the next one.
All right, into the final question to solve for this project. Super excited, we're almost done with this. For this, we're going to be working off that scatter plot we built in the scatter plot lesson and then improved on in the advanced customization section so we get all those names not being on top of each other. Anyway, this visualization still needs to be upgraded, right? We need to shift it to this new visualization that now has percentages instead of counts. So we can actually do an apples-to-apples comparison of what's going on here. But we're going to spice this visualization up just a little bit more. We're going to actually color code it. Specifically, we're going to be able to see which ones correlate to programming tools, databases, cloud technologies, whatnot. So we can actually extract deeper insights into not only singular technologies, but also technologies at large. So here I am in VS Code. We're going to start a new notebook analyzing what is the most optimal skill to learn for that analyst. We're going to start with this first one of grouping the job skills in order to determine what the median salary and likelihood of being in a posting is, basically that percentage. First thing we do is import in the libraries, load all the data, and then clean it up. Next thing we need to do is filter our data frame for not only data analyst job postings, but also the country of interest of the United States, and you're running the copy method on this. Similar to before, we're going to drop any job postings that don't have salary data. We're going to explode out the job skills column, and then let's go investigate it. Yep, import it in, good. So let's perform a grouping of this data frame in order to group the job skills based on the median salary and count. So I group by on the job skills column using that salary year average as the aggregation of count and also median. This is a good start, but I want the count of skills, basically the higher counted skills up at the top. But whenever we change that to a percentage, it's still going to be in the same order. So I order by count, and I set ascending equal to false. We're going to have multiple columns in this data frame, so I want to be very clear about what these different column names are. In this case, count and median isn't descriptive enough, and it may be confusing later on. So I'm going to rename our data frame that I just created above of DFDA skills and rename it to skill count and median salary. Displaying it below, we have updated names. Now we need one more thing in our data frame. Specifically, we need that percentage. And so what we can do is use our original data frame of DFDA US, the one where we removed all the salary data from it. We can get the length of this, and this will provide us the number of job postings. So I'll create a new variable called data analyst job count and assign it that of length of the data frame. Now we need to create that new column of skill percent. And for this one, we'll set it equal to the skill count divided by that data analyst job count right here, multiplied by 100 because I want to keep it not a decimal place because I'm very particular. We're going to Control Enter. We have now this final data frame that we can use for this. And if you're doing this, you should be noticing that these skills, these top skills should be specific to a data analyst around 50%. Top skills for data scientists should be around 70% or so, and same for data engineers. If you're any different than this, you probably didn't calculate the correct length of the data frame. Now, this data frame has 168 rows. I'm not going to want to plot every single one of these on our scatter plot. Instead, we want to calculate basically what percentage, or we're going to have a cutoff percentage of what values we do want to include on there. I'm going to set a skill percent variable equal to 5. And I've played around with these numbers, and 5 for data analyst seems to work to not basically clog up the visualization. So with that variable, I'm going to create a new data frame to basically filter our old data frame down to make sure that we have values greater than 5%. Printing this data table out underneath it, we can see that, yep, we got, it's about 12 different jobs. I think there's a pretty good insights into what we want to focus on. So going back to that advanced customization lesson, we plotted that there, and I'm going to basically copy all this different code and then paste it into the notebook that we're working with right now. So with this, we're almost there. We can see that there is some yellow highlighting. Specifically, we have the wrong data frame inside of here. So I'm going to double click this one up here, press Command-Shift-L, and then change them all to be that DFDA skills high demand. Additionally, I'm just going to change this title down here to most optimal skills for data analysts in the US. Let's go ahead and run this, see if it works. And bam, we get this bad boy, which almost done. We forgot to change the count of the job postings. So I'm going to double click skill count. I notice it's in two places. Press Command-Shift-L and then put in skill %. When you Control Enter, we now have a percentage down there. So I'll update that X label instead of being counter job postings as % of data analyst jobs. Now, a few things I do want to clean up with this visualization cell. I know we're going to go into actually color coding the different skills in this, but what we're going to do here is also going to be transferable to our final visualization. First is we need to clean up this salary values on the y-axis. In order to do that, like last time, we have to access the axis. So I'll do AX equal to PLT.getCurrentAxis. For this, we're going to be doing the y-axis, and we can do the set major formatter. This one, we're going to use the built-in one from the module of pyplot, specifically func formatter. And we've customized this similarly on the past ones using this Lambda function. So I'm going to go ahead and just copy this and then go ahead and run it. All right, so we have this formatted now. The only thing left now to format is the x-axis to get it as %. And we did that back in that second problem we were trying to solve. So I'm going to copy the code for that one as well. And then inside of here, I want to specify ax.x-axis and paste in that set major formatter and then that % formatter. Right now, we haven't imported it in, so we need to actually import that in. From Matplotlib, import % formatter. Okay, we'll go ahead and run this. It's from matplotlib.tigger, wrong module. Okay, so now we have not only everything on the X and the Y axis formatted correctly, we have everything here that we need. So as we identified when we first talked about scatter plots, we want to be in this upper right-hand quadrant right here, because not only is it a high demand skill, but it's also a high paying skill. Conveniently for us, there's nothing directly there, but there's things around there, things like Python, Tableau, SQL. And then we're getting into outside boundaries here with Oracle, R, and Excel. But we want to take this visualization a step further, and I want to color it by the core technologies. Now, inside of our original data frame, if you scroll all the way over to the right, we have not only a job skills column, but we also have a job type skills, and this includes a dictionary in it. So if we look at the first 10 values, we can see that first it has a key, like in this case, analyst tools or async or cloud, which is like the technology. And then inside for the value, we have a list. So for analyst tools, we have things like Tableau, SAP, Jira, or we could have even multiple tools. So Tableau and Splunk in this case. So I went through and cleaned up this data set to basically, well, let me just run this code that I went through. And what it does is it aggregates all the values in the data frame and basically puts it into a singular dictionary. So in our case, analyst tools now has all the analyst tools that appear within a list. Conversely, when we get to the next one, where for databases, we get all the different databases in a list. And then next for libraries, all the different libraries in a list, and so on. So we have all the data we need. Now this code, I'm not going to go through line by line because we've gone through all the different things needed to understand what's going on here. So that'll give you that as a little bit of homework, or feel free to just copy and paste this and put it into your code. So with this dictionary, I'm going to make it into a data frame and assign the columns of technology and skills. We need to break out this skills column. So we're going to explode it out, specifying that skills column, and then we're going to print out this. And this gives us a singular data frame of technology with their associated skill. So now we can merge that back to our original data frame, specifically our data frame that has our different skill counts, median salary, and skill percentage. So I'll copy this data frame, and with it, we're going to merge that data frame technology. And we need to specify how we're going to actually do this. So for left on, this will be using the job skills column. And then for the right on, for the one we just actually created, we can scroll up and see that it's skills only. So we'll specify skills. When you Control Enter, we have now this singular one where it has not only the skills, but also the technology. So now we have the data frame that we need to plot. So I told you all that work we did earlier wasn't for bad use. We're actually going to copy all this code and just reuse it. One thing first, I'm going to define this as df_plot because that's what we want to plot. Now down here underneath this, I'm going to just throw this in for the time being. We're actually going to modify it. So we do see that the visualization gets made, but remember, we want to color code this based on the technologies, and we want to include the technologies. So we need to use the Seaborn library for this, vice just using Matplotlib. Or in this case, the Pandas method of plotting, which uses Matplotlib. So we go ahead and comment this out, and instead we're going to define sns.scatterplot. We have quite a few variables for this. First is data. We're going to set that equal to DataFrame plot. Next is x, and we want to use the skill % for this, just like above. From there, we're going to do y equal to the median salary, which is what we did above as well. And now for the hue to actually color it, so hue equals to, in our case, we want to set it equal to technology. And that's that column up here of technology. So let's go ahead and print what we have, or let's go ahead and display what we have below right now. All right, not too bad. So we have actually the different technologies coloring it in. I do want to change the theme and then remove this spine because I've been doing that frequently for all our other visualizations. I want to keep them the same. So I'm just going to add in this dspine function along with setting the theme of ticks, what we've been using previously. So bam, we have this bad boy now, which we can start to now extract insights about the technology itself. As we can see, things like programming for Python and SQL, also for R, SAS, and Go, are in some of the most optimal skills in that upper right-hand corner. Granted, R and SAS is more towards the middle, but based on having none in there, I think it's close enough. Next up is analyst tools. So this is like visualization tools or Microsoft Excel, things like that, things that are specific to an analyst. And they're sort of like middle of the pack. With things like PowerPoint and Word, like we discovered before, at the lower end of being paid well. And then finally, we do see some databases and cloud technologies appear, but not really prevalent. So I think the insight from this is focus on those programming and also analytical tools if you're a data analyst in order to get the most optimal pay. So now I know what we got to do now. We got to update our README for all that different work and insights we now discovered. I'm going to start first with the code necessary in order to visualize all our data. And then next adding in that visualization for what we just uncovered. Then lastly, get into those insights, sharing everything that we just learned about what is the most optimal skill and proving utmost that Python is the most superior skill. Although maybe biased on that one. All right, so congratulations on wrapping up this last problem we're tackling for the project. We're now going to be going forward with moving into actually making this project public available, not only on GitHub, make sure it's updated, but also on LinkedIn as well. So I'm personally proud of the work that we went through to get to this, and I hope you are as well and getting into sharing it. With that, I'll see you in the next one.
All right, we're almost to the finish line. We just need to get this work uploaded into GitHub and also update our README in order to include relevant information and guide our viewers on how they should understand our project. So for the README, we need to have some sections to basically build a story of what we did here. So here's a breakdown of the different components that we're going to be including in our README. And this is per the suggestion of Kelly, and this is how she formats all of her different READMEs and projects and blogs based on her past success with demonstrating her experience. Now, we've already done the analysis of this README document, and so frankly, that's the bulk of the work. The rest of the stuff is pretty easy to fill in. Oh, and all this is just a recommendation. You can feel free to adapt it to your own need. For the introduction section, I just provide an overview, basically telling them what this project was all about and that I completed it in conjunction with my Python course. For the background, that's when I jump into the questions themselves, defining the 4 problem statements that I'm trying to solve from this. And next up is tools we used. Make sure you're listing all the different tools for this. There's a great section to demonstrate all your different experiences with these different technologies. And then we get to the analysis, which basically includes all the stuff from our last 4 lessons where we went through and added the images and the different code blocks. And then we get into wrapping it up. So I went over what I learned, and frankly, I learned a lot more about Python even building this course. So thank you for that. Next, I provide some insights that I captured from the data itself, understanding skills, salaries, and market trends. And then from there, jumping into challenges I faced with this, whether that was data problems you had or issues with actually visualizing, included in this section. And then finally, I just have a little wrap up section at the end to conclude all this work, basically capture in a few lines what I did. All right, so now we have a README done. We need to get on GitHub. We go to the source control tab. I'm going to give this the title of final commit, sync changes, and then go navigate over to GitHub, make sure it uploaded. One thing to know is you can have up to 6 different repositories pinned in here. So in my case, this Python Data Analytics course, I'm going to put it up at the top left. If you're not seeing it there, you have more than there. You can customize it and add the appropriate one to it. Anyway, let's go on into this. All right, bam. Now we have all of our different code, and now this README updated with all our different analysis that we did. This was nothing short of a lot of hard work, so you should be super proud of it. Now that we have this all on GitHub, we only got to do one more thing, and that's update our LinkedIn to include this project and our relevant experience that we gained from this course. So with that, I'll see you in the next one where we get into LinkedIn. All right, a little bittersweet. We're on this last lesson of this course. Been a lot of work. I'm super proud of what you've done so far. All right, we're going to jump into how we can actually update our LinkedIn to demonstrate all of our different experience that we've gained from this. For those that purchase the course problems, you'll be getting a course certificate and you can update your LinkedIn for this. Now, it's not too late if you didn't purchase those course problems, as you can still get that and get that course certificate. You don't necessarily have to work through all the problems to get that certificate. You made it this far, you deserve it. After we update for the certificate, we're going to update our project section to show this portfolio project and then make a post. After you complete the end of course survey, I'll be sending you via email your course certificate, and you can just download that and save it for this LinkedIn section. All right, so once you navigate to LinkedIn and then navigate to your profile itself, you'll go under Add Profile section. Specifically underneath the recommended, you'll add licenses and certifications. For the name, you'll just name it Python for Data Analytics, which is the name of the course. For the issuing organization, you can select me and have a picture that pops up for it. Next is the issue date. There's no need to select an expiration. There's no expiration. For the credential ID, there's a specific ID that you have on your certificate. Paste that in here. Next is the credential URL. Whenever I sent you that email, you also should have received a URL associated with that certificate. You just copy that one. It's a very unique URL, and you post it in here. Next up is the skills. I recommend putting these 5 in there as they're the core technologies we focused on: Python, Git, Matplotlib, Pandas, and Jupyter. You can feel free to add other technologies too, like Seaborn and GitHub. The last thing to include is the certificate itself. So you go in and add the media of that document downloaded. You just add the media to it. And then finally, all you gotta do is click save. The next thing, whether you purchase the course problems or not, you can actually add the project to your LinkedIn. So once again, we're gonna go to this add profile section, and under recommended, we're gonna select add projects. I'll select a project name of data science job analysis with Python. From there, I include a short description, which has a call to action for them to go to my GitHub page, check out my project. Once again, for those skills, add in those core skills that you wanna add. Feel free to add in, like I said, Seaborn and GitHub. Next is the media. In our case, we want to include that URL to our GitHub project. So I can select add media, add a link, and then from there, paste it in and click add. From there, include an appropriate title and click apply. The last few items to include were the start and end date, and then any contributors. In my case, Kelly helped me out with a lot with this project, so I'm including her. And that's it for the project section. We can go ahead and click save. The last thing to do is make a post in order to share your project that you completed, the certificate, and I'd also link your project in the comments so others can check it out. Don't forget that if you're making this post to tag Kelly and me in it, so I'd love to check out your projects and see the different work that you've done for this. All right, so congratulations. This has been nothing short of your hard work. I know a lot of effort went in personally for me just building this course, so I know you've put a lot in actually working through it, solving all the different problems, and getting to that final project. With that, I want to congratulate you on that. Now I'm going to be making courses on Python and Excel coming in the future, but if you're curious about what to learn now, I would recommend, if you haven't done it already, taking my SQL for Data Analytics course. As we learned from this analysis right here, SQL is right up there from Python, and I'm using both of those in conjunction with each other all the time, so I highly recommend learning both. All right, with that, really appreciate your time and following through all this, and I'll see you in the next course.